And so if we take a look at what we're going to really be talking about in this lecture and in this web application course is the technologies, the different technologies that are used to, in effect, produce a web page, right? So we have a web page over here. You go to URL data.pr4e.org/page1.htm, and here comes a page, and this is like a super simple page. But there are so many technologies, like how browsers work with JavaScript and jQuery and CSS and eventually Vue and things like that. That's a whole set of front-end technologies, and then there's sort of back-end technologies like Django or Flask and databases. And we're gonna learn in this. My focus in this class is less about how to make it all look beautiful, although that's important, and more about how to deal with the back end. So what we're going to see is these technologies that define the look and feel and the interactivity of your web pages, but also then how data and HTML, CSS, and JavaScript are served up by the remote server. And so the internet here is in the middle. The browser is sitting on your laptop or your phone or whatever, and it has all these technologies built into it. It makes requests, and then the server comes back with responses. And so the simplest version of this protocol is that you click on a tag, and when you click on that tag, you get a new web page. Now, if you watch your debugger console, you will see that sometimes it's 120 different request response cycles used to construct the page. But in a sense, they're all the same. Now, as we move to things like HTTP2, there are ways to pull down multiple documents in a single connection, but we'll stick with the old HTTP1 way of thinking about it. In the simplest form, the browser asks for a document and then retrieves the document and then shows the document, and that is the basic request response cycle. So if you look at how this works, that browser is an application running inside your computer on your laptop or your phone. That is a piece of code. And in that, it's got a connection to the screen or the keyboard or the mouse or whatever, and it's watching for events, meaning that you're going to go and you're going to click somewhere, and then this application is going to respond to the events. So on a web page, in the simplest case, you got stuff that you can click on and stuff that you can't, and you go find your way through whatever to click on part of that web page, and that click is intercepted by the application, whether it's Chrome or Firefox or Safari, running on your piece of equipment. And then that application then opens what's called a network socket, a socket across the network to a web server, and sends a request. And that request, as we'll see in a bit, is a specially formatted request. It has a GET command, and then it has the URL that it wants to get from the web server. And then the web server does a bunch of work inside itself, maybe reading disk files and running programs, generating what it is that you want, and then it sends the response back on that same socket connection. So there's like this socket connection through which all of this stuff is viewed. And so the HTML is the basic thing that comes back. As we go further, we'll see that it's not just HTML that comes back, but other things as well that come back. And so when the browser receives that HTML, then it says, oh, I know what HTML is. I've got this header1 tag. Here, let me change the color of this thing so you can see it a little better. Yellow is way better. Okay, so when the browser receives this page, it sort of sees it and it looks at it, and then it looks at all the HTML. And so part of this course is to understand the syntax of HTML. That itself is how to build good HTML and CSS and how to make it look beautiful. But ultimately, something in that HTML plus its CSS plus its JavaScript leads to a visual display of the page, and then that's the thing that you see. And so this is the request response cycle. So up next, we're going to talk about what these network sockets are, or the things that fundamentally underlie this request response cycle. So network sockets are like phone calls for computers, and literally in the 1960s, when they were designing the concept for network software, that is the concept that they came up with. And that is that, in a sense, we make a call, we talk on the call, and we hang the phone up. And as computers were going to share data, and some computers were going to have data, and other computers were going to want data, they thought, oh, the way to do this is not necessarily have a permanent connection to that data, because there's going to be so many computers and so many sources of data and so many computers that want to consume those data. And of course, in 1960, they had no imagination that there would be billions. They just thought there would be 10,000, and they thought that was a lot. But they came up with a protocol that basically said, when you don't have continuous permanent access to data, you actually make a phone call, you know where the data is at, you kind of say, you dial up, you grab the stuff, you get it back, and then you let the connection go. And so it means that with billions of computers, each talking to each other, the network isn't so complex. And so there's this connect, talk, disconnect. Connect, talk, disconnect. And it's the way the phone system in our world scales to all the people, and it's the way the internet scales to all the people that want to use that internet. So this is made inside of software using an abstraction or library called sockets. And sockets really are computer phone calls. You know where you're going to call. You can start the call, wait for them to answer. Once they answer, there is a two-way communication. It's kind of like a file, except that you can simultaneously read from the file and write from the file. Although it's important for the two cooperating pieces of software to know who's going to read first and who's going to write first, because it's like, if when you pick the phone up after it rings, we all know to say, hello. And that's kind of a protocol. Who talks first is a protocol. And then the person goes like, who is this? And then eventually conversations happen pretty naturally. Somebody talks, listens, someone else talks, listens, and that works. But there's complicated protocols. And you can think of this not necessarily as the browser on your laptop or phone as talking to data on the server. It actually is talking to another program. And so even when it's just retrieving a file, it's talking to an application on that server, and that application is reading the file and sending it out. And we'll see that eventually, how we have to do that when we're doing things like uploading pictures. We upload pictures, and then we have to actually serve them back out. We can't just say, oh, the pictures are there, you can grab them. Because sometimes not everyone can see every picture. And so part of the software application decides, if you are allowed to see this picture, I will send it. If you're not allowed to see the picture, I will not send it. And so that's where it's a piece of software that you're talking, even if you're looking at a picture. Sometimes that software is really simple, and you barely notice it. But there is software in the loop. It's not like you just go straight to data. It is really two pieces of computer software talking to each other, and we use the internet as that intermediary to allow that conversation to happen. So if you read my book about the TCP/IP, you'll learn this in super great detail. But every computer has an IP address. It is a number. There are two kinds of addresses. There's IPv4 and IPv6. IPv4 version 4 is the one that's got 4 dotted numbers, like 142.16.42.14. But within each of those, they have what's called a TCP port number. And because this whole internet thing is applications talking to applications, we need to have a good way to know which application we're talking to. And that's where TCP port numbers come in. And you can think of this as like a phone extension. So you have a phone number, and then you have, extension 1436. And so TCP port numbers are like that. So we can not have a specific address for every application, but an application that has an address and a port within that address, or a phone number and an extension within that phone number. And so you can look these things up. Port 25 is used for email, server-to-server communication. In the old days, we used this thing called Telnet. We'll talk about that on port 23. And so the client is on the right-hand side, and it might be a computer where you've got a keyboard and it's you, or it might be a server that's got some mail that's being forwarded from somewhere, and they all talk and they connect to an IP address. In this case, 74.208.28.177 is the IP address of this computer, and then port 25 is the extension where one computer sends email to another computer. And each of the arrows in between them is a separate protocol. So if you're talking to an email server, you expect to talk an email protocol. And if you're talking to a login server, you have a login protocol. That's kind of the simplest one. Or a web server, Web server can be on port 80 if it's unsecure. Preferred, of course, is HTTPS, which is on port 443. If you have a mail application like, say, Thunderbird that's reading Gmail, it talks to ports 109 or 110 or a couple of other ones that are ways for a mailbox application to talk a protocol to a server-based mailbox to retrieve the new messages or delete a message or view a message or whatever. So there are these ports on servers that have protocols, and then we can build software on our clients that talk these protocols. The one we're going to be playing with the most in development mode is port 80, and in production mode, port 443 for the HTTP for web documents, basically, and web application documents. So up next, we're going to take a quick look at the Hypertext Transfer Protocol. I always want to call it Hypertext Transport Protocol, HTTP, and that is the protocol that we talk to port 80 or port 4. Hypertext Transfer Protocol is the protocol that browsers use to talk to servers. Now, we've used it for all kinds of other things because it turns out that it's a super simple and super elegant protocol. This goes to a long time ago. This protocol was invented in 1990, which is like going on 30 years ago. Yeah, going on 30 years ago now or more. And there were many protocols. You would have one piece of software, and there was server software and client software. You had to match them up, and then you talk to the right port with this server software. And one of the inventions of Tim Berners-Lee and Robert Cailliau at CERN was that we came up with this notion of, instead of lots of pieces of software, we would have one piece of software called a web browser, and it would be multi-protocol. And so we have this thing called the URL, or Uniform Resource Locator, and we just sling these around. We just use them. But these things, this was itself an amazing innovation in 1990, because in the old days it'd be like, use this piece of software and talk to this address. So the URL captured three really important, very separate things. The first thing it did is it allowed for multiple protocols. Now, the one that you mostly have seen is HTTP or HTTPS, but that's a protocol. FTP colon or mail2 colon might be the other ones that you've seen. And then a host, and then a document. And that host is a domain name, which is a nice symbolic way to get a server address. And that eventually resolves to an IP address like 141.206.14.22 or something. And then the document within that server, and that /page1.htm is the document in the server. And I'm just saying, before 1990, there were many protocols and we did many things. But after 1990, this one protocol, HTTP, found its way into so many awesome solutions that it's by far, other than email, the dominant protocol that we use on the internet. Like I said, it was invented at CERN by Tim Berners-Lee and Robert Cailliau to retrieve documents and images. And as soon as they built it, because it was all the other protocols that came, most of the other protocols were kind of complex, because we're computer scientists and we make complex things and we love complex things, and we're very, very good at complex things. But this was, when the web was being built, Tim and Robert were not like, we're going to make the greatest thing ever. We're just going to make a simple thing. So they made a simple thing, but it turned out to be the greatest thing ever, because different engineers would be like, oh, wow, I can use that a little different way. And it was, the grounding of it was super simple. And the basic concept was, you connect to a server, you figure out where it is, you send a single command with a bit of extra data, and then you get back something, a document. It could be an image, it could be data, it could be HTML. And it was really amazing, right? And so the sockets, the underlying sockets, are the things that make the phone call. HTTP is what we do once this phone call has been established. So one of the things that made the internet so successful starting in the 1960s was a radical openness, we're all around the same campfire feeling, very friendly, respectful, that still allowed criticism. There wasn't like one super genius that designed this or one company that designed this. This was a collaboration. And the collaboration was around a set of open standards and meetings to help build these standards. And they were called RFCs. They were called Request for Comments. And there was a group that built these called the Internet Engineering Task Force, the IETF. And The request for comments is a fun notion. We're looking here at a September 1981 document, which is 40 years old about now, and it's called a request for comments. And the idea is, as engineers, we might have a design that everyone thinks is the greatest thing ever, but we should always question. No design is perfect. No design is beyond question. No design is beyond commentary. And so even when they're 40 years old and used worldwide and dang amazing, we still say there is room for improvement. And so this talks about, I think this one's IP, and there's an IPv6. There's another one if you look for this RFC that we're looking at here, there'd be IPv6, and you'd start reading it. And it's pretty dense reading, but as an engineer, it gives you all the details to build a router or build a piece of software or build whatever. And these are 100% public documents. And the idea is that no company, because literally the companies that were around in 1960, if they had said Burroughs or Sperry owns the internet or Digital Equipment owns the internet, they're all out of business because they didn't make good choices, but the market was able to make good choices. And because the commons were these open standards and open specifications, new companies like Sun Microsystems and new operating systems like Linux could come in, and even Windows could come in and participate as full participants because they just read these specs and all of a sudden they're interoperating with everybody else. This is fundamental and foundational to how the internet works. And I'm not saying you're supposed to go read them, but it's just fascinating to understand that the entire technological infrastructure upon which the internet is built is free, license-free, royalty-free, and you could build a brand new gadget and you could hook it to the internet by reading these specifications. You don't have to pay a developer's license or nothing. It's cool. Sorry, I'm just a little bit too excited about that. So let's take a look at one of these in particular. Now this is probably supplanted, but we'll look at RFC 2616. They go up in numbers, and so this is HTTP, Hypertext Transfer Protocol. And if you wanted to build a web browser or a web server, you could read this document. Go ahead, read the document. And if you read down far enough, you'll say, oh, this is how you make a request. Blah, blah, blah. It's got a header, and it's got like a carriage return line feed, and then a message body, and you got to do this, and this is what it looks like. This is how it works, right? And so at some point, you're deep in this document, and you're finding out in this page right here of this document how your browser is supposed to format it. And this tells both the client and the server what the rules of the protocol are. Now, it's a lot easier for me to tell you. So you connect to the server on a socket, usually port 80 or port 443, and then the client is supposed to make the first sound. It makes first request. It sends a line with a carriage return line feed at the end that has the characters. There's other ones, but get, G-E-T, space, a URL, space, and then a protocol. And right now I'm using this HTTP 1.0 because I can do it by hand, right? And so you ask for a document, and then you can optionally send some header information, things like what language this person at this browser prefers, what are the capabilities of this browser, what version browser we have. So there's a series of things. You say, give me this document, and here's something about the browser that's requesting the document, including information like cookies that are being said. Now, so this, in case you want to know who is doing this request because you've logged somebody in and set a cookie to indicate that they're logged in, that's all sent on this GET request. But we'll not send the headers. There's actually incoming headers and then outgoing headers. We'll see these when we start looking at Firefox's debugging console. And so this is an entire interaction that you can do on your laptop. Now, I'm not going to do it for you, but I would note that the program Telnet that this uses has been removed from most computers. It makes me sad. They think of it as a security hole because it doesn't use encrypted connections. Like port 80 is not an encrypted connection. But ultimately, you can install, go search on your favorite search engine and find out how to install Telnet. But if you get in a command line, whether it's a Windows command line or a Mac command line or a Linux command line, and you get Telnet properly installed, you can type the following command: telnet datapr4e.org 80, and then hit enter. And at that point, so Telnet originally was used to log into computers, but if the server we're talking to and the protocol that we're talking to is simple enough, and in this case HTTP1 is simple enough for us to be able to do this, we're actually talking to the server, because remember I said that these are applications. Your browser is not talking to files. Your browser is talking to an application on a server, and the server might give you back a file. So it's really talking to a piece of software, and we'll see this in more detail in the next section. And so what will happen is, because the HTTP protocol requires that the client speak first, we have to type. Now, if you can get this working and type wrong things, and type a couple enters, new lines, you will see that you're talking to a piece of software, and it will say, "You have violated my protocol." You're not talking to a thing that has any online help or user interface or anything like that. You're talking to a server, and your job is to request some data using the proper format because you read the specifications about the proper format, right? So in this particular one, it's easier to cut and paste this, because some of these servers, if you don't type fast enough, they'll be like, "You're not a software, you're a human, quit playing with me." Like you talk to Facebook or something, and you can talk to Facebook and see what happens on port 80, and it will time you out really fast. So it's good to have a cut and paste buffer. So you paste this get command in, and the other thing that's important is you got to put an extra blank line. And this extra blank line is to indicate that you're not going to send any of those headers. If we were going to send things like what language we would prefer or what formats we would prefer as a browser, the browser has certain languages and other configurations and login information, and that can get sent up to the web server along with the request for the document. And we would be able to type them in here. But we're not going to do that in this very simple. We're just going to say enter, which means no more headers. If you were putting in headers, you type header, 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 and then enter on a blank line, and then the server would know that our request was finished. But we can just ask for a page, and then what the server does is it sends us back two pieces of information. First, it sends us headers. The first header is HTTP 1.1 200 OK. That's actually a status line. Now, you'd have to go read the documentation on what that works. But for example, 200 means that you got a document. Another one that you might have seen is 404. It might say 404 not found. So if you go to a web page and it doesn't exist, something will say 404 in your browser, usually, unless it says, "Here's a search box, go find it." But there's a status, and so the thing that you're typing, page1.htm, may or may not be on this server. If it is, then you'll get a 200 OK and the data, or you'll get a 404 not found. And then we get some response data, some header response. And this header response looks pretty much like the same format of the data we would have sent into the browser if we were sending things like that in there. Here it's what the date is, what the server we're using, last modified. And one of the important things is what kind of content are you about to see. Content type, in this case, is text/HTML, which means the thing coming next. And then there's a blank line. And the blank line is our indication as we're reading this data that we've finished the header, which is really metadata about the page we're retrieving, and the actual page itself. And so the rest of this page is the actual data, and we know the format of it because we were told before the page starts. This could be image/PNG. This could be XML, application/XML. Then it could be JSON. It could be like anything. And then the browser is supposed to, and if this was an image, it would be like garble, 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 right? It would be all garbled stuff that we can't really see, but the browser knows what a PNG or JPEG looks like, and it shows it to you. And it basically uses this text/HTML to tell you what's going on. And so then your browser has read all this information. It has both the metadata and the data about the retrieved page, and then its job is to sort of produce a pretty rendered version of the page and show it to you. And that is the request response cycle. Again, you don't have to do this. You can just sort of believe that it's done here. But if you want to install Telnet on your system, it's not a bad thing to install Telnet. It's kind of a classic, fun thing. It's far less useful than it was in the early days because we used to use Telnet to test everything. Now we've got like browser developer consoles that are way easier than Telnet. But It's kind of a cool thing. Feel free to do this, and you'll be like, I know what's really going on. And so I'm a big fan of using the console, of using the terminal, of using text-based interfaces. I think they're actually way more accessible. I think it's awesome. And in a way, all these fancy graphical user interfaces distract us from the simplicity of what's going on inside of computers, because you think, well, where's the button? And the answer is, oh, there's probably some command inside this computer that does what the button does. So I have a former student of mine who actually wrote the scene in, I think, maybe it was Matrix 2. I think this was Matrix 2. Yeah, Matrix Reloaded. And this scene where Trinity is breaking into the power grid and she is using the console. And it turned out that the way this scene was written is it was written exactly as a hacker, whether that's a hacker with bad intent or good intent, because there are hackers with good intent who are trying to break into your system so they can tell you, you pay them to break into your system so that they can tell you your vulnerabilities. But you can take a look at the analysis of this little scene, and just this sort of is just one of the cool things about me teaching people about how to use the command line, and increasingly me teaching people about how to use Linux. I really think that it's okay to know your Mac and Windows command line, but really increasingly the world in the server world, and we're starting to work on web servers in this class, and you might as well start learning some Linux, because that's an important skill. Just writing some Java code or Ruby code or Django code, that's a skill, but knowing how to start the server, debug your application, find log files, etc. in the command line is really important in real production systems, because we're going to play in some simplified environments to make it a little easier, but those simplified environments go away once you go into real production in a real job. And so I'm really into teaching you Linux, command line, etc., etc. So up next, we're going to show you in Python, in effect, as few lines as I can possibly show you, how a browser works, how a browser sends the HTTP protocol, how a server reacts to the HTTP protocol and returns documents. So that's what's coming up next. So now we're going to build a very simple browser and server in Python. Okay, so import a library, import socket, and that, just like, import math or import whatever, that pulls in a library into Python. Sockets are built into Python. It's very cool, and it's very, very simple. So sockets kind of function like files, but they're files that we can send data to and receive data to. But when you're using a file in Python, you've got to first open it. And so the opening of a file, of a socket, is really a two-step process. First, you create the socket, and that socket sort of lives in your computer as an endpoint that's not yet finished. It's the endpoint that you're going to send and receive data to inside your computer. But then we have to actually make the phone call. So socket.socket, and don't worry too much about this syntax, we don't change it. Socket.socket basically says make a phone. That's what we're making. And then mysock.connect, that second line, is dial the phone. And we're dialing the phone to a domain name, data.pr4e.org, and a port in that domain name. So that is the call. Now, if we made a mistake, right, if we were dialing and not talking to the right server, or that server didn't exist, this connect would blow up, meaning we'd make a phone call, a data phone call to a server that doesn't exist. That line is what's going to blow up. But as you continue down to the next line, if it gets that far, now you put try and excepts around this if there was but I want to keep this really short, so I'm not putting in all the stuff, all the error checking. So connect might blow up. Socket.socket won't blow up, because it's like, unless you don't have networking at all in your computer, but it's unlikely these days. But mysock connect is like dial the phone, dial the data phone to this endpoint, and it includes the port 80 that we talked about before. And now we need to send a command. And in this command, it's exactly what we talked about before. It's exactly what we sent via telnet. It's a get, followed by a space, followed by our URL, followed by a space, followed by a protocol HTTP/1.0, and then we hit the enter. Now it turns out in network world, you actually hit two things. It's the /r/n is a return and a new line. And you have to hit it twice to enter at the beginning of the first line, and then remember we had to put that blank line in because to say no headers. Now we would put in between here, we'd put all our headers in there if we were going to do that, but we're not going to do that. And then you have to use encode, and encode means that the data sent across the internet is generally sent in what's called UTF-8. Inside of Python, the data is in Unicode, so that you can put literally any character in a Python string, and then preparing it to send it out across the internet, we kind of encode it into the more dense more compressed UTF-8 format, rather than we don't send strings across the internet in Unicode in general. I mean, it's very rare, but you'd have to control both ends. We want to send them in UTF-8, and so the string get blah blah blah, that's in the Unicode string in Python, and .encode says convert this into a UTF-8 string, and so command cmd is a variable that has a UTF-8 string in it. And then we say send. Now remember I said that you can simultaneously send and receive on these sockets, but the protocol tells us whether the first thing we're supposed to do is listen or talk. And we're the browser in this case, and so we're supposed to talk first. So we send the request out, and that's just like you typed it in Telnet, because in effect you're scripting Telnet. Telnet, we liked Telnet in the old days because it was kind of like a socket. I could connect to any host, any port, and type things and see if it's broken or not. And then the protocol says once the server has received the first line, any headers, and then the blank line, then it's to return it. So then the next part of this is we're going to have a little loop. So the protocol tells us we are supposed to receive data until the socket's closed. And at the bottom of that telnet, you saw that it sent a bunch of lines, like 4, I think, and then it closed it. That's what's going on here. We are retrieving data, and then this receive, this actually waits. If the server is coming slow or the network is slow, this piece of Python will be sit. Oh, got a little bit, up to 512 characters. It will wait until it's gotten 512, or it's done and it's got 100 or so. But the receive is a blocking, waiting operation in Python. It says, give me up to the next 512 characters. Now, usually the network's so fast that the Python doesn't even wait because the operating system already has it. But we get it, and if we get no data whatsoever, that is our indication that the network connection, the socket has been hung up on, closed by the remote server, and away you go. So that's why we are going to break if the length of the data is less than 1. And if not, we're going to simply print out the data, but we're decoding it. And that's because the data that comes in is in UTF-8, but the print statement wants to print Unicode. And so decode says, here's a variable that has UTF-8 in it, convert it to Unicode for printing inside of Python. So because this data is externalized to us, we encode it before we send it, and we decode it when we receive it before we use it, because Python inside itself doesn't use UTF-8. Python inside itself uses Unicode, which is awesome and a whole separate conversation. I'm just kind of bringing that up to remind you how important it is, because we're not going to write much of this in Python, really, and all this stuff is taken care of for us in web servers when we get to that point. But it's just a good time to review Python's strings and Unicode and encode and decode, because it's really important. So if you run this and you've got it right, it runs pretty simply. Let's get the color back. Get back to yellow here. So if you run it in your system, Python socket1.py, all the work is done up here before you see your first output, and then all this output that you see is just this loop running. And what you see is really the exact headers that are coming from this server, and then you see a blank line, and then you see the actual page that's coming out. And you don't see it, but at the end here, the connection gets closed, and you break out, and you're done. And then we close our end of the socket. The far end was already closed. That's how we know to stop reading data. And then we hang ourselves up so that our local system does not end up with a bunch of half hung up phone calls. And so that's basically how we talk to a socket in Python. Now, that was literally 10 years ago how I would debug applications. I would like telnet or write a little thing like that and dump all the headers. And that got really tiring, really boring, really tiring. And so browser developer mode is going to be your friend. In a way, browser developer mode, and I'm going to have a separate video on this, browser developer mode lets you look at the sent headers, the received headers, the received data, the sent data, what URL it went to, and it's super awesome, especially because a lot of web pages have like 40 to 150 request response cycles. So you don't want to debug them all by hand. You just let the browser do its thing and say, what was that second one and what went wrong in the second one? I spend a lot of time when I'm debugging web applications using the developer mode, and that's why I have a special little video that gets you familiar with it. And I tell you, by the time you've done web stuff for a little while, you're going to know your browser developer mode. So next we're going to talk about writing code in the server to respond to these requests. So we build a browser in Python. It's time to build a web server in Python. So remember that what we've got here is we've got, the browser is an application, and we've made this a Python application now that sends this GET request. So we have effectively, like I said, built the world's simplest browser, and that sends a GET request. The server does something, and then it sends the response back. And now we're going to kind of change this, right? We're going to assume the browser exists, and it's like, okay, because we're going to be the server folks, right? So now we're going to look in greater detail at what goes on in the server. And so here is a very, very simple web server. It's a few more lines than the simplest web browser, because we have to put a little bit of error checking in with some tries and accepts. Okay, so let's walk through what this code does. Okay, let me change the color again to black. If you're from Microsoft and you can tell them to make a key to change the color on the scribbler, I'd greatly appreciate it. Oh, and then I went down a page too. Okay, so we're going to pull in some more stuff from the socket. We're going to pull in some stuff from the socket right here, and so we're going to make a function called create server that we're going to call right down here, and it's going to print out how you're supposed to access it and then start the server. Now the whole idea of the server is the server is woke up to wait for incoming connections. So the server already exists. So when you start talking to a web server, that server's in that computer already. The server software is already running, registering its interest in incoming request. So that's what we do. So when this Python program starts, it's going to sit there and wait in an infinite loop for incoming requests. So the first thing we do is we're going to make a socket. This looks very much like the time we made. It's an endpoint. It's not actually making the phone call. Remember I said this socket call is making the phone. So we're saying we're going to make a phone, and it's up to us later to decide if we're going to make a phone call or receive phone calls. And then this next thing is like the connect, except this is I am willing on port 90 to receive the phone calls. Now it turns out there's only one program on port 90 that can receive phone calls. So this might blow up. You might try to do this, port 9000. And if you run this twice, and you can do it in 2 windows on your computer, the second one will blow up and say, you can't have port 9000 because another piece of software has it. But as long as there's only one running, away you go. And that's part of this whole try except thing, because if you run this twice, it's going to blow up the second time, because you cannot receive phone calls on this server on port 9000 with 2 applications. One application gets the phone calls. That's what socket listen says. The 5 on there says, dear operating system, if I'm busy handling 1 phone call, you can hold on to 4 more and queue them, and then I'll come back and get them for you. And that you're asking the operating system to queue incoming calls. Don't just say you're busy, shut down. If you didn't say this, listen 5, if you were busy writing the data for phone call 1 and phone call 2 came in and you weren't ready for it right that instant, it would just deny the phone call. So that's what listen says is, dear operating system, hold those temporarily, I'll get back to you, which is how it works. And then what happens is we go into this accept. Now this accept is, I'm at the phone, I've registered what my number is and what my extension is, and I'm ready to pick the phone up. Let me know. So this accept is blocking. It stops and it just sits there, and it can sit there forever. It just literally forever. If nobody calls it, nothing happens. The next line never runs until you blow it up or the server goes down. So that's except is a blocking. And the reason we do this except, well, we have to establish the phone call first, right? So then this next line runs only when a phone call is received. So that means that we, on the browser side, we already connected, we made the phone call. Now we haven't sent any data yet, right? And so this is just now, at this point, somewhere out there, there's a piece of client software that has done a socket.connect, and we have done accept, and our accept has succeeded in the server, the connect has succeeded, and we are ready to talk. So the phone call has been made. Now the question is, who's going to say hello? And this is where the HTTP protocol solves our problem. The server knows that the client must speak first. So it just does a receive. Now you'll notice the receive and the send are the same function calls because it's a two-way thing. Whatever the browser is sending, the server is receiving, and whatever the server sends, the browser receives. And they can do it simultaneously if they can figure it out. But usually you kind of like say, it's your turn to listen and my turn to send, and then I'll listen. And usually they kind of go back and forth. In this, there's only one step. The server listens, gets the GET request, sends the data back. And so then we're going to read some data, and we're going to get 5,000 characters. We're going to get the whole thing. Remember, it's one line. It has a GET request in it. It has the optional parameters in it. And so we're going to split it. Now again, we've received it as UTF-8. We've got to decode it for UTF-16. Not UTF-16, Unicode inside of Python. And then we split it based on new lines because the GET request is on one line, then header, 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 and then the blank line to tell us that we're into the headers. And we're only going to take, in this, we're just going to look at that first line. We're not going to do anything with it. Most servers actually look at the line to figure out what document to send. It's a very simple server. It sends the same document no matter what the URL is. All we do with the URL is we print it out to prove that we got it. And then we construct a response. And in this response, again, go back to RFC 2616 and it will tell you what this response is supposed to look like. It sends back a 200 OK. Remember, this is all the stuff we saw. Probably I cut and pasted it from a working thing. We tell it that we're sending it back in content type text HTML, the character set UTF-8. Remember I was telling you that. A blank line, and then some HTML. HTML body, hello world body. And I'm throwing in these /r/n's, which is the network's version of new lines. And then you will notice that I encode it before I send it because it's Unicode inside of Python and it needs to be sent as UTF-8 because the phone, when you're in a socket, the thing that's going across the socket almost always is supposed to be UTF-8. So we encode it. And then because the protocol says so, as soon as we send the data, we close the connection. Now remember that the client had to close the connection too. So we close it, it's half closed, and then the client gets all of its data, gets the indication that it closed, knows it's finished all the data, and then the client shuts its side down. And so there are two hangups. It's kind of like a phone call. The person hangs up, and then click, you hang up. Now you can't really keep talking, but you do want to have both sides hang up, and that shutdown is what's going on. And then the rest of this is all try except for various things. So we clean up our socket so we don't have to restart our server when our software blows up. And so the rest of it's pretty simple. And then, so this while one, the first browser will talk and then it'll send some data and then it'll go back and wait for the next phone call. And that's what's going on. The next phone call comes in, it sees a GET request, it sends the data back, then goes and waits for another phone call. So this is an infinite loop that sits and waits for incoming phone calls, and it answers the same thing. So it's like you call this phone number and it goes, and you go, I would like a pizza. And it says, hello world, and then click, and then you call it up and say, I would like a car. And it says, hello world, click. And then you say, I would like to register for this class. And it says, hello world, click. So this is not a very flexible server. You will build far more flexible servers. But it's the one I could build and fit on a single page in a slide deck. So to run this, if you you download this code, and it's a tiny bit of code, and you run it. So you go somewhere, maybe your laptop, maybe Python Anywhere. I don't know if it works on Python. It probably doesn't work on Python Anywhere because you can't actually talk to ports. But let's just run this on your laptop, and you start the server up somewhere. Get a hold of my sample code, or download it from here, server.py, and it's telling you this is just output from the server. And this is the moment at which it's waiting, right? It's waiting. The server could wait for hours at this point. But I just give you this in a print statement so you can copy that and put it into your browser. So you paste localhost 9000 into your browser, and then the server is printing that it got a GET request for the / document from this browser. That's what the browser send. I mean, we're talking from Firefox browser to the little web server that we just built. Now there's a second GET request that you don't even know because you didn't ask for it, and that's because the browser is built in to ask for a URL called favicon.ico so that it can make an icon, and that icon ends up in the tab or wherever in your browser. And so that's like an icon for the website. So you didn't ask the browser to do this, but it's a thing browsers do. And you'll see when you're looking at your debug logs when you're building stuff that it's a favicon. And so this happens like blink blink, and now it's waiting again, right? And you could hit refresh, or you could go start a different browser, and you would see these GET requests. Every GET request you're going to see in your browser and your server. So it's working, and it works really well, and you're welcome to go ahead and play with it and try it all out. So now what we're going to do is build a simple web client, and that'll talk to our server. So the other web client we made, talk to data.pr4e.org, this one is going to talk to yourself. So it almost looks identical, right? We're going to make a phone. We're making a phone. We're going to connect to localhost 127.0.0.1 is the IPv4 connection, what's called loopback, right to the same host. We're talking to port 9000 because that's where we've got our web server running, that little web server we just wrote. And then we're going to send a GET request, a valid GET request to this thing, HTTP10, and then 2 new lines, and we're going to encode it into UTF-8 before we send it. Then we send it, and then we just have a loop that prints it all out, and then when the socket gets closed, we hit a break, and then we close our end of the socket. So the server clicks the phone, and then we're done with our data, but we've already printed it out, and then we hang up the phone on our end to kind of clean everything up all the way in between everything else. So this is a very simple web client. And so now you can run the web server, right, just like we did before. And instead of talking in a browser, we run this client. And this client gets a header of HTTP1 OK, its content type HTML, it gets a new line, and then the body, and we're done. Now, I mean, it's not a browser, but it is a client that's talking HTTP. And so now you'll notice that this server sort of sits and waits for incoming calls. You could run this over and over on the client, run the client over and over again, right? And then you would see more requests. But in general, the server is destined to just sit and wait for hours potentially until a client connects to it. And then at some point, you'll just abort this server. And then if you Control-C or blow this up somehow, this will fail. The client will fail, and it will fail. It will fail in this connect code. So if you want to play with it, try to run this client without running the server, and you'll see that the connect, which is the part of actually making the phone call, this will continue to work, which is make me a phone on my current computer, and then connect is make a call to the remote computer. That will blow up. And then if you wanted to play with this, you could put some try and accepts around it, say remote computer is not responding on port 9000. That's if you blew up. You could put a try and accept around that. But I'm not doing it because it don't fit on my slides. So here is an even simpler web client that we can use. And again, you can get this code from my sample code. We don't talk to this. There's a higher level thing that the previous client talked to sockets, so I could show you the low level. But because we spend so much time talking about to URLs, we then have a URL lib. So I'm just going to use URL lib. And this could be a local host or it could be whatever. I'm just going to make a 4-line URL lib call. And so I just do a URL open of that same URL. Now we're operating at the HTTP level because URL, the concept of URL is not a socket concept. The concept of URL is HTTP concept. And we just get, in effect, what looks like a file handle to us, and we loop through it and print it all out. So we run our server, and the server sort of says this and waits. And then when we run our client, it basically hits our server, and we can see in the server window. You got to do these two things in two windows, right? You got to do these things in two separate windows. So in the server window, it'll sit and wait, and then in the client window, when it runs, you'll see the client will make the request to the server, or blow up if the server is not running. And the server will see the GET request, and then the data will come back to the client. So you sort of do this in two things, and you can run the client over and over and over again, and you'll see every time you run the client, the server sees it, responds, and away you go. And again, our server always says hello world no matter what, which is delightful and classic. It's a classic. So you actually can watch when you're running Django. There will be a way for you to see when you're running Django locally and you start the server up. This managed we'll do this later, managed pi.run server, and then you talk to it and you will see all the GET requests. And so Django, when you run it locally, you can debug a lot of what's going on. So you can see like the favicon that it's asking for, and that is 5 or 6 HTTP requests to produce that little Django web page. And so that will be something that you will learn how to do. And so that sums up what we're doing in this. At the beginning, you look at it very simply. Pretty soon, you'll just be looking at the developer console, and it'll all make sense to you. I want you to be able to know that you can dig as deep as you want to and understand all of these protocols that are going back and forth. Okay? Cheers. Hello, and welcome to another walkthrough for Django for Everybody. In this walkthrough, we're going to talk about the browser debugger console. And so this is something that in the old days was only in Firefox, but eventually everybody built it in, and you used to have to build a plugin. And it shows up at different places. And so in Firefox, it's here under Tools. It turns out that you can kind of go to any of these things because these are they're just different tabs here. In Chrome, we do View, Developer, JavaScript Console, and then you see a similar kind of thing here, right? So I'm going to do it in Firefox here. And so you can see things like you can see the document object model, you can see the JavaScript console. This little error hardly matters. It's because it's such a simple page. You can actually debug JavaScript code. You can watch the network. You can play with CSS, etc., etc., etc. Performance cookies are in here. So there's a lot of things that you can do. I'm going to start and show you right now. We're at the very beginning class. I'm just going to show you some of the most basic things here. I'm going to clear this out and then refresh the page. And so what you see here is you see each request response cycle, right? And so I came up here as if I type this. Let me clear it again so you see it. I'm going to type this. I'm going to press enter. And that tells the browser to go retrieve this page. So it connects to the server, www.drchuck.com, and gets the document page1.htm. This favicon.ico, that's basically getting this little favicon right here. That's the little thing that shows up in the tab bar. And so websites can have a file, and later we will actually make a favicon. But what I want to show you from a request response cycle is you can see some detail here. So let's go up here, and you can see detail. You can see that this was the URL. We sent a request, a GET request. We got back a status code. The status is the first thing. 200 isn't okay. 404 is not found. And we used HTTP version 1.1. The request headers, they always show you the request headers, response headers first. So these request headers are actually part of the HTTP protocol where we are telling things like what my preferred language is. what kind of documents we can handle, you know, and cookies that we're sending back in. We'll learn more about all of this stuff. And so this is actually when the browser makes the connection to port 80, sends the GET request to the URL it's interested in, get http www.drchuck.com/page1.html space http 1.1. And then after it sends these. And this is pretty much the format, except colon, blah, blah, blah. And so that is and then it sends an empty line, and then it's done. And then the browser sends back first a set of headers. You know, what the content type is very important. The size is sometimes in here. gzip means that it compressed it on the way. And so these are the response headers. And so if I go to an error page, not a page.htm, so now I'm going to clear this. And what's happening here is it's putting up a page from my hosting system. But the most important one here is this, and that is the 404 error. And so it was going and it sent a GET request to http://drchuck.com, not a page.htm, and it got back a 404 not found. So that was that 404 not found is a different status code that said this is a thing that's not there. 500 means the server had an error, and we'll talk about all these codes. But the point is you can debug all this stuff quite nicely. So let me go back to page1.htm. So let's clear this and refresh it to make sure we got it all right. Okay, so we grabbed the page, and now I can, another thing that you probably by now have figured out to be able to do is inspect element. So now you're actually looking at this document object model, right? And so this document object model is not necessarily the code that came back from the server. If I go here to network and I click on get and I look at the response, this is the response down here. This is what actually came back from the server. And then the browser parses this and turns it into what's called the document object model. So this is the source. Now, just as for fun here, you'll notice that I can change the document object model here, right? If you are cool, you can switch to the second page. So you'll notice the document object model changed, and what I saw up here changed as well. And so this is like inspect element. I can do something like, I can even add here, I can add some CSS, style equals color :red semicolon. And if all goes well, there you go. You see I switched the color. This is the document object model. Now the server was completely uninvolved in that. And later we're going to write a lot of code to mess with the document object model. So the server is still, it doesn't have the red in here. It didn't change this to cool. So this is what we originally got from the server. And this is what we've got in the browser. And so once that page comes from the server, you or JavaScript can mess with that page. So it's pretty dang cool. Okay, so now I'm going to clear it, and I'm just going to click on the second page, which is an anchor. Let's inspect it. Well, it's an anchor tag, and so it's going to do another GET request. And so this time it went and grabbed page 2, and there's the second page. And you can go back to the first page. And so there's a lot of things that you can see. This persist logs is an important feature. That means that it keeps them across more than one request, and disable cache means that sometimes the browser wants to keep a copy of something, and you, while you're debugging, you want to say, hey, go get the original every time. And so this, right now I'm starting you on very simple pages, but if you take a more complex page, and I can never remember where it is, view, developer, network, let's go here. If you take a more complex page with a bunch of things in it, and you hit refresh on this page, you will see that it does a GET request, but then as it parses that GET request, it finds things like all kinds of stuff, right? So here, this took 44 response cycles, 1.6 megabytes, and it took almost 1 second to download all that stuff, right? It took a second to download it. And so if you scroll all the way up to the top, the original GET request was to this URL, which is /lessons/rrc, which is the URL. But then if you were to look at the response, And I don't want to see that. I want to see the actual HTML. So if you look at the response, you see all these URLs for more stuff, some CSS or from JavaScript, some who knows what. And so then what you see is you see it then retrieving all these other things that it needs to actually construct the page. Some CSS, grabbed a font, it grabbed jQuery, it grabbed time ago. That's a little thing like, and it grabbed a bunch of JavaScript and fonts and this, and then the translate. So you see this little translate thing? It's doing that. And so you'll see that's how it quickly builds up to about 44 request response cycles to produce a page. Now, so that's just my quick introduction to this. You may not see these little drop downs like this. You might have to turn them on in preferences. So you go into preferences somewhere. I turned them on a long time ago. I probably couldn't even find it, but you might see it. The other thing that I would suggest is don't use Safari, because Safari's trying to hide too much stuff. Like it doesn't even show you the URL unless you click on it. So Safari's kind of a pain in the neck. And so I would suggest that for this class, you either use Firefox or you use Chrome in addition to using Safari. Safari is fine for daily use, but I just find it as a debugger, it's bad, which is really sad for Safari. They made Safari unfriendly to software developers, which means we're not going to test our stuff on Safari, which means if it breaks, too bad. Okay, well, enough of that little Safari diatribe. Again, I hope that you found this walkthrough for Django for Everybody, as usual, helpful. Cheers. Hello, and welcome to this lecture on the structure of a Django application. It's a little early to be going through all the detail, and there'll be some things that we're not really going to understand until a little bit later in the course. But I wanted to sort of show you the lay of the land so that as we add features, you realize that there's sort of a method to the madness. And so Django is a way of building web applications. Django has a pattern within itself that it organizes folders in a certain way and puts files in certain places. And we're going to build these projects and applications, and you're like, why are these things organized the way they are? Well, it has to do with the fact that if you go from one Django project to another Django project, you can fit right in and understand how things are going to work. So the important terminology that's, a bit frustrating is there is projects and applications. And from Django has this notion of you have applications, and you might have a project, which is really basically a website, and then some applications. But if you had two projects, you could share applications between them. And so it's one or more applications per project, with the ability to potentially reuse a application across multiple projects. And so we're going to work with my DJ4E samples, which I hope you have downloaded somewhere, at least so that you can look at the files, look at the folders, look at the names of the files, and look at the contents of the files. This will all make more sense when you get a little farther down the road. So here is an ls statement, ls-l, DJ4E samples, and hello. This is within the folder DJ4E samples. There are two basic folders. One is, in effect, the project-wide settings, which is the same name as the folder that we're in. So it's DJ4E samples / DJ4E samples. And then there's the first application, which is hello. And there's a couple things here, like the __ init.py. You'll notice it's an empty file. It's just some bookkeeping that helps Python know that there are files that contain classes and objects in here. Settings.py and urls.py and wgsi.py is kind of like the traffic cop for this entire application that routes things coming in to the right, this entire project that routes things to the right application. And then within the application we have some files. And you really are going to learn a lot about object-oriented programming because all these files contain objects. So Django is a large piece of software, and you change its behavior by defining objects that accomplish things and then in effect registering those objects. So a common thing will be to take something like admin.py or models.py, create a data model, and then tell the admin user interface that you didn't write how to show your model, and so you write stuff in admin.py to communicate into the admin user interface how your data model that Django currently knows nothing about is supposed to be shown, et cetera, et cetera. And so there's a lot of files, and we will talk through these files. Now, this is an example of a request response. It's a web application, and so what we'll talk about is once a request makes it into the server, it's going to do some work and then produce a response. But in that, we're going to look at all of the work that goes back and forth. And there's effectively like a routing step where it picks what part of your application to route this request to. There is a view part, which is going to receive it and potentially store data. Some would call that the model. The storing of the data is certainly the model, but the receiving of the possibly new input data, like you're going to create a new thing, that would be the model. And then the view, at some point you got to finish it and send something back out, and that's the purpose of the view. We call this pattern for building web applications, model view controller. And it's not like you can't build applications any other way. It's just by saying, it's a terminology that I can say going forward, that's the model, that's the view, and that's a controller function. And you don't have to know it right now, but these are words that they're loaded and have valuable meaning to us to be able to do. So at some point in this picture on the left side, we have a browser. DOM stands for the Document Object Model. And at some point, the person clicks somewhere in the current web page they're looking at, and the web browser intercepts that and says, oh, okay, I've got your click right here. The web browser intercepts it and then makes a socket connection across the internet, which we've seen before, and then does a GET request. And that is what then goes into the server. And so the three functions are the routing, the views, and the models. And there is an overall configuration file, the settings.py, which is sort of how you just say, oh, here's my view files, read these view files, read these model files. So the settings.py kind of controls everything. But when a request first comes in, it consults urls.py, and then for the project, and then it will include urls.pys from each of the applications. So once it's chosen what view to run, it looks at the URL, pulls out the pieces of the URL, and finds the views in views.py. That's a Python file that has the destinations for these incoming URLs. There's a file called forms.py, which we'll see later, that is used to make the forms aspect, the part that you fill in, as pretty as possible. And then we take the resulting data that we're going to send back and we merge that in through what's called a template. And then if there's any data that we need stored, we call the model and we store that in a database. And there's this file called model.py, which informs how we store data in the database. And then when that's all done, we read potentially new data from the database, merge that into a template, and then send a response back to the browser, and then that response is all shown to the end user. And so that really is the request into the server through a Django application, pulling data from various places, merging a template back in, and then sending a response back to the application. So up next, we're going to talk about virtual hosting. Now, in general, you're not going to have to worry about this. It just kind of explains how something like Python Anywhere is able to manage a whole lot of domains on a single system.
Hello, and welcome to another walkthrough for Django for Everybody. Today, I'm going to actually sort of fast forward a little bit into the future and talk a little bit about how the auto grader works. So I'm going to go about to the middle of the course and show you an application that you're going to be working on called the Autos CRUD application. And Autos CRUD is kind of our destination. The idea is that it's got to create, update, and delete. And it talks about login, etc., etc. And so I'll take a look at the assignment for this. And it tells you how to log into this. You're going to have to make your own account. And this is your assignment, and there's a lot to this assignment. I want to point out to you that one of the things that we always encourage you to do before you submit to the auto grader is to do your own testing. Okay? And so let's just do some testing here. Let's run this program, this sample implementation. I'm going to It's going to log in, add a make, add an auto, view the makes. All right, so I'm going to log in, DJ4eCrud, and there's a password there. And so we'll go to the autos one. Let's add a make. So we're going to do a Dodge. Let's add the make. So we're kind of running through this manual test. Then add an auto selecting the make. Add an auto Eon 1, 1, 2, 3, 4. Some comments. Pick the make Dodge. And this is code. It can break, right? You know, view the makes. Update the make and press cancel. Update the make and press cancel. It should go back to the list. So what I've given you on a lot of these more complex assignments is an outline of things that you should test, right? And then if you update this and you I'm going to update the makes. I got to view the makes. I got to update the make. I'm going to say Dodge exclamation point and submit it, and you'll notice that this changed automatically because of third normal form and all that stuff. And so you're supposed to write this code and then submit this to the autograder. So the way the autograder works is you're going to submit it. So you're going to get your homework all done and you're going to test it, and then you are going to submit it to the autograder. And then and you'll say evaluate. Now one thing you'll notice is this takes a little while, and that's because this is doing a whole bunch of request response cycles. So let me just show you. Well, I mean, and if it's good, it tells you I like what you I like this, I like this, I like this, I like that, I like that, and then it figures out your score. And you can see the pages that it's actually retrieving by looking at this show hide retrieve page. So let me just kind of show you a little picture of what's going on. So normally you're sitting here and you got your browser and you're using Python Anywhere and you're writing code and you're testing code, right? You're testing the code in the browser just like I was doing here. I'm just me in my browser and I'm doing stuff and I'm working in Python Anywhere, right? And so let's go ahead and make a console in Python Anywhere, and I'll say work on Django 3. Because I always say that. Oops, work on Django 3. And I'm going to go into CD Django projects, CD CRUD. And so here's my code for CRUD, right? That's the code that I've got for CRUD. You might be doing this with your full screen editor, but I am basically at this point, I am working up here where I'm in my browser and I'm working on Python Anywhere and I'm making changes. And I'm testing those changes in another tab, right? So the code that I'm running, right, is running right here. So let me just make a little mistake here. Autos urls.py, and let's just break both the update and the delete. I'm commenting these paths out. And then I'm going to go to my web tab. Oops. Click web, open a new tab, and I got to reload. So I'm going to reload CRUD. I'm going to reload CRUD. So I just messed my code up, right? So you can see, so the code is mostly working, right? But when I click the update, like add a make, it's going to work, right? I can make a forward, that part's working. But as soon as I hit this update button, oh wait, what happened? No. Oh no, it's the makes that I broke, sorry. I broke the makes. Now when I update this one, it's going to blow up. Okay, so I almost didn't, I meant to break it. So what'll happen here is I'm breaking it. I'm talking up here to the system. If I go and I run this in the autograder now, this dj4e.com is going to make requests to Python Anywhere and get answers back. And sometimes it likes the pages that it gets and sometimes it doesn't. The safest thing to do is test it by hand. But now if I go back to the autograder, I mean, I saw this error, and what I should do is fix the error. But now I'm going to go to the autograder, and I'm going to rerun the autograder. And again, this takes a while, and the longer the more steps the autograder is taking, the longer it's going to take. Sometimes it'll take about 20 seconds. So I think it's done. So now we can see it's doing good. It logged in, it added a make, it's deleting makes, it's doing something. And oh, look, here we go. Page may have errors. HTTP status 404. Did not find a form with a submit button. Now, you could just call your teaching assistant or me and say, what's wrong? Or you can click this button called Show and Hide Retrieve Page. And now it's saying, look, the autograder is looking at this page. This is the exact URL that it's looking at. You can even click and you can open that URL. You'll see it's exactly this URL, right? And so what you need to do is then you need to fix your application, right? Fix your application, which I'm going to do right now. I'm going to undo, oops, come back, undo, save that, and then I'm going to reload my application because I'm now going to fix it. Takes a moment. So now that I put those routes back in, this update will work, right? Now that code works. And if I run the autograder, because I got this thing to rerun the same test, you can redo it. So then it's running the test, running the test, and now it's done. So now it made it past. It's all green, it's all green, it's all green, and we got a good score. So the key thing is to get used to this idea that you should test your code, run through all the scenarios. When you run the autograder, it will take some time because it's actually doing all of the things. It's pretending to be a browser. djfree.com is pretending to be a browser in order to test your URL. And then at some point, if it has made it through all the tests it wants to do, then it sends the grade to the appropriate gradebook inside the learning management system. But the key thing is to get used to the idea that scroll to the bottom, look for what went wrong, and then see what it was that it was seeing. This particular one is working, and you can see it. And the autograder is not trying to trick you, and it's not trying to mislead you. The autograder is as best I can do it, telling you everything it's doing, everything it's looking for, and when it can't find something, it shows you the page that it was looking at, and that page wasn't right. Okay, so you'll get used to the autograder. It's a good helper and a good friend. Make sure to look for the manual testing section in your assignments and do the manual tests. It will save you a lot of time, and it's just easier to fix your application by running your application yourself and then making changes to your application and then reloading your application, and away you go. So I hope this little summary of how the autograder works has been useful to you. Cheers. Hello and welcome to a demonstration for Django for everybody. This is to install Django on Python Anywhere. In a sense, we're going to just be getting started. This is a bit tricky because there's a tutorial on how to write your first Django application. There's a tutorial on how to set up django.org on Python Anywhere. And neither of these are exactly perfect. So what I've got is an assignment that sort of walks you through a series of things that lay down some necessary things for this class. And so the first thing we're going to do is you should have a Python Anywhere account. And you should be able to log in on the Python Anywhere account, and you should be able to get somewhere. So this is my Dr. Chuck. This is my account that I use to, to be a student on this. There's other accounts that I have for the production stuff, but this is one of my student accounts. And so the first thing you're going to do is you're going to use a console, and you're going to start a bash shell. So this is actually Linux, and I love Python Anywhere. I love the fact that we're learning Linux. Hopefully you'll just get a little more comfort with Linux as we go. But this is where you're going to do a lot of the command line of the system. So we're going to do make dir virtual environment. You might be able to make this Python 3.7 or Python 3.8. The later that Python is, the better. This is going to take a while because it's going to create what's called a virtual environment that allows you to have your own version of Python Your own set of installed Python libraries and virtual environments are a wonderful thing in Python, because then you don't have to ask the owner of this system, which is Python Anywhere, hey, could you upgrade to Python? Turns out you can upgrade to Python all by yourself. So we will sit and let this, oh, there we go. It ran right away. And ran right away. So let's go do the next thing. The next thing I know takes a long time. So the next step is to install Django. Now this is pip is installing software. So it's going to download a bunch of software, and then it's going to install that software, and it's installing it in our Django 3 environment, right? And so this is not installing it for the whole system. It's just installing it for us. And so you'll get used to the idea that you've got to work on the Django in your appropriate Django environment. We're using Django 3.0 in this situation. As the recording of this, Django 3.0.2 is out. Django 3 is quite nice. So we'll just sit and watch this for a while. So it's finished, and now we have it installed. Now there's a command that gets us into, this is redundant right now because we're already in it, but work on Django 3 and make sure that you're in it. Then the next thing to do is grab this command and make sure your Django version is right. If that says 3.02 or later, then life is good and you have your Django working. Now, I want to also have you install some of the sample code in the class. Let me get this started and explain what's going on. So this is GitHub, and this is code that I maintain, and I can update this code and I can send it to you. And so this is a lot of sample code. So if you go to DJ4E tab, I hit the tab key to do completion there. There is a bunch of files in here, and this is the kind of sample code that we're going to go through in the class. And so we need to add the requirements. Pip, again, is the dependency manager. There's a file requirements.txt that says, hey, we need a whole bunch of libraries. And so let's install those libraries. Now, in your first Python applications, you're not going to need all of these libraries, but I want to get them installed into your virtual environment early on so that as we go along, you're not going to add a feature like social authentication, which is this little application right there, like social authentication, and then oops, we had to install a thing. So I want to get all that stuff installed at the beginning. And this will take a little while, so we'll just pause for a bit. Okay, so that finished. And now what we want to do is run a command, manage.py check. You're going to run this command a lot. And this, we're in actually a Django application, and this Python manage py check reads through your files and these files that point to other files, looks for syntax errors, and it's a good way to check the sanity of your application, because if it won't pass this manage.py check, it's not going to start. We haven't even tried to start this application yet and put it up on the web. For now, we're doing that. So don't worry about this message. We'll get to that later. We can say Python 3 manage make migrations, and in this one it's going to say no change detected, and then we're going to run migrate, and that will create a bunch of database tables. Don't worry too much about that. So we've finished there. Now we're going to actually pick up in the Django application, but we're going to basically make a new Django. We're going to make a folder. So we're going to go back to our home directory. CD tilde says go back to home directory. And we're going to make a directory called Django projects. This is so you can have more than one of them. We're going to go into that directory, CD Django projects. And then we're going to start the project My Test Site. Now what this does is this actually created a whole bunch of files in My Test Site. Okay. Now we do have to edit one file. I'm going to edit this file. Now I have a whole thing on how to edit files on Python Anywhere. I'll do it the way you probably will do it. and that is use this files screen. Oops, I just have to go back and get my shell, dang it. Console, open like a new tab. You'll find that you'll want to have, go back to that console. So here I am. I want to edit some files, so I can go into Django projects, my site, and then settings.py is the file that it's telling me to edit. So it's just my site, my site. It's a little weird that the name is doubled. You got to go down to around line 28 and say add quote star quote. And that has to do with protecting what systems can talk to this web server, and we're just going to say anybody can do it. Do not set this default. Forget this warning. It's a lie. We are not in production, we are in development. So then we have to say save. So then we'll save our file. Okay, so let's go back. We had to do that. Here's different ways of editing the file. You could use nano on the command line, that's cool. I just use this #1 way to do that. VI is really cool, but we won't do that. Okay, so now we need to convince Python Anywhere to run the application. Okay, and so that is under another tab. That is under, and I'm going to open this in a new tab. So now I have these files. Actually, I don't need this tab anymore. I have my, oh, I should oops. I should say Python 3 manage.py check here just to kind of be creative. Yeah, that's good. So you always want to do Python 3. I'm in this file, the site, the actual website that has manage.py in it. Python, actually, you don't have to say Python 3 anymore. It's after the year 2020. So you can say Python manage.py.check. You'll see me type Python 3 all the time because old habits die hard during the transition from Python 2 to type Python 3. So that's good. That suggests that this application in Django projects is in good shape. So now I have to go look at this web app setup. And what's going on here is this is Python Anywhere's way of taking the code in that folder and running it and giving you a web address for that. And so the first thing you got to do is you got to set this up. This is correctly set up. You got to point to the folder that has that manage.py in it. And if I go to the console and type pwd, print working directory, you see home Django Dr. Chuck's my site. And this is the file that has the folder that has manage.py in it. So these two things have got to be right. This code here has also got to be right. When you see this, it's going to start out really big. Throw it all away, throw the sample away. I give you the entire code to put in there. And again, it's all setting up which site. And then, oh, we also have to set the virtual environment in this web tab. Go back to the web tab. We've got to set this virtual environment. And I want that to be, you gotta go and change the name of it. Don't do the same as me. This is for my virtual environment. So it checks, yep, there's a good virtual environment. So you gotta have this source code, working directory, WSGI configuration file, and virtual environment set properly. We'll come back to this. These are error logs. And if all goes well at this point, let's double check the assignment. Hit the reload. It's what it says. So every time you change your code, you have to tell Python Anywhere. So this takes a little bit. And if all goes well, I will open this URL in a new tab. And it worked. Debug is true. Please leave debug true, or else this course is going to be really tiresome for you. Okay? So that's the first step. But then we have a little bit more work to do. We're going to add a polls application. So we're going to go back into that. I'm already in that folder. I'm in that folder, and then I'm going to start an application. Oops. come back. I'm going to build an application. This is a way to create a bunch of source code. So one of the things about Django is that it comes with batteries included. And so in this particular case, it's writing a bunch of code in a folder named polls. Okay? And so that's now in polls. And then we go continue on our, now we're going to pick up in this Django tutorial. So we said start at polls, we did that. And we're going to edit a file, polls/views.py. And we're going to, I'll copy this code here. Open in a new tab. And Django projects, my site, polls, views.py. So I'm going to put that code from the tutorial in there. Okay, so that code is in the tutorial. Going back to the tutorial, it says create a file called urls.py in that same folder and put in this code. So I'll copy this. So I'm going to create a new file here, urls.py, new file. Let's put that stuff in there and save that file. Then we go back, and then we are going to go in the my site. So polls urls.py is an application. My site is for the entire site. And so I'll grab this code also. This file already exists, so we go my site, settings. This is the only folder that has settings.py in it. Oh, I wasn't supposed to edit settings. I was supposed to edit URLs. And this looks pretty good. We'll just add the line. Well, actually, we got to do all of it because we have to import the include. So this little import include, this little part here was there. So this was, I copied this. These are all, of course, comments. So all these files are just some Python. This is setting a variable called URL patterns to an array, and path is a thing that returns an object. And so you can go read and you should read all the documentation. And then I will save this. And then let's go back. Now, every time you see here when it says Python 3 manage run server, you want to go do Python 3 manage check. So that's like do everything but run server except run the server. And again, you could get errors here and read those errors. They're tracebacks. You'll say, oh, no comma found. Let me just make a mistake so you see what happens. I'm not making mistakes. Come back. Let's go into this file. Let's forget a parenthesis. Okay? Let's save it. Shocking. See? So now, when I did a Python 3 manage py check, it blows up and it tells me, oh, something's kind of funky around line 22 of urls.py. Looky look. I mean, my editor even told me that. So there we go. So I fix that back up and I say save. And now I go back and I type, by the way, you can hit up arrow and you can run a command again. Python 3 manage.py finds no issues. So then what do we do to test our application? We go to the web app. Now we've got these guys set up. We don't have to change those. They're all set up again. So we hit the reload button. Take a little bit of moment. Then we go over to our actual application. Now this looks like a failure, but it's not, because it turns out that that little bit of code you run is sitting in polls. And so that's the code that you ran. And so at this point, you have completed the assignment. I got a little bit about errors down there. But so we walked through that. Wasn't too bad. Getting things set up is often the hardest bit. But hopefully in a little bit of time you'll have it all working, and then we'll start adding things to our application. So hope this was helpful. Cheers. Hello and welcome to our lecture on HTML, the hypertext markup language. So we're going to place this in the context of our request response cycle, and sort of here's us in the request response cycle in our browser and what we're seeing. We make a click, it goes across the network to the web server, runs some code, maybe talks to a database, formats up some new stuff, and we get the response. Then HTML comes out, and then that's parsed to make the DOM, and what we see is the document object model. And we're going to ignore most of that in this lecture. We are really only going to talk about this part here, and that is what this response is. It's HTML, and it is parsed, and it's read through, and it's used to construct the document object model, which then shows what we see. And so HTML is just a technique of using some special characters, less than and greater than, to add tags to indicate what we want to see, like the paragraph tag. The paragraph tag, that's a paragraph tag. Strong tag makes things bold. Emphasize tag and a paragraph tag. And so we have these tags and we just mark up. We're communicating meaning. If you're old enough to remember, word processors used to have ways to look at the actual codes that were being stored in the word processor file. So the web is, the HTML and hypertext transport protocol and all that stuff is a relatively recent invention, and we're doing so many cool things with it. It's continuously evolving, and really, we're less than, we're in a 20 years old, and so we're doing so much with it. It's continuously evolving. So HTML and CSS are really kind of at the edge. Looking back in the early days, if we take a look at what HTML was really intended to do, it worked on a Next computer in the early 1990s, and so this is the Next browser, which came from CERN, and it had everything in a new window. Images were not shown in line. And then there was the NCSA Mosaic browser, which was the first browser that was universally available on Unix, Windows, and Macintosh. And you see things like gray background and blue links and highlighted links that you visited in purple. And so in the early days, it was nothing like what we see today. In the early days, we were just amazed and happy that we could see a link, and you'd click a link and something would happen. But today, money is to be made based on making stuff super beautiful, and the number of pixels, and how things line up, and how things are shoved over, and how navigation looks. And so today we need to create beautiful web pages, whereas in the old days, we were just amazed to have web pages that worked in the first place. And of course, computers have gotten much faster, capable of handling video and images. Back in the old days, images were costly, both for network bandwidth and for the time it took your computer to display them. And so that just affected how we did it. And it's kind of fun to use the Wayback Machine, otherwise known as the Internet Archive, to go back and look at some of these older web pages and realize that it's still amazing that a lot of them pretty much work. And in the good old days, HTML was kind of a Wild West. The browsers did not want to show broken HTML as broken HTML, and so they compensated for it. And so in the old days, we had things like tags that could be uppercase. We would have a paragraph tag that didn't finish. We would have li tags that didn't finish. We would have attributes that didn't even have double quotes in them. So there was all kinds of stuff, and literally you can take this bad page and you could put it into a web browser and it will still display. So HTML, while it technically is a very precise language and you can make syntax errors, browsers are extremely flexible in terms of parsing it. Now, you're not going to get predictable results. Like, browsers can go into what's called quirks mode. And so in order to create the standards environment that we have today, Tim Berners-Lee, one of the original founders of the World Wide Web, helped found an organization called the World Wide Web Consortium, or the W3C. And it really decided that instead of just letting people write a browser and having HTML be defined by the browser, instead they would write a spec for what HTML was, and then multiple vendors could produce the browsers. And it took a while for this to become successful, but there was a need for every vendor to build a web browser, and so they worked with the World Wide Web Consortium. And like the mid and late 90s, 95, 96, well, 94 through 98, 99, the World Web Consortium created a lot of wonderful standards around the World Wide Web. Now, once we started having rules, then we tend to want to follow those rules. And so tags need to be lowercase. Attributes like this image source equals have to have double quotes around them. You have to have open tags and closed tags, open tags and closed tags. And so there's a set of rules, and now we are much more precise about our HTML. And we try to write it as precise as we can so that we get the best performance and the best sort of rendering out of the browsers that we can possibly get. Because if you don't write precise HTML, then the browsers are going to make decisions as to how to render things. Whereas if you write precise HTML, then you really are in control of how the browser lays things out. So up next, we're going to talk about HTML itself, look at some HTML documents, and take a look. Welcome back. So let's talk about some of the basic syntax of HTML. The first thing is to look at the overall document layout. And they start with an HTML tag. You might have a thing called a doc type up here, and we can put in one if we like, but HTML is the outer tag, and then there is a head tag and an end head tag, and this is sort of non-printing information. We set styling up, we declare the title of a page, perhaps load some JavaScript, and then the printable page of the content is in between a body tag, and mostly what we're going to talk about is the stuff that we put in as page content. So you'll find that there are special file names that we use. It really has to do with the fact that what we do is we make a directory within the web server, and when we go visit the directory, the web server looks through a series of files that it's configured to look to, things like index.html, index.htm, or index.php, and each one has a slightly different order and a slightly different set of things. It might even be called default.htm or default.asp if you're on a Windows box. It is configurable, so different systems do things differently, but usually index.htm is probably the safest thing unless you're doing PHP, which we will be doing later in index.php. And so those are usually the safe bet. Now, when you're viewing things off of disk, which we can do, if you download all the code that I've got in html.zip, then you'll have to open the index.html by hand. So we can put multiple files in the same directory, and then we can use them in what are called relative links. And so we can easily create links between one file and another. And so you'll tend to see, if you look at the zip file, that you've got a whole bunch of files in the same directory. And with little anchor tags, they point back and forth between each one. And so, like I said, you got tags like the paragraph tag, the strong tag, and the emphasize tag. They have to start, they have to stop. But another thing that's really important about HTML is the fact that most of the time we are logically marking up the text. And so we're saying we want this stuff right here to be a paragraph. But the end of the lines that we put in the HTML that we write are not really that important. What happens is depending on the width of the browser, if you change the width of the browser, the text will be rewrapped. And that's because there's still a paragraph, but we don't want to hard code it because we're not working on paper. Sometimes browsers are really large, sometimes browsers are really small. Sometimes you're on a phone, right? And on a phone, browser's really small. And so you don't want to tell exactly how many pixels it is wide, except when you start doing really fancy layout. But in things like paragraphs, you just say, hey, make it a paragraph and rewrap it. And that also, the rewrapping then also changes how tall the pages are, because the narrower pages, it kind of extends the page down. But the white space inside of the HTML is really generally ignored, and the lines are generally ignored. There are some tags, like the pre-tag, that changes that, so white space is respected and new lines are respected. But most of the time, we just let the browser rewrap things, and it's good. You have beginning tags and ending tags. So here's a beginning tag, and then here's the ending tag. The slash is our indication of an ending, and they're paired. And they're also nested. So this P tag has a strong tag within it and an M tag within it, and that's totally okay because this whole thing is a paragraph and this is a piece of bold text. So they have beginning and end, and slash is the end. You can also have self-closing tags that have like an image tag that has like a slash, and that means that you don't have to have like a slash image over here. That's the same. You just put a slash here and it self-closes. Another thing that you will get used to is the fact that you can put on the opening tag attributes, so key value pairs. And you'll go define what you go read the documentation on the image tag, and it'll say, oh, put a source attribute on to say what picture what file we want to display as the picture. The image tag is to show pictures, basically. So given that less than and greater than and other things are special characters, we have to have a way to print the special characters. So how do we print a special character? Well, we use ampersand LT semicolon, and there's a whole list of these things. HTML special characters. And you can look them up. And there's some that are kind of fun, like the special characters for the deck of cards. There's mathematical special characters, and you go look these up and you can find them. The key thing is they're cute, and you'll see that I'll use some of these arrows in the things that I'm doing. But the key ones that you really need to know about are less than, greater than, and ampersand. And just because ampersand becomes a special character, less than, greater than, or ampersand are really the special characters in HTML. And so to represent less than, you do ampersand LT, ampersand GT, and ampersand MP semicolon to get those things right. HTML comments, like in any programming language, any situation, the start of an HTML comment is less than exclamation dash dash. It's a little clunky, but we just want to make sure it's really clear. And so dash dash less than comments can go across many lines if that's what you want to do. So that works as well. Links is a critical element of HTML. It's why search engines work. It's why, when I first saw it, I'm like, I click on a thing and there's a new page. Isn't that amazing, right? And so hyperlinks is the H in HTML. It's the H in HTTP. And so it is how we, in effect, use this thing that we're sort of just scribbling on to create knowledge that Google then can extract. And so the anchor tag, the A tag, is the tag that we use to do these things. And so, there's a header one, a paragraph, and the anchor tag this is the start tag, and this is the end tag. And so the text that's clickable is second page, and you can see that it's clickable right there. It is styled with a underline and blue to indicate that it's a link. And so there's the href, which stands for hypertext reference, and then it's an attribute, so it's key value with double quotes, and then this is another URL. And so that's like, in effect, putting that URL up and going into that next page. So it's a hotspot. In the early days, and I'll show you a few of these links were like the coolest thing ever, and so we made them pretty colors, like the blue with the dash. People didn't when they first saw the web, they didn't know to click places, so we sort of styled them quite brightly. And then because you were often scanning and searching the whole web, because the web wasn't so big in the beginning, we would mark them as purple after you'd been to it. So you could sort of slowly but surely work your way through the whole internet as it existed back in the old days and keep track of the ones so you didn't have to go back to the ones that you'd seen before. And that was an absolute link, and here's one with a relative link, and that assumes that we are now in the same folder, same directory on the server, where we have href, and so here's the start tag, here's the end tag, and then first page is the clickable stuff. And you'll note that that is a purple link because I have already been there, because page1.htm was exactly where I just came from. And so you click on that, and you can go back and forth, and those are the pages we played with in the HTTP lecture. And so these absolute references are references that start with, HTTP or HTTPS or whatever, and relative references don't. And so that basically means that this page1.htm file has to be in the same folder as whatever file we happen to be viewing right now on the same server. So if you want to switch folders or switch servers, you have to use absolute references. And if you are just moving between files on the same server, you can use relative references. Images are a lot of fun. In CSS, we'll see how to wrap text. One of my favorite things was to wrap text. There is an image tag, which we saw before, image, and then the source equals is the attribute, and then in quotes the name of the file. And it can either be an image that's all by itself. In this case, this paragraph is what we're seeing, and you can see that this image is a tiny image, but it's sort of like blah, 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 blah. The image right here works kind of like a character. You got to be careful because the images can be really big. That's why I made a tiny image. And you could even, for example, in this case, I have an anchor tag, and the clickable part of the anchor tag is an image. So if you click right there, that will move you to lists.htm. And so you can make an image be a hypertext reference as well. Now we're going to do much more with these things, and this is just, at this point, the basics. Lists are an important part of HTML. There's ordered lists and unordered lists. And so the unordered list starts with the UL tag and ends with a UL tag, and then that sort of bounds the whole list. And then each list element starts with an LI, list item, and /LI. And I want a little bit of spacing. If you don't put them in paragraphs, you don't quite get the default spacing. This blank line's really coming from the paragraphs. So I'm putting a list of paragraphs, basically. It doesn't have to be a list of paragraphs. You could make a little denser list with a list of links or something, but I'm putting paragraphs in. And so you can see that I have LI to end LI, LI to end LI. I'm putting some links in here, etc., etc. And so dot, 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 and it puts all the bullets in. It does the indenting automatically. We'll see in a bit how we can control all that formatting and do different things if we want to do those different things. But for now, we're just going to play with the default formatting and learn the HTML, which is our way of representing that we want a list on the screen, but we're not so fancy about exactly how it's supposed to look. So in HTML, we really are looking for the meaning of the page, not how pretty it is. Tables. Tables have a bit of a checkered past. In the early days, people tended to use tables to lay pages out on grids. And they would just put, a paragraph here and a paragraph here and then a paragraph underneath it, and they would move them to move them around, and they would put images in some of the table cells. And that turned out to be really bad, and that notion of tables as graphic layout is long gone, and we use CSS now, which is the next lecture. So, but tables were always a good idea for tabular data. And so if you have something that sort of makes sense, is like a list of cars with some make, model, and mileage columns and a list, then you mark them up. And so the table markup is pretty straightforward. We start a table with the table tag, and then we have a series of rows using the TR tag, TR to /TR. And then if there's a header line, which can be formatted a little bit different, we do a TH to /TH. And then this basically says it's going to be a 3-column table because we have 3 table headers, 1, 2, 3. And then we're going to put TDs for the data. TD stands for data, 1, 2, 3. And so that's the Ford, edge, and then the mileage of that, and on and on and on and on as we go. And so it's not hard to build them. You kind of have to keep track of how many of these things you've got. And there are tricks where you can make a table that has like 4 things, but then in one row this expands so that's, I can't erase it. Can't erase it. So there are ways to do things where a data element spans more than one column, call span, for example. But the key to tables is that we use them for tables. We don't use them for arranging things that are not themselves row, 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 row. So I'm going to stop there. I'm going to record some exploration of some sample code at www.webapplicationsforeverybody.com/code/html. And I really am intending that you will, these are very simple pages, but the idea is to look at them in developer mode and take a look at them, and then you can see how the various things work. And you can also then look at the source code and see, oh, here's how a pre-tag works. Or where's the pre-tag? No. Oh. Yeah. So we look at the source code, take a look at things, and show that the line wrapping does not actually matter. We look at pre-tag in another one. So I'll record some walkthroughs of all this sample code, but I encourage you to take a look at it because it has a lot of good examples of the basics of HTML. And so HTML is a continually evolving thing. It's a very creative space. It's a lot of fun. We have to be really tempted. We have to avoid the temptation of trying to make everything look pretty in the HTML, but instead delegate that to the CSS, which is what we're going to talk about. Hello, and welcome to Web Applications for Everybody. In this screencast, we are going to play with some of the sample code, and you can either download it and play with it on your own computer, or you can look at it in your text editor, or if you just want to browse it, you can browse it here and take a look at the version that I'm using. It's really been intended that you look at this in the developer tools And so you can do things like, say, inspect element. And so here we are. This will also be a little more valuable even when we're doing CSS, but you can see the document object model. Now, the interesting thing here is it shows something I'm always talking about, is the difference between the document object model and the source code. So this is the document object model. It's kind of stylized. If you look at the source code, you have to say view page source. And so the source code, this is literally exactly what's in the file. And if you go look at this file in a text editor, you will see this. And if you're looking at it here, it doesn't quite look exactly the same, and some things have been done a little bit differently. You know, they kind of got this extra stuff. And this is kind of after the browser has looked at it. And we start talking about JavaScript and changing some of this dynamically, you'll see this part is the document object model. But the source never changes. The source is what was originally downloaded when the server sent this back to us. So let's take a basic look at this. I'll hide this unless I need it. I'll go back and forth between the source. So we have a basic document, HTML, with a head tag and a body, and then a header. And of course, here's our header. We're using default styling, and paragraphs are an important part of things. You can squeeze this up as much as you want. White space sort of doesn't matter, right? So this white space kind of doesn't matter here. The fact that this has got extra space, it doesn't much matter. And so you can see an anchor to a strong tag that leads to a boldness. Let's just go ahead and look at it here in the inspect. We'll go down here, we'll find like a strong tag, that's the bold. We got an emphasize tag, and if you look a little farther, you'll see there is the anchor tag, which is the whole anchor tag is this whole tag from the A to the /A list.htm. That's where we're going to go if we click on this text right here. And so you can see, now this is a relative link, and it turns it into an absolute link, and that's because the browser knows where we're at, and so it sort of prefixes everything up to that to the relative link. But that's nice, because if we look in folders, we will see that these folders are all here. Here, let me go find you that folder. It's pretty deep in my... Later, this will all make wonderful sense to you. I do a lot of stuff with web. Code, HTML. Okay, so here we have, after all that, here we have the files, right? And so this is index.htm, and index.htm is right there, and list.htm. And so if I click here, I'll go to list.htm, and that'll pull this other file up. And so these guys are all in the same folder together. It just means that I can use relative links to go moving between them. A tag that's really becomes more important, especially as when we're talking about writing code inside HTML and showing people code, is the pre-tag. And so the pre-tag, and you can just say inspect to hop right down to where the pre-tag is. The pre-tag respects spaces, so all these spaces happen, the new lines happen, and it also shows it in monospace font. Now you can change all these things once we get to CSS, but pre-tag, when we're printing debug out from, not in files like this, but when running code, sometimes it's good to print debugging out in with pre-tags. So let's go to the next page. And so here's a whole series of things we're going to play with. This is a unnumbered list. This whole thing is an unnumbered list from top to bottom. So when I highlight this, you see the whole beginning to end of the list. Then each item in the list has a start and end li tag, right? Down, down, down. So here's this. We should learn about tables. And there's a href, there's another relative link, and so this is sort of my jumping off page to get to all those other things, right? Learn about tables, etc., etc. And so you can see these. We probably use just to take a look at the source code of this page. And so that's the source code that I typed in, and you can see the li tags, the p tags. I'm putting p's inside of li's to get space. Let's see if I can sort of show you that. So if you look at this and you look at the LI tag, the LI tag is that, and the paragraph is what actually creates the vertical and horizontal space, right? So that orange that you're seeing, that's paragraph. There's space that the paragraph tag has preset. So that's how I do that, putting paragraphs and hrefs. And so that's what this all looks like. So let's take a look at special characters. And so this is an interesting thing because it's not really what came out, because less than requires ampersand LT, but it's kind of processing that. So let's take a look at the source code to this one because that'll be more instructive. So ampersand LT, ampersand GT, ampersand amp. This is an ampersand in HTML and then just the letters AMP semicolon. Semicolon's not special. There are only really 3 truly special characters: less than, greater than, and ampersand. And you can put all kinds of fun stuff, clubs, hearts, and diamonds. And so you got the clubs, hearts, and diamonds, some arrows, stuff like that. What's nice is browsers just have these built in, although they're not necessarily the sexiest or coolest things. And I think what happens when I go back on this link is I go back to the list. So that's just special characters. And you'll notice that the default styling that says we've seen this one, and this is how the web worked 1,000 years, no, back in the 90s, is you sort of, oh, it's kind of nice that it's turning purple. And you'll notice that Google does this as well when you're doing Google searches. It actually lets the links change color after you visited them. So let's take a look about links. We look at links. I'll view the source of this guy. Absolute link, ahref, right? And then /a. This is the clickable text, right, between the beginning tag and the ending tag. The attributes are on the beginning tag. Another attribute that you can add, and I do it all the time, is target equals blank. And that basically is the way we say, open this up in a new tab. So you'll notice pop up in a new tab. And so that's where that one goes when it pops up. And so you can decide whether or not you want this to go in the same page, back, or in a new page. And then I got to close the tab to get back. And now I'll go back because that's just a relative link to list.htm. So I can go back and look at the next thing. Let's take a look at how images are represented. So this is just a paragraph that has an image in it. Right, so it's a paragraph, but there's the image. Source equals medium.jpg. If you look in my folder, you see the image right there, medium.png. You don't see the suffix because Mac is trying to hide it from me. And so that's just, you see this space here and here. The image doesn't have any space. We could add some with CSS later, but the paragraph is what's adding that space. Then we have just a regular old paragraph. I'm not supposed to use the center tag. We'll get to the how to center stuff. So that's what that is saying right there. And you can have an image that's right in the middle. So you see where that image is. I think of images, if they're right in the middle of text, they're like a giant character. And so that's how that works. And you can even sort of stick an image as the thing inside of a link. So here's the anchor tag. It's that bit right there. And then the anchor tag body is an image. And so if I click on that, it's going to go back to list.htm. You'll notice these all go back to list.htm, so I can work on the next thing, right? Tables. Again, you're not supposed to use tables for laying out like blocks of text, which we used to do. We used to do things like use tables to draw borders around things, which we'll see in CSS. But now that's totally verboten, and you're supposed to look at tables in a way that they're, nice and pretty. So let's do a view source here. So let's see, there's our table, our slash table, and a table row. Now let's take a look at the DOM. So apparently I didn't put a T body. We're supposed to put a T body in there, and I didn't do it, but this is the DOM. The DOM put it in. That's put in by the parsing, and so clearly I made a little mistake in my HTML because I didn't put a T-body tag, and so that was added by the browser as it was parsing and reading through this, like, oh, we forgot his T-body, So it just like slapped one in for me. And I think the mistake is this is my header row, and I think that should be like a T head. So there I go, bad HTML. It's the story of my life. And then I've got the rows, and you'll notice that the DOM is kind of prettier. So sometimes I do this, the DOM is indented nicely. So this isn't really the source code. This is the data that represents this visual, right? It is the thing that you're seeing, but it read this from the file or from the server, parsed it, and produced the document object model. I only say that like a million times. Okay, so back we go to the lists. We're making pretty good time. So here's some really bad HTML. I'm going to view source on it. And again, you'll see sort of the difference between the document object model. When you're debugging these things, you will have to sometimes view source. Sometimes document object model will be the only way to debug it, and sometimes view source. So this is the one that's got bad stuff, like H1 is uppercase. This paragraph tag is not terminated. This UL tag is uppercase. This LI is not terminated. I don't have double quotes here. So there's a series of mistakes that I've made in this HTML, but it looks pretty good. And you'll notice in the document object model, it's fixed all that. Now, each one is lowercase. The P tag is finished. There are double quotes, meaning the document object model is not just your HTML source code. It's like the sensible, parsed, pretty version of the HTML source code, and so, this UL tag, these LI tags are now done. The UL's lowercase, everything's lowercase. So it's like, I'll take care of your mess. I'll patch up and fix your HTML, and then I'll display it for me and make sense of it. So the document object model is not the same. It is sort of like a sweet, awesome, better version of it. But this is what changes that. So let me just show you something, how I can change the document object model. Let's see. Let me see if I can change this text. I change the document object model. That changes. So I'm actually, but that didn't change the source code here. The source that it was retrieved to produce it, but I can change the document object model. And later in the class, we will write code that will actually change the document object model. So we'll change this. We'll call this be going to lists. Yet again. So I can change the document object model. Doop. So you see it changed it. So when we change document object model, what we see in the browser changes, but the source doesn't change. Did I say that enough times? So let's click on this and go back to lists. Okay, so some HTML can be broken so badly so that it doesn't render at all. Whoops, that didn't work so well. I'll do a view source on it. And then I will let you figure out why this doesn't work, why this doesn't show. You take a look at the source, you figure it out. I hope this has been helpful to you.
Hello everybody, and welcome to our lecture on cascading style sheets, CSS. Of course, this follows right on the heels of our HTML lecture. I'm going to use a bunch of examples from webapplicationsforeverybody.com, and you can just bring these up in your browser. I love to place everything that we talk about in the context of the request-response cycle, because that's the whole Web Applications for Everybody. You cursor out here, you do a click, it sends a request, a HTTP request, maybe talks to a database, gets some stuff back, sends some stuff back. This is the request-response cycle right here. And the thing that comes back is HTML, and then that is parsed, put into the document object model, and the thing that you then see, the pixels you see on your screen, are from the document object model. And so that's what we've been doing so far. And so far, in that HTML lecture, we just talked about this, what the format was when you parse the response. So what we're going to talk about today is we're going to talk about, in addition to that, we're going to go and pull another file, a CSS file, CSS, and that is going to inform the document object model, and it's going to change how things look out here. And so, we'll have some CSS in the HTML, but we'll also have some CSS in separate files that make separate request-response cycles. So we're going to be putting files like our HTML files in here and our CSS files in here. So we're going to be serving them a little bit, but mostly what we're worried about is sort of the form, how to make the DOM look pretty, and that's sort of what CSS is all about. So In addition, I would like you to install this thing called Web Developer from Chris Pedrick. Chris Pedrick has been doing this a long time, before there were even developer consoles in browsers. And it's funny that the developer consoles don't do what this does. I don't use all of its features, but it has some wonderful features for CSS, in particular turning on and off various styles. And so it's a great way to sort of dig through CSS issues in addition to the Web Developer Console. And you can do a lot of sort of fine debugging, but there's some real nice stuff with Web Developer. It's just a plugin for your Safari or your Chrome or your Mozilla browser or whatever. So please install that. I recommend it, and some of the assignments actually require it. So like I said in the HTML lecture, the HTML started out with, we were just amazed in 1995 when we could see a page with a gray background and blue links, and it was lists, long lists of links, and the links turned purple, and we would click on a link and another page would come up, and we were like, holy mackerel, this is the future, right? And we were so happy. And our curiosity was piqued. We did interesting things. But, in the 10, 15, almost 20 years since all that, it's become a business. And in business, the look and feel for the average non-nerd user, they don't care that there's a request response cycle. They just want to do a thing, talk to their friends or look up information or whatever. And so the CSS is in the middle of this time frame, that the ability to precisely lay things out and make pages beautiful became super important for the web to take its sort of leap into commercialdom. So if you look at the Yahoo web page, for example, this is just a screenshot I took a while back. They do studies as to how much white space is in between those two pieces. And they'll add a pixel and take away a pixel, and they'll see how their revenue goes. And so these user experiences, these visual looks and feels are highly tuned and highly sort of taken care of. And so CSS needed to be able to precisely have a pixel perfect layout in every browser. And so CSS is a very, very precise thing. HTML has become precise, but we don't want to do our markup and layout in HTML. I showed you tables previously, and in really early versions of HTML, we used tables to create look and feel, and that was never good. So one of the things you can do with the Chris Pedrick Web Developer plugin is you can show a page without CSS. And what you should expect when you see a page without CSS is it's sort of beautiful even without CSS. It's beautiful in a logical and a structure. And so here's my web applications for everybody website, right? It's got some cool stuff. It's got these little things that go over there. It's got the little border. The color's gray here, and it's a little lighter gray, and this wraps around and it looks really awesome, right? Well, turn CSS off, and you should still see a page that you could effectively navigate. It's like going back in time to a simpler time of, okay, I want to see this. This is really a list of links at the end of the day, and there you go, it's a list of links. And the default is I've already clicked on lessons, so lessons is purple now. And here's this video, and if you scroll up and down on this, I mean, it's really fun to go to a website and, turn CSS off and see how good their HTML developers are and how pretty it is. And so it's supposed to be pretty in a simple way. And what's nice about this is it really leads to good accessibility, meaning some people do not see the graphics, they hear the page read to them. And this way, this is how it's read. And the simpler and more beautiful and elegant your HTML is, the easier it is for a person who has reduced visual ability to understand your site. And that is, I remember the joy of hearing from people who were using the web and Gopher in the early days, how they all of a sudden could go anywhere and see anything and do anything in a way that that visually impaired people could never do for like hundreds of thousands of years. And it's joyful. And then what happened is we ended up with this really nasty markup. And then it was like the web was simple and they loved it. And then the web became ugly and nasty, and HTML became nasty. And they're like, the world is horrible because now you go to all these cool websites, but I can't go to these cool websites. because I'm visually impaired. And now we're back. We're back to that. We're back to beautiful HTML, simple HTML, and then beautiful web pages, and CSS is the matter. Okay, I think I've done enough advertising for CSS and accessibility and beautiful HTML. So ultimately, if you look at how this thing is assembled in your browser, there is an HTML page that is pulled down, and then there is CSS, sort of both inside the document. Sometimes there's CSS in the document. If you look at this, not that it matters, there's a little bit of CSS in that document, and then a whole bunch of other CSS that brings all the beauty to this. Sometimes it even takes some JavaScript and whatever. And so we understand that the HTML does not have the beauty in it. The beauty comes from the CSS. And that is part of what we try to do, is learn CSS. So if you're going to be like a coder and you're not going to be a graphic designer, you still need to know enough CSS so that you don't write horrible HTML, so that you know what a really good CSS developer is capable of doing on your behalf. And on large projects, including like Sakai project, which is an open source learning management system, this allows separation of concerns. And you can have people that specialize in the back end and the HTML, and then a web designer can, the web designer, so if you think of the developer, usually there's a back end, and then they generate, from the back end, they generate the HTML, and then the designer will build the CSS. The designer will often have skill enough to sort of tweak the HTML if the developer built bad HTML. So they kind of meet in the middle at the HTML, with the developer mostly being responsible for building the back-end developer. And then the front-end designer can then tweak the HTML a little and then tweak the CSS. And so the HTML is where the back-end developer and the front-end developer come together. But it means that you can have lots of people working, and you can develop highly specialized skill sets in larger projects. I know that my skill set is in this side. I am not skilled in this side, right? I can clunk my way through CSS, and everything that you'll see is my CSS, and you'll be like, whoa, that's not very good. And if it even looks pretty of mine, I'd probably use Bootstrap, and I cheated and found a CSS framework, and I didn't build it, I just did it. Now, there are people who are smart enough to build Bootstrap. They can build such gorgeous websites, and my job is to build beautiful HTML that then they can add CSS to and make it super gorgeous. So the CSS basic syntax is different than HTML, right? HTML is less thans and greater than. CSS has curly braces. I don't really know who invented the first. I should find that out and go videotape that person. But it has curly braces and semicolons, so it kind of looks like a little bit of C. And it's really a set of rules. And it's not sequential, although the order does matter. Because what comes later has more importance than what comes earlier in CSS. But it's not like code that gets run. And so the anatomy of a CSS rule is that there is some kind of a selector. And in this case, the simplest selector is the tag that we want to affect. We want to affect the body tag. Now, there's only one body tag, but you could have a P for a P tag and say, I would like to do this to all P tags. And so it's implicit, kind of like SQL, in that a body tag means for all body tags. There's an implicit loop for the whole document. And we'll see how to reduce that later to it, so it's not always the whole document. But for now, a tag means a tag there by itself means every tag in this document. And then there's a series of rules, and so this is really when to apply. This is sort of what aspect, and there's a whole list of aspects that you can have, and then what you want to do. I want to make the font size 100%, I want to use Arial, and then sans serif, etc., etc., etc. Holy mackerel, my little pen is undoing itself. And so then these end in a semicolon, and you can have a bunch of these, right? You can have just one, you can have more, but that's the basic idea. Is a CSS rule is go find a part of this document and paint it. I like to think of this as like, go find a thing and then run a paintbrush over top of it that is this paintbrush. That is the paintbrush that you go select a piece of the document and then paint it yellow or paint it bold or whatever. That's kind of how I think about it. Now, I'll admit I am just I'm really a very weak CSS developer, and I need a cheat sheet. And if I'm going to do CSS, having this even a single page cheat sheet is super helpful for me just because I don't use it all the time. And so the attributes like background color and the border dash bottom, for me, they're all very self-explanatory. They're really easy to understand, or if you don't understand them, you just Google and you go Stack Overflow. But like for me, I'm like, is it border bottom or bottom border? I just can't remember that stuff, and so I just have to have a cheat sheet whenever I work. And this is one cheat sheet that I happen to like. And these are the kind of properties that we're going to be playing with. Color, the background color, how to align it vertically, how to align it horizontally, padding, which is space on the sides, etc., etc., etc. So there's just tons of CSS properties, and there's tons of great documentation on each of these CSS properties with little samples all over the place. And I have my own samples as well that I'll do some recordings and walk you through like line by line on my sample code as well. But this is the kind of stuff that we're going to play with in CSS. So up next, we're going to talk about how we connect CSS and HTML together. So welcome back. Now we're going to talk about how you use CSS within HTML, how you take these CSS rules and apply them to the various parts of HTML. And there are three basic ways that we do this. One is we take an HTML tag and use the style attribute and just put those little CSS key value, CSS settings right there, very close. The other thing is you can put it in the background of the HTML document, usually in the head area. And the other, probably most common thing, especially when the styles get large, is an external style sheet that's a separately loaded file with a separate request response cycle. So we'll start with sort of the simplest but sort of least used of these things. And that is, like I said, you can put a style attribute on any tag. And you say any attribute, you say it's got a double quote and a bunch of stuff and another double quote. And in there is a series of CSS rules that are basically CSS setting like border style, colon, and then the border style setting that you want. And so in here I'm saying I would like a solid border, I would like it red, and I'd like it to be 5 pixels. And that effectively determines how that particular thing gets painted, right? In this particular one, I said font family monospace for that particular paragraph. So this paragraph is painted with a font family monospace. And so you can just put these things here. I put on the body tag, I want an Arial sans serif font. So the whole body is not Times New Roman, except for the fact that this particular one is monospace. And so these two tags are rendering opinions about what the font's supposed to be. But because this one is closer, the monospace wins here, but the Arial wins everywhere else because none of these other tags render an opinion. And so that's kind of the cascading bit, meaning the closer it is, the more priority that it has, unless of course they put important up here. And important is something we'll talk about later. You can make the farther away override the local, but it's not something you want to use too much. If you're using important, that's a trouble. But don't worry about important right now. Just imagine cascading means the closer, the higher priority. Closer to the tag the statement of CSS is, then the higher priority that it is. So another place that you can put the CSS is right there in the header, right? So instead of putting it on a tag, we can use a style tag in the header. And so here we have the header of the document, right? The body starts down here. And up here, we're going to set a set of rules. And now we're using the thing where we have to say which tag it goes to. So now I can say the body tag, even though there's only one body tag. We want a font family Arial sans serif. And because they're all inheriting from the body tag, then all the paragraphs inherit from this, and the headers inherit, etc., etc. So it's like body on down in this particular case. The header 1, which is this, is blue. And paragraphs are supposed to have a solid border, red, 5 pixels. And so border style, border color, etc. And that means that each of the 2 paragraphs here are away you go. And I'm going to dig into the anchor tag, and here's my little anchor tag. And I'm telling the anchor tag that I would like to have a green font, and I would like no underline. The default is to underline them. If you look at links, they're always underlined. I'm overriding that. And then I want the background color of that text to be light gray. And so this is a set of rules. All that HTML is down here, lower down, and there are no style tags. There are no style attributes on the tags because we have basically said for all paragraph tags, for all anchor tags, for all H1 tags, and for all body tags, and we put it up here in the top of the document. Now the problem is most websites have multiple pages, and this gets really frustrating after a while. So, you really want to pull some of those widely used or repeated things out into a file and include them. And all we do is take pretty much that same set of CSS rules and we put them into a file. And in this case, we'll put them in the same file, same directory, same folder as the HTML. Although you can pull these things off of a website if you want, so http:// or whatever. But you put a link in here and tell it's a CSS, and it's going to be a style sheet, and then you give it an href, which is then going to pull this file in and sort of expand it as if it were right there in the middle of a style tag. And so it knows it's a CSS and it pulls it in. So that's how you change your HTML. So now if we take a look at the next example, we see that in this next example we've got a link, right? And down here we've got no style. Ignore this little thing. That's how we're putting this little, don't ignore that page. But in the real stuff here, we've got this. We've taken our, we got our pre-tag. We've moved it in. We've got some things here. We got all that stuff that we've done, right? And if you look, here is that rules.css file. Rules has all that same stuff. H1, border color, a tag, all that stuff that we put in the head now is sitting in this rules file, and we're just pulling it in right here in one fell swoop, and it accomplishes the exact same thing. Okay? And so this, including in a separate file, is by far a superior way to do it than putting it in the head tag. So, but sometimes you have to like change two things and you put them in the head tag. And it's up, you use all three of these ultimately, but generally you tend to start with a large amount of CSS in a file, and then you tweak in the head, and you might tweak on a tag here and there. And that's kind of how these three things tend to work together. And the whole cascading thing works out well. You can put the link first and then style tag second, and then it kind of overrides some of the stuff that are in the linked, and then you can have something on a tag which overrides the stuff that's in the head. Unless, of course, it says important. So, as the world went from hacking look and feel in HTML to, finely tuning look and feel in CSS, all these tags, paragraph, H1, body, they all had default styles that had kind of evolved, and links and all that stuff that evolved, and a lot of pages depended on those default styles working. And so they couldn't say, welcome to CSS, and now all the styles, a paragraph that's unstyled will look terrible. Not that they look great. And so we couldn't take the paragraph tag. Everything had a style. That's the problem. All the existing tags had something on them. So they had to make new tags, and the new tags that they made are the span and the div tags. The key to the span and the div tags is span is an inline tag that has no styling associated with it, no default styling. It is defined as having no styling, and the div tag is a tag that has no styling associated with it, but it's a block tag. And so we sort of use these to sort of mark text, but don't inherit, without inheriting any styling from some long ago 1993-94 defaults. And so the span tag is span tag here. That's kind of broke over a line. The span tag has no styling except that styling which you add. In this case, I'm adding it with a style attribute. And the same thing is true for a div tag, right? The div tag, and also divs can be within divs. So this is a nested div, right? There's an outer div and an inner div. And basically you know that styling, the div has no style whatsoever, right? The span has no style whatsoever. So if you just put something in a span tag and you don't do any, you don't sort of render an opinion about what it looks like, the span doesn't change it. It just is, it inherits from whatever else is there. And so if we take a look at this, right? So here we have a P tag with a green border, 1 pixel border solid. Now the interesting thing is you say, well, did the paragraph tag have styling? It turns out it does. It has some margin in padding to make it look better, right? And so the paragraph tag is not an unstyled tag. It is expected to create blank space around itself. And so, yeah, so the paragraph tag has a default style. It's supposed to have a default style. But then if you look at the div tags that we've got here, like this div tag, this div tag, remember, goes all the way down to here. This div tag, I just put a blue around so you kind of know what's going on, right? So this blue goes from here to here. but you can see right away that the div tags have no padding or margin or side of little white space to make them look prettier. And that's okay, you've got to do that. You've got to add the padding and the white space. They just start with nothing. It's just a block, right? And the span tag, this one here, changed it green because we put a style color equals green right there. And okay, so we did that. And the div tag, and you'll notice, interestingly, these, because the divs I'm using end up with a 1 pixel border as their style, meaning they started with nothing. You can even see that if you look really close, it's impossible, but you can zoom in. This orange border, the blue border takes up space, and then the orange border's on inside of it, and that's 1 pixel wide. So I'm adding to these through the style attribute, I'm adding CSS to them, but they start with absolutely nothing, and they kind of look ugly when you just like put something in a div, like right next to each other, because they didn't want anything. And again, they're nested, and there's reasons, because we'll use divs to say, this is the main body, and then there's divs within the main body, and then this is the navigation, and this is the footer, etc., etc., etc. And so we have, divs are ways to describe blocks without adding CSS styling by default, and it's, as such, letting you define all the CSS for these things. So these are cool. They're like the non-tags, the untags, the tags that don't cause anything to happen but let you cause everything to happen. So they're really important. They're really important. So the next thing I want to talk about is making a sort of finer selection of which tags that you want to apply a rule to, right? A rule to. And so if we look at this tag right here, this is the body tag, and that basically says I want everything from body to /body, then everything inherits. So unless it's overridden, I want Arial sans serif to happen. Okay? And I can do that with a paragraph tag, but I want to show you this other thing. So there's a way to mark a tag. Let's find this one. Where's first? First right there. So there's this ID attribute. An ID attribute is an attribute that was added kind of specifically for CSS as well. And so you can only mark one tag per document with an ID. And then there's this class tag, and you can mark as many tags as you want in the document with a class tag. And the idea is like ID tags are for chunks, like main page, like left navigation, top navigation, or something that's only going to appear once on the page. And so if you want to sort, in effect, what #first means is look through the whole document, find a tag. Where's div ID equals first? Where's that stop? Div, right there, right there. Find the tag that's got an ID of first, and then paint it with those rules. The class can happen more than once, but more space, let's see, class is more space here, that's there, and so that basically says, let's change clear and change color here. More space says look through all the document and find all the class. There's that paragraph. Ooh, do I not close that paragraph? Oops, mistake on my HTML. Here, yeah, so that basically says change the margin left. That means shove this in, and change the margin right and shove it in. So we'll see all these things. And loud, and then you can also see a situation where when you put classes on, you can have more than one. And so this basically will respond both to the shout and to the loud class. Okay, so let's take a look at what this page looks like. So here we go. It's a little busy. So if we take a look at first, it grabs this tag here, the div tag is first, right? And then if we look at like more space, this more space is affecting this one, and it's shoving it in both on the left and the right, and that's because it's this paragraph more space. Okay, shout, let's find the shout ones. Well, we can see them right here. They're all the loud ones. So that is red. No, that's shout and loud. Oh, here's one that shout. Oh, entire has been shouted, and all has been shouted. So you'll notice these guys are lowercase, but shout is a text transform to uppercase. So you can even change the case of things. And then in third, for example, where's third at? Third says so this says find the third div, which is right there, and find all the p tags within the third div. this P tag and this P tag, and then apply a background color yellow to all those, which leads to this right here. Okay? And so # means find ID and apply. Dot means find class and apply. You can have multiple classes, right? Pull in the definitions from 2 classes, shout space load, go find the whatever's in CSS. And then you can kind of have hierarchical things, and this is quite useful because you don't have to get special. It saves you putting classes on. It saves you from putting classes on all the paragraph tags here. You don't have to do anything, but you're not affecting the paragraph tags outside here. You're only affecting the paragraph. I think of this as go find third and the paragraph tags within third, and then do something to them. And that way, otherwise you'd be making more classes than you need to be. And so this is a very well-liked technique for really fine-tuning your selection, your selector for CSS to touch only the things that you want to touch. So up next we'll talk about images and colors and fonts and a few other things. So welcome back. Now we're going to talk about making our stuff look a little prettier with images and how we can play with images, colors, and fonts. So CSS and images are a lot of fun. We can fool around with them. We can move them around. Actually, this for me years ago was the thing that in 1994 that made me fall in love with the World Wide Web. So what made me fall in love with the World Wide Web was the ability to take a picture of me, and I love pictures of me, and then float it to the right, and then I put a little border around here. And so that's what I've done with CSS. So let's take a look at how I've done that. So if you look in line here, the navigation, which I'll show you when I go through the code walkthrough how the navigation works. But at this point, at the end of the navigation is right here. And I put this image in. So if you were to watch this inline, the image is right there. But what I do is, when I say float, that actually, and there's other things that we'll see when we start looking at fixed and absolute positions, you can pull it out of the regular stream. And so this is like pulled out of here. It's as if it didn't exist. And it floats to the right, but then it's vertically aligned. So the next thing you see is this header 1. This header 1 CSS, oh, there's a typo there. I got to fix that. So I'll pretend that was an H1 there, but that's okay. So this header at Quarks mode, I should run this all through the validator to make sure I'm okay. But okay, so the top box of this CSS and images H1 is right here, and then this floats over, but then it top aligns. Now you can change this alignment if you like, but it top aligns here, and then it actually looks at the width, in this case the width of the picture, but you can also control the width up here in the CSS, and then it carves out this space, and then I do a margin of 1em. And so on M, you sort of sometimes wish they would put default formatting on, but then they kind of tend not to put default formatting on, because if they did, then you have to turn that off. And so I wanted some white space, and so I had to put some white space around it. And so I said I'd like a margin of 1em, and so that puts a little bit of space here and here and actually here as well. So you see that this lines up over there. And then that talks about what is a 1em. So 1em, I could have said 5 pixels, 5px, and that would have been fine. But 1em is basically the width of the letter M, roughly. It is a width that changes with the size and nature of the font. I think of it as the width of an M, and I think that might be a soft definition of it, but I don't think it's a precise definition of it. But that's what I did. So float right hoists it and sends it over here, and then shoves this over so that this text is now, it reserves this space so the text is wrapped, basically, and then I held out some space just for prettiness, right? And so that's like CSS is making it look pretty. Now, what happens here is sometimes you want to basically force, after this float has happened, something back to the left margin, and there's this clear equals all that says clear any floats is what it's really saying. And so it means that even though this, if it wasn't for clear equals all, this next paragraph would have been kind of up in here, and then maybe it would have wrapped if it was long enough. And when you play with this, you can resize it and see how the wrapping changes. But no matter what the size is, after the BR clear equals all, this is going to format back to the left nav, right? So that clears that hanging wrap, that sort of But you don't have to. You could not do this, and then it would wrap and wrap and wrap, and then it would get longer and it would continue on. But if you want control over that, you can with the BR clear equals all. And of course, you can have images right in line, and this is just from the HTML bit here. There's nothing fancy CSS here. Images kind of are like big characters. I sized that one so it sort of fit nicely, and you could even make this a clickable link. But that's really just, this part here is just HTML, not CSS. But I could have, if I wanted to, change the width and the height of this. That'd be kind of fun. Make this guy be like the width of an M, and then you'd see it more like a character. So there's a bunch of colors, and the colors have to do with, there's the simple thing for us simple folks. You know, we just put in things like red and green and stuff like that, and especially if you're doing a developer and you're just trying to get basic stuff working, I often use colors in my testing that like put the border red. I do that all the time to say, where is that div at anyway? So I'll throw a 1 pixel border around it, red border, like, oh, that's where it is. Although the Chris Pedrick plugin has a thing where it puts 1 pixel borders around everything for you automatically. But whatever, these are not necessarily most graphically beautiful colors, even though I like them because they're super primary in terms of primary colors and strong. You'll see that I kind of use those colors in my slides a lot because I'm not a graphic artist, of course. I just like, oh, the greenest I can be is good. So there's 16 official colors, and they're here. Once you get a little more sophisticated, you can use precise colors from, I think this is a, I don't know, 32-bit. Yeah. So this precise colors are the ones that start with £. And so £, and these are hexadecimal numbers. These two numbers are effectively 0 through 255, but they're in hex. So hex is like A, B, C, D, E, F are actually numbers. 0 through 9, this is actually 10, 11, 12, 13, this is 15. And so E is bigger than 9, and F is bigger than E. But basically these are 0 through 256, that's a three tuple of 0 through 256 numbers. And so the more red you put in, the higher this is, the more green you put in, the higher that is, and the more blue you put in, the higher that is. So RGB, red, green, blue. And if you're playing with like a slider inside your UI, you might be changing this, but you're just changing these numbers ultimately. And so you can find these things. You know, so white is all Fs, and so if you turn it all on, it's white. If you turn it all off, it's black. The absence color is black. Red, green, so you turn, that's max, max, and max, and so you can make sort of a pure red, pure green, and pure blue. Picking these advanced colors is sort of way beyond my ability as a graphic artist, and people will pick colors. There are sites that help you pick palettes for your pages, etc., etc., etc. There is also a sometimes these colors can have a transparency, and there's a fourth set of two numbers that have to do with how transparent the color might be. So fonts are also important. The default font is a Times Roman because that's what computers had in 1994. And I think they're ugly, especially on screens. They're not so bad on print, but they're ugly on screens. And so I tend to want a sans serif font. It's too bad that and maybe they have changed in some browser default for sans serif. I just change it to sans serif all the time I want. Now if you look at fonts, the font family is kind of a special tag, in that you ask it a set of fonts, and what you're really doing is you're setting a priority. And the problem is depending on whether you're on Windows or Mac or which version of Windows or which browser or what fonts they've had installed, you can, fonts might not be there. And so what you basically do is you basically say, okay, I would like this. I think this is a Microsoft font. And if that font's not there, then I would like this font. And I think that might be also a Microsoft font. And if that font's not there, then there's Arial. See how much I know about graphic arts? I have no idea. I think this might be a Mac font. And if that font doesn't work, default into the fallback font sans serif. And there is always going to be a serif font, Times New Roman-like, sans serif, Arial-like, monospace, which is Courier-like, cursive and fantasy, which are whatever. And so all browsers are supposed to have those fallback fonts. And so you tend to see them here at the very end. And so when you see me, I usually will say Arial sans serif or something like that just to get sans serif. Although it's quite common, the more sophisticated a page is, the more likely. And the other thing that's increasingly the case is people are downloading fonts and having special beautiful web fonts, and then they download them and then they put that font in here, but then they probably still have fallback fonts. So font family is kind of a weird and unique and glorious thing that leads to some really gorgeous web pages, because so much graphic and arts work is going into making web pages beautiful, and we're going way beyond the operating system installed fonts and having pages that download their own fonts. Things that you can do is set the things to bold, italic, text decoration. Remember, links have underlines and we can turn them on or off. Font sizes are kind of troublesome in that you can set them to pixels, but then you're in danger if you get to a certain kind of a screen size or people start zooming the screen and stuff. And so you can tend to use these relative ones, but they're not as guaranteed as you might like them to be. And so just these are a little bit tricky. Absolute font sizes are a little bit dangerous. I tend to just go like, here's my font, here's the one that's a little larger, here's a little smaller if I need that. So most of the time I'm tending to do things that are like smaller. If I'm putting like a copyright statement and I don't want to distract from the main page, I'll just make it a little small. You know, I'll say, okay, make this small or extra small. And you know, what if it doesn't turn out to be that much smaller? It doesn't matter. I'm just kind of trying to so I'm not an expert in how to use those. I tend to use them as simply as I possibly can because they're not as predictable as it would be nice if they were. So links were a big part of the early web, and it's called hypertext markup language, hypertext transport layer, hypertext. And so links got really special treatment. They used to be blue before you clicked on them and purple after you clicked on them. The blue was to jump out at you and say, please click me. And the purple was to say, I've been there, because a lot of what you did in the early web is you wandered from place to place to place to places like, oh, I found a new thing. Let me explore this. And so you're always like exploring by clicking links. Once we got to the point where people assumed the web, these links didn't need to be blue and garish colors to teach us these things, because people just clicked on everything. And so it became more important to make things pretty. So we have a lot of control as to how we style links. We can say the A tag, we've already colored an A tag with just the A at the top. You can basically say an unvisited link is supposed to have the color black. After the visit, it's supposed to be gray. While you're hovering over top of it, it's supposed to have text decoration and down there and be black, white with a background of navy. And then active is not so heavily used. It's once you've clicked on the link while the page is loaded. So it's a way to kind of, you know, maybe disable it or turn it a color so people think, oh, I better wait until this next page loads. And so when I do the recording, you'll see this. It's a lot easier to see this dynamically. And so there's a whole bunch more samples that I have, and I'll record some walkthroughs of every single one of the samples. And so you can take a look at that at Web Applications for Everybody or in the recordings. So this has been a zoom through CSS. You know, CSS is quite the art and science, and it's evolutionary. I mean, people specialize in this. They're very good at it. It's a modern form of graphic arts. The basics are there, and I think every programmer who does anything on the web should know the basics of HTML. You know, they keep moving things better with things like nav tags and Bootstrap, etc. And while there will always be like edgy new things in CSS, and so sometimes you'll see CSS with like these Moz fields, which are for Mozilla, for the Firefox, but people are always pushing that boundary. And before you couldn't put rounded corners on things, but then the browsers added extensions to put rounded corners on things, and then everybody kind of agreed on that. So CSS is kind of always going to get better and better and better, because for the mobile and desktop, they really want to create as beautiful experience as possible and use standards wherever possible. And so the basics are there. You can do so many wonderful things, especially if you pull in something like a Bootstrap that just kind of cleans up the rough edges of HTML and makes it generally pretty and takes a lot of responsibility off of you. But you can certainly make a lifetime study of CSS if you like. So I hope you found this useful. I will see you on the next. Hello and welcome to our lecture on simple Django models. Now, as you've seen in previous lectures, we talked about SQL, structured query language, and that's how we talk to databases, and it's beautiful because it allows portability up to a point across databases. And we talked about all the create table stuff, and so this is just a bit of review where we can type these commands to SQLite. We run SQLite, we run a create table statement, and we do it to say .tables, so we can ask kind of schema users. We did all this in a previous lecture, and so that's basically how SQL works. And here's a series of SQL commands from a previous lecture, just kind of as review. It's pretty simple, CRUD. Now, one of the problems is as I mentioned, is that different databases like Postgres and MySQL do all this stuff identical, but then some more subtle things like how foreign keys work, which we'll learn in a bit, or how they do limits, like pulling like 25, next 25, next 25. That's a little bit different. And so if you want to build an application that talks across more than one database, you got to think a little bit. And one solution to this, also to kind of limit the fancy SQL you have to learn, I like to say that you can learn the first 60% of SQL in about 3 hours, and the last 40% is literally a lifetime. And so advanced SQL is difficult to do. It's really hard to teach a class in advanced SQL. I can teach you advanced features, but then there are so many features that you just can't learn in a class because which database you're using, and they're different for every database. So one thing that's happened in the past decade or so is the emergence of what's called object relational mappers. And that is you have the physical database layer, and then you have SQL, which is an abstraction. It's an imperfect abstraction. And then Django builds another abstraction on top of that called object relational mappers. So we just create a Python object, and we ask that to be placed in the table. Now the object may have a name and an email address and a birthday or something in it. It can have all kinds of data in that object, and then that maps into a name and an email address, and we have to tell it, like, do we want this to be indexed, and all these other kinds of things. We communicate through the ORM, so we leave the ORM alone. Now in Django, as we get more advanced, you can also sort of bypass the ORM because the way the objects are mapped into the tables is predictable. The names of the columns is predictable, and so it's kind of like it's a shortcut for. I like to think it's like the 80% of the most common things you do with a database are easily done with an object relational model, but object ORM. But ultimately, once you get to the more advanced things, you tend to not be able to do that with an ORM. You get to the point where writing the SQL is easier than using the ORM. But for about 80%, writing ORM code is way easier than writing the SQL. The other thing that ORM does is it allows you to have multiple databases because the ORM code inside of Django knows the difference between SQLite, Postgres, and MySQL. And so you could actually start an application that uses SQLite during all your development, and then when you deploy it to production, you just go like, you know what, let's just use MySQL or Postgres instead. And that's quite cool. I find them limiting, and so I want you to know both how to use objects and how to use SQL, but understand that most of what you're going to do is to use the object relational mapping, and we get a lot of power with this. So if we look at sort of the way we communicate to the database, or the way we define the database, in SQL we create a table, and that right there is portable, but once you start doing things like adding auto increment columns and things like that, it stops being portable. And so that's the way we do it. But in Django, the way we do this is we have a file called models.py, and it's in the application folder. And then we are going to use object orientation. So we're going to, from Django.db, that's a package, we're going to import models. And models is now a class. And we're going to create a class called user. This is going to be equivalent to the name of the table. And we're going to, in the definition, we're going to extend models.model. And so there's a lot of, this is called extending, it's called inheritance. We're going to get a lot of features and functionality, excuse me. We're going to get a lot of features and functionality from this code. So there's probably 20,000 lines of fancy code that we didn't write that we're using. By extending models.model, we're getting all that. And then within here, we create a couple of attributes that basically says, give me a character field. Models is a class. Char field is a method within that class. Max length equals 128, and that gives us the name. These two things are equivalent. And what happens is when we build this and we do what's called run a migration, then Django will make this table for us. But then we have this abstraction that we can use to talk to it. So this is called a migration, and so you have to be in the projects folder. And so once you create a migration inside of your Django application, then you go up into the Django project and you say Python 3 manage.py. Now manage.py is kind of like the thing that starts everything. So make migrations is actually creating files, because the idea with migrations is that you would debug your migrations like on your development environment, and then once you know, you would move them to production. So you'd make the migrations in development environment, you get them right, and then you'd like check them into GitHub perhaps. And then in production, you would pull your migrations out of GitHub, and then the migrate. So the make migrations bit, that is creating a set of migration scripts. And you can see that it's making these files, and they're actual files, and you can go find those files like 001 initial py. And then the migrate is reading the migrations and then actually changing the database. So that's the one where you might be able to make a migration, and it doesn't matter what database you're going to use. Could be your development in SQLite and production in MySQL. You would do migrate in both of those, and in your development it would make an SQLite database, and in your production it would make a MySQL database and put the tables in. And the SQL might even be quite subtle, and it will be subtly different between them, but you don't care. So migrate is the act of creating the database. Now in our development environments, we're going to be creating a file called db.sqlite3. And so if you get all messed up, you don't have to remake your migrations. They're just sitting there kind of as part of your source code. And you can like get rid of the db.sqlite3 file and then run the migrations again if you get kind of messed up. So the make migrations reads this and creates these other little files. You can take a look at them. They're kind of like Django's internal files. They're Python. It's just you're not going to write them by yourself. But then the migrate reads the 001 initial.py and then actually creates SQL commands and runs those SQL commands for us. And so if we jump, after we've done this, we see this file db.sqlite3, and we can jump in and take a look. Again, you have to be in the right folder, so you'd be in the Django_projects and then the folder of the project, but there'd be a file called db.sqlite3, go into a Linux command line, type SQLite3, db.sqlite3, and you will find a whole bunch of things. And when you go into SQLite and you type .tables, you will see that Django has a bunch of migrations that are all there from the sessions and stuff we're going to learn how to use later, authorization, etc., etc. But then the particular data model that you created, which is a user data model, there's a table in there for that. And if we use the schema command of SQLite3 and we say, hey, what is in that user model underscore user table? And you see a create statement, right? And so this is the actual create statement that the Django sent to SQLite to create the table. And I was talking about some of these things are quite predictable. The name of the column is quite predictable, ID, name, email, etc. It adds the ID field for you automatically. And most of it's portable, like this part here is quite portable, but this ID statement here, primary key auto increment, turns out that if you're in MySQL or Oracle or Postgres, or SQLite, that's a little different, but literally the migrate takes care of all that because the migrate knows that thing, and as MySQL changes, that particular syntax doesn't change very much, but as MySQL changes, then the Django stuff changes, and it all kind of works out. And so you can sort of run these commands and then sneak back into the database, and you can see what they've done, but it's all very predictable. I'm going to spill my coffee on my computer. So you can also you're talking at the low level when you run the SQLite command, but you can also be in that folder, same folder that has db.sqlite and manage.py, and then you can start what's called the shell. So this is different than the Linux shell, and you see the prompt change from $sign to three chevrons. And it's not the same as the Python shell, although it is the same as the Python shell with a whole bunch of Django libraries that are pre-mounted, okay? And so if you just say Python 3, you'll get this, but this next command that is from user model, models import user, that will fail unless you let manage.py start your shell, because again, it loads a bunch of objects and classes into your space, and then all of a sudden user model.models works, users there, etc. Okay, so this is pulling from your models.py file that you built, and so user model is the application name, and models is the models.py file. We import the user model, which is in this case a class. User is a class, and we're going to do a constructor call. And so we're going to say, let's make a new user, set the name to Kristen and the email to that email. And this actually has not done anything in the database. This creates, in effect, just a Python variable. And then to force it to be written to the database, we call u.save. And so save is a method on this new user object. Capital user is a class. We're using a constructor to construct from the class an actual instance, an object, and then we get that into u, the instance object, and then that object sits in our memory until we say save, and then it also pushes it back to the database. Now, one of the things that the save does, it assigns, in effect, a serial number or a row ID. If you look at these, they start pretty predictably at 1, 2, 3, 4, 5. But if you're getting a bunch of things coming in from a bunch of places, then the database just assigns each object, each row, and that's part of that whole auto increment thing. Come on, go back up. This whole auto increment thing that says, hey database, I'm going to put records in, I'm going to give you the name and the email, and you come up with a number, but then when you're done, I want you to tell me what the number is. And this is how you get that number, by saying, oh, print u.id. Now if you printed u.id before you did the save, it wouldn't exist. And then print u.email, you can see this email is just the data we put in, but now this is not only in your u variable, but it's also in the database as well. Okay? Now, we can dig a little bit into how this object relational mapping is working. And so if you're in the middle, you're doing things like that last statement, you can from Django DB import connection and then ask connection.queries. And then what it does is it just shows you a little bit of debug data and what it did, how it started, the fact that it ran an insert statement. And again, this looks kind of familiar. This is it's making up SQL for you for that insert, the save statement, right? That save statement there. It's making that insert for you, and then you can actually see what it's doing, right? And so this save, set up a thing and save it. You don't need to know insert into or whatever, because the object relational model does it for you, right? And this is kind of what we did before, insert into capital users by hand. And so again, you'll find this ORM is going to save you a whole bunch of time for 80% of the things that you do with the database. And so you can do basic CRUD operations with this object relational mapper. The save is the insert. You can select is basically user object values. That's like select star, so give me all of the objects. A where clause is user objects filter, and there's your where clause. This is email's a column name, and c7@umich.edu is a value in that column. Values is actually go get them, so you can create kind of a query. So if you don't put values on, you get sort of a query that's not yet executed, and then values says go do it now. So you can do a different, you can delete something where you say, and so this is a little different syntax. This is kind of a selector that says these are the variables to select, and dot delete says, the rows to select, and then delete those rows. So value says retrieve the rows, delete says get rid of the rows. And then you can, again, the same kind of thing. This is kind of like a where clause. User objects filter email equals c7@umich.edu dot update, and then change this column in a way. And you can, go retrieve all the values. And there are things that correspond to lots of the SQL, like give me all these values, order by email, etc., etc., etc. So it's kind of a one-to-one mapping, and you will, again, you're going to do a lot of programming using this ORM, Django, and every once in a while you'll sneak down to SQL. And that's why I sort of teach you the SQL first. And there's lots and lots of fields that might not actually be represented exactly the same way in the database. So for example, an email field. Databases commonly don't have email fields. There might be some databases that have emails and others that don't. But because the object relational mapper is a layer between you and the database, and you say, I'd like this to be an email field, then it can add rules and stuff like validity checking, etc., to say, you know what, that doesn't look like an email address. And so there's all of these things, and these are very useful. And later we'll talk about connecting tables, and we'll use things like foreign keys and many-to-many fields and one-to-one fields, and those are less about the data and more about the connections between tables, which we'll talk in coming up soon. And so just to give you a sort of a bit of a sense of where you're at, this is our application, right? And so we have a browser on the left-hand side with a user doing some clicking. By now you may have created a urls.py file, and that takes the syntax of the GET request slash this, slash that, slash whatever, and routes it to a particular view coming from the views.py file. You may or may not have made one of those. Templates and forms help produce output, but the models are our interaction between us and the database. And so the actual code we write in Django can talk through the models to the database, which you may not have done yet, but this shell is talking through the Django models to the database as well. And if you're starting to use the admin user interface, the admin user interface talks to the database through the models, and it's informed by the kind of things that you add to admin.py. If you want to use the Django admin interface and have your model shown a particular way, it's got a bunch of defaults, but often you want to override those defaults, and so that's what you put in. And the model.py file informs this connection between the database, and it also sort of informs the kind of code you write here in a view code in Python or in the Python shell. That's kind of the Django shell, which is a Python shell with all that stuff added to it. Okay, so this model.py is critical to defining our relationship between all of our Python code and the admin user interface and the actual database. And so you'll see a recorded demo where I go through a bunch of those things, which I kind of...
Hello and welcome to another walkthrough for Django for Everybody. Right now we're thinking about data models, and I'm going to show you how you can walk through and run this particular little example in the Django shell. So let's go ahead. We're going to Python Anywhere. I've already got a bash console. I love the idea of this bash console. This is Linux. I think that everybody should be learning Linux. So if I start my home directory, cd ... means go up a folder, ls -l. I got some folders here. I got DJ Free Samples, which I try to convince you to check out so that you can edit your file, edit my files, look at my files, use that as sample code for your own work. There is instructions on how to clone that, and so, but we're gonna assume it's already there, and follow the instructions. So we're going to go into that folder cd, and then we're going to type a git pull. And the way this works is this is in GitHub, and that way if I've made any changes or fixed any bugs in my sample code, you've always got the latest code. And I've already done this, but there is a bunch of, so, oh, by the way, I got to switch into my Django 3. I got to switch into my virtual environment. You'll notice I didn't have virtual environment. Now I do. And that's because this next command, this pip command, not Django 3. This pip command is going to change the Python configuration. And it's literally best if you do this in a virtual environment, so you're not like messing up your overall Python install on your system, whether it's your desktop or Python Anywhere. With my particular requirements. This is installing a bunch of utility code, etc., etc., etc. And is there some new? It looks like I got some new version here, and most of it's already there from a previous time that I installed all this stuff. But it's good that I ran this
to make sure that I have all of the Python requirements needed for this. So now it's done and it's installed all of my requirements. I'm going to type the clear command to kind of clear up my screen. Okay, so there we go. So then the next thing you run is this command that we run. We're going to run a lot, especially in Python anywhere, is this python3 manage.py check. And what this does is it reads through the urls.py and the applications and a whole bunch of other things, and it blows up. And so if you get no issues, that's good. The point is you do not want to continue down this other path unless check passes, because make migrations starts to make changes. So make migrations is Django reading through all of the models.py files and creating migrations. Now migrations are not SQL, they're actually Python code, and because this was checked out from GitHub, all of the migrations are actually sitting there, right? There's a way if you want to remove the migrations and remake them from scratch. So the migrations reads models.py files like vi users models.py and reads these and then creates migrations. And then the next thing that happens is we're going to actually, I'm going to get rid of my database.sqlite3. You can, that throws away your database. It actually tells you to do that right here. And then migrate reads the migrations. Migrate doesn't read the models.py files, it reads the migrations. And then it creates the database. And so it's going to create a database, and it is going to create a bunch of tables in that database. And so you see for each of the applications that I have in this Django project, it's creating a bunch of tables. And so here, for example, is users one initial. That is the table that I'm going to mess with up to that point. So now I've done all this stuff, and it's time to actually run Python manage py shell. So what this is it's like starting Django and loading all of the Django libraries and reading all the Django configuration files. So there could be a bunch of errors that happen at this point. And if they are, go back and fix those errors, okay? You can't just like, oh, I think I'll ignore those. This is what the manage py check did. It sort of did that. But now it's like you're in a views.py file, which we'll see in a bit. You can type Python commands that Django, inside Django. It's not just Python, but Python with Django and all of your Django application preloaded. So that's why it takes a bit of time to get to this point. And now it's pretty easy. So now we're going to type Python, right? Now we're going to import the user model, and that worked. And now we are going to create a new user object. So these next two commands are really important. So what that user says, name equals Kristen, email equals, that is going to create a new user model object in Django's Python's memory and give it back to me in the variable u. At this point, it's not stored in the database. So if I say, where did this store in the database? Oops, u.id. There is no ID currently, because if it was given an ID in the row, it gets a serial number basically of the user after it gets saved. And u.save says, see this u variable that I've got in memory full of data? Well, store it in the database. And now I can say u.id, and I can see that it was stored in the database at position 1, which is exactly what you would expect. These numbers are pretty simple. They start at 1 and they go up, and we'll see as we do a few more folks. Let's put a few more folks in. we reuse the variable u. I'm just going to copy and paste all these at the same time. And now I can say u.id for where u.name is Sally. That's the last one I did. And then u.id is 5. It's the fifth one. So now I have 5 models that have been persisted, stored in my database. Now if I want to retrieve those, user objects. So user is the name of a model. That's actually a class. Objects is a attribute in there which has a method of values. So I can get back all the values, and you see what I get is what's called a query set, but in all intents and purposes it functions like a list, and then in that list there is a series of objects, and it looks exactly like the data that I put in, but it pulled that from the database. And the thing that's in there now is the ID is now in there. So this data has a primary key for every other one of the rows that I put in there. And so I can say that. So I can add a filter. And so you'll see this pattern where user objects, and then I sort of throw these things in, and then the dot values comes at the end. And that's because filter is a method that returns a thing that has a method. So this is the values method that the filter returns. And you can just keep putting these together. So I can say this is like a where clause in SQL. So this basically says give me only, and it's a query set, so it's a list, but there's only one object. Now, there could have been more than one because we don't have any uniqueness constraints on email. There could be more than one record that matched email c7@umich.edu. You can delete, so this is basically let's go grab that record, but then run the delete method on that model object, model instance. So this will get rid of the TED record. We can go retrieve all of the objects, and we can see, oh, there they are, but there's no TED. There was a TED before, and now there is no TED. We can update. So let's check this one again. Let's grab that and pull out. So we're going to change this name here. This is in the database, and so we're doing CRUD here. And so we're going to update, create, read, update, and delete. And update's the last one we got to do. We deleted. And so again, we're going to grab all the objects. We're going to filter them down with a where clause to the ones where email c7@umich.edu. And then we're going to set new values. And so if I now say, what is this? Well, the name has become Charles. So it switched from Chuck to Charles. And it's in the database, right? This is not just in memory. This is Django writing all this stuff to the database. Now, just a little bit more, and you can go read up on this, and we'll have lecture after lecture and all kinds of example codes, but you can sort of sort this stuff by email ascending. So A, C, Colleen, CVL, and then K comes later, or we can descend. We can see them descending. So did I get that wrong? Oh, that's in descending order by name. So S, K, C, CO, CH. So they're descending by name. So that gives you just some of the kinds of things that you can do in the Python shell. Let's say quit parenthesis here. Yeah, there we go. Okay, so I hope that you found this this Django for Everybody walkthrough useful. Cheers. So the make migrations is what reads the models.py files, and then it creates what are called migrations. And the key thing is this is guided by the list of applications in settings.py. So if you make a new thing and make a new application, and you edit the models.file and you try to run and make migrations and it doesn't see anything, you're like, what did it just do? Well, did you edit your settings.py? Because there is a thing called installed apps in your settings.py. Now, migrations are portable across databases. This means that the migration is a logical description of what the tables should look like. And they're an evolution. What they mean is like the first version of this table from the first models.py when migrations was first run is 001. And then if you change models.py and you run a migration again, it looks at the changes from the migration 001 to models.py and then 002. And then 002 is not like wipe it all out and start over. It's like oh wait, you just added one column, I'll go ahead and add that column. But it's not done it in a way that's actual SQL. So migrations are themselves kind of Python-like, and they're portable across databases, which means that you might on your computer use SQLite, and in production you might use MySQL, and the migrations are the same for both of them, because they're just saying, here's the columns, here's the types, here's what they're supposed to be. Now, contrast that with a migrate command. The migrate command reads all the migrations and then knows what database it's talking to and runs the SQL commands to create the necessary tables and or evolve the necessary tables. So it looks and says, oh, here's the first migration, here's the second migration, here's the third migration. I'll make the table, I'll change the table, I'll change the table, I'll change the table, and at the end of all the migration, the migrate then goes through all the migrations and then has a database table that reflects the sum total of the migrations, which also reflects the latest the latest models.py file. So it's a little complex. It has to do with database portability and the fact that we want to separate out the portable parts of this from the non-portable parts to this. So if you look at the make migrations, and here's in DJ free samples, my little sample stuff, there's lots of models in there. And if you take a look at all the models.py, you see that for every application in the DJ free samples project, you see a models.py file. And that's a Python code, that's class, book, blah, blah, blah. That's very portable, and that's how we, in our Python code, in our Django code, see the database model. And when you run the make migration, that produces these migrations files. And they're just in like autos migrations, 001 initial.py, etc. And so you see some of the ones I have here, there's actually two of them. So it sort of made the first one, and then I must have changed the models file, and then I ran make migrations again, and it showed, it recorded how that model changed from the first version of the models file to the second version. If you can look at these, don't edit them, you can check them into GitHub, but don't edit these. But take a look. They're a very portable representation. They kind of look like the models.py file. You're not supposed to change them. You're supposed to generate them with make migrations. And again, those can go into GitHub. Now, the migrate basically reads all those migration files. And not just one, but if there's a sequence of migration files, it applies them all in order as needed. And if the database has the first and second migration applied, but not the third one, it knows that and says, you know what, I'm going to just tweak this database that already exists, that's already running, and then add a column or change the width of a column or whatever it is that you've asked to be done by editing your models.py. So when the migrate is done, you then end up with a whole bunch of tables in your database. And they're all based on the name of the application and the name of the model within the application. And so somewhere in here is book one book, book one instance, and book one lang. They're all sitting there. And so those are all the tables. And we took a look at those tables before, but that's the migrate. That goes from all the little migrations spread across all of the applications in this project and then puts a database together that has all those things. And I keep saying that the migrations are all about evolution, right? Because if you take a look here, you see one little table called Django migrations. And what Django's doing in that Django migrations table is remembering which of those migrations have already been applied to this database. So as it's going through the migrations, it says, oh, here's one that's not yet done in this database, so I got to tweak the database just a little bit. So it remembers the migrations that have been done. It's pretty fascinating, and in these little tiny applications, we don't always need to be so clever about that. So sometimes what you want to do is just like, I'm confused. I'm going to rerun the make migrate. Because you're not really running production, you're just really doing it over and over again. So you can rerun the make migrate. And the way you do this is you basically simply delete the file. You can delete these files. I would delete all the ones that start with 0, right? If you're going to rerun make migrate, just rerun make migrations. Delete all the ones that start with 0. And this is in application, migrations, and then get rid of all these. And then you can rerun the make migrations. And it will read your models.py file, and then it will do all of the necessary things to recreate the migration file. Right now, that's not the database. That is the instructions on how to create the database. Okay, so that's how you rerun make migrate. You can run migrate from scratch. This is actually easier. So you can kind of wipe out the migrations for one application, and I did that, just wiped out the book 1 here. That's what I did and started over. But you can wipe out all the migrations and all the database and everything by just removing the file. In this case, because we're running SQLite, just wipe out the file rmdb.sqlite, because after migrate, that's where everything ends up, is in that file. So then you wipe that out, it's gone. Now you might have created an administrator account or something, and you're going to wipe that out too. You're going to wipe the data out, you're going to wipe the tables out, it's all gone. That's one thing I like about SQLite. You remove this one file, and it's literally all gone. And then you rerun Python manage 3 migrate, and it reads all the migrations and makes you a nice, clean, perfect, empty database. So if you're kind of stuck, and you're not afraid of losing your data, which in most of the beginning programmers, it's okay to wipe out your SQLite thing and run migrate again. Just go ahead and try it. Like I said, if you made an admin account, well, you got to make it again. But that's the worst that you can do. So at least in these beginning applications.
Hello and welcome to another Django for Everybody walkthrough. This walkthrough is the 04 Model 1. This is a walkthrough where we're going to talk about one-to-many models. And this is a situation where you have 2 tables and there is a one-to-many or many-to-one relationship between them. And this is all in my Django for Everybody DJ for eSamples. You can track it's public, you can check it out, and it's in the tracks project. So I'm going to go into DJ for eSamples, CD tracks. So here's so I've got tracks, I got the tracks model, cat tracks model, models.py. So this is a model. We went through this in the lecture where we built this model. There's an artist, an album, a genre, and most of these are kind of simple. These are kind of, this artist is no different than the artist is no different than a single table, but this album is related to, and this is where this foreign key comes in that says there's an artist field inside the album table that points to a particular artist in the artist model. Okay, so it's the artist that belongs to this album. On delete, set null, that basically means if an artist gets deleted, will the album get deleted? And null equals true means that we allow this to be empty. We allow there to be an album without an artist. That's what null equals true here. On delete means if we delete an artist, do we delete all their corresponding albums or leave them? And this says if an artist gets deleted, we're going to sort of clear out the artist in the album table. The genre table, again, just has a single field. And the track table has 2 foreign keys, the album foreign key. And what we're going to do here is if we delete, on delete cascade means if album gets deleted, we are going to delete all the tracks. And on delete equals set null for genre means if like a genre like rock and roll gets deleted, we're not necessarily going to delete the track. We'll just have a sort of an empty genre here. So that's what this on delete. It's the on delete of an album entry or a genre entry and how it affects the track entry that we've got. Okay? So we've got this put together here, and we're sitting in here, and we've got our model. We could say Python 3 manage.py make migrations, but since I checked this out of GitHub, the migrations are already in there. And then if I say Python 3 manage py migrate, it'll actually do a bunch of work and make us a database, including all of the tables that are part of the tracks model. So now if I have a dbSQLite 3, and if we were to take a quick look at that, like SQLite 3 db.sqlite, and we say what tables, we'd see there are all these tables, tracks model, album, genre, and track. And if I say like schema, tracks model.track, you'll see that it's got some indexes, it's got these things, it's created a bunch of SQL that represents that model. So we'll get out of that for a bit because we're not really here to do SQL. We're here to do the object relational mapping. So we're going to start the Django shell. And again, some of these Django shells have different user interfaces. Some of them have arrows. This one here has this little prompt. And so we're running Python basically. So we have to import our models. This tracks model.models, that is sort of in our Python, and the manage.py knows how to set the paths up. So we're in the tracks project, and we're getting to the tracks model application.models, and we're importing 4 models. Now these are classes that we're now going to start making some objects. And we start by working from the farthest out leaves of the tree and working inward. And we're going to store all these things in, I'll just grab all 3 of these. I think it'll paste pretty nice. Yeah. So this creates a new artist in memory with the name of Led Zeppelin. And then I'm going to have this in the variable Zep. And then I can send it to the database, save it, and say get the ID, which was the primary key that was assigned to this, as 1. Now, later I'm going to use this variable because I'm connecting models to each other. So the next thing we're going to do is, and the names of these variables are just variables. Sometimes I use mnemonic ones, sometimes I use silly ones. I made an artist called ABC for ACDC, but the variable is ABC. Be careful, this is just a variable in Python that we're using. This ACDC is data we put into the, if we do abc.id, oops, we get a 2. Okay, so if we say, well, how many artists, what's in the artist table? This at this point is just a single table thing, and we can sort of see what the primary keys, those ID fields are the primary keys that were assigned. And so the next thing we're going to do, this one here is the tricky one. So we're going to create an album. Now albums has a title, which is just a string, but it has an artist field, which is an artist. And so this is who made who, and the artist is ABC, which is this variable, right? This title could be a variable too. This variable is an artist object, right? And so we're saying connect this album to AC/DC, right? That's what we're saying. When we made AC/DC, we retained that object and its ID in particular, and we're going to make an album and connect it. Then we have to save it, or it doesn't go in the database. And then we're going to make a Led Zeppelin 4 album, and we're going to give it a title and use this variable Zep, which we created up in here, and then we save that. So we've got, if we take a look now, we say what is in our album table? Album.objects.values. What's in our album table? So we type that, and we see that we've got 3 albums, and you see this field here, artist_ID. That is a convention that says that's the ID key in the artist table. That's a foreign key. It's in the album table, but it points to a key in the artist table, so they name it artist_ID. It's a common pattern in object relational mappers, and as a matter of fact, it's common pattern for people who use SQL to use this pattern. So it just signals right away, I can look at this and know on hundreds of database tables what that means. That is, oh, that's a foreign key into the artist table just by the name of it. It's a convention that the Django object relational mapping enforces, but a lot of people follow the convention even if they're not using the Django object relational mapper. But we now have 2 objects, and they have connections into the artist table. So this is the important part. It's the part you should understand, where you're creating a foreign key, but when you're doing this new album, you got to have this variable present. It's got to be there. Okay? So let's make a new genre. Let's make 2 genres. And again, these are just variable names. So I've saved those. I could do genre dot objects dot values. And we can see what we put in genre, but that doesn't surprise us, right? Okay, so now we get to the big deal right here. So we are going to create the track, and the track, if you recall, the track has two foreign keys, both a genre and an album. So when we create our first track, the album is the variable ZEP4, which we made right here, and the genre is rock, which is the variable we made right here. Okay, and so that's how we indicate that the genre is rock. And we do that. The title, rating, length, and count, they're just standard fields in this. And then we say x.save. Boom. And then we got these other ones. But the pattern is the same. They're just, when we have foreign keys, we're referencing variables that are themselves the right kind of object. Album equals ZEP4. That's an album object. Made is an album object. Made is an album object. Met is an album object. A genre object. And rock is a genre object. So I got these, constructed correctly. That's why I gave them to you and didn't make you type them. And now we can take a look at all the tracks we've got. And so it's a little hard to see, but we've got a query set, which is a list. The first object is ID 1, Black Dog, rating 5. Count, album ID, first foreign key, genre ID equals 1. So those are the pointers into the primary keys of the album table and the genre table, respectively. And if you go through this carefully, you see the second one, ID 2, Stairway to Heaven, ID 3, About to Rock, ID 4, Who Made Who, rating, with an album ID of 1 and a genre ID of 2. And if you carefully get it right back, you know that the AC/DC things were metal and the genre is rock. Okay? So now we have set things up, but now we can also look things up. So let's just say we're going to grab that one with a primary key of 1. That's going to be Black Dog here. Track objects get primary key of 1. So that's the variable first. And I can say first. And that tells us it's a track. If I say print first, it uses the stir method, and then it gets to the Black Dog. Okay. Now the stir method is __ stir method is what decides which of these fields shows up when we print that out. That's why the stir method is important when we're defining models. Now we can say print first dot ID. We can say print first dot length GHT. Got that right? Oh, then GTH. Okay. But we can also print first dot genre, which is rock. We could be even more clear to say first genre name. So first genre is a genre object, and name is an attribute of the genre object. We can say print first dot album dot artist dot name. So that says first is this object that we've got, which is this object of the track Black Dog, and then album is the album associated with that track, and then artist is the artist associated with the album, and name is the attribute of the column in the artist table. Okay, and so this is an object. First is an object. Album is an object within first, and artist is an object within album. and then name is a column within artist. Okay, so I hope that was interesting to you, so that you could see how a one-to-many data model could be worked with and used. Hello and welcome to another walkthrough for Django for Everybody. This is kind of a supplement to Tutorial 2. In Tutorial 2 you're playing with models.py, and if you go through the tutorial they'll have you do a thing and then they'll do another thing, and they're kind of showing you migrations and how the migrations happen. And if you get them to have a mistake, if you make a mistake, then you can get to the point where you need help or whatever, and sometimes it's easier to just like wipe out your database. But if you've added a question or added some choices or built models, you got to do all that stuff. But it's sometimes just easier to reduce some of those things. So I'm going to show you what to do if your model/database gets messed up, and like your manage.py make migrations and migrate are not doing what you think, or they're giving you weird errors. Now if they're getting a syntax error, make sure you do a Python manage py check right before you declare that your database is messed up. So let me go into my go into my site. So here I am. Here's all my files. So just so here I should do it before I declare that the database is a problem. Manage.py check. Oops. Oh, I messed that up. I'm in my virtual environment, of course. Okay, so we got no issues now, so that's good. So I got a couple commands here. Let me explain this. Before I'm going to actually delete these, I want to show you where the migration. I probably showed you this. So I have a thing called polls 2, and I got all the polls running. So this is like in tutorial 2. The migrations are in files with a number, and they're Python files. So if you recall, migrations are portable representations of what happens in the database. And then the migrate creates the file db.sqlite. So you need, if you want to really start over, you got to get rid of both the migrations and the db.sqlite file, and then you can start completely fresh. You can sort of do parts of them, but I'm like, if you're messed up here at tutorial 2, it's probably easier to just get rid of them both. So at this point, my application is going to stop working. So I get rid of the migrations, and then I get rid of my database. And so at this point, the only thing I got that has to do with anything to do with my database is a few models.py files. And this is where we are editing our code. And so this polls to models.py, in my particular example, is the code that's going to be effective, because I got all the versions running at the same time. That's why you're seeing this. So the next thing to do is Python 3 or Python manage.py make migrations. So what make migrations is doing is it's reading all these models.py files, and it's writing this file. So I got rid of that file, but now if I do an ls, you'll see that it's come back. And sometimes you might see an 002, etc., and then you throw it away and you make it fresh, and you should only see an 001, and then you can say Python manage py migrate. And then that, well, if you do an ls, let me control C there. If I do an ls, you'll see that there, oh, wait a second, how come that, oh, the db.sqlite 3 is 0 size. So I'm going to do Python 3, or Python manage, sorry, my Mac, migrate. So that's reading these files, plus a whole bunch of other ones, and actually creating databases. And so now if I say ls-l, my db.sqlite 3 is back, and I might have to create a super user. If I created a super user account, then I'm going to have to create one again, right? And so I'm going to do that. J4E, chuck, sev at umesh.edu. I should make my passwords easier to type. Now at this point, things should start working. But again, if I created any data, like a question or something, it was gone. It was gone at that moment. When I got rid of that database, DBS QLI3, it is literally gone. So it's gone now, and away we go. And so and again, this is just if you can't seem to make these migrations or migrates work, back up, start over, and then redo some of the work. And that probably will be a good way to get things done. Cheers.
Hello and welcome to our lecture on data modeling. We're going to have a couple lectures on data modeling. This first one is sort of the one-to-many, which is the easiest to understand, and then we'll have another lecture on many-to-many. Just to give you sort of, we're still sort of building a Django application one piece at a time, and we haven't built a whole Django application. But basically, we're really focused on model.py and a little bit more on admin to inform. So model.py is where we define the structure of our database, and we see this database through data models, data model objects, and we can register our data models in admin.py. There's not too much in this admin.py. But so we're going to be talking to things like the shell, or you can even run scripts in here. So the whole thing in this lecture, we're not talking much about the routing or the views or forms or templates. So we're really focused down in this area of our Django application. And it's okay, we'll get to the rest of them. And we're just kind of talking about the data modeling now. So I came to databases late in life. I saw them a little bit in grad school, which is a very long time ago, and I didn't like relational databases much. And I went to a job, and I had to learn relational databases for the job. And luckily, I actually was pretty advanced programmer at that point in time. And so they taught me how to do data model design, and I picked it up really fast, and I totally fell in love with databases. And so model design is a interesting problem to solve. The basic idea really comes down to efficiency of storing and retrieving data. And it just comes down to if you build an online application like Facebook, and if you're not clever about how to store your data, and somehow every time you logged into Facebook you had to read all of Facebook's data to find you log in, it would really literally take you 2,000 to 3,000 hours to log into Facebook if it had to read all of its data. Now obviously millions of people log in per second in Facebook, and so obviously they're a little faster than that. So somewhere between days and days and days to read the data, and can read the data a million times a second, in there is where databases win. And so at times it seems like when we're building a data model, you're like, oh, this is so difficult, why are we working so hard? And the answer is you just can't scale. I mean, you can read through your data for simple data mining things, but databases are really important. And especially when you're building interactive online applications, speed's important. So it turns out that like most things in database, you can learn the basics pretty quick, and the rest of it is sort of an art form that you learn as you go. And so the goal is to figure out the data that you want to store in your application, and then draw a picture spreading that data across multiple tables and then creating links between those tables. So you kind of start with a sample data set. Now this is where we're going to end up, and this is the model for the data for this local library application that we're building, and this is the thing we're going to keep coming back to over and over. So this is the destination, but we're not going to hit this destination. We're going to start more with the data. Now different applications, when you work at different organizations, you're going to find that the data model is very important. So this is the data model of my auto grader, which is based on a framework I built called Sugi. And so if you were to learn this thing, early on I say, oh, and here's our data model, and here's how we store stuff, and here's this, that, and the other thing. And this data model took a lot of time to get right, and it's a real important part of the application. And another project I work on is called Sakai. It's a learning management system that's open source.
And this is a tiny fraction of the data model, but if you want to work in this application, you want to improve something or add a feature, you got to figure out this data model, because where the data goes, it shows up kind of flat in the user interface, but eventually it's stored in very specific locations and linked. And that's why you see all these little boxes, but then lines. The lines are also the links between the various tables. So there's a whole bunch of theory about database normalization, and it's important. It really is. And if you take some time, go ahead and read about it. First normal form, second normal form, third normal form, version A and stuff. I'm not really into the math. I don't really want to explain the math to you. The key thing about database normalization, ultimately, that it can be sort of distilled down to: don't replicate string data. And what I mean by string data is like names and URLs and things like that. So in a system, ultimately, if my email address is stored in text in that system, it literally should be stored once. There should be no email address, email address, email address. What you need is to have the email address one place, and then kind of give that email address a number, and all the places you want to indicate about that email address, you use the number. And so these integer numbers are the key. So we create keys, which are the lookup handles, and then we point to those keys. And we use integers to make links between the tables, because integers are fast. They're the thing that computers understand better. Computers understand and move integers around. They use less data, they calculate, they compare really fast. And so integers are very important. So now let's design a data model. Usually you start out with a user interface that, if we're going to build an application, you're going to end up with a user interface. In this, I'm not going to really start with a user interface. I'm going to start with like a spreadsheet view. And if you've ever done something like tried to organize your music collection with a spreadsheet, or a video collection with a spreadsheet, or you find that spreadsheets are super convenient because you can scroll around and do stuff, and you've learned SQL, you can go into various cells with SQL, rows and columns, and update and do all this stuff. But you find that after a while, you start repeating yourself in spreadsheets, and you find it's really difficult, because it's really easy when you're putting data in to copy, paste, paste, and put the same stuff in. But then what if you want to change it? And this is where this vertical replication, or the replication of data in multiple places, is very bad. So here's kind of an exploded table view of that same data. And it's okay. This is the data that we've got to do. And so if we look at the use cases of our application, what we see is there's a series of books. Like in this course, Wisdom of Crowds is a book, Introduction to Networking. These are all books coming down here, Unlocking the Clubhouse. So the first column is titles of books. The second column is the ISBN. And then we are sort of keeping track, because we're a library, and so we might have more than one book, and we're going to call those the book instance. So instance 1, instance 2, instance 3. Each book, each physical actual book, so you might have no physical books actually, or you might have one physical book or 5 physical books, and each physical book might be checked out and have a due date. And so we have a status. And then we have something like, say, the language of the book, or the genre of the book, or who wrote the book, right? And so that's kind of the data we're going to represent in this application. Now, when you're looking at this, the first thing you do is you go like, anything where you've got vertical replication is a problem. And so you've got to be careful. So you look for vertical replication. And the places that are problematic in this table view of all of our data, like the status, the language, the genre, you see the word think. Those are strings, right? They're not numbers. Okay, Wisdom of Crowds, Wisdom of Crowds, Wisdom of Crowds. And the problem here with Wisdom of Crowds is that there are 3 instances of the book, but then because we've got this all in one table with just a bunch of columns and not multiple tables, well, we have to replicate the name Wisdom of Crowds 3 times so that we can represent the 3 instances. The same is true about the English language and the genre and the author name, right? These are the same authors. Okay, so this vertical replication is your first clue that says that you've got to come up with a smarter data model than just this. And so the idea is you're not allowed to put something like the string EN, English, in more than once in your whole database. So what you have to do is you have to split this all out. Somehow you have to remove duplication by making a language table, a book table and an instance table. And so in the book table, you only put Wisdom of Crowds once, and you only put the English language in once and Spanish in once. But then the problem is, okay, somehow we've taken this data, moved it from one big long bunch of columns to 3 tables with sets of columns. But we still have to represent all the original data that we were working with before. We have to represent all that stuff. And so this is where we have to be able to make connections. And this is the essence of relational databases, and that is they don't replicate data, but they make connections from one data item to another data item. And so what we're going to do here is, in the case of the Wisdom of Crowds, we are going to have 3 book instances, but somehow they all point to one book in the book table, right? And so we have 2 books that point to the English language and one points to the Spanish language. Now this seems like, wow, that wasn't such a big deal, but when you do millions of records, it actually matters. It's the string data that gets you in trouble and requires far more scanning and far more storage. And another thing that happens is when you follow this rule of only one copy, well, what if we wanted to turn this to uppercase EN or something? That means as long as the data is linked rather than replicated, that means you're only changing one copy, okay? So the replication has a performance advantage, has a storage advantage, and it has a modifiability advantage when there's only one place. If we mistakenly misspelled the title of Wisdom of Crowds, it's easy, we fix it. It's not in these other tables. Whereas if we misspelled the Wisdom of Crowds here, we have to go find on the top one where it's just all one big long spreadsheet. We got to go and like do a search and replace. But what if that's in a different column? And so the idea of getting to the point where we have unique rows and we connect those rows. Now, I haven't told you much about how this magically works. I just said we can draw some arrows. And so by drawing those arrows, we got to show you how those arrows get drawn, because that's really important. So this is how you start drawing the picture of your database. And so the kind of relationship we're going to have between tables is like a many-to-one. So when we say many-to-one, what we're saying is that there is one English language entry and then there are many books that go to it. So that's a many-to-one relationship. So it could be just one, but it's many. And if we look at the data model that we see from the Django example from the Mozilla Developer Network, we can look at this and we can see here, right? This connection between the book table and the language table has 2 ends to it, and it has a direction to it. And one end says 0 ... asterisk, and the other end says 1. So this is many. 0 ... asterisk means a number between 0 and infinity, including 0, which means it's possible for a book not to have a language. We call that null in database concept. So there's a book with no language, or many books can have one language. So there's one language, English, and there is as many books as we want, including potentially 0 books, right? So we might have a language that has no books in our library with that language, and that's okay. So in this one, between book and language, it's okay to have 0. So 0 through infinity on the book side of the relationship and 1 on the language side of the relationship. If then we look at the relationship between the book and the book instance, now remember what the book instance purpose is to record the fact that we have the actual physical copies of the books that we have. And so we might have multiple copies. And so if you look at this, it's pretty much the same in that there is any number of book instances from 0 until infinity. And you could have a book in your book table for which you didn't actually own a physical copy, and that'd be okay. We would know things like what its author was, what its genre was, etc. And then we would buy a copy of said book, and we'd add a copy to the instance table, and then we'd link that into that book. So again, you can have 0 book instances, 0 through infinity book instances mapped to a single book entry. Okay, and so this little legend, 0 to infinity to 1, is how we read this table. And you will see database tables that have different syntaxes, but they all are capturing the same thing, and that's the cardinality. So now what we're going to do is we're going to talk about how we can represent links in a database. And so up till now I've just been drawing arrows and just assuming that you know how to do them. And so here's some arrows, right? We got some book instance rows that can somehow magically connect to some book rows, and some book rows that can magically connect to a language row. And so there's a way that we do this, and we put what we call a key column in every one of our tables. Key column. We call this the primary key, and we often call the name of the column the ID. There's a way in the database to make it what's called auto increment and primary key, and you index it so it's really fast. And so that then becomes the handle. The primary keys are like the destination endpoint of the arrows, right? So that's how we say English becomes language number 1, and Wisdom of Crowds is book number 1, and Introduction to Networking is book number 2. And so the ID is something that we then can use throughout the rest of the system. Integer replication is not a problem, okay? And so then what we do is we put columns in that we call foreign keys, right? And so those foreign keys are the starting point of the arrows, right? So book underscore ID. Now by convention, we name these by the name of the table followed by an underscore followed by the word ID. These are called foreign keys. Foreign keys. And so by having a foreign key everywhere we need to start an arrow and a primary key everywhere we need to end an arrow, now really we pretty much put primary keys on every table so that every row of every table has a primary key. Now in this example, I've just got one foreign key per table, but you can have more than one foreign key per table. There could be another column here that points off to another table. But that's it. That's how we do it. We just simply add these integer numbers, and then we kind of maintain them and put them all together. So like I said, the primary key is that column that we add, and that is our handle for the rows. And then the foreign key is the column that we add to a table so that we can point to something. So basically, once we create these foreign key columns and the primary key columns, we start being able to build, using these links, we can build the links that replicate the data model that ends up being our picture, okay? And so that's how they work. So we've talked about how we reduce replication by moving data from sort of one table with too many columns into multiple tables, and then make links with primary keys and foreign keys. But we're really not going to operate at that level because this is a Django class, and we're going to do this in Django. And so we use data models in models.py to do this. And so a lot of the model field types are characters or numbers or dates or long text fields, etc. But some of them are special and used in this one-to-many, foreign key, many-to-many fields. These are the fields that we use to do the linking in our Django data model. And so we'll take a look at how these all work. So if we have our book instance that links to our book table, and then our book table that links to the language table, we end up with special little lines in our models. So most of this is pretty familiar. We got a language, it's got a name. Now one thing about Django is it automatically adds the ID field, and that's kind of nice. So you just assume that everything inside of a data model, every one of these three tables are going to have ID fields. And we don't even talk about the name of the foreign keys, even though Django names them the way I just showed you with the lang underscore ID. We have just a regular old thing, so lang is suitable as a destination for a link because it has an ID column automatically added by Django every time. The book table has an ID column, so it's suitable for the destination of a link, but then title and ISBN are there. And then there's this language, and that's the first one. And so this is where we're actually modeling the need to have links between the book table and the language table. So we're starting at the from, or the start of the arrow, and we're saying we need to have a language. But the language is not a string, it's not a number, it is a foreign key. And it's a foreign key into the table called lang, and this table called lang matches that table. And then we have a couple things. I'll talk about on delete in a second, and then null equals true is whether or not it's required. And so what it's saying when null is true is we're allowing emptiness. So that means it's possible to have a record in the book table that doesn't have a language. And so that's what we're saying when we're saying null equals true. The instance table points to a book,
It's a foreign key to the book model, and it has a do back. Now the status was in there, and so I sort of shortened it a little bit, but we have a foreign key that points into it. And so again, we're defining where we have the beginnings of the arrows, because the ends of the arrows is kind of implicit. Django gives us sort of the primary keys for each row in these models automatically without us having to say it. But you can put it in a Django model if you want to override the name of it, but if you just want a column called ID, which everybody pretty much does, you just leave it out and Django puts it in for you automatically. Okay? And so again, you see this from the point of view of the data model, where we have the arrow between book and language, that's a many to one, and then a book instance to the book is a many to one as well. And so those foreign key links represent the arrows in this data model. Now, just to sort of review, you might have done already some of these migrations. So once you edit these data models and you get them right, you have to do a two-step process to get them so that your database reflects these models. The first one is you have to make migrations. And so the way the make migrations works is it looks through all of the applications that are registered in your settings.py, and for every one, it checks to see if the data model has changed since the last run of make migrations. So make migrations actually creates files in your application based on the models.py. And it's a series of files. Like 001 here, that's the first one. There might, if we changed it and then run make migrations again, there'd be an 002. And what it would do is the 002 is evolution up beyond the 001. Now the migrations are portable, okay, in that they're not specific to the MySQL database, the SQLite database, etc. Now the migrate reads those migrations and then updates the actual tables in the database. And so the migrate is mapping the portable representation of what's supposed to be in the database into the actual physical representation in the database. Now you'll notice if you run these both twice, once they work, they'll say no changes detected, because in the case of the make migrations, it looks at your models and then looks at what's in the migrations already and says it's a perfect match. And then in the migrate, it looks at what's in the migrations and what's in the database table, and it says everything's there, everything's been done. So this can be confusing, because in my documentation I'll say run a make migrations and you say no changes detected. Now there's another reason why you might get no changes detected, and that is that you have to add it to the settings.py file before you can, it's going to be detected. So you might have edited a model.py file and changed it, but if it's not, the application is not in the settings.py, then it won't be detected. So the make migrations is reading through all the applications listed in the settings.py, checking for differences, deviations between models.py and the migrations. It might be a little easier just to show you these things. That's coming up. I'll show you those in a second. If we look at what the migrate does, the migrate creates the SQLite file. And so we can take a look at this file. You don't have to, but you can take a look at this file after you've run the migrate. And you see so I have a tables book 1%. That's actually a wildcard, because the like statement, that's like the like statement in SQL. So that says, show me all the tables that start with book 1. And you see that there's 3 of them, book 1 underscore book, book 1 underscore instance, and book 1 underscore lang. Book 1 is the application, because Django has project and then applications within project, and book 1 is the application that we're doing. And then instance, book, and lang are the 3 models that we've specified in our database, in our models.py. So if we take a look using the schema command of book 1, we can see how the migrate statement produced the table. And so we created a book1 underscore book. It has ID, auto increment, all that stuff from the SQL stuff. It's got a title, it's got ISBN, and then it's got this lang ID. That's the foreign key. So it's actually building the foreign key the right way. Now in SQLite, there's one way of building foreign keys. In MySQL, there's a different way of building foreign keys. And so that's all something that the migrate operation understands how to build. And if you look at the language, you just see that there's an ID column that's automatically produced, and then a name. And then if you look at the instance, you see an ID and a dude back, which is date. And then
and then you see the book ID, which is the foreign key into the book table. And so you can kind of see how these tables implement the links as described in the picture. Now, I was telling you that about this on delete. So the problem is what happens when you have a row in one table, like in the book table, that's pointing to a row in a language table, and you got records that are pointing there. So you've got two books that are pointing to English in this situation, and then you delete the English row. What happens to the rows? And there's a couple of different things that you can do, but the two common things is cascade, and what cascade says is that you're going to delete all the rows. If you delete those rows, you're going to delete all the rows that have the matching language ID. And set null basically instead says, oh, that's okay, we're just going to wipe out these and make them null. And in this in this language, if we delete a language from the language table, we probably just want to set it to be null. Okay, and so if you look, you'll see that the relationship between the book and the language, which is right here, if we delete one of these things, we set it to null. We set the corresponding language to null. We just throw away these links in a sense, and that's okay, because books are allowed to not have languages. Okay, and so languages are allowed to be null. Null equals true. Languages are allowed to be null. But if, on the other hand, we get rid of a book from our books table, then we probably want to wipe out all of the instances that are related to that book. And so that's why we in here say on delete cascade in the book foreign key entry. And we don't say null equals true. And so set null requires you to be able to say null equals true. So you have to say, I am willing to allow nulls in this column. Oh, and by the way, if the thing that this column points to is deleted, then set it to null, which means don't delete the row. Cascade means if the thing we're pointing to is deleted, then delete this row, because we don't want inconsistent data. We don't want those little things pointing off to absolute. So now we're going to take a look at the kind of Python code we can write to manipulate these data models. So to do this, we're going to use what I call the Django shell. Now the Django shell looks a lot like the Python shell, except that there's a whole bunch of stuff preloaded. You can't just run Python 3 in interactive mode. You see the chevron prompt. On Linux you see a bracket prompt. It's the same shell, but in the Django shell, what happens is actually reads the settings.py and goes and finds all the applications in settings.py and preloads the applications and then gives you a shell. So it's like there's a bunch of things that happen that's not just a shell that are done before you're in the shell. And this statement of from book one models import book lang instance, that wouldn't work if you just ran the Python shell by itself. That's because the book one application was loaded by Python 3 manage.py shell. After that, you've got all these things preloaded, but then you can pretty much run any Python that you want that messes with all of your Django classes and objects, etc., etc. So let's take a look at the kinds of things that we can do. So if you remember, our data model was named lang for language. And so we can create a new object in memory with lang parenthesis name equals quote en quote. And that basically says, give me a new language object and set the parameter, the attribute name to be en. And give that to me back in a variable. That's an object-oriented constructor. We're constructing an object. Now that doesn't store it in the database. That simply creates it in memory and gives it back. So it's a Python object with an attribute. It knows it's a language. Now the save method, z.save, that is the thing that says, you know what, I've got this thing in memory, please persist it to the database. Write it, transmit it to the database, and come back. Now what's cool about that is this ID column, that's been set at that moment. So we can say, what ID did we get? So remember how every row that we put in a model gets an ID value, and we're going to use that ID value as the handle to point to. So this is the primary key, which is the way we point to a row in a table. So then what we can do is we can make a book, right? So we made a language, and we know what its ID is. Now we're going to make a book, and it's got like a title and an ISBN. And what we do is we say, and the language is Z. Now Z there is that variable. Now we don't use the ID. Django knows all about how IDs work, and so it knows when you're saying lang equals Z that it's going to make a lang ID and put the
ID of the language row in, foreign key, all that stuff's just done. You just have to have a variable that has an ID value and pass that in. So what that's doing is that is making a book and then connecting it to a lang, right? Now that's also not saved until you save the book. The book is now transmitted to the database. It has a foreign key in it. It gets its own primary key, so it's primary. It's the first book that we've inserted, so its primary key x.id is 1. And then we can make an instance, and the instance needs a due back, which is a date, and then it needs which book it is, and we use that variable x to indicate which book that we're talking about. So that's just creating a link from the book instance in memory that we get back in the variable a. It's a book instance that points to the book it's in the variable x, which is py for e, ISBN 42. And then we save that, and that has an ID. So now we have created a language record, then we created a book record that linked to the language record, and then we created a book instance record that linked to the book record. Okay, and so that is, you know, this whole linking thing, right? So these are the pointers, and what Django's doing in this situation is Django's trying to hide from us the whole idea of the foreign keys and the primary keys. Other than me asking what the ID is, it's not really something you have to do. So all those asking for the IDs aren't necessary. You just say, look, I have a book and its language is this thing. I don't know what its ID is. You should please make me a column and do all this magic stuff. So much of the bookkeeping of these one-to-many relationships or foreign key relationships in general in Django is just done automatically. Now, we can retrieve these and we can sort of walk down these things, walk through these things. So here we are again in samples, and we run the shell and we import our models, and we can say book.objects, and book is a class from our models. It's book1.models.book, and then a lot of the methods that we talk to inside of these classes are under the attribute .objects, which is, you could think of it as all of the rows in a sense, or all the objects in this model, all the rows in the table that lives there. Book objects, and then get is like, which one do you want? Get pk equals 1. Pk means primary key. I don't know, I think it would make more sense if we called this ID, but ID is the name of the column of the primary key is really just kind of a convention that's done 98% of the time. It's not required, it's not the truth, but it's so common that it might as well be. But pk really means primary key, which 9 out of 10 times is the column ID. So we're loading from the books table, we're pulling that in, and we're getting the row number 1 from the books table. So if you say what the title is, well, the title of that is py for e. Now, there's a title, but then there's lang. Lang is that foreign key that points to the language. And so we can say x.lang, that is the entire language row, but x.lang.name is within that row, it's the name column. So we sort of walk down the little arrow and grab one of the elements out of that. So it's like walking from a book to the corresponding language row and then pulling the name out of that corresponding language row. So I think that's a really pretty syntax, and it starts to make sense after a while. You walk through the little arrows. And this is why the picture of the data model is so absolutely important. Oops. And then, and so now we're going to go grab the book instance number 1, the first row of the book instance table. So instance.objects get pk equals 1. That says give me that first row, give it back to me in the variable y. What is the do back of this one? And then you can sort of walk it. You can say, I'm at a book instance, and I want to follow the foreign key to the book table to get me a book, and then give me the title of that book, right? So from a book instance, you can walk to the book table and then get the title of the book, and then we get py for e. So you see this sort of starting from one row, walking to the corresponding row that's pointed to by this relationship, and that's the essence of this. We're going to do this a whole bunch. By the time we come back to this will all seem... So we've been working with the Django shell and typing commands in to insert records and populate fields and create the both sides of many-to-many and then link them together. And so some applications that we're going to build, you're going to put up your super social ride sharing thing that you just built, and people are going to start filling it with data. But other times you're actually building a website for which the data is already known. You might actually be reading a bunch of data and putting it into a database from some source. Maybe it's an API, maybe you're scraping or whatever. And so you have some source of data and you want to put it into the database, and you don't want to put it in by hand. And so we're going to talk a little bit how you can write a script to load data into your Django database, into your Django models, after you've defined those Django models. And so we're going to actually take some CSV data, we're going to read it from a file, and it's just comma separated values, and we're going to use the course person membership model from before, and we're going to say basically here's a person with their email address, their role, which is instructor or learner, and then the course that they're in. And what we're going to do is we're going to write a script to read through all those things and then insert and populate. Because you gotta, when you're making a many-to-many, you gotta like put both sides in and then connect it together. And so the code will be in DJ Free Samples scripts manyload.py. That's the code to load it, to read this file, and then create it, put it into DB-SQLite, informed by the data model in the many-to-many example that I gave you with the course stuff. Okay, so that's what this is. Now, running scripts is part of a feature of Django called the Django extensions. Now, if you've already done this through when you installed DJ Free Samples and you ran pip3-r requirements.txt, you already put this in, but it doesn't hurt to go into your virtual environment and type pip3 install Django extensions and make sure it's already there, because if it's not already there, then it will get installed. Otherwise, this whole script thing won't work, right? After you install it, you do have to put a little link into your settings.py. That's Django _ extensions in your installed apps. And there's documentation on how all to do this. So that's the first thing you've got to do. Once you've installed it with pip, you have to pull it into your Django application. So when Django first loads up, which is python3 manage.py, at that point that says pull this in, pull all these other things in. All your apps, your extensions, the Django features you need, etc., etc., etc. And that's in the project settings.py file. So Django extensions won't work if you don't put it in this file. Now, if you're running on Python Anywhere, of course, after you edit this file, you gotta reset your web, but I think you probably figured that out by now. We wouldn't have got this far if you weren't resetting your web server on Python Anywhere. The next thing you do is within your Django project file, you make a scripts folder. And you put this file, empty file, touch is the Unix command to create an empty file, scripts / __ init __.py. This is just kind of a thing you do. And what it is an indication as Python is reading through these folders to say, this folder contains modules that are suitable for importing. And that's just a signal, and I think later versions of Python make this less important, but we've always put this in. So if you're going to put like classes that are intended to be imported into some other application, we always put this empty file _ init init .py. So touch says make an empty file of this name.
So let's take a look at our files inside of the DJ Free Samples folder. So I am currently in the DJ Free Samples folder, and it's the main folder. The settings are in DJ Free Samples. We're also in the same folder as the manage.py because we're going to be running commands, the manage.py commands. We're all playing with the folders cats and in the scripts. So the cats is where we have the models. Cats models.py. So we have two models. We have a cat model that has two normal fields. One's a nickname field that's up to 200 characters. The weight field is a floating point number. And then the breed is a foreign key into the breed model. And the breed model, other than its indexes, I mean its primary key, has one field called its name. And of course you want to have run your migrations. You probably already did this. No more migrations to run. If you run a migrate, it'll say I'm all taken care of, because these were here when you first checked this out. So the migrations, yeah, so we're good now. So the data is in a file called cats/meow.csv. And comma separation, it's got a heading at the top, name, breed, weight. We're going to skip that in a second. And then you've got the cat's name, the breed, and the weight. Now the key problem here is from data modeling. We've got some vertical replication, Manx, Manx, Tabby, Tabby, Sphinx, Sphinx. So we can't create a whole bunch of breeds. We can't just put these in as strings. So we're going to create a many-to-one relationship, and the breed is going to be in a table. Yeah, cats. Back to the model. All right, we're going to put each breed is going to go in uniquely, and then we're going to get a primary key for that breed. And then when we insert each cat, we're going to reference or point to using a foreign key. Point to that breed. So let's take a look at the scripts. Now, just the way this works is you've got to put these scripts in a separate folder. And the reason is so that this import statement works. So that has to. So there's a whole bunch of stuff to load Python up, but then load your Django application up as well. And once your Django application is loaded, then this cats models exists, and we can import the breed. And if we look through the code, we're going to open the file cat/meow.csv that we just looked at. We're going to use a CSV reader. Now you could do this with a split and commas if you really wanted to, but we are going to skip past that header. Remember the header, this was the first line. I'm going to skip past that. And so we can run this over and over again. We're going to just call cat objects all delete, and same for breed, to get rid of any data we put in, because it lets us run this over and over and over again. And so now we've read the first line, so we're going to start the second line, and then we can just iterate through the remainder of the CSV reader. I'll print the row out. In this line here that says B created equals breed objects getter create name equals row 1. So the first thing is this row 1 is going to be, in this case, Sphinx for the first one, and then Burmese for the second one, and Manx, Manx. So this is a pretty cool, this getter create method is a pretty cool thing. It's saying if there is a breed with a name of Sphinx, get it for me. If it is not, make it for me, and then get it for me. And that whether it's created or retrieved, it comes in this variable B. And created is just if you want, it returns a true or a false as to whether it was newly created. Sometimes your code is more sophisticated and wants to know if it's the first one. So then we have to create a cat object. And let's just take a look via cat/models.py to recall that the breed has a single variable, a single field name, and cat has nickname, breed, and weight. But breed is a foreign key. It's this special kind of thing. And so what we're going to do is we've got a breed object, in that was created with, in this first line, Sphinx. And then we're going to make a cat object. And the row sub0, which is, in this case, Abby, is the nickname. The breed is a reference to the breed object, which is in this variable B. So breed is the field inside of the model, inside of the cat model, and then B is the actual row that it's pointing to. So that's a real live saved row in the variable B. And then weight is the third column, which is in this case 6.4. And you know that just by calling the cat constructor, we do not actually store it, but you call it to call c.save. And then this loop goes round and round through all the readers, and eventually it creates all these things. So let's go ahead and run this. Python 3 managed py run script. Cats load, I think. Hopefully I got it right. Oh, yeah, maybe I should put a T in there. There we go. And so it's successfully loaded. This is just printing as the rows are read, but it's all loaded in. Now, we can verify this by saying SQLite 3 db.sqlite. That's a database. Now, I got to be in the right folder for this to work. And I can say .tables to see what the tables are. So we're kind of going down into SQL, and you can see the cat's breed and the cat's cat. So I'll say select star from cats underscore breed. And these are the breeds. And they're the primary keys. So Sphinx is 26, Burmese, Manx, and you'll see we've only put them in once. And then I'm going to say select star from the cat's cat, limit 10. And so we've got Abby with a weight of 6.4 and a breed of 26. So Abby is a Sphinx, right? And then Annie with a weight of 7.6 has a breed key of 27. And so there you go. And so now you see that you've built those. If we say select count star from cat's breed, there was only 6. And if we do that same thing for cat's cat, we have 104. And so there you go. This is a simple way of running a script and reading some stuff. And this get or create is a wonderful way to allow yourself to do many-to-one relationships and make sure that you're not doing vertical replication in a column. So the get or create is kind of really doing almost all the work for us with the vertical replication. Now I want to talk a little bit about a concept, model view controller. It's not super essential to understanding how everything works in web servers, but it's a great set of terminology that we use among web developers. And I think as you move into your role as a web developer, you ought to understand this. So this is a picture of the request response cycle. At the bottom we have the browser, and at the top we have a web server talking on port 80. The user clicks on a page, clicks on a link, the browser intercepts that link, opens a connection up to the web server, sends a GET request, the web server does its work, and returns a web page. And so that's sort of the basic request response cycle. And now we're going to, as in much of this class, really expand what we're going to do when we're in that web server. So that's where we're going to take a look at this. So basically, model view controller is really a set of terms that allow us to say this aspect, this part of the work that's going to be done in the web server, it's either the model, it's the view, or the controller. And so it's the most value that it has to say, oh, that part right there, that's controller. So model view controller is independent of the programming language that you use, independent of the operating system that you use. It's pretty universal across as a concept, as an architecture, as a way of talking about web servers. So the 3 parts of it, it'd be probably better to call it controller view model, or model controller view model, or something like that. But model view controller rolls off our tongue better. So the definition in my mind of these terms is the controller is this sort of abstract idea of what happens next, what is the sequence of events that happen, and then where do we start from, what do we do when we get a request, and then afterwards, where do we go at the end of that. The view is all the stuff we see. It usually is at the end of the request response cycle, we produce a view and we return the view back. And one of the things that the request response cycle often does is either interacts by storing data in a database, like an insert, or it edits something and puts it in a database, or it just reads stuff from the database and shows it to us in the view. And so that's called the model. The database itself and sort of the notion that we have persistent storage inside the application, that's what we call the model. The view is what we see, and the controller is kind of the glue that puts it all together. So the controller orchestrates all this stuff. And so sometimes you don't say that's the controller, but the controller is like several places and the actual shape of your application. So when we receive a request, we have a number of tasks that we often have to do for each request. Sometimes if it's like a form that's been sent to us, we have some data that we have to receive, validate, and then process, and then store it in a database maybe. And so that's often thought of as the model work.
Then once we've done that, we make a decision, like I stored this, where do we want to send the user? What do we want to show next? What page to show next? Maybe we show them, a thank you page, or maybe we send them back to the top page of the application. And so once we know what page we're going to send back to them, then that page has some data that we might have to pull from the database. And so we retrieve that using the model, and then we produce, perhaps using a template, some HTML response, and then put it back. So these are the 4 typical steps that we break down to say, in comes an HTTP request. First thing we do is, if it has data that we're supposed to do something with, we handle it, maybe store that data in a database, then we talk to the database and retrieve more data to produce the next output that we're going to make, and then we produce the HTML or the other form of output and we send it back to the browser. And so if we take a look at this in our Django application, the Django application is pretty much a model view controller application, in that the routing is very much the controller. It is that which it's like, here comes a URL, it's a request for something, where do we go? And so when you write urls.py, you're informing the controller. So the urls.py, I would say, is part of the controller action, the controller activity. The views is named the view. So the view is a little bit controller, in that sometimes the view is storing some data in the database. Sometimes that's the job of the view. Here comes some data. Before the view produces the next output, it actually has to store what came in on this request. And then the view will do some controller activity, like it might decide, I don't want you, this is the wrong page. Now that we've processed your data, I'm just going to send you over to some other page. That's kind of a controller activity. So it might say, I'll store the data. It might, let's see here, So it might say, here I go, I'm going to store some data, and then I'm actually just going to send you to a different place. I'm not even going to give you an HTML. And we'll talk about that redirect. That's called a redirect in a bit. Sometimes there is no data, and so sometimes you get some data, you're routed to the right view, and maybe some data has to be retrieved from the database, merged together, and result is processed. So when we think of views.py, that is, to me, both the controller and the view production. So sometimes it's making decisions about where to go next. Sometimes it's just handling incoming data or sending data out. And similarly, the models is taken from model view controller, because the models.py is where we basically do all the work to talk to the database, whether it is storing stuff in the database or retrieving stuff in the database. We use the Django model capability to implement the concept in model view controller of models. So just a quick summary. I like to think of urls.py and some of the views.py as the controller. The models, of course, is all the things that talk to the database. And then the views are like the second half of views.py. So produce using templates and forms.py and et cetera, to produce the output and send it out. So now we're going to start producing the actual output of our application in the views and using templates. And there's a lot to cover here. So up till now, we've been starting to talk about URLs, which are simple. It says, when you get the request with a URL of this format, choose a view and send it to that view. We're going to talk a lot about views.py and templates. In an upcoming lecture, we'll talk about forms. And we spent a bunch of time talking about models.py and how the models can talk to Python code, talk to the shell, how the models can inform how we write to the database and how we read from the database. So we're starting to fill parts in. As we put the views together, we're really starting to create our entire application. And I know it's taken a while to get to the point where we can update get to the point where we see the whole thing. So I just want to say that from time to time, wherever you have DJ for samples, whether it's on your laptop or whether it's on Python Anywhere, you should do a git pull from time to time, because I'm always working on these samples and I want you to make sure you have the latest copies of these samples. Sometimes I add little bits. I don't change the samples, but I add bits of documentation as I'm like, ooh, I should have added that. So views are like the core of the application. I mean, the URLs find their way to views. Models tend to serve the needs of views, act as this layer to allow views to write and read the database. And so the views.py has a model aspect in that it handles incoming data. When we get to forms and post data, then we copy that into the database. The views.py decides sometimes whether or not to send the user to a different screen, or if it's going to produce the actual screen, the HTML, it produces that HTML, often using a template, and then sends it back. So the views are where the work really gets done. And what you see is you write a lot of code in the views. You write one line in the URL, few lines in the models file, and then lots of stuff in the views. And I consider the templates kind of part of the views as well. So the first thing that Django does when it receives an incoming document, a request for a document, it basically parses that URL. And the first thing after the domain name is generally the application. So remember that Django has a project, and then underneath that there's one or more applications. In each of the DJs for each samples, you see lots of applications, each application kind of to show a little bit of sample code for a topic. And so that second part of the URL, that is the application name, and for all intents and purposes it's also the folder name within the Django project. Now within that, usually the next chunk is the view. And so that view within application the view within application is defined in urls.py. And then after that, there are two kinds of parameters. One is like a key value parameter that comes after a question mark. It also uses ampersands for that. And then sometimes we just put after slashes. This is more of a REST style URL that's very pretty, and you put the parameters right on the URL rather than the question mark, which is sort of the old school for doing all this stuff. So there is this thing in Django called the URL dispatcher. I sort of call it router on my picture. It's basically to get you to be able to define the URLs and how those URLs are to be parsed and handled, and how those URLs to be routed to the various bits of view code. And so we do this in urls.py. There are three basic patterns. First, you might route a particular URL pattern to a predefined class, and you'll see the example of that coming up. Or there's sort of functions, really old school function that take this request, which is an object that captures all of the data, the parameters, the URL, whether it was a secure request or not, what host it came from, what's the IP address it came from. All that stuff is wrapped up into this request object, which we'll talk about in a second. And that view function looks at that request object, decides what to do, talks to the database, maybe, and then sends back a response, whether it's a redirect or some HTML. And the function is kind of the low-level thing, but you can also then define a class. And defining classes, as we'll see, is really quite nice. The classes have methods like for get and for post, depending on the kind of incoming HTTP request that we're handling, and it also, in those methods, the request and any other URL parameters can also be sent in. So let's take a look at a sample urls.py from views, and we see examples of all three kinds of these routes. URL patterns is a global variable. It's just a list, but it has very special meaning. This list has very special meaning to Django, and you see these path commands, and there's other ways to describe these things. And then you have the path, and the blank path means sort of just slash right after the application name. And then we have which view to send it to. And so this template view as view, this is basically to save you from writing code if all you want to do is take a template out of the templates folder and return it. So you don't have to write your own code in views.py. And so it's already there. And that's why we go into Django Views Generic Import Template View, and we're going to say, you know what, I'm going to route, I wrote that template, but I just don't want to write the code to go send that, just read that template and send it back. And so this is a predefined bit of Django that does this for us. Sort of the more old school thing is this syntax right here, and basically from .import views pulls in views/views.py. And then this, you will see our functions inside there. And then these are classes also from our views.py for this particular application. And the syntax is a little weird. This is the module we imported. This is the class from that. And then asView is a static method that returns a function that then can respond to the incoming requests. And we'll see. So now we're going to take a look at the code that actually writes the views, the code effectively in views.py. Now the first view that we're going to take a look at is one where we're not even writing any code at all. And this is that predefined view, that template view. And again, template view is code that a class that's given to us from Django, template view, and you pass it a parameter. So we're actually kind of calling a function here and passing a template name to it, and that is a file, views main.html. So this is the application views, there's a subfolder called templates, and then I'll talk about this in a bit. We repeat the application name twice, so that's a little bit weird, but it has to do with the fact that these names are global across all of the applications, and so you want there to be possibly more than one main.html, and so that's why you have this extra folder name, and you put this there, even though that feels a little bit redundant, but it's okay. And so this is just a static HTML file. I'm not going to read any data from a database. I'm not going to write any data to the database. I'm just going to read this file and send it back to the browser. And that's a common thing where we just have a file that we want to send back to the browser. And so we just don't even have to write any Python code other than add this entry into the URL patterns in urls.py. So that's a view where you wrote no Python code. Now, for the parts where you're going to write Python code for a view, you're going to be passed in variables. The variables are all about the request object. The request object is all the data coming in, and the response object is something you produce in the view and you send it all back. So the request object is an object instance of class HTTP request. This is a predefined Django, and there's just a whole bunch of things. The scheme. Now, what is the scheme? Whether or not it's secure or insecure HTTPS. The body, it's a string. So there's like about 20 or 30 attributes. We're going to use some of them, but you don't have to use all of them. But you can go look up the documentation, and the more sophisticated your application becomes, the more likely you're going to have to go digging in to find some little bit of the incoming request. You could think of this request data as all that data you see in your browser debugger about what data was sent to the server. That all ends up somewhere in this object. Now, when we return from a view, we have to send a response back. And so the response is something that we create inside of our view. It might be simply text that's HTML, or it might be a redirect object, redirect response that says, hey, go to a different page. And so we make that the main job at the end of the view is to produce a response and then return it back to Django. And so here is a very simple view. So here we're saying, we're in the views application. We're going to go to the view funky, right? And so in the URLs PY, we say map/funky to this function named funky. It's a funky function. That's why I call it funky. And so when it sees this, all the data coming into the request shows up in this variable that is the first parameter sent to that function. So that's what this is saying in urls.py. Take everything that goes to views/funky, gather up all the request data from the browser, put it in an object, and then pass that request object in. Now in this, I'm not really going to do anything with that request object because I'm always returning the exact same thing. And so I just have a nice triple quoted string of some HTML with less thans and greater thans, and I'm going to basically return. It is my job in the view to give back a response. There's two main types of them. One is an HTTP response, which is just like a body of text, and that's what I'm sending here. I'm sending an HTTP response. That's a constructor. We're constructing a HTTP response object and taking that string that I put in there, and away we go. Okay? And so that basically, if you hit this path, you're going to get this page back, and it sort of looks like that when it's all said and done. Okay, so now we want to talk about how we can get at parameters. So I mentioned that this request object that comes in to your view function has all the data from the request. Well, if we send to a view with this question mark, key value pairs, that's guess equals 42 on there, and we're going to route danger to views.danger and urls.py, and so all this data is wrapped up in this variable called request, passed into the function named danger. And so inside of request is some data. Request.get is a dictionary of the key value pairs that are on that URL. So to pull the 42 out, we can say request.get bracket quote guess quote, and that pulls that out. And so that's all we've got here is a really simple HTML page, and we are replacing that little chunk with 42. And so whatever this number is comes back out in the output. So your guess was 42. So that's how we pass get data into a view. So it's important from time to time to talk about ways that you as a web application developer have a responsibility to create secure web applications. And so I want to call your attention to places where you write code that seems like on the surface that it's what could go wrong, and then you realize, oh, wait a sec, that could go wrong. So it turns out that you take data from the user in the request object, whether it's from a form or from the URL, and like guess equals 42 seems innocuous enough. And then what I did is I just concatenated that into HTML and I sent that back. And so the problem is what if somebody with ill intent tries to produce data that actually does something? And the problem is if I take data straight from the user and put it back in the HTML response, well, HTML and JavaScript are programming language. Your browser is being programmed, and that means that a user typing data into your system can program the browser. And what's even worse is that, having them program their own browser, not such a big deal. But in a way, what they do is they put some data in your system that turns into code, and then they kidnap someone else's browser when they take a look at data that came in. This is called cross-site scripting, where in a sense what it's doing is it's trying to run code so that it can read stuff from your site and then hand it to a rogue site. And so we have to protect against this, and it's a very simple thing. So if we take a look at the code that was bad, basically we have this parameter guess, and in the last time I showed you that was 42. And we just took this request get guess, which is this stuff, and we simply concatenated it into some HTML. Well, if I carefully construct my guess with %C3, blah, 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 all the blah, 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 all that stuff, well, that turns into, this is a URL encoding of less than, B, bold, greater than, bold, slash, so that turns into HTML. So I passed into this application some HTML, and I as the developer took that and I concatenated it together. So the response source has HTML. It's HTML that mostly comes from the application, but this little bit of HTML came from the person who put it in. And like I said, it's not such a critical problem if I in my browser put stuff to take over your browser, but it is if someone, you can move that into someone else's browser. So what happens is the browser sees this bold text in HTML, and instead of showing us the less than and the greater than, it actually shows it to us as bold. Now this seems innocuous enough until you do something much more clever, and that is I am going to carefully construct some code, JavaScript. And so what happens is this here is encoding of that line right there, the script alert owned slash script. And so what happens is that came in and it was concatenated straight out, And if you run this page, you won't see the data, but actually JavaScript will run, and it's going to show up an alert box that says owned and OK. Now, you can go ahead and look at the Wikipedia entries on cross-site scripting. Generally, the idea is once you're in JavaScript, you don't just say alert that I've owned your browser. What you do is you do something like grab a cookie and send it to a third party, or you call, say, a web service on the system with a cookie and do bad things. Like you can convince a teacher to log in and change someone else's grade or delete all the grades in a class. Once you're into a person's browser in JavaScript, you can do a lot. So that's really quite scary, and there's all kinds of scenarios where you're taking data from the user, and you got to be careful because, yes, I said the guess is supposed to be a number, but if it's not a number, if I concatenate it without escaping it, it's a problem. So here is a safer version of that. So I've got another view function called game, and it takes that same request, and it still pulls that get data off, which is this bit right here, but then it calls a function, and that's Django utils HTML escape, right? So what that does is that concatenates that into the HTML, but escape processes any dangerous characters and turns them into what are called HTML entities. So less than becomes ampersand LT, greater than becomes ampersand GT. Right? These four things with ampersands are a safer version of it. And so that means that even though I put in the data for bold, it comes out with the less thans and greater than showing, and it's not actually interpreted, right? So this whole notion of escaping or HTML entities, converting data, running the data from a user through an HTML entity's automatic filter ensures that the user cannot provide you data that turns into code in their or someone else's browser eventually. So that's the kind of thing you have to think of as you're concatenating stuff together. And the key thing is the request get guess that came from the user, and so we think the user's going to be nice, but a user with bad intent can send data that they carefully construct to cause the maximum trouble. But if you just escape your data before you concatenate it, there's nothing they can do about it. So another of the views is where we're going to parse the parameter off of the URL itself. These URLs are a little prettier sometimes than the question mark keyword equals value. And so, so let's take a look at this. The way you do this is in your URL patterns, you have a path, and instead of just having the path name, the view function name, you actually have this bracket, int colon bracket, guess bracket. And what that is, and you can go look this up in the Django documentation, there's a whole series of these things, that says the parameter after the word rest is an integer, and please pass it in as the parameter guess. So I've chosen the name to pass it in as a parameter, and then once Django sees this, it pulls that 41 off and hands it to us. So we don't have to tear the URL apart. Actually, in this request object, we do get the URL. We could do a bunch of splits and fool around, but nah, it doesn't matter. Let's let Django do all that work. Let's just tell it we want that parameter after the word rest. It's supposed to be an integer, and pass it to me in the variable guess. And then that same 41 comes in. I am cleverly escaping it before I concatenate it, and then I return a text-based HTML response with some HTML back to the browser. So this escape is there just because of cross-site scripting. I'm still taking this value, still coming from the user. So if any value comes from the user, you have to properly escape it before you show it to them. Now, those are all function-based, which are sort of a lower level. We haven't got to the point where we're talking about forms, but eventually in those lower level functions, you have to check whether you got a get request or a post request. Post request often comes from forms. And so this class-based view allows us to give a method for get and a method for post and let Django pick whether it's a get or a post. And And this is an object, and if you're a little rusty on objects, I've got a URL there on pythonforeverybody.com to review just like what a self is. I'm not going to cover all that. In the path command, you just have a string that comes after the application, routing to this. The main view, as view, is something you got to add to it because main view is a class, not a function, but as view is a function. And then we have to create a method get. Self, of course, is just part of Python's object-oriented work. Request is that first parameter, right? And so this one here is just a stock response, and I, just like the other ones, I return an HTTP response. Now it's like, why this looks a little more complex than the other one. Did the same thing, but it turns out there is tons of things that we can do. And inheritance, the fact it's a class, there are so many things about object-oriented programming that over the next few lectures we're going to really take advantage of this, and we ultimately will rarely write the old school function-based view. We'll do class-based views. And so we can also pass parameters to class-based views just like we can pass them to function-based views. You say, okay, with a prefix of remain, slug is a kind of string, and then guess is the parameter, so that says pull the string after the word remain off, right? Views is the name of the view, remain is the view within the application, and then this third parameter is the guess, and it's automatically parsed and handed to us in guess, and then we're going to respond to a get request. Self, of course, is the object-oriented thing. Here's the whole request, and guess is that little piece that comes off of the end of the URL. We're going to create a response by escaping the user-provided guess bit, so that if the user puts something nasty in for cross-site scripting, we stop them from doing that. And so that produces the same kind of output. Your guess was ABC12342XY, So talking about return values, everything we've shown you up till now is your basic 200 OK, which means you asked for a page, I gave you a page. You're probably familiar with 404 not found, which means you ask for a page, that page doesn't exist. There is another kind of response that's not actually a page, which is a response header that says, you know what, it's not like you made a mistake, but you're at the wrong place. And we call it a redirect, and 302 means I know where you're supposed to be and it isn't here. And it was originally used for sites that would move. And it's all handled by the location header on the HTTP response. And so we send a redirect response, which is a 302 with the location header being set, and it uses our URL. And when the browser gets that the 302 and a location header, it doesn't show you what it just got, but it immediately re-gets that URL and then shows you that URL. And the original idea was that if you renamed a domain or something, you wanted to have the old domain redirect web browsers and search engines, you use these 302s. There's also a 301 header that can be used to redirect all this stuff. But now we use it for all kinds of things, and it's very much a controller function. If you go to Model View Controller, controller says, okay, we're done with that, but I want your browser to go over there. So that routing, that sort of routing the browser, changing the browser, putting the browser where you want it to be, that's part of the application's controller phase. So we can send a redirect from a Django view. And so here we go. If you go to this bounce, it's going to actually not end up at this, it's going to bounce it to somewhere else. And in the path, we just say if you go to the bounce view, run to this function. This is not a class-based function. This is an old school function. And so the request data is passed in. And instead of now returning an HTTP response, which we would put in here HTML, we are doing an HTTP response redirect, and now we put a URL. And what we're saying with this whole thing is, you're at the wrong place, please browser, when you get this response back, go here. So it's like it bounces to the browser and then bounces back and then reads that URL. So, and you can have some output, but folks generally don't need output when you're doing a redirect. So if you take a look at that bounce, watching it in your network console, in a JavaScript debugger, what you see is you see a set of 3 requests, actually just 2. You'll see the first request is going to bounce. And if we take a look at this request, we see that it's a 302. It's kind of small. You see we got a 302, which tells the browser something's wrong, I'm not at the right place. And then also the server sends the location header that says this is where you're supposed to be, and the browser immediately turns around and does a get to that URL, simple.htm, and then that's what we see. And then this 404, interestingly, the 3 statuses I talked to you about, is because at this new location, djfree.com/simple.htm, there's no favicon. Remember, the favicon is the thing that shows up like right there in the top tab bar is the favicon, and I don't have a favicon, at least not now for DJ Free. I should put a favicon there, but we get to see a 404, and all that means is the browser looked for a favicon and didn't find it. So we see a 302, which is moved with a location header, and then we see a get, which returns then a 200, which is a success, and we see the document, and then we see a 404 because it tries to grab the favicon. And so the HTML you get back from djfree.com simple.htm, that's this simple page with a simple link. Hello, now we're going to talk about the other half of the views, the templates. And the templates are our way of creating HTML. And again, just to ground everything that we've got here, we're in the views, and the views are really sort of the code, the Python code that we drive. We're going to get to forms in a bit, but views kind of merge stuff from the templates, merge stuff from the models, send stuff in and make pages, right? So this is going to look a lot like HTML. It doesn't have to be HTML. It can be things, but other than HTML. But templates in our class will mostly be HTML. And so they're kind of the last little piece of the puzzle to start building user interfaces. And from this point on, we're going to be making user interfaces rather than introducing the parts of a Django application that have the user interface. So this is the text from the Django website. It's about convenient ways to generate HTML dynamically. And there's a couple of different templating engines. We're using the default one. And there is some data that we pass into the template. There's a process that's called rendering, and then we get the HTML back, and we return to the browser with that HTTP response, which we've already been doing. It's not the request response cycle is the same. The difference is instead of writing Python code to concatenate a bunch of things together, we are going to use a template engine. So this is the kind of stuff that we've been doing all along. We have a class in a view class, REST main view that extends this view. In comes perhaps the request object, and then maybe even another parameter. That's not changing. What we're doing here is we're using concatenation. Concatenation, these little plus signs, escaping, we're doing all the escaping and concatenating, and then we are sending back a response. So what goes back as a response, what comes in as a request, what goes back as a response. We're still going to do that. We're just going to get rid of that middle bit and make it a little prettier and make it a little more sense. If you look at that, if you look at it, you got to get it syntactically right. You got indentation problems. That's 3 lines of Python. I'm using triple quotes. I'm using plus. I got to get all that matching together. And then eventually I'm going to be in the HTML is going back. I'll be using single quotes and double quotes and all those kinds of things. And JavaScript's going to look really ugly here. Indenting of the HTML kind of will fight with the indenting of the Python. So this is just general. I mean, I've only done short ones because I only wanted to show you a little bit before we showed you templates. So the basic process is a bit of software, a template software that Django provides us. We're using the built-in Django one. And basically template is some HTML with some hotspots in it that says put data here. And then the rest of it is just HTML. And then we pass the data in some kind of an object, dictionary, etc. And then a bit of code pulls all that stuff together and then produces the HTML with all of the data placed in it. Often the render data that we're passing in is coming from a model, for example. We might talk to a database, load up a bunch of rows, and then put it in. But in the simplest form, what we've got is like a little dictionary. Call this the context. You could call it the render data, and then you have the render template. So the render template is really HTML, and that's what makes it a lot easier to look at because you're not putting double quotes around anything. There's no concatenation, but there are special characters. And what the double curly brace surrounding it says is instead of that, take this bit out and replace it with whatever's in the variable dat from the render data. And so that's how, when it's all said and done, this is replaced in the fun stuff, replaces curly brace dat in the final output. And if you thought about it for a while, you could probably write a render engine. They're not that hard. Now you'll see they have some sophisticated features eventually, so you probably don't want to write your own render engine. But you could imagine a Python assignment where I say, write me a function that takes a dictionary that looks like that, and then with key value dat fun stuff, and then take some text file that has curly brace dat curly brace, and then find that and then replace it with that string. You could write that code. You don't want to write that code. Django has already written that code for you. So here's the code in action. And so this is we're going to call this. We're in the application named TMPL temple. And so we have the application temple, we have the view game, and then we have a number 200, and that's what we put in our urls.py to route the game view and take one parameter. Remember that slugs are a special version of strings that are letters, numbers, and dashes, I believe. And so the entire request coming in from the browser is coming into the variable request. This number 200 is coming in the variable from the URL is coming in the variable guess. And so instead of us concatenating together, we are going to create a context. What I call a context, which just is a dictionary of key value pairs. And the key for guess is GUESS. It's a string. That guess will matter inside the template. And then we pull this number 200 and we convert it to an integer, and then we pass it in. And this render, we pass it the request object, we pass it the name of a template, and then we pass the context, the key value pairs, to be substituted in that. So let's take a look. So if we look at this template, it has a series of curly brace, like hotspots, places where you would replace stuff. And so the double curly brace just says retrieve the string that is under guess and put it in. And so that's how we get your guess was 200 in the ultimate output. And then we have curly brace percent all the way to percent curly brace. And this is a series of if then else's. So you can put logic in here too. You don't have to just take this string and put it in. So what we're doing is we're basically saying if the guess is less than 42, we print out too low. If it's above 42, we print too high. And of course, if it is 42, we print out just right. And since our guess was 200, it prints out too high. And so basically this makes this view code a lot simpler and doesn't put a less thans and greater thans and concatenations. It's all substituted by this render routine. Now the render routine returns an HTTP response request. So when we get that back, we just return it. So we hand back to Django the HTTP response request, and then the page is displayed in our browser. Remember that we have a Django project, and this is the Django project. In my case, the Django project is DJ Free Samples, and I have a bunch of little applications. All these things, as a matter of fact, Temple is the one we're working at right now. Those are just the different pieces of sample source code that I built for this class to talk about. And so those are applications. So it's just that Django terminology. Project made up of one or more applications and folders. Okay? And so the problem is these templates, when Django starts up, based on the settings.py, it loads all these files up. Loads them all up. And so it loads them all up, and the templates are actually global, and we'll see this in a bit. They're global across all of the applications. And so the problem is that if you have a template name like detail.html and you have a whole bunch of applications like I do, all of which want to have a template named detail.html, it doesn't work because which detail.html, it'd be template/detail in two folders. It's not clear which one you're talking about. So we've adopted a convention that we take the application name and we make a subfolder inside of templates. That's the application name. And then we use this favs/detail.html or /detail.html as the name of the template. So in a sense, we're introducing a subfolder. It's a little jarring at first because you see there it's the same. It's a good convention. I mean, it's unfortunate we have to have the convention, but because these names end up being global across your entire Django project in each application, and to get them a name, to get them properly named, it's necessary to introduce this extra level of redirection. And when we get to logins, there's templates that are stored outside in other applications. So sometimes you want to get a template in some other application. So there's all kind of reasons. This is a great idea. It just isn't the prettiest thing in the world. So just when you see it, don't freak out. I try to call it out in the slides. And so we put these paths that includes the application name twice. It's weird, but it is necessary to do this because of the notion that all these template names are global across the entire application. But if then we call this the template name with the name of the application prefixed, away it goes. Django could have made that a little easier for us, but they basically didn't, and so we have to do it. So now we're going to talk about the actual template language. As I mentioned before, there's more than one templating language. We're using the default one, and I think it's actually one of the better ones. This whole notion of double curly braces. There's all kind of templating engines, and a lot of them use these double curly braces. Sometimes there's a one called mustache because the curly braces look like a mustache. So this double curly braces, you learn it in Django, and you'll find it all kinds of other places. I've used it in front-end processing. This is back-end processing because we're doing all the substitution in the back-end. So there's basically a couple things you can do. The double curly braces do substitution, and one thing that's cool about this, if you recall, I talked about how you have to escape data that came from the user. Anything in the double curly braces is automatically escaped. As a matter of fact, you have to do something to not escape it, because it turns out that 98% of the time you want to escape data that you're printing out, because it doesn't change what it looks like, but it does make sure that it's safe. If you add this vertical bar safe afterwards, that's like a modifier. I think it's called a filter in Django that says, look, don't run that filter on it to do the HTML entities. Just do it as is. I know there may be HTML in that, but I've taken care of that because I am the application developer. You can call functions, like with the code is the percent, curly brace percent. And there you tend to call a code. This is like code. This is like calling a method or a utility code. And so the first part of this is what you're calling, and then later you can have some parameters. So this URL says, I want to find a URL for the view cat detail, and I'm going to take the number that is the current cat primary key for the cat record and put that on as the URL as well. The author in this case is and we'll see this later, is a model item, and get absolute URL is a method inside that model item. You can have sort of ifs and if then else's. It's kind of Python-like, which is nice in that you don't really have to learn new things. There is looping code that's in there, like a for loop that we'll talk about in a bit. And then there is blocks that can be replaced. So you can have a template that sort of pulls in another template and then substitutes in part of it. So you can have whole blocks of substitution, not just little strings of substitution. And so we'll talk about each of these in turn. So here we go. We'll start with a real simple one. And you'll notice that in this particular simple one, we have no parameters on the command on the URL. So we don't have any parameters here. I'm going back to a non-class style, just a simple function, and I'm not sending a context. The context would be the third parameter on the render call, and so I'm just saying, hey, and this is what you do when you just have some static HTML that you don't really need to change anything, and so that's what's sitting in here. It's just a simple page. There's this thing called a built-in template view class that sort of does exactly this thing, that just grabs a template, turns it into an HTTP, grabs a file, turns it into an HTTP response, and sends it back to Django. So that's just a super simple template. Now here's one where we're going to take a parameter to the context, and I'm not taking it from the command line quite yet. I'm just going to make the parameter always be 42, and the key is, this is a key and this is a value. So zap in this case is the key and 42 is the value. I often call this variable context, but the fact that's just a mnemonic memory thing for me, context or CTX is what I tend to call it. And now I'm passing in the template, this template here, the guest.html template, and it has one little curly brace substitution, and remember that does escaping for us automatically, so there's no need to use escape the way there was when we were doing this by concatenation. That alone is a good reason to use templates. And so this ends up sending out your guess is 42. So this is just really focusing on what's in that context and how the things come out of the context. This name here, zap, in the context means pull the thing out of the context under the string name zap, and then it substitutes the results, like the 42. So instead of it saying guess was zap, it's your guess is 42. So that's really focusing on the substitution. So this is showing us how we do the save stuff in case you actually want to pass some HTML into a template and actually want it to render as HTML, not as HTML entities or HTML entity style. So we're sending in a thing that's bold with a B and a less than B. That's HTML. It's got less thans and greater thans in it. And then we got zap. And so you can see that the zap comes out as 42. It's HTML entities, but it has no special characters. But if we escape text, text is the one with the HTML entity characters, that automatically escapes it so that you see the less thans and greater thans in the browser output. Escaped, less than B, bold, greater than B, right? And if you say text and then add the safe filter to the end of it, that says don't escape it. And so then this bold goes right into the HTML document, and instead of you seeing the less thans and greater thans, you're actually seeing the text turn to bold. Now, usually the bad folks that are trying to get into your computer are not just turning your text to bold, they're trying to run JavaScript. And all we're showing here is that whatever less thans and greater thans would be in that context value txt, they're going to end up literally in the document, and the browser is going to interpret them as HTML. I mean, there's just no way that somehow your browser knows the HTML that came from your program versus the HTML that came from a context variable, because by the time it gets to the browser, it's all one thing. And so it doesn't know, oh wow, that's dangerous. That came from a variable. No, by the time the response goes back to the browser, it's just a blob of text. Now we can talk about some loops here. I am passing in two arrays, apple, orange, banana, and lychee. And then I'm passing another array called n with peanut and cashew. And then I'm going to create a context. And in that context, I'm going to have fruits point at the list F, nuts point at the list N, and then zap is just the string 42. And do I even use zap in this one? No, I think there's another place that it. No, oh yeah, I just don't have it in the. So here's the template, a part of the template. It's not looking at zap, and so here's the key. So we got this for loop, for x in fruits. Well, fruits is looking up something in the context under the key fruits. They're string. They don't look like strings in. They don't look like strings in the template, but it looks up there and it finds a list. So that little list F is what really is going on here, and F is a list of apple, orange, banana, lychee. And then X becomes the iteration variable. That's only within the template. And then I'm going to print it out, and then I'm going to end it. So that's like the start and end of a for loop. Apple, orange, banana, lychee. Now you'll notice that I have an li tag, which is the list item tag, and it just generates all that HTML. And again, the double curly braces are doing HTML entity escaping automatically. So, so we take a look at nuts. So we ask, is nuts present? Because that's a way to tell if variable's present or absent. If it's absent, I'm going to ask another filter on the end saying how long was it? Okay, and so this is the n, nuts is the n list, and it has a length of 2, which means it has 2 elements in it, and so we see the number 2. And so you can do various things. So this is an if-then-else, the syntax of an if-then-else, with curly brace percent. Now we can pass objects within objects, and so it's a little tricky. We have a context in this X variable, and the sort of the outer key is pointing, the key is outer is pointing to another dictionary, and in that dictionary there is a key of inner with a value of 42, and then we render the nested.html, and you see the outer, but then outer dot inner, that's so outer is that object, and then object dot inner, then this thing becomes 42. Okay, so you can kind of walk through objects if you have hierarchical objects, objects that contain objects, or lists that contain objects, or any number of hierarchical structure of lists and objects. You can walk through them. So here's just another simple example. This one has data coming in instead of hard-coded. So we again have game 200, and we're running into game view. It's a class view, and the 200 comes in as the parameter because we said it's the parameter that comes after the word game, and so guess comes in as 200. It's a string at this point. It hasn't been converted to an integer. So when Django pulls these off, well, it does some validation based on the types, but it doesn't actually necessarily convert them. And so we're going to create a context, x equals a key of guess, and convert it to an integer to pass it in. And then we're going to pass the context in and the template in. And so the word guess is going to come out, and we sort of saw this. The guess is 200. And then depending on the if then else logic, it's going to say, in this case, too high because your guess was 200. And of course the right answer is always. So now we're going to talk about a technique called template inheritance. And this and other times, it's a great time to review object-oriented programming, because I'm just going to use object-oriented programming definitions and words and not completely explain them. So you got to know what a class is, you know what self is, those kinds of things. And I've got a great online lesson that you can go read and listen to and understand objects, and I'll explain it to you in 30 or 40 minutes. So inheritance, actually from that lecture, is the notion in object-oriented programming to not repeat yourself. You have some kind of a shape, and then you make a bunch of objects that mirror that shape. But you can also, with inheritance, you can have a shape that makes another shape, like a shape in general that's a triangle. And so you can inherit that all triangles have everything shapes have, and all squares have everything shapes have, and all circles. And it's just a way of capturing information once, writing code once, and then not repeating yourself. Functions are a form of DRY, don't repeat yourself. Modules are, but inheritance is the key. And inheritance kind of can get in our way as programmers because it leads to smaller and smaller code. If we're going to make 5 things, each of these 5 things is really small because we make a big thing over here and we inherit all 5 of those things from it. But then you look at it and like, oh, I don't understand that, right? I don't understand these only one-line functions. What are they doing? Well, the answer is there's 50 lines out here that we're inheriting from. So we'll see some of that. I'll try to kind of allude to that part where, look, there's magic over there. And a lot of what you do in Django is use classes and objects that you didn't even create, meaning that they've got data in them like .scheme or request.scheme. And so this is just also a way of trying to simplify the way you handle sort of things, objects that are handed to you, and then you hand objects to other parts of Django. So template rendering basically says, okay, here's some rendered data and here's a template. What happens now is there's this thing called a base template, and the base template and the template combine together to be sort of like the ultimate template, and then you pass in the rendered data and produce the rendered output. So let's just say that we had a bunch of pages and we were doing the same thing over and over again. Now we will soon do this with navigation because you want to put a menu at the top of every page, and literally that menu could be 40 or 50 lines of HTML, and you do not want to repeat that menu every time at the top of the page. So you want to put that one place, and then you want to make many pages that have the same top navigation so that your pages, as you go between them, look like the navigation is the same. So we're going to do this in a very, very simple way. So we have one template, this cond.html that we've been playing with, you'll notice it has some HTML and a title and a body tag and some of this, and then it's got this stuff. Well, let's say we wanted a bunch of pages that had that everything but the body. So what we basically then do is we take parts of this, like the repeated parts, and we put it into a template. And then we take the part that we're going to change every time and we put it into a template that then extends. So see, this one here has one line that says extends temple-base.html. So this one uses everything in here but then adds some stuff. Okay, so the basic idea is we split this one big template into reusable parts and non-reusable parts. And then we have a bunch of templates that come off a base. We call it base commonly in object-oriented world because it's like the thing that we're basing it on. So, you know, this is the base, and then we're going to build on it. Base, build something else on top of it. So how this works in practice, we have a view here. We're going to call this view game2, right? So we're going to use the URL game2. We have a class-based view. We have a get method in there. The request data comes in as request. We told it to parse the slug off the end and pass it to us in the variable guess. We make a template, which is exactly what we did before, where we have a key of guess and the value is the actual guess itself. And then we pass that template in the variable x into render, and we tell it to go read temple con2, which is the condition, the second conditional one. And the thing is there's nothing in the Python code, in the views.py, that knows about the base. What happens is the only place that the base is aware, the only place that the base is noted is in the con2 template itself. It says, hey, go grab this one and extend it. Now the way it works is it starts out a little counterintuitive. It says it really says start with this template here and then push this content into the base template. And this block content and end block, it basically, that tells what I want to replace. You're replacing blocks in the base template. So all the stuff in the con2.html that is between the block and the end block is what is then pushed into the base template. And then in a sense, the base template with those blocks replaced is what is returned as a result of the render and then returned to Django as the HTTP response. We're going to use these a lot. When we start doing navigation, we're going to go crazy with these things. So up next, we want to talk about URL mapping and reversing, where we have to actually make a link in one page to a different page. So now we're going to take a quick look at URL mapping and URL reversing. This has to do with basically routing, and it really allows us to generate links from one page to another. So we're in the middle of a page and we want to make a link to a different page. We've got to figure out what the string of that is. So again, we're sitting here in the middle of our code. We're in the views. And this URL mapping is basically a set of functions that allow us to read the urls.py. In a way, if all these functions didn't exist that allowed us to read urls.py, we would write a bunch of functions to do that. And so these are just now part of Django. And so often these are used in the view. Sometimes they're actually used right inside urls.py to come up. So it's like, if you know the name of a view, what would be the URL to get to that view? And sometimes views have just a URL, and sometimes they're a URL plus a parameter, and that's all set up here. And so it's like, give me a link to a view, please. And then Django looks in the urls.py, potentially across applications, and gives you that string. And it's just to avoid hard coding the strings. That's really the idea. And so this is just a common problem. This is the documentation right from the Django website. You don't want to hard code these things. You actually can, but then if you rename an application, the whole idea is you could make a Django project that had 4 or 5 applications, and then you could reuse some of those in a different Django project and add some more applications. So, you know, you don't want these applications to have too many hard-coded decisions. And it might be easier to hard-code some of these things, but it is actually in the long run much easier from a maintenance perspective. And so it's better maintenance. It's another, don't repeat yourself, or doing a table lookup rather than hard coding strings. It also lets you hunt around in your code to see where it is that you're talking to that other application. Because we're going to do login eventually, and login is another place. It's not in our application, but our application is going to have to generate login URLs by asking the login application, hey, What's the URL to log in? What's the URL to log out? And that's where we'll mostly start doing this. So I want to talk about it now, so when we get to log in and log out, you'll have that will make more sense to you. And it also is some of the stuff that you're doing from the tutorials. You're putting these reverse lookup things in, and you may or may not know what they are. And my goal here is to give you a little sense of what really they're there for. So let's take a look at an example. So here we have our urls.py, and most of it, I mean, this is the application route, so if you're looking in the samples, it's in the route application. The main thing that we've added is some names. Names are here to look up these paths. We don't really want to look it up by this path mapping because that could actually change. So we're basically saying this view in your views.py, second view, is going to be referenceable by this second dash view. I named them differently very much on purpose. So here's what happens if you just go to the route/route, the name of my application. It pulls up this main/HTML. And so the first thing I want to show you is what a hard-coded URL looks like. Now we know that blah 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 samples/route/second is going to go to that second view because the application's name is route and the view name is second. And that's good. That will work. It's not going to break, but this is where you lose flexibility as you try to recombine applications from one into the other. And so in a sense, what we're asking to do here is we're going to instead use this URL utility. And so in our template, we use curly brace %, and then we're running a utility that's been plugged into the template system that is like when we're running the URL function, as it were, and we're going to pass a string to it, and that is within the route application, the view that is named second view. So that goes into this file, the route urls.py, read down the views until it finds second view, and then it reverse generates the path that works for that. Now in this case, these two strings are going to be the same, and yes, that looks a little uglier, but the key is that we can make changes here, and this will not, the top one, route/second, will not reflect the changes, but if we're looking it up by name, we can do all kinds of crazy things and remap stuff quite naturally. And so again, it's just this URL command, the name of the view, the application, the view. So this is what it looks like when it's all said and done. There's no parameters to this. So if you take a look at this route second view ends up under this hard-coded, the route/second view, the hard-coded ones ends up under the string in the URL output, the page output. We just see it's /route/first is the thing that comes out from running the code URL and passing route:\first view in, so that's what it looks up. And we can make a link. This is now an href, and the actual path is sitting there in the href. So now we're going to see how we do this when we're going from one application to another. So an application we're going to look at in just a bit is this thing called the generic views. It's an application called gview. And we want to make a link to that application, and we know that there are two views. There's a list view and a detail view. And all we have to do is go take a look at the urls.py, and we know that it's an application gview, and this view has a name and that view has a name. The view that is all the cats is got a name of cats, and the view for a single cat is cat. But the cat one takes a parameter. It's an integer number, which is cat number 42 or whatever. And so we're sitting here in the route application, main.html, and we can now go create a URL that actually is pointing to another application and a view within that other application. So this is a URL for gviewcats, and that'll just look it up. So now we don't even have to know what the URL patterns are inside of gview/cats. Now, we can look at gviewcat, which is this URL, but you'll notice that this has a parameter, and so we actually have to add a second parameter, which is that 42 number. And so this will generate the URL straight to the detail page for a single cat. Now, there's a lot of nice stuff about this. So for example, if you omit this, it's going to look this gviewcat up and find it and say, you know what, I'm supposed to have an integer, and it'll blow up on you, right? If you get that wrong. Or if you put a 42 on this one, on the gviewcats, you're not supposed to have a number on that. But gviewcat, you are supposed to have a number. So this is one of the nice things about this reverse URL lookup, in that there's some error checking that goes on, because if it could just blow up silently, and in many ways when code blows up silently, it's worse than blowing up in a spectacular fashion, because if it blows up in a spectacular fashion, you can fix it. So this is what it looks like. So this gviewcats URL and gviewcat42, this one that actually is the detail page that demands a parameter, it constructs that just fine. Okay? So that's going from the route application to the gview application. Now, you can also, this is kind of subtle, and we will need it when we start doing social login using GitHub. So I'll just mention it because we're deep in it right now. And so basically this is actually the overall DJ Free samples URLs.py, and that's the one that's pulling all the URLs together kind of in the same folder as settings.py. And so you're pulling in a bunch of URLs, and these live in an application of their own name, but we can actually give them a name of our own to reference them. So you can actually name them, you can reference them with the name they were already given by the application that we're talking to, or we can say, you know what, I'm going to call these social : or nsroute : So if we take this route application and include all those URLs, and we're going to use a namespace of nsroute, you still can say route : or you can also say nsroute. And so you can see that in this example, right? We can go to the second view of route, or we can go to the second view of ns. And so there's route. Route is one way in, but nsroute is our own way in case we somewhere have an application named route or something like that. And so this allows for a second way to access these URLs using a namespace. And it's not in the URLs.py in each application. It is in the URLs.py for the Django project. So I just finished showing you all that in the templates, but we can also do this in Python, and we'll find that sometimes in like models.py or views.py, or even sometimes in admin.py, we'll need to sort of be able to find a view in the same or another application and automatically construct it. Sometimes in forms.py, we're going to do it as well. And so this, you tend to call this reverse or reverse lazy to look these things up. And the URL feature inside of the template is pretty much just calling this reverse lazy automatically, because the parameters are kind of the same. So I just want to show you how to do some of those things that I just showed you in templates, how you can do them in Python as well. So here's the one in templates. We just have this little plugin to a template called the URL plugin. It takes one parameter and looks up in the URLs.py of the first application, the URL named first view. Maybe there's parameters, in this case there's not, and then it generates a path to that, /route/first, right? And so that's how you do it. It's really under the covers calling this reverse lazy. And so these reverse and reverse lazy are from the Django.urls library. And so in this view, there's nothing tricky about this view. It's just a class-based view. We have a get method. We pass in all the request stuff. But basically, we can call reverse lazy and pass it the exact same string, which is go into the gview application, work your way down until you find the cats, or go into the gview application, go in and find the one for dogs, or in this case, this is the dog detail, and it requires a number, and so this gview dog, go find that one, and then the second parameter is 42, so make me one for that. And in Python, U2, and U3 are all just strings, which I'm passing in through some context under the variables x1, x2, and x3. They're really lousy choices of variable names, but I do that sometimes to point out that they're arbitrary and capricious, and all they have to do is match. And so then, like the x1 matches in this substitution, now we're just doing string substitutions, which is different than calling the URL, but it's still just a bunch of strings. You called reverse lazy in your Python code, and now you're just pulling that string into with double curly braces. And so this is how it ultimately works. We can, we get these, we're just showing how this output turns out, where we go reverse lazy for gview cats, gview dogs, or gview dog with an argument of 42. We pass it in, we replace it, and so this is how it prints out: gview cats /gview dog /gview dog 42. And so that's how that reversing works in Python. And you'll see that certain situations, whether you're like in a model, sometimes you're in a model, it's very common in a model to want to put something about the reverse in it. And the reverse lazy says delay until later to look it up. So up next, we're going to put this all together and ultimately start writing using the generic views, because we're going to look at list pages and detail pages, and in time we're going to look about delete pages and update pages. And Django has these wonderful features that make it work really simply with very little code. But we want to talk about it because sometimes the less code you... We're on to our last mini lecture about views, and it's a big one. It's about generic views. It's a really big lecture so that we end up with little tiny views with one line of code. So I've been building up views, and we've talked about inheritance with the templates, and now we're going to talk about inheritance and views. And we've been inheriting all along with views. So here we are in the views.py. This whole thing, these particular kinds of views, we define them in views.py, but they're very informed by the content of model.py, which means that views are constructed automatically just looking at the data in the models.py. So it's again sort of the logic of don't repeat yourself. If you have a thing in models.py, you've defined exactly what the fields are, and things like, you know, what the help text is for this field and what the description for the field is, that has nothing to do with the database, but it can inform the views. And so it's just a way for, you'll see how it all fits together nicely, but sometimes when we use these super awesome techniques, we end up with a little tiny bit of code, and it's really important to deeply understand that tiny bit of code, because you can sort of just fade away and not realize what's going on, because this code is so cleverly reusing a ton of other code and pulling stuff in from other places. So if you go all the way back to, we talked about SQL, the four basic operations are put data in a database, get data out of a database, delete that data, or update that data. CRUD, create, read, update, and delete. And we're going to build a bunch of things, whether they're add things or auto things, where we got to insert an auto, update an auto, delete an auto, list all the autos, insert a cat, delete a cat, list all the cats, update a cat, right? And so we have a bunch of user interfaces that we're going to build over and over and over again. And as you build your own projects, you'll probably have 4 or 5 tables and then little CRUD user interfaces for each of the tables. And sometimes you make them a little different and there's pretty stuff on them and they're customized. But surprisingly often, these things just look the same and we end up repeating ourselves, which is something we don't want to do as software developers. So here is a simple CRUD application. It's the cur, create and read. Or no, actually, it's this one here is only read and detail. So we have a list of cats, and then you click on the cat list, and then you see the data for a particular cat, and then a link back to the list. So this is like a detail page. But we're going to do a lot more than that. But this, I just want to show you how these generic views work by keeping things very, very simple. So we're going to talk about a generic view in the list and the detail, which are 2 of several generic views. So this is our gview application, and here's the urls.py. In this gview, it has a list of cats, an individual cat, a list of dogs, an individual dog. And so you see this sort of repetition. And I'm putting so many of these in here because I'm going to show you sort of different approaches to implement them using less and more detail and less and more inheritance. So they're all kind of the same. I give them a name. You know, some have integer primary keys, and away you go. And so here is the cat list. I'm going to start with a template. So we're going to expect in the cat list template that there is a context variable called cat_list. And that is a list of cat objects. And then we are going to iterate through the cat list, however many cats there are, with inside of a list, and generate an li tag, and then create a link URL, and then pull out the name of the cat. So the cat has a name, and the cat has a primary key, and so we are going to generate a link to the cat Sophie, and underneath that link is the link to /cat/12, whatever that number is. And if the cat list is empty, we're going to say there are no cats in the database. Now we've actually got a script
that you use to preload all of this data. So there's instructions in the sample code as to how to preload that data. Take a look at the README for it. And so if we're in the detail page, we're going to pass a cat object in, and that has a name, and then we want a link to go back to the cat list. And so again, we're using something from the immediately previous lecture where we're using the URL macro, passing in the name of a view within an application. So this is the GView applications, the cat view, and then that makes for an href, that makes a valid link with the string go back to list to be the thing that does. So we're going to build all this stuff, and that's the basic idea, that template and the HTML, that's how we're going to do it. But we're going to look at how the views work. And again, this is a reminder of the dry principle, the don't repeat yourself principle. Again, sometimes this dry principle gets us in trouble because the idea is that some bit of logic is placed one place and reused as many places as possible, because don't repeat yourself would probably be as well described by calling reuse, 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 reuse. Do it once and then reuse it as many times as possible, so that if you have to fix it and you got a bug in it, you don't have to find the 49 places that you put all this code. And because we do the same thing over and over and over again, cats, dogs, horses, we do it over and over and over again, cars. The idea that you have a list view, a detail view, an edit view, etc., it's a common thing. And really, if you're going to do this stuff, why not make it look consistent and function consistently? If you have one developer build the cat's editing interface and another person develop the dog's editing interface, and they like go off the same, go off in their own way, and they got some groovy design, but it's different, who cares, right? It's inconsistent. So consistent, you still want a beautiful design, but you want the cat's data and the dog's data to make sense with that consistent design. So both of them can have a nice design. So we got templates. The templates expect variables, like the list expects a thing called cat underscore list or dog underscore list or whatever, and then the cat detail just has a cat variable in it, and then we call it. So if we just forgot about all the stuff that we're about to learn and we just wrote a view, it would look like this first one, this cat list view here. And so we would inherit from view. We're going to go to the database. We've imported the cat model, cat.objects. This is the way to query all the cat objects and get a list of cat objects and put it in the variable stuff. That's what cat.objects.all does. Now we've done this before like in the shell, but now we're doing it in actual Python code in the views. Like I said, views are where all the stuff happens. So that says make a database call, load all the cat records, turn them into objects, and give me a list of those objects. And then I'm going to pass in the context into the template, the gview/catlist.html, I'm going to pass an entire list. And if you go back and look, there was a little loop in the template that printed out, Sophie, Frankie, and made links underneath them into the detail page. Okay? So this is how we would do it if we were going to not repeat ourselves. Okay? Now, this next way of doing it for the dogs, we're going to do it another way. And so what we're going to do is, it looks like it's more work, but it's more reusable. So the stuff that we're doing here. So what we're doing is now we have a dog list view, which is just a class, and we're going to create an attribute variable in this object called model. And we're just going to say that this model for this particular one is dog. So the idea now is in this get method, we take this code right here, and we said cat, make that be generic and have it be driven by this one variable. Okay? Now the tricky part that makes this a little tricky is sometimes we're just using the model, and then other times we are going to actually turn it into a text string. So if we take a look at this, we have this variable model, and in the get request, self.model is the way refer to the particular instance that we're in, that model variable. And this little meta verbose underscore name title
to lowercase. You can figure that out by yourself by going to Stack Overflow eventually. That's how I figured it out. I wanted to get a lowercase version of the model name. So the model's name is a string DOG, which is not the same as the dog model. Okay, and so that just is a way. Model name is going to be lowercase dog, but if model is cat, then model name will be lowercase cat in this bit. So I'm trying to make reusable code. So yes, the reusable code looks a little more complex because it's generic. But you'll notice that I'm creating a variable called model name underscore list because I'm just concatenating it together. So it's model name and is going to be dog underscore list. So that's what's going to happen. I am going to talk to the model and retrieve all the objects. That's okay. I don't have to change it to a string. Self.model is dog.objects.all. So then I'm going to get a list of all the objects and stuff, and I'll put that in the context. And then I'm going to go get myself a template out of the GView folder with the model name underscore list, so that what used to be cat list in here is now dog underscore list. I'm concatenating it together, and I passed the context in. And so then when that happens, then you get a dog list and some list of dogs, and away you go. So what I did is I generalized this code and put it in here, and then I passed in a sense, to the object that was made from the dog list view class, the actual model that I wanted it to operate on. Okay? So I do this to give you a sense of how this works. You can do the exact same thing for horses by doing this. And that is, you import the generic, Django views generic, right here, and you say, I'm going to make a class called horse list views. I'm going to extend not just view, but generic list view. So this is a generic class. You can go look at the Django documentation for this. It's a generic class that does a list view in general. And the rule for the class is you have to add one line here to say which model it functions on. And that's it. And that's because the get code is already in this model. We're extending that model. We're inheriting all this code, not from dog list view, but instead from generic list view. So we took something that was 5 lines, a little more generalized, it's like 8 lines, and now it's 1 line. And so that's how the extension works. But you have to trust, and you have to go read the documentation for list view to know how it is that you inform it as to what model you're supposed to use. So I want to show you a little bit of how this is happening by making one of these list views that's mine. It's not as cool as the real Django list view, just to give you a sense of what's going on behind the scenes in the Django list view. So if you say, so I'm going to make a new class, DJ4E list view, and then I'm going to extend view, and then I'm going to have a get method, and it's going to be all this code. It's looking for a variable called model, and you'll notice that it's not defining model up here because it's intended that this is a class that's going to be reused. So I'm going to say, oh, well, whatever the model is that's been set up here by the class that's being created while we're extending it, go grab that, convert it to a text, get the title of it, and then convert it to lowercase, make that model name. Whatever the model is, retrieve all of its objects and put it into stuff, and then put model name underscore list, in this case car underscore list, and then pass that list into the template, and then render, gview car underscore list context. Okay, so this is not doing anything per se. DJ4E list view is creating a class that I'm going to extend later, and I'm going to extend that 2 lines later. I'm making a car list view that extends DJ4E list view, and the only thing I need to do to get all of this code in here is extend it, and then I do need to add model equals car. So you'll notice that car list view has the exact same syntax as horse list view, right? Horse list view, you basically tell it, the generic list view, tell what model to work on, and then generic list view does it all. And if you look at car list view, it says use this generic list view that I just invented to show you the source code of what it is. That's the source code behind the scenes. Like I said, it's way more complex and sophisticated than what I did. This is the crudest, simplest version of an extendable generic list view. But when it's all said and done, you don't write any of those versions. You literally make a list view, and tell it what model it is. You make a cat view and tell it what model it is. And you just reuse the list view over and over and over again. So the fact that I give you 4 different ways to do this, yeah, I think 4 different ways, maybe 5, 4 or 5 different ways to doing this. The real way to do it is one way, but when you look at code like that, you're like, horse list view is an extending generic list view and the model is horse. I'm trusting a lot. And the answer is, yeah, you get used to it. And now the code you have to write is only 2 lines of code. And you have to write the template still because it's going to call your templates, but it knows the name of the template by looking at that horse, right? It knows, oh, horse, oh yeah, horse underscore detail, right? Or horse underscore list. And so this is the actual detail page that shows you the horse and goes back to the list, etc., etc., etc. And so using these generic views, you can make things really short and really succinct and really simple. So generic views are excellent. They allow us to produce lots of similar pages without repeating ourselves. They keep your code consistent. The repeating yourself, doing the same thing over and over, even if it seems quick to cut, paste, change, cut, paste, change, cut, paste, change. Our next topic is to talk about login and logout. Now, just in general, I have this GitHub repository called DJ Free Samples, and every once in a while you ought to see if I've found some bugs and fixed them. So go over to your samples and do a git pull. So every once in a while, just do that. So Django, like in lots of situations, comes with a built-in login, logout system. There's lots of ways to do it. You can read up on it. It has a way to create users, has this nice admin interface. And so one of the things we like about Django is that we don't have to build some of these basic maintenance things. It has permissions and groups. We use this in the local library application, but we're not going to use that so much in our applications. And passwords, etc. And it has a way to store these things in various techniques. And so the first thing that you'll probably encounter when you're doing this is to create a super user. And so you have to log into your system, you create a super user, give it a name, an email address. The email address is for password recovery, even though you can log in and you can change your super user password anywhere. And then you do it. Now there's a great XKCD cartoon for so many things. This is, one guy says, make me a sandwich, and the other one says, what? Make it yourself? And then says, sudo, make me a sandwich. And the other person says, okay. So what sudo means is it's a Linux command to switch to the super user and do a command. So if you don't have permissions to do a command, you can say sudo a command. And so that's what this XKCD. So that's what we call a super user. That's the user that has all permissions, doesn't need to get any special permissions. This might be a good time to review what you're going to do when you wipe out your database. When you create that super user, it just adds a row into a table in your DB SQLite. And you can wipe this out anytime. That's why I like using SQLite for development in Django. If you remove it, you've removed all the tables, all of the tables created by migrations. The migrate command is what creates tables. The make migration actually creates migrations with your Python code. So if you're going to start fresh, you got to remove the DB SQLite file. That's got rid of all your users, all your super users, any data you've put in, it's gone. And then you have to wake it back up with a bunch of empty tables with a manage.py migrate, and you'll see all those things. Lots of lines come out at that point. I didn't include them. And then you're going to have to create your super users again. So just if you wipe your database, you got to recreate your super users. Once you have a super user, the rest of the users are put in using the admin interface. You just go in and among all the other models that you might have in your application, the groups and the users are just models. They're models that happen to be built into Django, and you don't have any responsibility for building them. And so, like I said, the groups and permissions is useful, and you can read up on that, and maybe your application needs to use those. But for me, I pretty much just make users and call it good. Later, we're going to learn how to use like social login. So we'll use GitHub to log people in, so you don't have to create any users other than your admin user. So now we're going to take a look at what we do with Django to handle logging users into and out of our application. So we talked about sessions recently, and making a session is not the same as being logged in. Logging in actually changes data in the session. Logging in
in general, the most basic way of logging in depends on the existence of a session, and logging in is putting data into the session about the current user and their name and their email, and then logging out is removing it. In the session, you could have multiple users, log in with one user, log out, log in with a different user, log out. If you're just in the same browser, you're going to end up with the same session, just associated with different users. So remember, sessions and login are not the same thing. Just like cookies and sessions are not the same thing, sessions and login are not the same thing. But they all build on each other. Sessions build on cookies, and login builds on sessions. So to make this all work, you have to add to your installed apps all the Django support for all this login and logout stuff. Now, if you automatically built your project and you got a settings.py that they're going to just put this in automatically. So this is just so you know when you're looking at it where it is that all this magic functionality comes from. It comes from this installed apps. Also, for the login and logout, you're going to have to add a path to your project-wide. So DJ for eSamples, DJ for eSamples, urls.py. This is not in any of your applications. This is in your Django project, and you add a path, and there's a bunch of URLs, and that gets all registered, and a whole bunch of wonderful magic happens at that point. And so that's how these URLs are activated in your Django project, so the applications. So the way we get the URLs to the login and logout features is we use the reverse. We've been using reverse all along. Reverse is the way we look up for a particular view. And in some urls.py, matter of fact, in that Django contrib auth URLs, in that there is a name equals. And so there's a view in there that they've got that we didn't write, and it has a name equals, and it has name equals login and a name equals logout. And so we can do a reverse lookup like we would of any of our views that we might have. Say, give me the URL in this Django project for the view named login or the view named logout. And it's pretty simple. You could even probably hard code these, but maybe the route isn't exactly account slash, right? And so maybe you called them something else. And so that's why we use the reverse to look these things up. And so that's just a convenient way of doing it. Now, one of the things about logging in is sometimes you have an application and there's like a login button, but sometimes you just have pages that are protected by login. And then when you go to a page, it says, oh wait, you got to log in first. And then after you log in, you'll notice it typically just takes you right back to the page that you wanted to see. So you might bookmark a page when you're logged in, and then you log out, and then you click on that bookmark page, but that requires that you be logged in. So you're going to go to the page, and then when you're done logging in, you want to come right back to that page. And so that's using redirecting, but it's redirecting after login is successful or after logout is successful. Logouts are almost always successful. And so there's a parameter that we can add, a get parameter that we can add, and it's the next equals, and what we do is we give it a path. And so here's a little bit of code that we're going to play with in my sample codes under the authz project, under the authz application. And so I got a bunch of views, and I'm going to give them some names so that we can play with them. So these are just the urls.py. So if you take a look in this main.html template, you see a whole bunch of things. You see this next feature in action. So here's a couple things we can do. So there is this user object that in a sense is passed in. You don't have to do anything to pass it in. There's this user object that sits there in your template context that's automatically. We'll talk later about how you can sort of inject into every template certain little things that you got to inject. But the system injects this user. There is an attribute called isAuthenticated, which is true or false, to say whether you're not logged in or are logged in. And so if we see it, we say, oh, what's their person's full name, user.email, user.id. User ID is the primary key. We might actually have later we'll have a foreign key that goes into the user table, and we need to know what the primary key of the current user is so we can populate our foreign key. So when we have a row and it's owned by such and so, we're going to actually put a foreign key into a table that we didn't even create. But the thing I'm talking about now is you can get a URL, that URL tag that's looking up a name of a view. Log out is the name of a view. Log in is the name of a view. And then we have this question mark next equals. That's the parameter to say when you're all done with that log in or log out, go back to this particular URL. Okay. And so that says go to the URL that's in the authz application, the view named open. And so that's one way of doing it. Another way, let's say in login, we're going to get the login URL and send ourselves back to the request path. Request is another one of these things that's dropped in automatically for us. That is the current URL of the view we're at. So in a sense, this is a contraction that says go ahead and go to login, and when you're back, come right back here. So login will log in and then redirect back to this page that we're on, whatever the page is, because this is going to be, this little main.html is used in a couple of my different views. So request.path is like come back here. So that's a good pattern to know, to just say log in and come back to this current path when you're all done. And so here's just a bunch of connections to this thing, and we have here's just all my links, and I have a couple of things. I have some no login required pages just to play around, and then I have one that's protected by hand in Python, and then one's required by a login mixin, and then I sort of dump all that data, and I think I showed you that one already. So here is one of them, right? I showed that. That's what this all looks like. You can see that these links have the next in there. This is how it turns out to be. You get accounts login. Oops, come back. You go to accounts login, next equals authz open, and that's basically, I'm in this file right now. I'm in that URL, and that says go ahead and log me in, and then come back to this URL, to the authz open. Here's an example of the logout URL with a next setup in it. And so the login page is something that's provided by Django, but it needs a template. And so what happens is we get to control the template. And we're going to go to this URL, the code behind the views, the code that looks up the password, the code that gives you errors. That's all taken care of. All the views are taken care of. And what we get to do is we get to describe a template that controls our look and feel. And so we can have a simple login thing or a pretty login thing, and we can have links to the rest of our application. And so we want control over our login page so it looks like it comes from our application rather than having it look like it came from Django. So I'm not going to go through in much detail about how this works. You have to create a template that can be accessed as registration/login.html. And remember that no matter which application in a Django project you're working in, those names are global. So for example, this name right here, registration login.html, the fact that it's in my home application doesn't matter. And that's why we have this extra slash in here. So just because it's in the home application doesn't mean it has to be, the home and the registration don't have to be the same in this particular case. And so this is a template that if they just do a render, so in their view, in the login view that's somewhere deep in Django, they're just going to do a render to registration/login.html. You have this somewhere in some application because the templates are global. It's going to find your template and put that in. So within this template, there's a few rules that you've got to follow. They're going to send some errors, and there's errors. If the form has errors, you have to have some output that deals with that. If next, that's actually that next equals parameter. Okay, and so if the next is there, and you come into this log, and this one's a little bit weird. If you have a going forward page, that means you came from a page and you're going to go back to a page. If the authentication happens, that means you've been logged in, you went to the page kicked you back because it's protected by more than just logged in user. Okay, so this little bit right here, this is a little bit subtle. If you're not logged in, that's kind of the normal case. Please log in to see the site. And then we basically create a simple form. We're going to post to the login URL. That just looks up the login URL. And we've got this context variable called form, and we can print that out. That form has the key, that form has all of the input stuff in it. We're going to talk about forms coming up soon. And so that's what generates this form here. Generates all this stuff right here, and so there could be a bunch of things in there, but the form is a variable created by the view that has all the input names and areas, etc., that it wants. So we didn't have to actually construct the form. We do have to submit, put the login button, we could put a cancel button, and we do have to pass the next back as a hidden field. Now a hidden form field is just like a text field, except that it doesn't show up here. And so that's in there. And if you were to view source, you would see that. And so that's after you submit this form, it needs to know where we're going to go next. So then if you're successfully logged in, it's going to log you in, say yay, and then it's going to redirect to whatever that next value is. And that's our way of, it's going to give us the next value inside this template, but we have to give it back to the view when we post back into the view. So like I mentioned, there's a whole bunch of data that we can get. There is this user variable, and that user variable has their full name, their email, and very importantly, the primary key of the logged in user. But these things are only defined if user is authenticated is true. You can access this user data in Python. It's in a little different spot. It's in the request. So this, I just changed the name of request to REQ. That's just a variable name you pick. I will generally always write it as request or REQ. And so the user information that is pretty much the same as what's in the template tag, template context user. User is authenticated. Their username, their email. I could have had rec.user.id if I wanted here, and otherwise it's not logged in. And then I just throw this back as a simple HTTP response. This isn't all that useful. It's just showing you how to get your hands on those values if you're in Python. So sometimes you're in Python, sometimes you're in templates. Quite commonly you're in templates. So I've been talking about a view that requires a logged in user. And so again, imagine something where you're sort of reading your messages on an online system, and you bookmark the message reading URL, and then you shut your browser down, which logs you out of the system, and then you click on that bookmark straight to the messages, my inbox or whatever, and then inbox looks at you and says, you're not logged in. So I got to send you to log in, you finish logging in, and then you come back. That's what the next equals does. Now there's a couple of ways in views to write that kind of feature that basically says, this view is fine, but only fine for logged in users. So let's take a look. So one of them is checking to see if user is authenticated. So I have two views in here. One is, I'm going to protect it manually, and that's so you can see how it works, but it's really not the right way to do it. I mean, you can do it this way, but it's like, there's always a better way in Django, always a better way in Django. So here we have a class-based view, and we ask, is the user authenticated? If the user is authenticated, we just do whatever. Now, there might be a whole bunch of stuff in here. There might be a whole bunch of, but I'm just going to render the thing so that's a view. So I'm protecting this particular manual protect view. But if you're authenticated, you can see it, right? It doesn't do anything in particular other than dump a bunch of data out. If you're not authenticated, then I'm going to construct a login URL by calling reverse, say look up the URL for login, add a question mark, and then add the request path, which means wherever we're at, come back to it. So that's the next, and that's going to put next equals, blah, 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 blah. And then instead of returning a render, we return a redirect and say, okay, go to the login URL. So the way this is going to work is, it's going to come in once, right? You're not logged in, so it's redirecting. It's going to go out, but then it's going to come in back again, and this time the user is redirected, and so it's going to show you the page. So you end up going through this twice. Now, that's the bad way to do it, or the wordy way to do it. I mean, it's only 5 lines of code, but I don't like 5 lines of code. So there's this thing called a mixin, and a mixin is a class. The idea of a mixin is that, you know, we have kind of an inherited class. We inherit things that are like just a feature almost. So what we're doing is we're going to take our protect view. It really extends a view, but it's going to also add the capabilities of login required mixin. So login required mixin basically says to Django, if this is here, hey, I want to do this. Don't let the user into this particular view. Protect the view. So this is another protected view, but by simply including this little signal that says login required mixin, I've mixed this into my view, then it does all this work for us. So what'll happen is it won't even come in, right? It won't even come in if the user's not logged in. It will redirect and then come back and then let this code in the get run only when the user's logged in. And so this is by far the most common way to do it, is just called login required mixin, saving you from writing all these lines of code, right? So all these extra things, because do I remember how to do this? What if I write that 5,000 times in an application? It's really kind of silly when we've got login required mixin that takes care of all this stuff. And just to review, this is what that view looks like. It just sort of dumps all that stuff out. I use the same I use the same template for all of these views. So login, like many things in Django, is simple. It's easy. You add the things to installed apps and URL patterns. You make yourself a template. I didn't go into great detail. Django has great documentation if you want to get really sophisticated. What I tend to do is I get 1 or 2 templates working for login. I'm like, I want to use this one today or that one. So this is where like the sample code has 2 different logins that we're going to use. One is a simple local login, and the other one actually is a login when we're going to use GitHub to do our logins. You can get yourself you get your URLs for login with reverse lazy, or the URL template tag. And then if we want to come back, we add an X parameter to those URLs. And then when we have a view and we say, look, this view is going to depend on request.user or the user in the user template tag, just add login required mixin, and then Django takes care of making sure that you can't get to the view unless you're logged in. And if you try to get to the view, it tries to let you log in. And if you are login successful, you come back to the view and it's all transparent to you. And it's literally just one little comma thing in the create. Hello and welcome to our lecture on forms. There's actually quite a few lectures here because we're going to talk about how forms work in HTML and HTTP, and then we're going to talk about how they work in Django. So forms are the way that we put HTML in browsers that have fill-in-the-blank areas. And so the idea is that you draw some fields and some places for the user to type, and then you have some way of sending the data up to the server. And so we'll take a look at a number of different ways to gather this stuff up and send it to a server. There are 2 basic ways to talk to the server with form data. Everything we've been doing when you do an anchor tag is a GET request, which means you're going to get a document and show it. And you can put parameters on the end of those, like question mark guess equals 42. You can put that on the end of a URL. But then what we're going to really introduce and talk more about is the notion of posting data. So in forms, you can actually do getting or posting. And so let's take a look at some code here. So this is a little bit of utility code that I'm going to use over and over and over again because the get data and the post data and even the cookie data and stuff come in as dictionaries. They look like dictionaries, key value pairs. And so I just wanted a way to dump the data. I want a little label, probably should call that guy label, and then a dictionary. And so I'm just going to retrieve, go through all the items and call HTML escape so that we just don't end up with HTML cross-site scripting injection. Just print the keys and values out and put some paragraph tags and stuff like that. So it's just a way to dump this out so I can show it to you and not put this code on every one of my slides. So just remember that that's what dump data does. And here is a little form that prints out a form and then retrieves the form. So you'll note the dump data. If there is no data in request.get, it doesn't print anything out. But this ends up producing a form, right? And there's a form tag, there's an input tag. Input is the painting. Just put some text out, and then this label, this box here, is the input type equals text, name equals guess, size equals 40, and then we put a submit button out. And we can type some stuff in and we can hit the submit button, type 42 in and hit submit button. And you will notice that once this submit button is hit, it adds automatically onto the end of the URL that it came from, question mark guess equals 42. And then it sends that back and does another GET request, but this time it does a GET request with question mark equals 42. In comes this guess equals 42 is put onto the request.get, and then we dump it out so we get to see the key value pair of guess equals 42. And again, Django's taking care of all that parsing and everything before we get to it. Now, this is pretty much the exact same thing. Later we're going to talk about this CSRF exempt. This is to keep it as simple as possible for now. And all we have to do is tell that we would like to communicate this same form of data one input field and a submit button. We're going to communicate this from the browser to the server using the post method. And so this is a communication to the browser when the server says, I would like to send this data using the technique of post, not the technique of get. And so, you know, it prints out, we put in the number, we submit it, and so the first thing that you'll notice is there's no key value pairs, and that's because the post actually transports the data to the server in a different way. And it appears in a different key value pair. We can tell whether it's a post or a get, and if it's a get, we get our get parameters in request.get, and if it's a post, we get our post parameters in request.post. And so we still get the same guess keyword equals the number 42, okay? And so that's simply the two ways of transporting it. And this is talking about those two ways, right? The browser has a form, you know, blah, 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 input type equals guess. And the name field, name equals guess, is the field that is going to tell what the key value pair is. So if you're going to put a post, I mean, you're going to hit the submit button on a get form, it does a get to wherever it came from, right? And then appends the key value pair to the end. And again, that goes into Django, which parses it and puts it in request.get, etc., etc., etc. And if all you do is you tell it with a method equals post, then it chooses a different way. So the post is going to the same URL, but there are no parameters here. And so there's a series of headers like, you know, what is my preferred language, etc., etc., what I'm using for my browser, the content type, is this application URL form encoded, and that's talking about this. Now remember, this is going into the server, so the content type coming out tells if it's an HTML page or a JPEG, but the content type going in tells the browser, tells the server how to parse this. So it leaves a blank line, it's very symmetric with how the server sends us pages back, and then guess equals 42. Now, there's some complexity here, and there's some complexity in that post data, and there is some complexity in the get parameters where if you're sending special characters, there's ways they have to be encoded, but we're going to ignore that for now. Just understand that the reason you don't see the parameters on the post request is the data has been transported as part of the HTTP connection, and it's later on in the connection after all the headers have been sent. So you might say it doesn't matter. Well, it does matter. So there's a couple of simple rules. The post needs to be used when data is going to be created or modified, and we'll see situations where we force this, where you don't want to delete something on a GET request. If you're reading or searching, GET is great. It should never be used to insert, modify, or delete data, anything that's going to change the state of the system. And part of the problem is that web spiders will find GET requests. So you might, if you build a bad application and like a catalog of bearings, for example, and you have a delete that happens to be a GET request, and a web spider grabs your page and hits all those URLs, you might find that the web spider just wiped out your database. So web spiders do not follow posts because they assume that by following posts they might be changing your data, but by following gets, they're just reading your data, and that's all a web spider really wants to do, unless of course it's doing some kind of automation. So get URLs are supposed to be idempotent. So the idea is if you say blah 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 guess equals 42, it's supposed to kind of give you back the same page. Now that's like saying you know, blah 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 current calendar. Well, what is the current calendar? It might be, it's not identical, but it is sort of semantically the same thing. So you're supposed to be able to go bookmark a get. You know, you can bookmark a get URL, but not like you might say, where's my inbox? You know, here's a URL to my inbox in some kind of a system to read my data. And so you can bookmark that and go back to your inbox. It should be a GET request. You shouldn't be bookmarking posters. The other thing is that depending on your browser, your web server software, etc., you may have an upper limit on the GET. Let's just think 2,000 characters. Doesn't mean you should worry about it too much, but just large things, especially when we start uploading files like pictures, then all of a sudden the GET is impossible and you have to use post. So now we're going to do a real simple run through of the kinds of things that you can do in HTML and forms. This is only the beginning, and there's so many great online resources for how to do forms in HTML. So I've already showed you the basic text field. We'll talk about the password field, radio button, checkbox, select, and drop down. And I just got kind of this one HTML page that you can view the source of and borrow. I kind of write this stuff up for me for a quick reference. So we've already talked about the text field, right? So input type equals text, and then the name is the value. The ID, don't get too stuck on the ID. The ID has to do with how you associate the label tag with the field, and so that knows that somehow account and this text box are connected. So the ID is more of a browser thing, and the name equals is the thing that it's going to be sent to the browser. So the browser is always going to get key value pairs. And so, when we type Beth and we hit submit, then we're going to get the incoming post data is going to have the value account equals Beth. Now, if you look at password, that's a type. Password, for all intents and purposes, is a text type, and it shows it so people can't shoulder surf and see what it is. Of course, they can watch you type your password, but it shows asterisks in the box while you're typing. But then it's important to realize that once the data is submitted, the data is submitted in plain text. And so here's another one, another nickname. So Nick equals NICK. So that's basically the variance of the input types of text. Hidden, type equals hidden is another one where you just don't see it in the user interface. We're going to use one of those input type equals hidden in a bit. A radio button is designed for situations where you can only pick one of two things. So when you hit AM, the PM goes off. When you hit PM, the AM goes off. And you can actually have a whole bunch of them, and you can click them. Now they're drawn together because they're type equals radio, and then the name is identical. And interestingly, you can scatter these literally all over the page. It doesn't lead to very good user interface, but away you go. And so what happens is again, no matter how many of these you put with a name equals when, no matter where you put them on the page, if you click one, all the others are going to turn off. And so the one that's clicked, they all have different values. And so what will happen is whatever one is clicked at the moment that you actually send it, that will be the key value pair, where when equals PM, because only one can be selected, and it's up to you to make these things unique. Or maybe you don't want them unique. You do whatever you want. And so in this case, the PM one is selected, so we see when equals PM in the incoming post data. So that's a radio button. So this is a checkbox. This is probably more useful in many ways. Checkboxes, you can have as many that you want, and each of them are individual and distinct. So if you take a look, for example, you see that you have different names: class 1, class 2, and class 3, right? So that each checkbox has its own name, but the checkboxes are actually just little checkboxes. The text here is just text. The text is not really a critical part of it. The value is what will get sent if that checkbox is checked. And so in this example, we've checked Pi free and SI 539, and you'll notice that two of them have values and one of them doesn't. Now the key is often you're just checking to see if the data is there. In this case, class 3 is not in the post data, and class 1 is on. That's the default. If you don't say value equals, it's like value equals on, or whatever the value is that you put in that checkbox. And so you get to decide these. You might easily think that you don't need any values whatsoever because you're really looking for the name of the field, and you want the name of the field to be distinct. And so again, you can check as many of the checkboxes as you want. You can uncheck them, you can check none of them, and you can check all of them. So those are checkboxes. So to describe a drop-down is a multiple choice option basically for a single value that's going to be sent back to you. And so we have a select, which is the whole thing, and that gives the name, the keyword that it's going to be sent back to. And then we have a series of options, and you'll notice there's no value on the select, but each option has its own value, right? So I happen to be going 0, 1, 2, and these are strings, not numbers. They often are just numbers to make our lives simple. And then you have some text, etc., etc., etc. And so you pick one. In this case, I leave it default, and I hit the submit. So soda is going to be equal to 0. So this happened to be the one that's selected when we hit submit. Okay? So that's what a select looks like. You can also make a select that has some defaulted one, and so you just put selected on one of them, So that means it's the drop down. They're all there, right? They're all there. If you click on this thing, you'll see, if you click on which snack, you're going to see all the different snacks. Peanuts is pre-selected. And if I don't change it and hit submit, then we're going to see snack equals the value, which is peanuts. So that's an example that you don't have to make numbers, although it's really common to be using numbers. So that's a drop down with a default other than the first item. The default is it's the first item unless you do it otherwise. When you're typing in comments or a blog post, a big long blob of text, you use a text area tag. The text area tag is a little bit different in that it doesn't have a value equals. It does have a name equals. It has rows and columns to tell how tall it is and how wide it is. There are clever styling libraries that make these a little prettier. But basically what it is, it's a series of text, including paragraphs, including new lines, etc. And you're just allowed to type with new lines and edit and cursor around in here and build all kind of stuff. And then you send it in, and you can put default text in here. You can edit the text, you can change it, and it comes in as a key value pair with new lines and everything and any weird spacing that you might put in. But it's basically a block of text, like a comment or like a comment or a blog post or something like that. So the last thing on this page here is the submit button. And so you can make a type equals submit, and you can give it a name, and again that's a key value pair and a value. Now the submit is a little bit weird in that the value actually appears on the submit. What we tend to do is this submit, and if you're in a multi-language environment, you're going to want that to be whatever language of the user. So usually what we do is I carefully name the variables, or the name of the form, and then I check for this to exist. And if I have a bunch of buttons, I name them differently and don't really actually look at this text because that text might want to be translated at some point in time. So that's an input type. Input type equals button. This is a little pattern where I'm going to do like an escape or a back or something like that. And then sometimes it's easier just to do a little JavaScript. And what this little JavaScript chunk is, location.href equals quote www.djfree.com return false. What this says is it actually sort of, when you press this escape button, it goes up in the browser and in effect pastes this little URL into the URL bar and then hits enter, and return false keeps the form from being submitted. And so this is a way that I often will put a simple cancel or escape or something else in a form. Just if I know the URL I want to go back to or go to, then you can put it in here and click location.href. So those are the input types that have been around for probably 20 years. Yeah, at least 20, 25 years. HTML5 is a more recent phenomenon, although by now it's pretty well supported in most browsers. Defined a whole new set of input types. And what's nice about this is we were slowly but surely building complex libraries to solve all these problems. But now we can use these input types, and now each browser can support them to their own way. And they all fall back to type equals text. And so if you have a really old browser, these don't cause trouble. So here's just some samples of some things. So type equals color is a color picker, and that's going to pop up a color picker, let you cruise around. That color picker is defined by the browser and usually the operating system, and so you'll pick a color, and then that color is going to go in hex format, and that's the red, the green, and the blue, and so that's what colors look like. You can have type equals date, and so here's a date, and they pop in here. You're going to pop up a date picker for the birthday. You'll pop up a date picker, and you'll be able to kind of move around and pick a date, and then that'll put that date in as a string. They're all going to turn into strings when they're being sent in. A couple of the other ones, like email, name equals email, that basically does validation that says it's got to have an @ sign. There's some rules about what is and isn't a valid email, and so this will refuse to submit this form unless there's a valid email in there. The same is true for number. If you put something that's like 25 and it's not between 1 and 5 with min and max here, is we're going to refuse to submit the form. The same is true for a type equals URL. It's really a validation on the form to say, look, you can't put something in here that's not a valid URL. And just to prove that it doesn't matter, if you make any type, which flying doesn't exist, you can type something in and it just functions as a text field. And so in a way, all these fall back to text fields. Now the key thing is when you hit the submit button, normally that gathers up the form and sends it to the server. But when you use this HTML5 validation like date, number, email, URL, it actually will, before you hit the submit button, before it actually sends it, it's going to do a quick validation on these things. And it will actually stop and say, you know what, you didn't get that one right. And it just refuses to submit. So you can't override that in your application. What happens is the data doesn't get submitted at all so the browser blocks the submission of the data. Now, if it's not an HTML5 browser, it's going to get submitted with no validation whatsoever. So we still have to kind of check this data for sanity, which we'll talk about soon about how to do that in the server. But this is quite nice because it gives your user some immediate feedback, kind of customized to the browser, so the browser takes some responsibility for helping get the user to type the right stuff in. Now that we've talked about forms a bit, I want to talk a little bit about security in forms. I want to talk about a security issue called cross-site request forgery, or CSRF. So the idea of a CSRF attack is that a rogue site, it has to do with cookies and how cookies get sent to sites. So let's say you're logged into my site, and a rogue site generates a page that's going to post. And on every form you can post to a site other than the one it came from. And so if I can get data that I want to send to the legitimate server, the rogue site can set up a post, and then if I can convince you to hit the button, then it will grab the cookie and send it to the legitimate server that you're already logged into and perhaps do something dangerous. And so the rogue server doesn't need to know the cookie. The rogue server just needs to convince you to click on a rogue form to send to the request server. So the defense for CSRF is don't be confused with session. It is going to use session. We're going to grab another large random number, and we're going to call it the CSRF token, and we're going to stick that in the session. And then what we do is every time we send a form out that's coming from our server, we add a little input hidden tag that has this CSRF token. And then when the post comes in, we check the CSRF token that's coming in the post data, and then we check it against the one that's in the session, and then rejects it if it doesn't match. So here's a picture of how this works, right? So we'll have a legitimate server, right? We're going to produce a page by the legitimate server, and it's going to post back to this same server. The action is the URL to send the post data to, and we got some key value pairs and a submit button, right? So you hit the submit button, and it's going to come back to the server. Now, one of the things that the browser is supposed to do is pull the cookies for that server and send it. So it sends it both a post and the data, but it also sends the session ID cookie. And then what happens is that the Django gets its hands on it. It looks up the session ID, pulls it in, and notices that it's C7 and I've been logged as an instructor. And then I can actually change this grade and set the grade, and it works. Okay. Now, here is what happens when you get to a CSRF attack. So somehow a page gets sent to the server, right? Sent from a rogue server, and it just has this form. Method equals post, action equals DJ. It's not the action, it's going to a different place. And it puts sort of a new grade and then a submit. So what happens is this submit comes in, and the browser dutifully appends the cookie to it, and it sends it. Now you had to be tricked into getting to this page and sometimes tricked into submitting the page. But once the post comes in, it has the legit cookie in it. The cookie is used to look up the session and reassociate it, and we can check in the session that the user is indeed logged in, and we'll let the thing set the grade to 1.0. So this would be a way, if you could convince a logged in instructor to run a post form that you created, you could basically change your grades. So that's how it works. That's how a CSRF attack. You have to be tricked twice first, but there's ways in JavaScript to make it so it's hardly noticeable that you get tricked. So if you do this with CSRF, the legit the legit server basically adds another value, not the session ID, but another value in the session, which is a large randomly chosen number. And then when a page comes out, it's a legit page, and it uses a type hidden variable and puts the CSRF value in. Now you hit the submit button, and the CSRF is coming in as post data. Your regular data, the grade data is coming in, and the browser dutifully appends the session. And so then using the session cookie, it reassociates the session, says, yep, you're C7, you're the instructor, and the CSRF works, CSRF matches, so let's go ahead and let you set the grade. So we let them in. With the attack blocked, because the rogue server can generate a page, but it doesn't know what the CSRF is. So it could, who knows what the CSRF is, so it generates it. Maybe it can put a CSRF, but it doesn't know it. So then the post happens and all the data gets gathered up, and so it sends the CSRF, but it's not the right CSRF. The session ID is sent in, and so the session is pulled in. We know it's user C7, we know it's instructor, but we're going to check to see if the CSRF matches, and then it blows up. And so then you just refuse the post, probably log the user out, and then log some kind of a security error. So the idea is by having this little CSRF number in the session, we can then take care of that. So like most things, Django comes out of the box with CSRF protection built in. Just like the session, we've got CSRF middleware just dropped in, and actually it works automatically. You don't even have to ask for it to work. Once you have a session, it starts putting out CSRF things. Pivot a little bit and talk about how Django helps you do all those things that we just got done talking about doing. So if you look at this picture, you see that like forms are kind of in the middle of this picture. That's the final piece we're filling in. And forms are connected a lot of ways. Forms can be connected to models. They're used in the view and they're used in templates. And so they're a very powerful part. And all the things that we've been doing as abstractions, where we write a little bit of code and find lots of ways to reuse that code. Or we write some code that extends an object and then we add a little bit to it, and then we've got some very powerful object when we're all said and done. And so that's what we're doing here in forms. And forms can be used in views, they can be used in templates, and they can interact even with models. And so we're going to talk a lot about forms. There's a lot of like just menial labor that just working in forms, and if you really had to build all the HTML from scratch like I did in some of those earlier examples, it's just really painful. And there's other problems too, and that is that there's just a lot of repeating yourself. We kind of want to use like object-oriented techniques and other techniques to not repeat ourselves. And it's really easy to put the HTML up for a crappy form, but why wouldn't you want a beautiful form? And so if you write the HTML and you write some CSS and you do a kind of crappy version of it, then you have to fix it or hand it to a designer, and then they have to go fix 100 pages. There are things in Django, Crispy Forms is something we'll talk about later, that just like says, hey, I'm using forms in Django. Wait a sec, I want them to be pretty now. And then you just make them pretty. And if you want to change how they're pretty, you can change how that works. And then you change them all at the same time. And so not repeating yourself, being able to like lean on utility code. Seems like, why would we do this? But in complex applications, you just fall in love with this idea that you don't have to repeat yourself. And even though I've showed you some of the things like post, redirect, refresh, CSRF, all that stuff, it's even more complex than that, especially when you start talking about pulling data from the database and putting it in an edit form and then checking to see if the data is valid. If the data is not valid, send back an error form and give them a chance to resubmit it. If they're successful, you do post redirect and then you send a message in the session. We've done all that in really simple, but if you really look at everything that you need to look at, it's pretty complex. And so we're not going to do all this in this first lecture, but this gives you a sense of the kinds of things that a create form, where you're going to go like, new cat, and then you got some forms to fill out, fields to fill out about the cat, and then you hit the save. And so if we just go through this, these are the steps you need to do to insert a cat in your cat database, right? So your browser initially goes and gets a GET request, and then you fill out the empty form with a bunch of fill-in-the-blank fields. The user can always cancel out of that and get out. The user might enter some data and hit post. Now the problem is, what if you have some rules about the data, such as this is required, that has to be at least 5 characters, etc. You have to then send a form back with that data to let them fix it and resubmit it again. Or if it's good, you go ahead and store the data in the database, but then we have to put some kind of a success message, like in a session or something, and then send a redirect out, and then the browser immediately comes back and gets the redirect URL, which pulls the message out, sends the page, and sends the success. And so we've done parts of this already, right? We've done parts of this already. The big part we haven't done is kind of like this middle part here, where we're like validating the data and have this error retry loop that we put the user back in the loop and give them another chance. Now that's the create form. The edit process, where you're pulling in an existing cat and you're going to edit their fields, is even more complex. You know, you go load up a cat, but you might have an error page because they're looking for a cat that didn't exist in our database. You send out the form with the old data, they might leave, they might edit it, they might come back, they might validate the data and get an error, then they have to fix the data. They got to go around here until, okay, we got some valid data, and then you store the data in the database, put a message in a session, send out a redirect to a success URL, and that success URL, you put out the message and say yay. So that's complex too, and we're going to figure that out. Delete is not as simple as you might seem. The problem with deleting things is that you can't delete with a GET request. So usually you have to go navigate, like you see a little delete button, you click on it and you go to a delete page. It's going to load the data that you want to delete so you can build a confirmation page. Confirmation pages turn out to be really important because they're also our tricky way to convert a GET to a post. But if they're asking for the wrong data, we have to send an error message. Otherwise, we send a confirmation form that says, are you sure you want to delete this? That's both nice for the user to give a confirmation, but it also then turns this into a form. And of course, they can leave with a cancel, but if they click on yes, that turns into a post, and it has the key. So the first thing it does is it has to load the data again from the model. And then if that data is not there, they got the wrong key, then you send an error page out. And if you got the right key and the user has permission to delete the data, then you go talk to the model and you delete the thing, right? Then you put a congratulations on your deletion in a session or something. Then go with a redirect, because you can't respond with a 200. You got to respond with a 302. And then the browser immediately does a get a success URL, pulls the message out of session, makes a success page with the message. Now we're going to cover this a bunch of times, so you don't have to get this the first time. But I just am telling you that forms are complex. And what's cool is Django form objects that we're going to create act like glue. They can generate the HTML, they allow for a consistent look and feel, and they allow for you to change the look and feel. When the post data comes back from the browser in a form that it created, then it puts it all in the right spot. It validates the data based on a set of rules that you say, like this has to be this kind of a thing and that kind of a thing, or a date or a character or an integer or a floating point. Whatever it is the rules are, that's all done for you in Django. And if something goes wrong, then it hands you an error form that you can send right back to the user. It really greatly, and then of course, once it's validated, it moves it into a model and then actually can even do the database store automatically. So the form is like this glue thing that sort of talks to templates, it talks to browsers, it reads data from browsers, it plugs stuff in. And so in a way, the form is like the controller, it's like the view, it just makes your views really succinct, and you're gonna love it once you understand it. So here is a simple form, and so forms live in a file called forms.py, not surprisingly. And basically, just like them, it looks a lot like the models file. And so you're going to see the one thing that forms do differently is they can have these things called validators. Models have rules about max length, etc. But there are even more complex validators, and you can even write code that you have your own functions that when the form is coming in, you're going to look at this one field and you're going to say like, oh, I wanted 2 uppercase characters followed by 3 lowercase characters. Sorry, you didn't do what I said. That's what's called a validator. And that's when that error page goes back and it says, hey, you're missing this stuff, and we'll show you how the validator stuff works. But basically, you put in little lines just like you did for the model, and you're effectively defining a user interface plus a bunch of logic behind it. Now, the one thing I'm not doing in this particular section, we'll do soon, is connecting this to a model. So you could say, wait a sec, I'd like to make a form and I really mostly want to inherit from a model. You can do that, but that's not this one. That's coming up in the whole next section, but it won't be long. So the form object, right? So here's this form we just made. It's got 3 fields in it. And this is a real simple view. It's not useful. It just kind of shows you one of the things you can do. So make a basic form. When the basic form is defined as having these 3 fields, and then you say form and then call the method as table. And so what this produces, it's just a dump. There's nothing, the UI of this looks really ugly. But basically it generates all this HTML for you, all this HTML, input tags, and we told it to do it as table. That's not necessarily the prettiest way to do it, but all that HTML is generated from the form utility. So it can send it out as a list, you can send it out as paragraphs, etc., etc., etc. And so this is just to show you kind of the dump. If you go to this URL, do a view source on it so you see this stuff in here. So that you define a form object, and one of the things you can do is make me HTML. And this is not a good example. We'll come up in a bit with a better example. The better example, of course, is to use it in a template. And so here is a template with a simple form in it. We got a form, it's a post. We got some submit stuff. We got ourselves a cancel, button that we put in. And we got a CSRF token. And we're going to use that form as table, and we're going to surround it by a table tag so that it looks a lot prettier. And so this is a far more typical way of doing it. That first one was just to dump it. And so this, when you do this and you give it, you sort of make the form in a get request, you make the form and you pass it into the context. If you remember, form.asTable, that's a very, come back. Too far. Form.asTable came from the context, came from the passed in variable, and that is right here and right here. And so we make the form object, which has all the fields in it, and then we pass it into our view, our template, and it renders that. And so then this is what it looks like, much prettier. And if you do a view source of that, if you go to this form create and you do a view source on that, you'll see it's all that same table stuff. It's the same table stuff that we had before. It's just now wrapped in some stuff to make it look a little prettier. We put a submit button, it's got a form tag, and then you can actually hit the submit button and something actually happens. So this is by far the more typical way of using a form in a template. So I talked about the create form, the update form, and the delete form. This is kind of an example of how forms can be used. Now, I'm not actually talking to the model yet. We'll do that in a bit. So I'm just going to pretend that we have some old data. And so this normally would come from the model. This old data, title, mileage, purchase date, that would come from the model normally. But for now, we're just going to make it up. And so then you basically start a form and you pass this old data in as the constructor. That's a constructor for a basic form. From the basic form class, pass in old data and give me back the form. Give me back an object of type basic form, and I'm going to have it in the variable form, and then I'm going to pass it into context. Now you'll notice I'm using the exact same template, the one I showed you before, because that form as table understands that sometimes there's data in these fields, and it properly puts the data in. It properly escapes the data. It understands that this is a number. It understands that this is a date. It's got all that stuff all figured out, right? And so this is how it works, is you just somehow get your hands on key value pairs of the old data, you pass it into the constructor, and now you render the form, and the forms library takes care of putting in all that old data. Believe you me, you're probably glad I'm not showing you how to do, HTML encode and all these things, and when you do encode, but this is a little different because it's inside of an attribute. You don't want to know that because you just are going to use form as table, and it's got all the rules figured out. This is hundreds of lines of code that you're not writing.
Hello and welcome to another Django for Everybody walkthrough. So you are probably at this point working on your autos assignment. This is our first real create, read, update, and delete assignment. And we're going to, a lot of what this assignment is to look at the code I've given you in DJ Free Samples and pull it in. do not clone the repository for this assignment. The DJ Free Samples is a monster. It's got all kinds of stuff in it that's way too complex. And you want to start with a nice clean application. Your previous assignment was to make a really tiny application. Now we're going to extend that application, and that's why you've already have this DJ Free projects in your wherever it is, okay? And so what this is this assignment is to evolve that using the sample code. But what I'm really going to do is I'm going to walk through the sample code because there's new concepts in this sample code. So this is more of a lecture about the sample code than exactly how to do the assignment. But importantly, you need to understand every single line, because literally every program that we're going to write for the next N weeks is a variation on this CRUD, right? And so these views, these default views, the get or 404, all that stuff are really foundational things. And what we're going to find is the right way to write this code, like everything in Django, is really small and succinct. Okay? So let's take a look at the code. Let's go ahead and run the code. Go to autos, and you got to log in. And so the idea of this is there are two tables. There is a table of makes. So I'm going to add a make, and then I'm going to add an auto. And the cool thing about this is neon 1, mileage 1234, Sakai car, and then I have this cool drop down. And so this is there's a whole bunch of forms going on here. There's drop downs. There's a many-to-one relationship going on. Then I have this list, and I can update it and delete it. So that's where our full CRUD is. And so we can add makes, view makes, add autos, etc. And so that's all the sample. So it's very close to what it is that you have to write. It's just don't go grabbing all that stuff. So let's start by taking a look. So I'm here sitting in my DJ Free samples. And if you look, you see all of my various applications under a project. And so we've got the autos, but I really want to start with the authentication code. The code that, if I go here, back to samples, let me log out, the code that allows me to log in. So if I go straight to autos, see if I've logged out. Right, so you'll notice that what it does when I go straight to autos is it routes me to login, and then with the next to go back to autos. So this view in autos, the /autos, has protected itself with login mixin. And later we'll do login. Your login won't quite look like this, but this is the one I have on samples, where you don't have to make it pretty yet. An upcoming assignment is going to make everything pretty. So now we're at autos and we're logged in. Okay, and your application has to have some more things here, but I'm more interested in showing you really the essence of the views in this autos, right? So if let's just review just briefly. Let's just review briefly about how the auto login works, right? So if I look at DJ Free Samples /settings.py, you need to have this auth plugged in, right? So that basically that's a bunch of code, some views, etc., that comes from Django, and that's been there all along when you did your start project. Of course, then somewhere in here we've got to have the autos, wherever autos is. Yeah, autos app config. You get to pull the autos app in. And if I take a look at DJ Free Samples /urls.py, then I can find autos here, and there needs to be some kind of a link that basically says at the top level, everything below autos is delegated to the URLs file in autos.py. But also then there is the accounts, right? And so if you recall, this is a bunch of views that comes from Django for us. It's pre-installed for us. And the thing that we've got to do is we've got to build we've got to provide this a template with the name registration.html. So I think I've got this in home /templates registration. Yes, I do. So I've got actually two logins. I've got a really simple one is login.html, and this is the one I recommend that you start with. Later we'll use the social login. And this is very simple. It's a login page. It uses the Django Forms capability. If form.errors, that means that there was a validation error and it came back and redisplayed this page and showed you an error. And then we make a simple post form with a URL that is a reverse lookup to a view with the name of login. Then we put the CSRF token in, and then we take the form, and I'm just making this with paragraph tags. And so that's a simple login. That's not the actual one that we're showing. And then the next is a hidden value that you've got to pass in so that when you actually successfully log in, it knows to come back to autos when it's all done. It comes back here after the login has been done. And so that registration/login, you can put this in any of your applications, but you want to name it registration/login.html. So if I take a look real quick and I go into home templates, these are all the templates, and I do an ls, you'll see that I have a home templates home and a home templates registration. You can have more than one folder here. And if I do look at what's in registration, you see that I've got this simple login and then later the more complex login that will give us the GitHub login capabilities. So we can log in using, what that means is login use social. The point is underneath this templates, you don't have to just have one subfolder. You can have more than one subfolders. And so that is the necessary configuration to make it so that when we tell our views to add the login mix-in, which we'll see in just a second, when we tell our views in the login to use the login mix-in, then it knows where to get the template from. So that's just part of it. And your instructions tell you how to do that. So any application that you're going to build or any project you're going to build, you have to put those in settings.py, urls.py, and then make the template. And then you have to start using login mix-in, and then everything just magically starts coming together. So let's take a look at the actual autos application. We'll look at a couple of different things here. Autos/URLs. And I'm going to do I'm going to tab so I can switch back between files really fast. You probably have a better text editor than me. So I've got URLs. I'm going to take a look at the views. Nope. Autos. Views.py. Then I'm going to look at autos model.py, models.py, and then I'm going to look at autos forms.py. And so let's sort of work through these four files: URLs, views, models, forms. Probably let's do models first. So this is pretty straightforward. We're going to make a make object class. It's going to have one character field with some validators in it. We kind of played with that with forms. You can put validators in models. We've previously seen validators in form, but there's a validator that basically says we're not going to accept data coming into this database table unless there's at least 2 characters. These __str, you've been doing this for a while. That basically is if you take a model object, an actual make, and you print it, it says which of the fields, in this case there's only one field, and so that just says when we're converting a model to a string, a model object to a string, we get to decide how that looks. Okay, and then we have an automobile, and it's got a nickname with a min-length validator, max length of 200, a mileage, which is an integer field, a comments, which is a 300-character field, and then a foreign key into, this is a one-to-many or many-to-one relationship, not a many-to-many, just a foreign key into make, and then we're going to do on-delete cascade, which really means if you delete a make, then the corresponding auto entries will automatically be deleted. And so this is a pretty straightforward model, actually very, very simple. And once again, we're always defining this stir__self, so that we know that we're just, if you're just showing it like in the admin interface, or if you're just printing it, or just converting the model itself to a string, the field among these fields that is supposed to be used is the nickname field, just to show to end users. So that's the models file. Let's look at the forms file next. So the forms file is interesting because we've seen forms that are just forms by themselves, but this is a special kind of form in that it's a model form, in that we normally, in the other models, we had all these fields, right? And we put them in, and it looked a lot like a model file where we'd have a character field, a positive integer field. But what we're basically saying is, you know what? We're going to make a form here. And really, all we want to do is take all the fields from the make model and make them form fields. So a form and a model are two different things. A form is something that goes between sort of the view and the template. And as you'll see, it also goes down into the models automatically, but you gotta, so this is just like make all the fields, right? Let's make a form, because form objects don't have to be associated with models, but in this case, we are going to sort of derive a form object from a model. And so instead of extending form, we're extending model form. So that's a model form must have, and this is just some data that says the model that we're going to pull all our fields from is the make model. And it only has one thing, which is a name. That's it. Okay, so this is auto-generating a form that if we changed it and added another field here, then this make form would automatically have a field. You can give it a list of fields, underscore, underscore, all, underscore, underscore, is like a signal to say, just give me all of them. Now there might be some internal things like created at or updated at or something that you don't want to use. So that's a form. Remember how forms work. Covered that before. Let's take a look at our URLs. Now, a lot of this looks pretty similar to things that we've done, right? We basically have a main table, which is our autos table, and our lookup table, which is our makes table. And we have sort of three things. There is the main list view, which is list all the autos. There is the main the make list view, which is list all the makes. And then we can make a new one, which doesn't have a primary key, because part of the idea is the create is making a new thing, which is going to generate a primary key. And then we're going to have a update and a delete. And so we have a read, a create, update, delete. So it's not exactly CRUD, but you see all four of these things. And so we've got views, and we name these views so that we can reference them in our views themselves and in our templates, so we can make links in between them. Okay? Okay, so these are pretty straightforward and not all that different. So the fun starts to happen when we're in the views.py. So login mixin, if you remember from the auth-z walkthrough, you just add this to a view, and it just basically says you cannot get to this view unless you're logged in, and if you aren't logged in, it will bounce to the login.html file and then bounce back after you're done. And so login required mixin is all we need to do. If you go to the auth-z sample, you'll see like I did that by hand, but you don't want to do it by hand. You just call login mixin. Now, so this main view is a list view, and so let's go take a look at what this is going to look like. This is the list view. So we're going to take however many autos we have, we're going to loop through that list, we're going to retrieve all the autos from the database, then we're going to have an add the auto link, then a view the makes link with a count of how many makes there are, and add a make. So let me also then go into autos templates, autos again, yeah, I'm sorry about that, and auto list. So this is the template that makes that. And so there's a few things that we get. We get an auto list. Now the names of these are not forced upon you, but there's conventions that turn out in a moment. They're going to look really useful. Okay. So we're going to get an auto list. And if we go back into our views, we see that we say get all of the objects from the auto table, all the auto class objects, retrieve them all, pass them in to the context as auto underscore list. Now we also want to be able to show that little count, this number 2. So we're going to ask, go ahead to the make objects all, but don't give me a list of them, count them and give just me a number, give me a number. So make count is stuck in there, and you'll see if make count is greater than 0, we can show the add an auto button, and it also somewhere, yeah, shows the make count, view all the makes, add a make, and the make count comes out here. So that's another thing we put in. The auto list, we're going to go through, and that iteration variable of auto is going to go through each of the separate things, and nickname, make, etc. That's right straight out of the models.py file. There's the 4 things that every auto has, and we're just printing all this stuff out. You also get the primary key, and so we're going to make a update URL, and that URL is to auto's auto update. So if we look in urls.py, we see this auto update looks up this, gives us a path to the view, but that particular path needs one parameter, which is a primary key. And so that means that this URL template tag, autos, has to have the auto ID. But because we're looping through the models, you got one, right? So, and you do an auto create, that's pretty straightforward. But one of the rules is you have to have at least one make before you can do an auto, because if you recall, add an auto has to have this drop-down list populatable, and that's being pulled from the make table. Okay? And so that's basically the way around this. That's the main view. Now, just like I showed you before, it turns out that there are here we go. Auto create update. Yeah, that's the autos view. So, and then if we do the make view, we're doing the same kind of thing. If we go and look at the make list, we're doing the same basic kind of thing. View all the makes. This is the, and now we got update and delete. We are, this way you don't need a count. We just want to grab all of the objects. We want to put it in a context under make list, and then we do make list under HTML. And this is even simpler. It's just going through the make list. It comes in through the context. If there's none, we don't print this out, and then we put out the name of it, and then we have an update and a delete button that goes to the update and delete. And of course, those, if you look in urls.py, those also, the update and delete, have primary key requirements. And so you have a primary key that you got to pass in here to make that URL the proper kind of URL. And then just some links to go back to the various things so that we can, get back to autos, view makes, add a new make, cancel, all that stuff. Okay? So that is the views.py for listing the autos and the makes. Okay? Now, we want to make the make create view. Okay? So if we take a look at the make create view, that is add a make. That's going to create this form. I can make this bigger here. Create this form where we're going to put in a thing called Chevy BY. So we need a way to make this form, right? And so we're going to make it a login required. We're not going to let folks do this. We're going to have some variables that are class-wide, like what template we want to use. And success URL is after we have done this right. Now, if you just submit it and it complains, it doesn't do it. But once you've done it right, where do you want to go afterwards? So Chevy. Where do you want to go afterwards? This is a controller function. Boom. I want to go back to the auto list. And so the success URL is go to autos:all, which in urls.py is this main view. That's the name of the main view. Okay? And so if we go here, which template to use and which success URL. If we do a get request, we're going to build a form for the make. That comes from make form, but really it comes from the make model, which is just one string field. It's simple as that, right? We're reusing this. We're just saying, let's make a form that pulls from here. We have to pass a form in because models can't be used to create this kind of a screen. That screen comes from a form, okay? And so if we take a look at the template, if we look at the make create template, make form. So that is, yeah, that's the template we're going to use to make form. We're going to need form as table, right? So that's from how we did forms. Put the CSRF token, you make a table, that could be as paragraphs or as tables, but whatever, you need this form object. So you need to pass the form object in. And so here we are. We're going to make a form, and then we're going to pass the form object in, and then we're going to render it at self.template, autos.makeform, HTML. And then we're going to return that for the get. And then when we hit the button, the submit button, add a make, we hit the submit button, it's going to do, it's coming into the post because we made a form post, comes in, we're going to take the, oop, don't do that, oh, that's terrible. I hate it when VI does that. But here we go, we're back. Yeah. So, post comes in, request.post has all the key value pairs, which are these key value pairs as defined by the form. So we say, let's make a make form with the initial data coming in from request post. And given that the form generated it, it knows what the names of these fields are, and this is something that hides behind how forms work. But it also checks to see if the form data is valid. And that means, were all these validator rules followed? If the validator rules are not followed, if not form is valid, we're just going to send it back. And so so this code here, this if form is not valid code, if I put in a single letter, A, and hit submit, it's going to come back and re-render the form, and all that error stuff, all that stuff is all handled by this form code. This Django form code figures out what is wrong. Right, let me move this over just a little bit so I can get back to it faster. There we go. It figures out what's wrong with it, makes an error message. The error message came from models.py right here. Oh, no, right here. And then went through forms.py because it is a form ultimately that we inherited from model form. Get it? And so that's cool. So that's the error condition. And otherwise, we do form.save. Now, the thing here is that's really super cool is because this form is a model form. It knows this, and the field names are the same as the field names in the model, and so it actually does a save on the model itself. So in a way, the form contains the model data that came from the post request, and then it saves it. Okay? That saves the form. It puts it in, and then we just redirect back to the request URL. So this is pretty succinct, right? We pull in the post data. We check to see if it's bad. If it's bad, we send it back, send the form back to the exact same template we did, and then we save it if it's good, and then we pop to the success URL. That is a beautiful thing. But just like in Django all the time, this is a far wordier thing to do, even though this is super succinct. And if you did this in almost any other language, you'd be like, 75 lines of code. And here we have like 15 lines of code. But it turns out in Django, there's almost always a more succinct way to do it. We have a generic create view. You can take a look at the documentation for this generic create view. Django views generic edit. Let's just go and Google this stuff. I always just put a dot here, and this usually gets me right to, because that's the actual package and the class inside the package. Oh no, sorry. It thought that was a domain name, so the search didn't work. But now I'll just say, Django something. Doesn't look like, so at least it's going to do the search for me. Generic editing views jump to the create view. So you can read through all this stuff, right? Generic create view. Actually, let's make do I have a reference to this? So there you go. Take a look at that. Now, this, just like some of the other views that we've inherited, have a ton of functionality in them. So if I want to do an auto create, this is all it takes. Now, auto create and make create, for all intents and purposes, do the exact same thing. So what happens in auto create, because we're extending create view, we have 3 bits of metadata. We tell it which model we want to use, which fields from that model we want, and where the success URL to go is. And then this generates all this code. We inherited all that code. You'll notice that there's nothing hard-coded in here except the make form. Now, we don't even have to make a form for the auto, because this code right here builds the form. And not only that, but it uses this name auto to pick the template. So if I do auto underscore form, I have to use this, right? I use this, that's my base bootstrap. Don't worry too much about that. And so it knows the name of the template that it's going to use. I don't even have to tell it which template to use in here, because it derives the template. Auto underscore form.html is the template. Pretty cool, huh? Pretty awesome and cool. So it automatically finds that and the success URL. And so this is all that's needed. As a matter of fact, I could, in this make create, I could have deleted all this code from here to here, but instead just do a create view by extending create view. So I'm just showing you this because I want you to see what's really going on. But this is not how you write your code. This is how you write your code. Okay? So now I want to show you the hard way of doing an update. So what's an update? Let's take a look at the code. So let's take a look at view makes. Update is the thing that happens when we go here, and that's going to go to make update. So here's make update. Here's urls.py. It's this one. Lookup primary key update, which then if you look under here, it's going to be autos lookup one update, right? So I'm going to update the Chevy one. It has to read the old data, has to show it to you, and then let us update it, and then submit it, checking, of course, for any validation errors, and then redirecting us back to a success URL. So if we look at the views, we're going to, again, foreshadowing, there's a much easier way to do this. So we set these variables, where the success URL, which template we want, and the model, okay? And then we have a get request, and because in the urls.py, there's this int pk, we're passed in this pk value. Now, this get object or 404 is really cool, okay? So self.model, this get object 404, self.model pk equals pk. That's this parameter, but we're passing pk equals, and it's common that they're the same name, but this is a parameter to get object or 404. The second one is the parameter that was called to our get. Self.model, of course, is make, right? And get object or 404 basically checks to see if, so I'll do this update. Let's go to makes. Let's do an update. And what it's doing is it's taking this number, this 3 here, autos lookup 3 update, and it's retrieving the old data. Now, what happens if I inadvertently have a number that doesn't exist in the database, like 9,999, and I do a get request to that one, I get page not found 404, right? And so what's happening here is somehow you say, hey, load this object and give it to me in the variable make, or just blow up and send out a 404 error, right? And so this is telling you what's going on, which view you just know matches the given query. Now, generally, you're not supposed to hand type these. 3 works, and so it doesn't blow up. So getObject or 404 is a way of loading the old data and then protecting, and using that data or just blowing up. So don't go any farther at that point. Now, then we're going to make a form and we're going to fill it with the old data. So what the instance is make. So that's the object. Make a make form. Here's a make form. All the fields from the model inherit from the model make. And then pass it into the template make form.html, which we just looked at. This form comes in. That's all we need. This is very generic looking. It really doesn't care too much. It's all pretty much encoded in this form, which is derived from the model. Then, of course, we type a bunch of stuff in, blah, 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 and we hit submit. And it does exactly the same thing as the create, in that it does, well, first it has to do a get or 404 because we post to the thing with the primary key. We load it up to make sure we have an object to update. Then we create a new make form from that database and then change it. So this is the starting data, but then it alters it to the data. So in this particular case, Chevrolet is the old value in the database, and if I say bow tie, request post will have bow tie. This will start as Chevrolet, but in this form object, then it will be bow tie. Of course, if it's not valid, we're going to return an error message right back here. And if it is valid, we're going to save it, and so this new bow tie is going to be saved in there. And so if we view our makes, we see that it's now bow tie, right? And we're going to redirect to success URL. Now, at this point, I would hope you could predict about what's going to happen next. Auto update extends update view, the generic editing view. It says which model it is, which fields you want, and where to go when it's successful. Okay? And then it does everything that's in here, right? It does everything that's in here. And literally I could go and say the exact same words for make delete, which is what happens when you go in here and you delete, and then you have a cancel. There's a there is a confirm delete, and the name of this template is not randomly chosen. It's got to be called the confirm delete, the model confirm delete, right? And there you go. You got a CSRF token. You're handed the make as an object in this, so that produces this output. There's no form in this one. There's just the make that gets loaded by object or 404, and then it passes make in and renders it, and then when the post happens, it retrieves it. If it's there, with a 404, again checking for bad data and deleting it, and then hopping off to the success URL. And it doesn't take much to guess what I'm going to do next, and that is, if you extend delete view, you get all that code for free. You just tell which model, fields, and where to go for success. And so the key thing is as you're doing your homework, I'm sure some of you are just going to copy and paste all this stuff. That's wrong. This make create, the make update, and the make delete should be as short as auto create, auto update, and auto delete, because you're going to do this a lot, right? You're going to do these generic editing views a lot, and we're going to do CRUD over and over and over again, and you really do not want to write 15 lines of code. That's unnecessary repetition, unnecessary cutting and pasting and changing code, if you can keep it really simple. So I can basically build a full set of CRUD forms and CRUD functionality with validation for a model with this kind of code. And then I don't even have to have a forms.py, I just have a models.py. So if you're doing your autos, you kind of would think, I made a mistake if I'm making a forms.py. Because if I just use this views.py this way, instead of making all of them look like make update, then you're going to save yourself a lot of time and energy. And when you have to modify these things, it's a lot easier to find all the changes and then modify them. So that is a walkthrough of the sample code for autos. And you're going to do an assignment on this, but don't just copy everything. I set this up so that the time you spend understanding what's going on, particularly in the views, right? URLs you'll probably just copy. Models you just copy. The URLs you'll just copy. But the views, don't just copy it. Figure out what's really going on and come up with the easier and more succinct way to do all this stuff, okay? Because Django is starting to look really beautiful at this point. So I hope you found this helpful. Cheers.
So now we're going to talk about data validation. Data validation is what happens when you hit the submit button and then that data is sent to the server. And what the server does is it checks that post data that it's getting to see if it's proper according to its rules. So if you go back to this picture I showed you in the create form, the part we're talking about now is really this part right here, where the user has entered their data, they've hit the submit button, and we in the server are going to look at that data. And then we are going to decide if it's an error, send back a form, or store the data, and we're actually sort of just have a comment say store the data, and then go to the success. So we're really looking at this part right here of receiving and validating the data and then taking all those actions, okay? So the idea of data errors is you're typing in a form and you forget your zip code and you hit the button and a little red box pops up and says zip code is required. Now you can also tell the fields in the browser that they're required so that the browser won't even send the data. That's different, and not all browsers do that. So you still have to check if you really want the zip code. You got to check to make sure the zip code is there. Now in this one I made it just to generate errors. I made a validator on that form, if you recall, that said that all the titles have to be at least 2 characters. And here's a little message, please enter 2 or more characters if that's not true. Because otherwise, the fact that it's not a string or a number or whatever, because the browser is a little too smart for us. So I had to come up with a validator that would fail in the server and not fail in the browser. You still need to validate data in the server. So you type some stuff in, you make a mistake, like in this case, the title was only 1 letter. I hit the submit button, and now what I want to see is a thing that tells me what the errors are and gives me a chance to fix it, including putting the old data that I just posted, right? So it gives me my post data back. And then I get a chance to resubmit. So again, here's the data form. And the validator there it's a min-length validator. If you go look at the documentation, there's a jillion validators. This was really simple and it fits on a slide. So basically, in addition to whatever the fact that it's got to be a character field, I want it to be at least 2 characters. And that's not a crazy validator to have, because you might have a post that says, look, you're not going to have a title of 1 character when you're doing a blog post or something like that, right? You might say, look, at least 5 characters. So now we're going to walk through that process. And so if you take a look at this code from the form, in comes a GET request, and that GET request is going to show up with some old data. It's going to create the form with the initial settings. It's going to build a context that it's going to pass into the render. Same render form that just makes the thing with the table tags and CSRF and form post. And so at this point, we are a GET request. We are returning a 200, which is returning the HTML for that page, right? So that's the first part of it. And that is in the edit process, get the old data, show it to the user, and give the user an opportunity to change the data. So now we change the data, right? And let's just say we didn't make any mistakes. You changed a few numbers, you hit the post, which gathers up all this stuff and sends it as a post request to the server. So then what happens is it comes into the post method. See how these class-based views are so dang pretty, right? So pretty. And so request post, right? All that data coming from the form comes into request post. And you just construct the basic form and say, hey, basic form, your old data is from the post. and all the fields are named the right way, and the key value pairs. I mean, this is basically a dictionary, but the form made the key value pairs. It knew what names to name all the forms, so it named them, and so it's not surprising it knows exactly what to expect in there, right? And so it takes a look at the post data, and then it constructs us a form object, right? It constructs us a form object and basically says if there was a validation failure, if not form is valid, then we're going to do one thing. But in this case, I didn't make any changes, so form is valid, so it drops down. This is where we would normally store the data off to the model, but I'm keeping this really simple. And then I'm going to redirect with a 302 to form success. The other thing I might do is put a message in the session so that the message makes it into here, but I'm keeping it simple. And the browser immediately comes back and does a get to /form/success, and then I return thank you very much. I might have pulled a message out, as we've seen in an example, where I have, from the post method to the next get, I drop a flash message into something, but there's better ways to do that, and I'll show you that in an upcoming lecture series. And so that's the success flow, and it works great. Now, let's take a look at what goes wrong. So in this case, I got my form, I put in the wrong kind of title, it's too short, I send a post, it gathers up all this data, sends it along with the post, that comes in request.post, and so now the form comes back, and now form is valid as false because I violated a rule. Now the interesting thing is in this form object is not only the old data, but also all the error messages, because at this moment it has constructed a form object, and part of the form object is error messages. Okay? So if it's not valid, let's make a little context. Okay? Let's make a little context and pass that in, and then out it comes, and at that point, that form as table is going to print out all of this stuff. All those error messages come back. So I render it back. Now, I render it back, and then of course you can submit it and maybe get to a success. Now there is one sort of interesting question about this page, which I have asked a Stack Overflow question about, and I'm not sure I'm ecstatically happy about it, and that is this pattern is exactly how Django wants you to write it. It wants you to write this. And if you'll notice, I'm doing something I told you not to do. Django is telling me to do something that I don't want to do, and that is return a 200 at the result of a post. So I got a post. Now the key thing is, the thing that everyone will agree on is once you store data, you have to return a redirect. And so the Django people who've done this for years, they consider it okay to return the 200 and a page after a post if no data was changed. Now the problem is, if you hit refresh on this, you're going to get the weird funky message. But this is how Django works. And so I don't know what to tell you. I can write my forms differently. It's a few more lines of code in here, and I've written that, and I've made it so that I pass the error message and I serialize the form and put it in the session and do something. But I'm not going to fight City Hall on that one. I'm just going to say if Django thinks it's fine, the thing we do agree on is if you're going to return a 200, don't return a 200 after you've saved data, because then you'll double save the data. Like you'll double commit a transaction, you'll double do a transfer, you'll double order, you'll do whatever. But in this case, all we did is looked at the data, came back, and then sent back an error message. So you can look at the Stack Overflow where I sort of argue for a little bit. So this has been a long lecture series. We talked about HTML, we talked about HTTP, how get and post are different ways of doing it. We've talked about the idea of how to fix the refresh.
Welcome to another Django for Everybody code walkthrough. In this, I am going to walk through the Hello World application that you've got to do. This is the DIY part of the course where we've been developing an application for a while, and you've been modifying an existing application, local library, and its catalog, local library project catalog application. And it's time for you to start fresh. And I want you to really understand what's going on. So I'm going to go through in some great detail. So this tells you how to get started. And we're going to assume that you're running on your local computer. If you're still running Python anywhere, that's okay. I've got another video for that. So somewhere you've got a folder called Django Projects. And so I've got my folder in, this is a Macintosh, and I've done all of the installation. I sort of followed this installation. Now the weird thing is there's so many different ways that you can install Python 3 and Django on your computer. You might use Anaconda or Miniconda or pip or whatever. And so I haven't given you like every single possible version of how you might do that. You have to kind of figure a bit of that out on your own. I've been giving you some online resources. But hopefully, when it's all said and done, whether you've done a virtual environment or not, you have things like Python 3 running, and you have Django, minus M Django, Python 3 minus M Django version, and you can look at what is your current pip. In mine, all my extensions. You might not even be using pip for your extensions, but if I say pip freeze, I use pip 3 to install them. Yeah, I see all the versions of all my extensions, and if I look through here, for example, I can find Django extensions, and that means that I have Django extensions. And some of the problems that people have are like when they don't have the right extensions installed. So here I am in Django projects, and if I do an ls, you see all the projects that I've got. I've got the local library and my test site. Those are from before. This is, DJ Free is the one you're going to work on, but you're going to work on that and add stuff to it, and so that's a later version of it. I made another one that's just this first Hello World, so I can take a look at it, and I named it First. And so you would do a Django admin start project DJ Free, but I did a Django admin start project First, and that's just the name of it. And then I went into that folder, and so I'm going into the first folder, First, and then I did a Python 3 manage py start app home. And so this shows that I've got a home folder, then this first folder, which is the project-wide settings.py and project-wide urls.py, and of course the db.sqlite3. Now, at this point, when you're in this folder and you've got these things set up, it might not hurt to do a Python 3 manage.py shell, because if this doesn't work, then you've got some configuration wrong. So the fact that this worked and didn't blow up with a big traceback, that suggests that I've got all the right stuff installed, and it's good. So I just have to Control D to get out of here. So there we go. That's a funny looking shell prompt, but that's how it is on my Macintosh. So that's weird. Your Linux boxes and maybe your Windows boxes look a lot prettier than that. But the point is, if you can't run Python 3 manage py shell, make migrations isn't going to work, etc., because this manage.py loads up everything. It loads up all of your applications and all the urls.py and all the views.py. And so you think, oh, just start a shell. Well, no, this is completely construct the Django application and then start a shell in that Django application. So if there's anything wrong with any of your files, well, you go, now ignore this little part right here. The .quit didn't work. Okay, so let's take a look at some of the files that matter. So the first thing is that the folder that is the same name as the project folder, and my project folder is First. There is first/settings.py. And if you take a look, it tells you what to do here. A couple things I'll call your attention to. So leave debug true. Do not set debug to be false, even though the comment right above it will encourage you to do it. What it really is doing is telling it whether or not to give verbose error messages. When debug is true, the error messages are verbose. When debug is false, the error messages are cryptic. Well, you're writing software. You need all the help you can get when you make a mistake. You want verbose error messages. So debug equals true means verbose equals yes. Allowed host. This is one we've had to do every time we make one, where we basically, that is the addresses from the internet that are allowed to access this application. And then start start project sets this up, and then you have to add a home config, your home apps home config. And so that is the setup to get your home application loaded. And if you take a look at first/urls.py, and by now, if you've done stuff in local library, your URLs are pretty complex. We've got pretty simple stuff. We're just going to include at the base URL all the home URLs, and then we're going to bring the admin in because we're going to need that later. So that is the urls.py. So that is the first things, and there needs to be a, in your home folder, urls.py, you have to create this file, but I give you the exact text of this file. And we're going to use a template view, and we're just going to have a template name. Remember that templates are global, and so we kind of re-add the, I just dragged that, I undid it. We add the home/hello.html in a way to kind of create a global namespace of templates. And so that's your urls.py, and I completely give that to you. And then the last thing that you're going to edit is the home/templates home. Again, you have to do this twice. Hello.html, and against this last part, home/hello.html matches the templates in the urls.py, and you just put HTML in here. And I just happen to put an h1 hello world. Now, if we are sitting here and we've got these things all correct, we just say python3 manage.py run server. Now, this is going to connect to my local host 8000, 127.0.0.1/:8000. That's port 8000. And if you've got one of these running in a different window, it will say the port is already busy, but you're jacking into the port. If you go all the way back, we talked about the request response cycle and servers. You should remember about ports and how servers grab onto ports so they can listen for phone calls. So we are going to go into localhost 8000, actually just go on 27, doesn't matter. And so that retrieves our page. Now this shows a couple of cool things, because it showed the get. And so one of the nice things is you can watch things as they go on, and you see traceback errors and everything. And so I really like developing locally whenever I can, because I can really quickly switch from one application to another. So let me show you how I will switch from one application to the other. I'm going to hit Control-C to blow this up. So now there is no server. And if I go to this, it's going to say, sorry, I can't get that. And now I'm going to say cd ... I'm in my Django projects, and I've got a whole bunch of things. Let's go up one even more. And I've got DJ for ease samples. So I've got this checked out. And there's a manage.py here. And I can say python3 manage py run server from this folder, which then runs that application. And now I can go to that exact same address, and I have a completely different application running on it. So this, and I can see the errors and favicons. This one actually has a favicon, I think. I don't know why the favicon didn't. Oh, maybe it doesn't do it for localhost. And so this ability to move around really quickly and start and stop servers in your Django application, and the ability to watch this stuff as it's running, is a real important part of why you'd run a local server if possible. And of course, I gave you a installing Django locally that does its best, because each thing is going to be a little bit different, and away you go. Okay, so in general, this is how my Hello World application is structured. There's really only 4 files that you need to edit and get right, and then you have to mostly the hard part for local running is getting your installation all done. So I hope this helps. Cheers. Hello and welcome to our tutorial on the Hello World application for Django for Everybody. So I am going to go in excruciating detail how I have this Hello World, how this comes out at drchuck.pythonanywhere.com. And now if you go to this website, you never know what you're going to see, because I have lots of Django projects that I can mount up on this URL, and I'll show you how that's all done. So, so let's go ahead and get started. I'm going to wake up my Python, just my Python for Everywhere, Python Anywhere dashboard, and walk through a couple of things. So I want to call your attention here to my left-hand side here. So you see that I've got a bash console and a bash console in the virtual environment Django 2. It's probably a good time to review what a virtual environment is. If you go back to your old installing Django on Python Anywhere, I have this assignment, and if you go back to this assignment, that's paw_install_md under the ASSN folder, you had this thing make virtual environment, pip3 install Django, and then work on Django, and then we would do Python 3 -m Django -- version. And at some point it showed you the Django version. And if you recall, this took some bit of a long time. And virtual environments are a way in Python for you to change the overall Python configuration and install things that the owner of this computer has not installed themselves. So, so Python Anywhere, they installed a version of Python, they may have installed Django, they may or may not have installed Django extensions, etc. And so you want to have more control over what bits of software are actually running in your environment. So instead of using the system-wide Python, you're going to use your own environment, and that's what a virtual environment is. And so this is creating files in your home directory, and if you go in under Files. So I'll go in under the Files tab of Python Anywhere. If you see it in your home directory, you see .virtualenv, and if you go in, you see one folder called Django 2. And that actually has lots of stuff. You don't want to include, you don't want to mess with this. That virtual env Django 2, .virtualenvs Django 2, that was created by you when you ran make virtual environment, and it downloaded a bunch of stuff. And then in that you could run the pip3 command, which is installing extensions to Python. Now on your laptop, you might be able to just run pip3 normally, and just install more stuff once you have it configured properly. But now we're on a shared system at Python Anywhere, so we have to do virtual environments. You can do virtual environments in your laptop as well. It's nice if you do it, but it's not essential. Sometimes you can just run pip yourself and have the system-wide Python get all your stuff. But sometimes your laptop can get messed up because systems like Anaconda or Miniconda really confuse your Python, and that's unfortunately because there are so many ways to install and reconfigure Python on your laptop that can get you in trouble. But in this Linux arrangement that we have with Python Anywhere, it's actually pretty easy. You make a virtual environment, it works pretty good. Now, every time you leave and make a new shell, you have to say work on Django 2, otherwise you've inherited the standard things. And so if I take a look at my dashboard, and you see I've got a bash console, and then I've got a bash console in the virtual environment named Django 2. And so if I click on the bash console alone, you see I don't have the work on the Django 2 prompt. Should be a sign that something's not going to work for you. And what you can do is you can always just say work on Django 2. And that says for the rest of this session, until that bash console goes away, I want to be using the Python that is part of my virtual environment. Now there's a command in Linux called which. So I'm going to say which Python. Well, now it might actually, this one might python3. So you'll see which tells me if I type the command python3, which python3 says, if I type the command python3, where's it going to load that code from? And you see that which python3 is going from the virtual environment, meaning I have installed a copy of Python 3 in my home directory, and that's the one I'm using when I type Python 3. And that's the essence of how this virtual environment works. So I'm going to log out of this shell. Okay, exit. We'll just exit. Okay, so now if I go back to the dashboard, I should only, so I have this one here. I'm not going to click on the bash console and virtual env yet. I'm just going to start a new console, and that'll start one up, and I won't be in the virtual environment. So that's the key. Every time you start a new one, you see I'm not in the virtual environment because it doesn't say Django. If I type which Python 3, that is my own local copy of Python 3, and I don't quite know how that works, but it's not the system one, but I'm going to guess that is not one that's in my virtual environment. But there's other parts that of the virtual environment that are important. So that just shows you that. I'm going to exit out of here using Control D, and that's going to close this. Now I can go back to my dashboard. Now, there's a really cool thing that you can do to make sure you're always in a virtual environment. And I do this all the time, almost without thinking. So I'm going to go under my Web tab in Python Anywhere. And if you scroll down, one of the things you were supposed to set up is this virtual env area. And I've got that path, the exact home drchuck.virtualenvs Django 2. That's got to be in there, or my online web application is not going to run and start. Okay? But I can also then start a console in that virtual environment. And that's how I created that console. And if I click on this, start a console in the virtual environment, it actually starts it and then does the work on for me automatically. And you see that I've got Django 2 here automatically. And so that means that sort of all my Python Anywhere stuff works. You'll notice I'm actually properly in the folder for my Django project. And that Django project is the one that's currently mounted into my, I'm going to exit out of here. And so close this, go back to the Web tab. And so back to the Web tab, there are these variables, source code, working directory, WSGI configuration file. Those are telling the Python Anywhere which of the Django projects am I really mounting at this point. And we'll talk about these later. These three files allow me to have in my home directory on Python Anywhere a whole bunch of different projects and let me switch between them. The local library project, the Hello project, the DJ Free project, the my setup. And so this is how you switch it. Of course, whenever you switch these things, you've got to do the reload, right? So that's sort of my summary of virtual environments. And so I would say, ultimately, don't try to reinstall your virtual environments, right? I would install it once, and chances are good, if you did it right, your virtual environment is not broken. What is most likely broken is the fact that you're not using the virtual environment. So a lot of people are like, oh, I'm going to blast this virtual environment, trash it, and try to go all the way back to the install. Sometimes you might have to do that, right? But it kind of confuses your system if you are like running in the virtual environment and you wipe out the virtual environment, you try to remake the virtual environment, and it doesn't work so well. So just in general, once you get the virtual environment set up, leave it alone. Don't try to fix it. It's probably okay. Start a shell, say work on Django 2, and if it doesn't blow up, you're probably okay. Okay, so that's a quick review of what we have with virtual environments. And remember, this is PAW_install MD is the place where we set that up. But at this point, it's some time ago. Okay? So now that we've done all this, I'm going to go into my Web tab. And from previous times, I've got this virtual environment. When you switch applications or switch Django projects, you don't switch the virtual environment. That stays the same. That's just giving you Django and Python and all the Python extensions, the Django extensions that we've added. So I'm going to go ahead and start a console. Hopefully I'm not running out of them. I keep exiting them so I don't run out of them. So I'm happy at the point where I've got a bash console and it's in the right folder and it's working in the Django 2 virtual environment. So you see that. I'm working in the Django 2 virtual environment. I'm in /Django_project/first. Now, I'm going to say cd ... to go up a folder. And so this folder is Django projects. If you're using GitHub, this is what you check into GitHub. And so this has all the work I've done so far in this course. I've got my test site, which was the very first assignment, then local library, which was all those whole series of assignments where we're making books and authors and all that stuff, and that code's all sitting here in local library. My folder's called Django projects because each one of these is a different Django project. Checklist is something we're going to build later. DJ Free is what you're building, hopefully, about right now. But I didn't name it because I had this thing called First, which is, I should probably call this the beginning. But First is this application that you're building from scratch at this point in this kind of DIY hello world. So First, I made First by using a Django admin start app, and let's go to that, the Hello World page. Hello World. So, right, Django admin start projects DJ for E. That's going to make a subfolder within Django projects. You got to say work on Django 2 if you need it. But if Django 2 is already showing in your prompt, and you don't have to keep saying that over and over again. And then you're going to start an application within that. So I've gone down one folder into tilde Django projects DJ for E. I ran Python 3 manage.py start app home. And so if I take a look at the folders, I've got database. I've got first folder, which is the name for the Django project. That's for settings.py and urls.py for the entire project. And then I have one application called home, and we'll talk about that in a second. And that is the sort of first application. And home is actually where the template that renders hello world is going to be shown. And so that's all good. And so I'm in project first, and I've done this other than I didn't name it DJ for E, I named it project first. Okay, now I say how to start Django new project if you're on a local computer. You're not on a local computer. You are in Python anywhere. So let's take a look at some of the files and the important things. And again, the instructions tell you how to edit these files. Or let's just file the outline of the homework assignment. So let's go into, I'm going to open this in a new window, the Web tab. Now, the Web tab is really cool. There's a reload, although you'll see that there's little reload buttons all over the place. If there's a little reload, there's not one here. I wish there was in the console, but there isn't. But reloading it is when you make changes, okay? So the key thing here is this code section. And there's source code, working directory, WSGI configuration file. Again, I said don't change virtual envs. And then there's this error log down here under log files, drchuckpythonanywhere.com error log. If you get the dreaded something went wrong with a smiley face, then you have to go look in this error log and scroll all the way to the bottom. But back to code and source code. So the working directory and source code are two of the three things you have to switch when you're going from one project to the other. And that is just the full path of the source code directory and the working directory. Working directory tells it how to find the db.sqlite file, right? So that is the file. And there's going to be many db.sqlite files under Django projects, one for each of the Django projects that I build. And that's where migrations, and so in every folder under Django projects, there is, here, let me go, cd ... I'm going to say ls-l star, that means in all folders, /db.sqlite3. And you see that there are a number of db.sqlite3s. And so it's important in the web app setup, I'll go back into first, cd first. It's important in the web app setup that you tell it where to go to get the db.sqlite3 file. You just edit this and you change it. Now, pretty much all this is the same, except the last part where it says first, and then you're going to change that. Now, you'll notice the path to the WSGI configuration file is not in your home folder at all. And so you just have to edit this. This is kind of in the system far, far outside your control, but it is the way that you tell the Django starter upper code that's part of Python Anywhere how to start your code up. And so here you generally have to get this path right, the OS path expand user tilde, which is my home directory, /Django project /first. That basically is the path to the Django project. And then you have to say first.settings. That has to do with the fact that this is the first module gets imported, and that's a object within the first module rather than a file path. So that's not really a file path. That is a module. Whereas that is a file path. And so you can switch back and forth, right? You can switch back and forth between many projects by changing those. There's two things you got to change here. You don't have to retype all this. You just change those two things. The word first, maybe it's local library, maybe it's my test app, who knows, but it's a way you change it. And then you go back to Web tab, you change that file, the WSGI configuration file, and then you change the source code and you change the working directory, leave virtual environments alone, and then reload your application, and then you should see your application. Finish reloading, and here we are, drchuckpythonanywhere.com, hello world. So I've showed you how Python Anywhere and virtual environments work, which is sort of like the outer wrapping of your application. And now I'll just sort of show your application. Now, this all is described in the section under djfree_hello.md. Change the source code, change the, your virtual environment should already be pointing, right? And then you gotta, I tell you to change these things, your name is not first, right? So your DJ, everything, or I'm using first, you're using DJ free. And then I tell you to make some folders. So home is the first application. Underneath it, you're gonna put more in here. So you got to make the folder for templates and folder for templates and templates home. The command to do that. So I'm in first, make dir home/templates. This is going to fail because it's already there. Yay! And then you got to add it again. Home templates home. Got to make that folder. So that you've got to do. I'll change that to put those instructions in. And then you got to create the file. Come back. Home/templates/home. So you got to put some HTML in. I'm going to put it in hello.html. And I say hello world. That's it. So I've got it. Okay, so I'm in hello world. Now you may have to put some more stuff in here, but that is the text that is this. Now, let's talk about how it all gets to work. Now, you've got to change the settings file, and yours will be DJ free. Mine is first settings.py. I'm going to edit that. So there's a few things to look at here in this file. Oops. So some mistakes I've seen students do is this debug, you want it true. They're telling you to turn it to false if you're in production, but you're not really in production. You're writing your code. When you're developing, you want debug turned on, and that has to do with the fact that it gives you more detail when you make errors. Otherwise, it's very cryptic about your detail. So a lot of students will come in, I can't figure out what's wrong with my thing because it just says error. Well, that's because you have debug to false. Now, reading this comment, it's really quite reasonable, so I just remind you over and over, do not set it to false, otherwise you will have great difficulty dealing with your application. You have allowed hosts, which basically says who can hit this application, and you want basically anybody, that's anybody on the internet to hit it. Okay, so we have the apps here that we want, and so those are the things that you've got to do. Get debug right, get allowed host right, and get the apps right. Okay? So that's that file. Then you've got to edit the file first, or DJ free in your case, urls.py. And this, you'll put the admin and home URLs so that you can eventually do the admin. The admin is less important in this particular first application, but you're going to need it soon enough, so we might as well just put it in. And then include the URLs from the home application within the first project. Okay, and then if we take a look in the home folder, pi home/urls.py, so here I just am going to import a template view, and then I'm going to basically route slash, so it's basically routing. The global URL routes the no path into, come back, global URL routes no path. There's like nothing here, right? There's nothing blah blah blah, there's nothing after it, right, slash this. So it's like there's nothing on the URL. That gets routed into home.urls, and then I'm routing nothing within home.urls into just the template home/hello.html, and I'm giving it a name for no particular reason. Okay, and so those files, the first settings.py, the first urls.py, home urls.py, and the home templates home hello.html, those are the files that you've got to create. And then you go to your web tab and you make sure that your code section has pointing to the right folder, both source code and working directory. Your WSGI configuration has been edited to point to the right folder and then load up the project-wide settings. And then, I think I can hit back here, yeah. And then make sure your virtual environment is right. Don't keep changing this, okay? And at that point, you should be able to reload your application. Visit your URL, and it should talk. And if it fails, if you don't get that and it sends the little funky message, well, let's just do this. Let's just cause the message. So I'm going to come in here in this WSGI configuration file, and I'm going to mess it up. Okay, and I'm going to save this, and then I'm going to go back to the web tab, and then I'm going to reload it. And if this goes well, something went wrong. Now everyone looks at this and they go like, oh, let's run and get help. It's telling you what to do. You look here in this error log first. I'm going to open it in a new window, drchuckpythonanywhere.com error log, and then scroll all the way to the bottom. Now the weird thing here is all of your errors that you've done, right, are in here. So you got to get all the way down, right? And you got to look at the bottom, and you can even look at the times of these things. And it's a traceback, so just like in any Python, there's a lot of stuff that has nothing to do with you. But look at this one. Module not found error. No module named XYZZY. Error running WSGI application, right? And, I just forced an error, right? And sometimes you can look in the server log to see it. If there's nothing that seems like it might be a suspect, you can check the server log. But the error log is mostly where you do this. So let me go fix that now. I made a mistake here, and I've got to change this to be first, XYZZY to first in the WSGI configuration, and then first again in the WSGI configuration, and then I save the file. Then I reload the application. This is up here in the file editing. I reload the application, and if all goes well, I should be able to reload it. So I hope this was helpful. It's a bit long. I wanted to just remind you of a whole bunch of things that can cause your application to go wrong. Part of the reason we're doing all this is so that your application can go right. But you've been working on the same application, and I want to get you focused on what it takes to build a new application and get that application running. Cheers.
So now I want to talk about a concept called virtual hosting. Like I said, this doesn't really affect you directly, but I want to sort of show you a little bit about how an organization like Python Anywhere can have a very small amount of resources and support a very large number of hosts. And this is the idea that they have one piece of hardware or very few pieces of hardware and many different domains running on that system. And this also kind of helps you understand why you have to configure Python Anywhere the way you do to help them route the request not just to the server but to your application within the server where your application is running. So if you recall with the request response cycle, HTTP, it makes a connection to a domain and then it sends a GET request with the domain in the GET request. And so here we have the little sample. We say telnetdata.pr4e.org, that's the host, and port 80, which is to say let's talk to the web server. And then we connect and then we send the GET request. And the GET request has a couple of pieces, right? The GET request has, the name of the document, including the server that it's going to, and then the protocol, and then a blank line. The key thing is you don't just say, get me any document. You actually tell it the host that you're looking for. And by looking at this, that's how the virtual hosting works. And so it says, oh, I'm one host really, but I can pretend to be many hosts and know which host I'm being asked for with that information. And so that's how the virtual hosting works. So when a GET request comes into a server, it can say, I have many virtual hosts inside myself, and I'll pick the right one. And so if we look at the browser's debugger console, we can see that it's asking and doing a GET request to a particular Python Anywhere URL and with a particular domain name, and the domain name is part of the request, which is what makes their virtual hosting happen. And so this is where in the web tab of Python Anywhere, you've got to give this thing about where are you at. And you have to say, within this server, I'm running at this home folder, and so that's your home directory, you know, Django projects, local library, your working directory, where it's supposed to go when it receives a request for you. And then it has this one configuration file, and you'll notice that that file doesn't belong, that www.mdntutorial_pythonanywhere.com_WGSI, the WGSI configuration file is not in your data space. So that's actually in the system, and that's the place where the system can look up where you're going, and then that file, and again, if you read that file, you'll see it's telling where it's supposed to go in the overall system to start in a directory and load the configuration for a particular application, and up you go. And so this is kind of the picture of how it all works. You know, you got a browser out here, and that the browser is making many requests to this server, which is one piece of physical hardware, and then there's a little piece of software. Often it's a open source software called Nginx, and it has a whole bunch of configuration files that you put in their user interface, and it has little instances of Django, one for each of the domains in those systems. And so you're isolated from all the other ones, whether it's MDN tutorial pythonanywhere.com, DJ4E pythonanywhere.com, or just some other kind of thing. It doesn't even have to be Django, it can be just about anything. And so there are these configuration files that allow, and all this really accomplishes is reusing some of the server hardware so that you don't have to have a dedicated piece of hardware for every single piece of software. And then within that is what I showed you before, and that is how the request works in your settings file. But the goal of Nginx is getting it to your front door so that your application gets the requests that are destined for it. So this is both how these applications are combined into one server using virtual hosting, but also how applications work internally. And so I just wanted to give you a really short overview of how this all works so that you can build the picture a little bit at a time over the next few weeks as you learn this material. Hello, and welcome to our lecture on owned rows in Django. So what do I mean by an owned row? Well, up to now, every CRUD application that you've written, you got a table or a model or two. Maybe they're connected, but basically if you log in, you can edit every row. And so if you do a list, you see an update and delete button on every row. Real applications don't work that way. If you're building a classified ad system, some ads belong to you and some ads belong to other people. You can see them all, but you can't edit them all. And so you have to decide when to put the edit and delete buttons up, and only do those for the owner. And we got to make it so you can't like sneak in and edit and delete other people's stuff. And so we have to protect these rows from being edited or deleted by anybody but the owner, but anybody can see them. And so that's why I call them owned rows. If there's a row that you own, you will see an edit or delete button. If there's a row you don't own, you'll see the row and the data, and you'll be able to read it and view it, and that's it. And so if we go back to how we were working in our CRUD application, we were making heavy uses of these generic views, the generic list view. And so when we're all said and done, after a whole bunch of machinations, you ended up with a very, very simple view. You ended up with a horse list view that extended generic list view. Generic list view is provided to us by Django. And the only thing we had to do was take this code, which is several thousand lines of code, and inform it as to which model we want it to be, and then we make another view, right? So we make the horse list view by extending generic list view and informing that list view that we want to do this in the model with horses. And from that point on, all kinds of convention happens. And so we know things like the variable will be named horse list. It'll be a list of objects that are retrieved from the list of model objects that are retrieved from the database. And so we kind of know how that works. And it makes things really simple, not a lot of repetition. Every view kind of looks the same. You probably have done cats, dogs, autos, a couple of different things. And they all look very much the same. And if you get good at it, you should be able to make these changes very rapidly. So if we look at how this is working kind of from an object-oriented perspective, we are making a new class called gview.views.horselistView, and we are extending, our parent class is the generic list view, and we're sort of adding our own little special sauce by saying one class variable model equals horse. Okay, and so that's kind of what's going on here. Now, in this owner view, we're going to do something quite similar, and that is when we're going to have an article, and this is all from the DJ Free Samples My Arts example, we're going to extend owner list view. Now, soon we will look inside owner list view, and we'll see that owner list view is extending generic list view, and this model equals article is informing owner list view. The difference is this is our code that belongs to us. And in the last part, we will show you everything that you have to do to build one of these things. And so we're taking the list view, which has almost everything we want, and we're going to add one feature to it, and then we're going to extend the list view and create a new view called owner list view, or you might call it list view for owned rows. And at that point, you're good. And this class owner list view, which we'll see in a second, has everything you need to deal with rows that are owned. And for example, we're going to have a owner column. So every article is going to have an owner, and if that's equal to the current logged in user, then we are going to show these little edit and delete buttons. But if the article owner, the owner value inside the article object, or the model, if that owner is not equal to the current user, we don't show it. Now, not showing a link does not mean you've protected it from editing. We'll show you later how that protection from editing happens. But this is such a common problem that we want to just be able to, in a sense, say, look, here's a list view. Here's a list view with this special owner column in it, and we want to maintain the owner column. We don't want to have to write hundreds of lines of code in every view that we want to have this owner column. So we just use object-oriented techniques to accomplish this. And so we're going to use inheritance, and we talked about it and talk about it again. Inheritance is the idea that you have a class, you're going to make another class that inherits all that parent class and then extends it, adds a little bit of stuff to it. And it's another form of don't repeat yourself. Do something once in a parent class. You make the parent class sometimes quite generic, then you make a child class that extends the parent class, and then we use the child class. Or we could call them subclasses or child classes. There's a whole bunch of different terminology, and it's all pretty much equivalent. Subclasses are more specialized versions of a class. They inherit attributes and methods from their parent classes and can introduce their own. Again, basic object-oriented. So now we're going to take a look inside of a generic edit view, and we want to look at how it functions internally so that we can override and extend some of those functions. So we can take the generic edit view and turn it into a edit view that supports an owned row. So this is a review. We've gone back a couple of lectures. This is the edit form flow, right? And I went through this in great and gory detail, so I'll just review it really quickly, right? So you've hit the edit button, right? So you do a get request to like /1 or /15. You're going to grab that data. Oops. You're going to go in. You're going to load the primary key 1 or 2 or 15. If you didn't find it, you're going to send in 404 error, and then you're going to fill the form with old data. The user's going to edit that data. They're going to post the good data. Then the form is going to be validated, of course, according to the form rules. Remember, the model kind of deals with the back end, and the form kind of deals with the front end. So the validation is a form aspect, and then if there's an error, it goes back and allows you to redo it. And then if there's no error in the submitted data, then we load a new model up. We reload the model, check to see if that model is accessible, and accessible is going to matter to a lot to us in a second. If it's there and you can read it, and you're legally allowed to read it, great. Otherwise, we're going to give you a 404 as you're submitting the data, and that has to do with if they messed with the form or something, or they're submitting it to the wrong URL. But if we can get the data, we change the data, and we store the updated data, and then we do the success URL, right? And so that That's the basic form flow. We did that before. We did that with every one of our CRUDs. And we also looked at this documentation in the generic list view. It could be in some of the edit views. At some point you will see in the Django documentation, it's telling you how this class is functioning internally, how it's working its own magic inside itself. And this is method flowchart. First it's going to call setup, then it's called dispatch. Check to see if the method's allowed. Get its template name, get a query set, load the data from the database, get the context object name, get the context data, and then render to response. And so you might say, why are they showing us all this? And the answer is because we can get our hands in and mess with these things. And these are like our access points into this generic list view class that allow us to dig in and make changes. And so if we were to look at that same picture and think of it from the point of view of which methods are being called at the moment where this generic edit, in this case it's going to be an edit view, this generic edit view is happening. So here we go. So the GET request comes in, it's got some primary key, so it does a GET query set, and it reads this thing, and then it reads it using GET query set. It's still reading it, but it happens to be doing it in a method called GET query set. And if GET query set works or doesn't, then it keeps on going. Then as it's rendering the template, it's going to get the context data by calling a method called getContextData. That's another place that we're going to play with, and we're going to inject ourselves into getContextData. Then we'll do the edit, the post will come in, and then it's going to do validation, but it does it in a method called formValid. So the first thing that happens upon the receipt of post is it checks to see if the form is valid. We're going to add our own little code into formValid as well. If it goes back, it does a render, so it's going to use getContextData. If it is good, there's no error, then it's going to actually call getQuerySet again to get the data, and then it's going to modify the data, and then it's going to store the data. There's some name for this, but I didn't put it in. The point is, each of these moments where there's something critical going on, formValid getQuerySet, that's a place where we can extend the behavior of this built-in class without knowing too much about the class. And I showed you at the end of a few lectures ago this crazy override. I did this crazy override where I made this weird equine view, and I have a model of car and a template name, and then I'm overriding getQuerySet. So this is extending generic list view, but instead of using the getQuerySet that's in generic list view, we're going to call our own getQuerySet. So instead of reading car objects, we're going to read horse objects. And then we're going to return a list of them. And that's what the getQuerySet has to do. The rule of getQuerySet is you get called, you have to return a list. If we didn't write this code, it would do this except with car. But we did write this code. Why? Because we wanted to override it. Was there any logic to it? No, just because I wanted to show you crazy things, right? And so because I've overridden in the generic list view, it's not calling the generic list view's query set at all, which would look at the model car, but instead it's calling mine that's in wacky equine view. And so when it prints out, you see a list of horses, not a list of cars, because I overrode what behavior was inside the list view class, which normally would be informed by that, but my code in here ignored it. Again, I have no purpose for this other than showing you that I can change the behavior of the parent class while creating a derived class. Now sometimes, in this case, I'm just completely overriding it, and it's like, I don't care what you were going to do before, I'm going to do something completely different. And you have to know what the rules are. I had to know what the return. It took me a while to write this, and I might have even looked at some Django source code to figure this out. But eventually, through Stack Overflow, I figured this out. So this is not trivial to write, and I'm not expecting you to write this. I just want to show you the technique. Like this keyword args, that's something. I'm sure at some point I knew what it was, but I just stole that off of Stack Overflow like everybody does. So in this def get query set, you'll see that I have just overridden and ignored the def query set from generic list view. Okay? That's one way of overriding a method. Another way of overriding a method is this get context data. So what is get context data going to do? Well, at some level, get context data is what puts in this list ends up going into horse list, right? So that's somehow this variable that I return here in query set ends up being put into my context as horse list. So then I can write this loop that prints that stuff out. And that's by convention, right? It actually looks at the type of this thing and says, oh, that's a list of horses. So it makes up the variable and puts it in the context. Now, where that's being done in generic list view is in a method called get context data. And so I actually don't want to completely replace get context data, although I probably could if I want, because this is so simple. What I actually want to do is I want to augment the context, and I want to throw something else in it. So what I want to do is I want to run the code from generic list view first. I want to get the context back from that, and then I want to add something to it, and then return sort of like this composite context. Okay? And it's not, the syntax is a little scary, but it's okay. So let's take a look at get context data. Just like anything, self is the instance. Self is always the instance. KW_args is just a way of taking all the parameters so I can pass them in. So what I'm going to say is I'm going to say, hey, super. Super is like calling get context data in generic list view. So go into my super class. Wacky Equines view is a subclass. List view is my superclass. Super, get context data, and pass whatever arguments were going in there. We're all good. So just call that. Do it. And pass in all the arguments. And do whatever. And that's what ends up putting in horse list. And so at that point, context is going to be a dictionary that has horse list in it. But then I want to put some more stuff in. So then that goes into generic list view and then comes back out of generic list view and gives me, and if all I did is return to context, then I really wouldn't have changed anything. But what I'm going to do is I'm going to throw in this little extra key called crazy thing and put the string crazy thing in it. And then I return all that, and then eventually it goes into the template, and this context finds its way into the template. And again, that's all inside of generic list view, and eventually horse list is there because of the call to the super, and crazy thing is there just because I explicitly put it in. And so I have augmented without replacing. The first one I completely replaced get query set. In the second one, I called the parent, and then I augmented the return value and then returned kind of the combination of what the list view did and what I want to add to the list view. So hello. With all that as lead up, we are going to finally start taking a look at how we actually build this owner list view. So let's take a look. So the basic idea is we're going to make a new class called owner list view, owner update view, owner create view, a whole series of classes that sort of mirror the generic ones, and we're going to add our own little sauce. And we are going to basically make our owner list view, which is going to extend generic list view, and we're going to extend owner list view to create article list view. So the thing we ultimately end up with as our view is sort of 3 layers deep, where we have our view that extends another one of our views that extends a view that came from Django. And so there we go. And so things like article list, HTML as the template, and all that convention, and the name of the variable article list, that's all convention. And we've been doing that quite a bit. So let's start with the models changes. Now in this model, everything except one line should be familiar to you and pretty comfortable. The only line that's a little bit different is this owner line. So it's just another field. It turns out to be an integer. It's a foreign key, like all foreign keys are integers. And on delete models cascade, you have seen that before. That simply means if we have a bunch of articles that are linked to a user and we delete that user, it deletes the 4 articles that were associated with the user in order to keep the internal pointers consistent. So that part is all the same, quite comfortable, and you've been doing that for a while. Now, settings, auth user model. We're importing settings from Django, and we are making a foreign key to a model that is not ours. It is something that Django maintains. Django always has a user model somewhere. It may be named one thing or a different thing. We just don't know. We don't know what the name of the user model is. And so we have to ask Django for it, and Django conveniently always leaves it in this location, settings.auth user model. And it turns out if you want to change it, you got to change that variable. But for us, we're not going to change where it's at. Django's going to set it for us, and we're just going to use it. So there's two tables. There's this article table and some user table somewhere, and there's a foreign key relationship between them in a database level. And once you make this database, you could go see what the name of that table is, because it will show you the create statement that it actually used. Not that that matters. And so it's pretty much a normal old thing like we've been making, except it's got this extra owner column. And that's the thing we're focusing on right now. Okay, so the views are going to be pretty straightforward. The thing you're going to see about the views is we're not going to use the generic list view, the generic detail, the generic blah, blah, blah. We're going to make our own. These are made by us, myarts.owner. So we'll see owner.py in a second. And so article list view, which is we got a urls.py that routes here, is going to extend owner list view and say, do this model. Things like the template name and everything, that's all done by convention, right? So we're going to have a detail view, a create view. Now the one thing that's different about the create and update is there are two things. There's a form, which tells what shows up on the screen, and then there is the model back here that shows up what ends up in the database, right? So the model, article model, is what's in the database. The form is what we show on the screen. So the model is which model is in the database, and fields are which model fields are to be put on the screen. We're not going to show all of the fields on the screen. In particular, we are not putting the owner field in, because we're not letting the user say this is owned by number 12. If it's owner 12, great. That number 12 is the current logged in user. It's not something we let the user see. So we don't put owner in here. We put the title and the text. We don't put updated at or created at, all the things from the model. We have to tell that we want this to put in the form and that to put in the form. This is going to be handled internally, and all these three are going to be handled internally. Owner, created at, and updated at are handled internally. Text and title are to be shown to the user. And so here we are in article create view, and we're saying this is the model, and make a form based on that model, but only for two of the fields. Ignore the other fields. The same for an update, and then the delete, it doesn't use an actual form, so you just tell it which model it's going to use. So again, this is a triumph of don't repeat yourself. All the brains of this operation are really add an owner column, add an owner column, and then extend these classes that we are about to make. Extend the classes that we're about to make. Now I want to show you how to make the classes. So I show you the easy stuff. Now we talk about the hard stuff. Okay. So this is the owner update view. And so let's take a quick review of the owner update view. And when we first do a GET request, if we go look at the documentation, it says, oh, I want to show you the old data in a form, and I'm going to call a function called getQuerySet in generic update view. Okay? And if I can't get anything, if I don't get anything, I'll give you an error. So this is like to a URL like /edit/2. And if the 2 is not in the database, then you're going to get a 404. So we call getQuerySet. Okay? And so let's just take a look at getQuerySet. So the way we're going to do this is, because we're in the middle of an update, the user is intending to modify it, which means we're not going to let them modify it unless they're the actual owner. So what we're going to do is we are going to override the query set. And I just put a print statement in for yucks. And so the first thing we're going to do is get the default query set. This is going to pick the model that we're going to query, and it's probably going to say something like, the primary key is whatever that number was, 2 or 14. And so we're going to actually get a query set back. And so that says, super, go into owner update view, go into update view, and go run its query set, and then give me back that query set. And then what I'm going to do after I got that query set is add a AND clause to filter it that says, okay, whatever that primary key was, fine. and the owner column of this model must match the current logged in user. And so it's like I'm adding a where clause and an and to the where clause. The other thing that you'll notice here is login required mixin. I could have put login required mixin on all those in the views.py, but I need to have this variable self request user properly defined, which means any owner update view, you really can't use it unless you're logged in. So it's like I'm going to put the login required mixin here. That's like a marker interface that says, look, if you're not logged in, send them to log in and then come back here. And if they can't log in, I'm never going to let them run this code. Because if you let a non-logged in user run this code, it would blow up right there. So in a sense, this is like a guardian pattern to say, don't even bother coming in here if you're not properly logged in and you don't have a user object properly passed in as request.user. And so that's why I put login required mix in there. So the key here is we're going to do a where clause, that is where ID equals 7 and owner equals 14, whatever the current logged in user is. And so that means that when you come in here, if you're trying to edit a thing, you're going to get a 404, right? If it doesn't exist, you're going to get a 404, or if you don't own it, you're going to get a 404. 404 is not found, and it's legit to say it might be there, but you didn't find it because you were trying to read it for updating. So by changing the get query set, in a sense, to return 0 records when you don't own the record, because this is an update view. If you look at the list view, it doesn't do any tricky stuff because you can list them all, right? And so a list view is no big deal, a detail view is no big deal, but an update or a delete view, yeah, detail view and list view are good, but an update and a delete, you have an intention of modifying it, so we're not even going to let you retrieve the record if you don't own it. So we do that by overriding the query set, calling the super, and then augmenting the query set when we get it back so that it accomplishes what we want to achieve. So the next thing we're going to look at is how we actually store the data. And the storing of the data is in form valid. We're going to override form valid. And what form, remember when the post data comes in, we're going to, it first calls form valid. That checks to see if the things are the right length, if it's a date, it's the right format. Who knows what it does, but we're also going to override it and stick our own code in form valid. So yes, it's going to do all those checks, but also we're going to do a little sneaky thing to make what we want to do that's going to solve the create and the update situation, but it's mostly for the create. And so in the create view, it sends out a blank form, and then in comes the data, but we never showed owner. Let's go back a little bit, right? So if we're going create view, the form that we're going to send out is title and text. There is no owner field. Now this owner is required, and so we have to get the owner in. So what we do here, it's really quite simple. We're going to, so there's a form object, which is kind of like the UI side of things, and then there's a model object. And so form.save commit equals false says just copy the data into an object as if we were going to store it, but don't actually store it. Commit equals false is make it, but don't store it. And then we're going to add the owner field, which is there, to be self-request user. Now self-request user, remember, is like 16. It's some number. It's the primary key of the user. And so that's going to copy 16 in here. And then we're going to save it. But then we're also going to do the validation and call the super to do form validation for us. And so we're calling the create view form validation as well to make sure everything else is done properly. Okay? Okay, so when it's all said and done, all we have to do to make an owner work in this situation is we add an owner column, foreign key to the right place, we import owner delete view, and then we just extend owner delete view to make article delete view, and then tell it which model to work in, and then the magic all happens. So I'm not going to show you owner delete view, just you know that it's going to force login, and it's going to only let you delete rows that you own in the system.
Hello and welcome to a walkthrough for Django for Everybody. So the walkthrough that we're going to be doing is the walkthrough for the My Articles, which is really focusing on the notion of owning rows in a model. And what I've got going here is I'm logged in twice. I'm logged in one with a user ID of 1 and the other is a user ID of 2. So let's just do a quick demonstration of what really owning rows in a model is. So here I'm logged in as my first user, and now I'm logged in. I'm using a separate browser because this is Safari and this is Firefox. You can't just do this with tabs because the cookies are shared between tabs, and so you can log in and log out. I want to just be logged in simultaneously. Okay, and so I've got 2 of these tabs. Refresh. So you'll notice that the edit and delete buttons show up differently for different users, and that's because this row in the table lawnmower belongs to this user, user number 2, and this row, these 2 rows belong to this user. So if I take a look at administration and I go down into groups, not groups, users, now I can kind of hover, figure out that CSEV is 2, you can kind of see at the bottom there. And DJ Free is user 1 and C7 is user number 2. So those are the primary keys in Django's user table. And now if I go and I take a look at these articles, you will see, and this looks a lot like if you were looking at, say, your autos. Here's the rows or the models in articles. And if I look at lawnmower, you see that there is a title, some text, and the owner is a drop-down. And that's because this is a one-to-many field. This is a one-to-many field between the articles and the users. And then if I switch to a different, so that's CSEV. So CSEV owns the CSEV owns the lawnmower. I'm logged in as DJ Free here. Oh, no, here. That's my name. I'm DJ Free. And if I switch to the trombone, we'll see that that one belongs to DJ Free. Now I can sit and edit this in admin, right? But that's not the point. The point is to build software. If you'll notice, when I create a new article, it doesn't ask me what user it was, right? So this is where you would say Dodge or whatever when you were doing cars. So this is like a race car, slightly used, neon. So now I have another one, right? And so the key thing is it looks like a create from things we've done before. And if I look at my articles, here's this, but somehow magically this owner field is populated. And that's the essence of owned rows, is we've got a row, a column, and these are marked, and we know in all our code, we know the difference, for example, between things we own and things we don't know, things we own and we don't own. So if I hit refresh over here, there's a slightly used race car, but it slightly used race car, but I can't edit it, right? So that's the ownership. Now, I don't know where to start. There's a lot to cover here. Let me show you. I don't know. Okay, I'll just start with where we always start. Let's start with, I'm running this locally. I don't know what that bug is there. That's not a bug. So this just looks kind of like your autos. If you look at it, it looks pretty much like the autos. I might add a mileage or price in there or something. The only thing that's really different at all is this. There's a foreign key. Now in your autos, you had a foreign key to makes. And the key difference here, the only thing that's new is this idea of where the foreign key is pointing at. Now the problem is in Django, there is actually a table that all these users live in. And I can probably come over here and type tables. And I can see it. I think it's probably here. So let's just try saying select star from auth user. So we should see a bunch of rows. And so they're my users. CSEV, it's all jammed together in DJ Free. So this is row 1 for DJ Free and CSEV. So there is a table and a model. The difference is we're not allowed to know that this is the user model in the auth application. And so what happens is we have to let Django tell us what the name of that model is. And so we go into settings, which is settings.py actually. And we're going to pull in the settings.py. And the default is auth user model, and that's the name of the model. And so this is a foreign key to a place that we don't exactly know, but Django will tell us and put in a string here. If we were to print this out, we would see what that is. That's just a string, but it's not a string we mess with. On delete cascade, that's just normal. The kind of parent row, the one row is in users. And if you delete a user, that means that all of the rows that belong to that user will get deleted because on delete cascade. I'm choosing that as the model. And so you see created at, if we go into that back into you see all of these things. Now created at admin doesn't show. It's pretty smart knowing about created at and update, so it doesn't bother doing that. And it actually updates them automatically, so it knows something about created at and updated at in admin. Okay, so that is our model. If we were to take a look at my arts article, we will see that there is a foreign key right there. There's a foreign key, and if we say select star from my arts article, we will see that there is a foreign key in there. So this row belongs to user 1, this row belongs to user 1, that row belongs to user 2, and that row belongs to user 1, which is perfectly reflected here. So now I am user 1, so I can edit 3 of them, and now I am here with user 2 and I can edit 1 of them. So I'm editing the ones where I own it. So ultimately we're going to write a bunch of code so that these numbers are properly updated. So when you add the article, it works the way you want it to work. Okay, so let's just take a look at urls.py. It's pretty boring. This looks just like autos. I probably hoisted up success URL here, put that in the as view as a parameter, and so that makes my views even simpler. My arts all points to that view. I think it actually is kind of prettier to put it in here because this is sort of a URL place, and so it's not in my views. So that makes my views really succinct. And so it's like what you did once you got your autos down to like just using the generics. And so I have a list, a detail, a create, an update, and a delete. And I have a model called article, which I just showed you. And I am going to reuse some general purpose views for owner kinds of rows. Now, these are not from Django. These are from me. I made them. And now I'm using them. So article list view extends owner list view. And then I can put all my things in there. The success URL, actually, I don't need that here, but for create view, I do need a success URL, but for create view, that success URL comes right from here. So I could have put it either here or I could have put it here. For me, it just kind of, after a while, I think this is prettier because now I can look all, the names of my arts, etc. So that's kind of nice. Okay, so here's views. We're going to come back to this. All the brains of this operation are in owner list view, owner detail view, create view, update view, and we'll look at that last. So that's where the hardest part is. But let's first look at the template. And so here's the template. This looks a lot like your autos. The only real difference here is that this edit and delete button is inside of an if statement. So it's, article update, article ID, article delete, article ID. That's the same. You've done that, right? But if all it says is if article.owner is equal to the current logged in user, article.owner is one of the article lists, and that's just one of the fields in the model, which happens to be a number, but we're given this user for free, right? It just hands us user, and so we can compare it. So if this is one that we own, we show this link, and if it's not one we own, we don't show the link, right? So we don't show the link for the ones that we own. Now, I hope by now you realize that we have to also protect, right? So So if this is number 4, right, and if I click edit number 5, but what if I just change this to 4? We still, just not putting up the link does not mean that we can't have someone go to that link. So I'm cheating by putting in this link, but this is going to blow up, right? And so we'll show you how just because you don't put the link up doesn't mean that people can't go to the link. They can guess what the link is. I just did that. I went to an article I could update. I noticed the primary key of one I could not update to be 4, and then I went to 5, and then I just edited it, changed it to 4, and I attempted to update 4. So it's not good enough just to not show the link. That's actually not security. That just is prettiness, usability. Don't show a link that is going to blow up if you click on it. So that's not really protecting us. This if statement is not really protecting us from clicking on or attempting to go edit or delete. It's just not showing it if it's not going to work. Okay. And again, article.owner is just a column in this model, and user is the current logged in user. Okay? Okay. So what we'd seen before is I would create a view and then use it in my urls.py, and it would extend another view. So now it's time to take a look at where this view is being defined. And so here's our view, generic view, the generic list view, delete view. These are the generic ones, and all I'm really doing here is I'm creating a class called owner list view that extends list view. Now, it pulls in everything that list view is, and you'll notice I've added nothing to it. And I really could, because the list view doesn't really care. It's not really doing anything other than the fact that that value is in the models, so it's going to come in, right? So I could have made this be list view, but I just want it to be pretty. I want to make it so that I could just say owner list view, owner detail view. And so you'll notice that I'm not making any changes at the moment of inheritance. I'm not changing owner. So owner list view is exactly the same as list view, and owner detail is exactly the same as detail. I just did it to make it pretty in case later maybe I want to add some. But now we get to owner create view. Owner create view is something that matters a lot. So there's 2 things we've got to do for owner create view. So let's go ahead and start to add an article. So the first thing is there is no field here for which user it is. It would be kind of silly, and I can actually mess this up. So if I go to create view here and I add user, then if I hit refresh on the create view, come on, back up. Oh, it's not user. Owner. So if I add it to that list, and part of this, what's going on here, is there is both a model and a form. This fields equals is informing the form, and the form is the user interface. So look at this. I'm allowing the user to specify it, and now they can set the owner. Pretty convenient. Well, that's not what we want. So that's why in this create view, you say, don't let them set the owner. I don't want them to see the owner, because it takes a little while for this thing to restart. Okay, now it's restarted, and I can hit refresh. So when it was blowing up, it was just because I was coming here too fast. What is that? I don't know what that is. So go back to the views. Maybe I have some tiny little bug. I'll dig through that bug later. It's working. It's probably passing the auto grader, so I'm pretty happy. So remember that there are 2 sides to this. One is the database side, and that's what the model deals with. And then there is a form. So these views, this list view, if you recall, once we tell it the model, it actually makes a form. So in this create view, it's making a form from article, copying all the fields in article or the fields according to this little list. And so that's why we're doing it. So the key there is we're explicitly not putting owner in there, and we're not putting created at or updated at. If I wanted to put created at in here, Say, hey, let's show them created at. Okay, let's refresh. Okay. Oh, okay. So again, it's trying to take a model, it's trying to go from the article model to make a form, and it's not an editable field, so it's mad at me. So I'll go back and fix it. I'm sorry. Okay, you get the idea. It uses this list of fields to make a form. The same for article and for update. In fact, the update and the create are so equivalent that the template for them is shared. It's basically, we'll talk about crispy tags separately in a different little video. The form is the same. The difference is when the update comes, there is already data in it. That's the only difference between a create and an update. It looks exactly the same, but update has data in it. A create has no data in it. So the code between create and update is super equivalent. Very, very similar, and the template is similar as well. Okay, so there we go. So we got create view, delete view, etc. Now, I'm going to focus on create view. And the key to create view is now in owner.py. Here's our form. That's pretty straightforward. In owner.py, this create view now has a little bit more to it. The list view and the detail view just inherited. So the first thing is that create view has a login required mixin. And that's because if you're going to create it, you need to be a logged in user. But to view it, you don't actually have to be a logged in user. Or if I was to, okay, let me log out here. So now I'm logged in as anybody, and so I can see all these. I can't edit any of them. I could log in if I want, and a detail view also works. So I'm completely logged out here, but add article, yeah. So add article is protected by login. So owner create view, login required mixin. And I do this because I don't want to trust the user who's writing this view to put the login required mixin here, because I am writing code right here that depends on the fact that this person is logged in. So this is like a guardian pattern. If I'm putting this in here so I don't end up with tracebacks inside my code. I don't want, if I didn't put this in if I didn't put login required mixin in owner create view, then they forgot to put owner in the views.py, they forgot to put it in an article create view, then this code would blow up. It would trace back at when I tried to set object owner to self request user. It would just blow up. Okay, so I'm extending create view, which is inheriting all the functionality, and I'm only going to override one method. This is object orientation. And you got to go read all the documentation. This documentation right here. Show you that documentation. Doop, doop, doop. So, this documentation is hard to find, and I'm sure I helped myself by doing some Stack Overflows. So that's why I put little notes at the bottom of the file, the things that took me a long time to find. So this form model mixin, and that is what they're really doing is they're giving us for these editing fields, like the update, they're saying these are the functions that are in this, and I can override them. So the one that I'm overriding is the form valid. And what that does is it basically says, here's your form, save it to the database, and set the current object for view, and then redirect to get success URL. Okay, that's its job. Except that right before it's going to save the form instance, I want to do something myself. Okay, so what I'm doing here is I'm saying, and the form is what's being called as the parameter, which is the form that has been pulled in from the post data and handed to me. And so what I'm going to do is I'm going to say save it, but don't save it to the disk. That's what commit equals false means. Don't save it to the database. Just save it into this variable object. And then I'm going to set the object owner. I'm simply going to copy the current logged in user into owner. And then I'm going to set it to the database. And then what I'm going to do is I'm going to call the original form valid passing form in as a parameter that's in this class. And that's really not going to do much, right? Because it knows that it's already been saved, so it's not going to save it again. And then what it's going to do is it's just going to do the redirect to the success URL. So this is rather late in the process of create view. It's been validated, it's checked for bad data, etc., etc., etc. And so this is like right before the redirect happens, okay? And so at a high level, my whole goal was to pause the saving of this data to the database and sneak the actual current logged in user into the owner column and then be done with it. And so that's the basic overriding. I'm really extending form valid to cause my code to be called right before the default code is called. Okay? Okay, so that's owner create view, and that's how once I add an article and put some stuff in and I submit, right as I submit it, and right before it's saved, there is a little field called owner that's going to be updated, boop, and it's there. And so the owner field came from this code. Now I don't have to, I could have put this in this view.py, but no, I got this really awesome creatable thing. I can write really cool code. I'm going to make hundreds of views and we will through the rest of the semester do this over and over and over again. We're never going to change this file again. Okay? So now let's talk about edit. Okay, so there's two things. So here we're going to load article 6 and then we're going to put out a form that has all this stuff. So the first thing that's got to happen in owner update view is we got to check to see if this belongs to the current logged in user. Remember when I tried to go to whatever it was, 4 here, and it blew up? This is the moment where I'm going to protect it. So if we take a look at the moment where it's loading the model, do I have a link to that? Django populate. Let's go to Stack Overflow here. This one I got from Stack Overflow. Been there 10 years, probably a good one. Right. I don't like that one. Use middleware. Somewhere in here. I should make that link be a better link. Yeah. Oh, I like this one. I'm going to put a link in just to this one here. Link straight to that one. It's telling us what to do. You see, I just borrowed this right there. Form valid. Over. Oh wait, no, that was the create. Sorry. Yeah. Okay. Can't find quickly where I can do this, but query set. So query set is called when it's loading ID number 4. Okay, so it's going to do a load. So query set is not the actual load, but it is the query to the database that we're going to do. So what I'm going to do is I'm going to tweak the query set, and this query set is probably going to say, show me where ID equals 4, right? So I'm going to say, it's going to say something like select from articles where ID equals 4. And if I just did the normal query set, it would work. But I'm going to change the query set. I'm going to change the query set. So what I'm going to do is I'm going to call the default get query set in the superclass, which is the delete view class. And that's going to say query where the primary key equals 4 in this particular case. But then what I'm going to do is I'm going to add another filter. This is like and owner equals the current logged in user. So so number 4 is owned by user 2, but a logged in user is 1. So this is going to be and logged in as user 1. So when it does the query, it says give me the thing that's ID equals 4 and user ID equals 1. It's going to get no records. And so as the delete code, or the update, am I looking at delete? Update and delete are the same here. Before it does an update, it has to load the old data. And I have made it so that if you're not loading data on something that you own, then it's going to give you a 404. So it's like that wasn't found. Now 4 does exist, it just doesn't exist for the current logged in user, but 5 does, and it does belong to me, right? Now the other thing is when it's going to call get query set again, new stuff, XYZ 1 2 3. So when you submit it, it actually is going to call get query set one more time before it actually stores the data. And so let me show you. This will be kind of tricky. So I'm going to try to mess with it on 4. I'm going to try to change 4. So I'm going to go into edit screen and I'm going to inspect element. And I am going to somewhere in here find that hidden? Where is the hidden? Oh, input type hidden. Right. So that is the input type equals hidden. No, that's the middleware token. That's not the one I want to change. Oh, this is gonna, where's the, I would think that. Oh, it's because it's in this URL. I don't think if I change this to 4, it's actually going to work. But let's try it. It's probably not going to work. Yeah, that one worked. Okay, but the idea is eventually someone could mess with that post. So you still got to protect it. Right when that data is being modified, it actually does, it runs this code again, and it reads the thing, and if it can't read it, then it won't let you update it. And so that protects you from people breaking in and attacking there. And the owner delete view is the same thing. So if you go into delete, it does a get query set, and I add this filter to say, and it has to belong to the right person. So if I try to delete article 4, boom, it says I can't load article 4. But if I come over here, and I've got to log back in. So this one I think was CSEF. I think. Yeah, so now I can't delete number, but I can delete number 4 here because it kind of hides it, which is crappy, but there it is. It's deleting number 4, and away I go. So, okay, a lot of stuff. Okay, so here's the thing. We're going to use owner.py over and over and over again. We're going to write simple and elegant views, and all we have to do, ultimately, any model that we want to have this owner feature with, we add an owner column to it, then we have the views extend an owner view, and then everything's taken care of after that point. So it's really, we're not going to change a line of this. It's really cool. We're going to use it in project after project, on table after table after table, right? Because this can apply to different models. It's just this one happens to be applying to an article model. So I've built a super generic owner capability that I can use over and over. And just take your time, watch this more than once, review object orientation, figure this out. It's hard for me when I'm teaching to explain why object orientation is cool. Object orientation is cool because it can let you write these super elegant and very reliable. The fewer lines of code you write, the more reliable it is. But the harder it is to understand because the magic is here in this object-oriented pattern. And again, it took me a long time to write this stuff, but now it's really gorgeous and really reusable. So keep thinking about object orientation. We're going to be doing a lot going forward in terms of object orientation. Okay, so I hope this helps. Cheers. Hello and welcome to another screen recording for Django for Everybody. In this one, we're going to play with the Bootstrap menu. So what's a Bootstrap menu? A Bootstrap menu is a common bit that's going to be on a whole different set of pages. And so in this particular menu, we're going to have like a page 1, a page 2, a page 3 inside of a drop-down. And then we have kind of like a login drop-down. I'm already logged in, I'll log out. And then it switches when I'm logged in. When I'm logged in, it shows my gravatar. When I want to log in, I'll log in as csev DJ 42 exclamation. Ooh, come on. Actually, I think let's call this DJ free. I think will work. Yeah, and so that shows a little picture based on your email address. And so I'll show you how all these things work. But again, we're talking multiple pages. Now, the couple things you'll see is we are changing the highlight of this. And so if I was to do a view source, these are completely different pages. And what you see is on the highlighted one, where was I? Page 2 is the highlighted one. I have a list tag for page 1, and then a list tag class equals active for page 2, and that's what makes this highlighted. So these are different pages. So in this menu, we have to know what current page we're on, so we can look at the request path. It's page 2, so we know to put active on the page 2 one. So there'll be some logic inside this navigation bar. So let's take a look at some of the code. So I'm really going to do this all in templates. So you see I'm using template view in the urls.py, and I just have I got 3 pages that are all going to render the menu, menu/main menu HTML. And so there's nothing in the views of any importance. It's because I just got template view that I'm using. So let's take a quick look at the actual menu. So it's really quite simple, because one of the things you're going to do is you're going to have these pages and lots of them. So you don't want all of this HTML that's needed for this header sitting in every one of the pages. So we will use the extends mechanism in a template to say, oh, let's go and grab base menu.html and start with that. So we've been working with base Bootstrap, and Bootstrap uses all kinds of pages, but it doesn't have a menu. And it has areas that you can replace. So we've been working with base Bootstrap for a while, but now we want to do the menu. So what we're going to see is, instead of extending base Bootstrap, we're going to extend base menu. And that's our own local file. So you'll note that base menu extends base Bootstrap. And this is the same base Bootstrap we've been using all along. And what it basically does, this app tags, we'll talk about that in a second. That's how the gravatar works. It is going to override this nav bar block. And you'll see that this goes all the way down. That's on just one big nav tag. And so the nav bar comes in right here, right after we say div class equals container. And then we have this welcome. We have these flash messages, area for flash alerts. Those are the messages that say, congratulations, you added a file. Congratulations, you deleted a file. And then the block content, and then the end of this container div. So block content is what we're going to override here. And the block nav bar is what we're overriding in menu. So block nav bar is being overridden. So we have one template that extends another template that extends another template. And so we're, just like any kind of object-oriented, we're sort of specializing and further specializing and further specializing. So Bootstrap can be used with or without a menu, but then once we add the menu to base Bootstrap, then we have base menu. Okay? So this is the top part of the page, and every page simply extends base menu and then puts whatever content it is. It says, just, I would like a menu here. So let's take a look at the menu. So the first thing you do is you go, I'm using Bootstrap. So if you go read up on Bootstrap, it'll tell you this is how you make a menu. And it tells you how to use the nav tag and what classes to put on the nav tag, how the container works, and the header and the brand and all these little classes. I didn't make this up. This is what Bootstrap said. This is how Bootstrap makes it pretty and dark and curvy little things, and they all line up nice, etc., etc. So I had to read that, and so this pretty much is taken straight from some sample code, except for one little thing, and that is the mechanism by which I, on different pages, can highlight which page I'm on, which is a very common something you want to do in menus. And so we have a UL tag, and a UL tag is this list of things. And then you have an LI. And what we're doing here, this is a weird little bit of Django template language. We are causing the URL function to be called with a parameter of menu:main to give us a path. So, right? Menu:main is /menu. If you look at URLs, it's menu:main is this view, and it's the path that's just /menu. And so this is like an assignment statement in the Django template language, and it leaves the value in XYZ. And now what I'm going to do is I'm going to put an if statement in. And all these if statements have been multi-line, but you don't have to make a multi-line. That is an if statement. If request.getFullPath is equal to XYZ, the variable I just computed, then emit class equals active. Otherwise, emit nothing. So again, now if we take a look at the source code, we view the source of this, view the source of the menu, and we scroll down, we will see that the home has a class of active and the other ones do not have a class of active. And that's why home has this little extra dark box, just to give a little clue to our user that that's the one that we're working with. And so this little pattern is repeated over and over to see if we're on page 1, if we're on page 2, and then we do the construct the drop down, and the drop down is just, again, this comes straight from the Bootstrap, right? And so we have the drop down, we have another URL, we have a little page 3 link here, and it shows up, and this is just the text to make a cool drop down. Okay, and that's just Bootstrap. Now we have a list that is the left side of the nav bar, and now we're starting on the right side of the nav bar, which is also an unnumbered list. So this is cool. So we basically have two versions. One is if the user is authenticated, and then else if the user is not authenticated. So if the user is not authenticated, let's go ahead and log out here. If the user is not authenticated, we are just going to calculate a URL to the login page, which is /account/login. Pass a next to say come back here, right? Now, come back to the main menu. So if you go to login, it will say next equals, and it's come back here, right? And so that you construct that and you pass that login in. So I can do DJ free and I can log in and it will come back to the main menu, even though I clicked on it over here. Okay, but now we're in this page, and in this case, user.isAuthenticated is true. So we're going to construct a drop down, and then this shows the drop down and takes the drop down out. And we're going to, in the drop down, we're going to say log out. But in the page, right, so this is the drop down menu, so that's the menu within the drop down that we turn on and off with a caret. But here's the gravatar. So this is an image tag, source equals, and then we have, undo that. Then we have a double curly brace user piped through gravatar with a size of 60 pixel gravatar. Okay, so that is making this little image. So if we do it, let's do a quick inspect on that image. Inspect, okay, just do view source. This image is www.gravatar.com avatar / this long thing. Okay, and if you go read on Avatar, Gravatar is a service. It's actually a Google service that you register your email, and this here is a hash of your email, and then that looks up and then gives you back this little URL. So if I was to take this URL right here, oh, don't do that. Just there's what I want. I take this URL and I put it https:// it shows a little tiny picture of me, right? It shows a little tiny picture of me. But the question is, how did this get generated? It got generated by passing the user object, which is the same as user.isauthenticated, except I'm piping it through a tag that I invented called Gravatar. And again, this is code that is going to run just kind of like this URL code or whatever these things are, right? So what we have is we have a thing where we've loaded these app tags, okay? And so app tags are tags that we as developers can create. And then we can do things in it. So here's what's in app tags. So this is how you make a Gravatar. You take the user's email, you strip it, throw away any white space, you convert it to lowercase, you encode it in UTF-8, and then you use the MD5, which is a hashing function, and make a hex digest. And that hex digest, this is an MD5, this long ugly string 2D0A2F51. That is a one-way hash of the email address. And if you go put that in to a thing, then if you know it, so that you can't figure out a person's email address from their Gravatar, but you can from an email address figure out what the Gravatar is. So this is not actually revealing the person's email address. So that's why we're using a one-way hash, an MD5 of the email address. And then I just construct the URL, put the hash in the right place, put the size, that 60 parameter. If you take a look, where are we at? This :60 is the second parameter to this code we wrote, so that 60 is size, so that's why it says 60 right there, s equals 60 right there. And then I'm going to, use the format. I'm going to use format, and I'll put the hash in and the size in, and return that as a string, and that goes all the way back here, and then replaces this double curly brace. So all those double curly braces and piping, that's just code somebody wrote. In this case, the Gravatar code is code that I wrote, and we wrote, or you could write, and that produces this URL. So it's a convenient way to put that URL in there, and it's really pretty, and it works out very cool. So you write this code, and it's in home template tags app tags.py, and then you basically have to load it in your menu. Where are we at? You have to go get app tags, and away you go. So that sums up how you can make a nice bootstrap menu and put it on your page through an extension menu, an extension mechanism. So we're going to extend it, and then boom, you make a page. Then you extend it again, and that puts it on the next page. So it's pretty easy. It's pretty straightforward. There's a lot of HTML, but luckily I hand that to you in the DJ free samples, and you're not going to have to modify that. It'll pretty much just work. You'll change what's in the menu. You'll be like putting different things in as the links and stuff. So you'll be working with this. But in general, most of the hard work is done. And as always, you can take a look at DJ free samples, just like we always do for inspiration. So I hope you found this helpful. Cheers. Hello, and welcome to another walkthrough for Django for Everybody. In this walkthrough, we are going to play with crispy forms. Crispy forms are a good example of how Django just has something and you plug it in and things just get better, and it doesn't take much work on your part. So the simple thing is let's take a look at a boring form. This is the kind of form we've been doing in our CRUD. and I'm using a form to do it, and all I have to say is let's just make that a crispy form. And now things are pretty. They got all these colors. They got the highlight. There's a bunch of CSS. Forms are actually, the markup of forms is actually surprisingly complex. If we take a look at the markup in this crispy form, it's got some CSS in there, and it's just, there's a lot to it. So if we look, we got all these classes and fancy stuff. And so Crispy takes care of that for us. And the key, I'll show you in a second, the key difference is just not that big of a deal. So let me walk through the code. So here is my Crispy URLs. So what we're going to do is use the same view and just switch between two templates, one called boring and one called awesome. Crispy is Urban Dictionary for awesome or cool or whatever. I'm not sure how cool of a word cool it is, but it doesn't matter. This is a riff on some of the forms code. This is a real basic form. I don't have any models in this one, and so I'm just using forms and putting them on the screen. And so I just got a simple form with a string, mileage, and purchase date. And that validator so I can make some mistake. And this is just a view, just similar to other things we've done in forms. I'm making a class that extends view, and I've got to set this template name to none, because really what I want to do is I want to pick the template name here in urls.py. Something about how Django works, you've got to put this in so that then you can override it here. And I like putting templates in here and success URLs in here when I possibly can. It just seems like the routing is going on here in urls.py, and so I like doing that. So you'll note there's only one view, but we're doing two things, and that's because we're just taking self template name and doing the exact same thing. And so the boring form, it basically is loading some old data, making a form, pulling in the initial data for that, and then passing it into the template and then rendering the template. The post, if I submit the post, this would be saving the data. You read the post data, check to see if the form is valid. If it's not, send an error message. And then if we'll see a flash message, I'll show you that in a bit. And then we just redirect to a reverse. So let's just see, for example, what happens if we violate a rule. We get this, please enter two or more characters. And that's something we've been doing before, and that's just kind of the get post of an edit form. So let's take a look at the template that creates this, right? We're going to do base bootstrap, put a title in, override a welcome. So if you take a look at base bootstrap, I should add a link here to show you base bootstrap. cd vi home templates base bootstrap. So base bootstrap has a number of different blocks that we can override. The title block, the head block, which is some material to put before the slash head, a navigation bar if we want it, a welcome message, and then we'll talk about these little flash messages in a second, like alert messages, and then the content, and then some footer. Maybe we want to put some JavaScript in at the bottom of a page. And so we've got these hot spots in Bootstrap, base Bootstrap HTML. So we're going to extend it. We're going to set the title. I'm going to put an H1, which is like a welcome. It's the beginning of the body, and then there's going to be some messages that come in here in a second. And then here's our normal block. So we got a form. We have to put the CSRF token in. That just puts out that input hidden tag so that we avoid cross-site request forgery, CSRF. And we're going to use form as table. Form is the context variable. As table basically renders it as a series of table rows. And then slash table. And so if we do an inspect element here, and let's do page source because my screen's too small so that you can see it on a sweet little mobile. So it's got the table, and then it's using TRs and THs and slash THs and just kind of putting it out. Not a lot of CSS. It's using the table so that these things can be lined up. That's what it tried to do. It has some aesthetic, and away it goes. Okay, and so the form as table, like if you make a mistake, this ends up view page source. Close that one. You see that this is just another, somewhere here, where's the error message? Yeah, it's just another table row, and it uses the table, and the table helps it do all this alignment, but it's not very pretty. Okay, and so then we have the table, we have our submit buttons and our cancel buttons, and we end our form. And so we've been doing this now for a while, just making boring forms. So let's start by, so if I go to awesome, so I go to cancel here and I go to the awesome form, then I am going to render, right, crispy awesome HTML instead. And so let's go there. So it looks almost the same. So here's boring, and here is awesome. So most of it is identical. It's extending base bootstrap, it's setting up a title, it's putting up a welcome chunk. But then we have this. So this is, you know, when you're using a curly brace percent, load crispy form tags, that's like running code basically, like the URL, this curly brace URL crispy main.py. That's running code. It's calling it's like the reverse. It's calling reverse to compute a URL given a string as a parameter. So this is sort of like making sure crispy is loaded for this page. If you do not do that, then this curly brace form vertical bar crispy will not work. Then the rest of this form is identical, except we just don't tell the form to render itself as a table. We use vertical bar crispy here, form vertical bar crispy, and this is called a filter. And we'll see another filter in an upcoming video where we'll make actually one of these filters ourselves. So we're taking the form object and piping it through a bit of code from the crispy library. And so that renders, it's not in a table, that renders all of the HTML for title, purchase date, and all that stuff. And it has all the CSS and makes it all gorgeous, right? So that's what it does. So form crispy does all that, and that's the main difference. Other than loading crispy form tags, that's the key thing. Everything else is the same. We had a table, form as table and slash table, and then we load crispy form tags, and then we just pipe form vertical bar crispy, and everything else is the same. And then we get this beautiful crispy form. And it makes things consistent. So you just use crispy forms. I'm not saying you can't build your own form system, but for me as a software developer, I like starting out with something that looks half pretty, and then away it goes. So that's crispy forms. That's how you use crispy forms. But let me show you a little bit more about how that works. Let me close a couple of my windows. So one of the things that happens is you've got to load in your settings.py, you've got to add crispy forms to your installed app. So that's when you're, so if you do like Python 3 manage py check, you've been doing this a lot, it loads up all these things. And so it's checking and loading, and it's reading through this settings.py, it's loading all of these things. Like this humanize is a thing that we'll talk about that later. Django extensions, we'll talk about that later. All these things we'll talk about later, but crispy forms is a code library that you're at that point pulling in. So if you don't put that in, then crispy forms is going to blow up. It's going to blow up right here because it can't load the crispy form tags. Okay, so that's the first thing. But then you have to install this, and you probably don't recall, in the very beginning, I had you check out, let me go to that, www.dj, I got it right here, djfree.com, lessons, installing Django and Python anywhere. So if I look at the assignment specification you did a very long time ago, you make a virtual environment, you go into your virtual environment, and then I told you to go grab DJ Free samples. This is in the very beginning of the class, and I told you to pip install -r requirements.txt. And requirements.txt is a file that looks like this. And what it does is pip reads this file and downloads a bunch of extensions. Django Crispy Forms, Django Filter, Django REST Framework. And so literally now for weeks, you have had these all, it's installing it into your virtual environment. And that's why sometimes if you run Python check and you're not in your virtual environment, it'll blow up. But then I say, oh, well, go into your virtual environment and it starts working, right? I need to run server because I'm running this locally. Okay, so because you installed these things into, you installed the requirements into your Django 3 virtual environment. And so that's why when it reads the settings.py and sees Crispy Forms in the installed apps, then it's like, oh, crap, you know, I don't have it, but that's because you're running the loading of this file not in your virtual environment that has all that stuff installed. And if you're doing this outside the class, you will want to make a virtual environment and then do the pip install for requirements.txt. So that's two prerequisites. Edit settings.py, make sure you have Crispy Forms in your requirements, and then pip install from the requirements. And then it's pretty simple. You just load the Crispy Form tags and then pipe the form object in a template through the Crispy filter, and then you will get gorgeous forms without hardly even trying, and you just keep using it. So that's our summary of Crispy Forms. I hope you find it useful. We'll pretty much use Crispy Forms from this point forward in the course. Cheers. It's a CRUD application. This is CRUD, and now we have this browse thing to upload a file, and so we'll upload that file, and then when we look at it, we're going to see it. If I click on the picture, I get kind of this overlay view. That's all JavaScript, and then I hide it, and I can upload it. I can edit and delete it. So let me kind of walk through how this works. So first off, let's take a look at urls.py. There's nothing particularly special. The whole pattern is kind of the same. I'll come back to this particular URL, the actual picture, the thing that in a sense serves the picture. So if I could open this, view the image in a new tab, well, it's this URL that's actually serving the image. This image is stored in the database, and so we'll come back to that particular one. It's the stream file view. Okay, so let's go back to all pics, and let's start taking a look first. Let's go at the model first, because this is where everything starts. Sure, let's go put the model here, put the views there, and the forms there. Okay, so let's start the model. We'll start from the back forwards. So if we were to go look at the admin, I think I've got the admin hidden in this particular one. Let's take a look at admin.py. Yeah, this is one of the things. Let me show you how the admin works. I hope I got admin going. Probably don't have my admin account. Oh, there we are. We have admin. So if I'm to take a look at the pics, so it turned out that I didn't want either of these two things to show up, because it turned out it made it difficult because I couldn't update things. So you won't see picture or content type here in admin, and I do that by excluding this. And instead of doing the shortcut, I am going to register for the model pic this particular class, and it allows me to have this class-wide variable called exclude so that I don't show those things. And so that's just a little trick on admin, so that when you see it, when they're in the database, they're just not there, because the admin interface is not smart enough to update these pictures the way I want to update them. So I'm going to hide that. So in the model, we've got a binary field, which is like a blob if you're into databases, and I'm allowing it to be null and blank and editable. And then there is this thing called the content type. And the content type is, I'm going to open this in a new window, copy image location. So if I were to do a view, develop a console network, one of the things when you're serving images is that you've got to set the MIME type. So this is a GET request, and it sent a bunch of data. But if I look at the headers here, the response header includes this header called the content type. Oh no, that was the icon. What am I doing? Persist logs. I'll clear this. It's not the icon. That was the icon, but let me retrash this. And so this is the actual PNG, and then the icon comes as well. Of course, the icon's that little picture, but the content type is image/PNG, and that's really important. When you're uploading the file, you get to have it, and then you have to send it back out. Otherwise, the browser will not know how to properly format this. So that is what is here, right? That's the content type. It's just a string field. The content type is just a string, but it's very important to track it. So when I am in an ad, when I upload the file and I pick it, it's actually communicated to me as part of the uploaded data, but I got to remember it. Actual pixels go in here, and the content type goes in its own character field. The pixel goes into the pixels of the picture, the actual colors and stuff go into this binary field. And I'm going to use the owner. So we're going to have this, we did this before, we have an owner, and that's just going to be automatically created when there's a owners.py, there's a owners.py. So there's owners.py, and I mean the owner.py from the previous thing, and that gets all taken care of in the views. So all we got, it's pretty much a standard thing, except we've got these two things, and those are hidden from the admin. So now let's take a look at the views. And so we're going to use the owner views again, and those are automatically handling all of the detail of setting the owner field, and there is just not a single line of code in here that has anything to do with setting the owner field. I have this owner field in my model, and then I just extend for all of my other views, I extend that, okay? So I have an owner list view, an owner detail view, and you'll notice those do not require login. I'm going to specify the template name. I'm getting a little tired of just remembering. I don't necessarily like their naming conventions, and so I'm going to have my own template names here. And pick create view. This one you're going to make one. Okay, and we're going to have a get request, just like going back because I can't quite make this one complete, and my post request. And so the post request. Yeah, I'm gonna. So I'm just this. I might have been able to extend something or put inside, but I'm just going to do all the work. You'll notice I'll walk through this. This will be a good review of that. So let's just look at the. Let's look at the pick create view next. So let's take a look at forms.html. So. Well, now let's look at forms.py. So the create form. So if you think about it, if you recall, right, there is the views in the middle, views, and then the thing that talks to the browser that really controls our relationship with the browser is the form, and the thing that controls our relationship with the database is the model, right? So the view is interacting with the form to get what it needs to do, and then it kind of transports it to the model. So that would be kind of like a controller function if we're thinking a model view controller. This would be, but that's okay. So the form is what determines all of what's going on this screen, and then the model, yeah, oh yeah, that looks really not good. The model is what is going on back here, and so you can think of the view as like manipulating both the form. escape, both the form and the model. And so it's interacting with them. And so you'll see when it's doing things in the beginning, like clear, escape, boop, boop. Okay, so you'll see that in the view, when it's doing its work, it's working with the form, and then eventually it's working with the model toward the end. Okay, and so to some degree, this post request is to get data from the form and handle everything when it's doing it. So let's avoid to some degree the hardest bits. We'll come back to that in a second. So let's go and hit cancel and then add a pick. Add a pick basically runs this get request. So we're going to grab the form, it's the create form, and there's a little bit of work in here. There's the create form, and we're going to jack into, just object-oriented ways, we're going to jack into the clean, we're going to jack into the save, but for now, all it's doing is this bit right here that you've been using for a while, and so we're going to tell it what, we're going to make a picture form, and so here's a thing. So there is a file field, and so we're asking the form to include a file field, okay? And so that's what puts out this file to upload less than or equal to megabytes. We've got a little bit of code to both have a numeric limit of the size, max upload limit, that's just a class-wide variable, and then a max upload limit text, which is that in text, and that little file to upload less than or equal to 2 megabytes, that's because I'm doing this in the form. So I got a little bit of logic in the form, and it is a model form, which means that it takes its input from it. I don't have to put these things in there, but I do have to tell it which things I actually want to do. And so I want the title and the text, I don't want the owner, and created, add, and update are kind of automatically. So that's why I've got the fact that inherit from the pick model, which is this model, inherit from the pick model, and include title, text, and picture. Now, title and text come from the model, and picture comes from right here. So we're not, if Django were our friend, it would understand this would be a file field, but it's not. And so we have to actually manipulate it and convert it. It's not hard, but in between the view, the form and the model, we got to do a bit of work, and we do it here in forms.py. Okay, so meta. Okay, so this part here in the top is all that is affected to create this screen, right? So that's what the get is doing. So if we look at the get, it makes a form, and then it renders it to self-template, which is pics.form.html. And here we go. It's pretty straightforward now. We're just going to load our crispy form tag, extend our base bootstrap, put out the CSRF token, pretty up the form in crispy, and that's sort of everything from title into file upload. And then we have a submit button and a cancel button. So one of the things that we're going to do is we are going to add some jQuery. And that is we're going to connect into this form, and when the submit button is pressed, we're going to run this JavaScript code. So that this line right here, upload form submit function, that makes it so that whenever this submit button here is pressed on this form, this jQuery is going to run. And so we will do a web developer. Well, it's not going to do us much good because actually we can. So I'll show you how that works. So what we're going to do here is, this is a bit of code. I got this off Stack Overflow right there. And what I'm going to do basically is I'm going to read whether or not this file is greater than or equal to 2 megabytes. So if it's greater than 2 megabytes, I'm going to stop and complain with an alert statement. So this is JavaScript. And returning false here says I'm not going to upload it. So let me create one with some stuff, and let me browse. Let me find a really large file. Okay, so now I'm going to do a web developer JavaScript console. Oh, and by the way, let me do a view source on this so you can kind of see that you can see all the stuff that came from base bootstrap, and you can see there's the CSRF token, there's the file input types, and then here's submit, and then here's the JavaScript at the bottom. And this JavaScript is running code out of jQuery. And we'll talk about jQuery right now. We'll just look at it as JavaScript. And we happen to be using the jQuery library. Okay, so now what I'm going to do is I'm going to press submit, and I'm going to watch this console. I'm going to press the submit button, and code is going to run, and you're going to see the JavaScript run, and it's not going to be happy with this file, Sakai, Ladies of Sakai, because it's too big, I think. Yeah, so there you go. Look, it said checking file size, and it complained that this Ladies of Sakai camp type must be less than 2 megabytes, which is exactly what I wanted. And so that I enforced that rule right here. Okay. Now it turns out that I got to also enforce it in the server because somebody could easily just override that and force it to be uploaded. But you see that the JavaScript is running in this browser and it's kind of protecting it. Other than that, this looks pretty much like a standard CRUD thing, except very importantly, if you're uploading files, you've got to say enc type equals multipart/form data, and that has to do with the format that the data is sent. If you just have like a few text fields, then you don't need this, but if you have longer things like files, you need that. And so that is how we get through the GET request. Okay? So now, let me pick a better file. Pong, my favorite. Where's my Pong? Oh, that's dangerous. One of my earliest, I don't know. I got so many little files. Oh, Apple iPhone, Sky JPEG, what I don't know, whatever. So this one's nice, less than 2, and I'm going to hit the post. So I'm going to hit the submit. Now the post is going to come through, and it's going to run this code right here. And this is probably the trickiest part of this code. So if you recall, we can construct a create form and get it back, and we pull the data request.post. Now it turns out that these little attached files, like Apple iPhone Sakai JPEG, comes in request.files, and or none just in case it's not there. Okay, and so what happens is this is where we're going to do some of our work. We're going to actually pull data from this request.files, and so we're going to jack into the clean. So clean is one of the life cycles of a model form, meaning once the data comes in, it's going to ask to be cleaned. So what we do is we call the super class, the model form class, and do the clean there. It doesn't know anything about picture because we're the one that added that. Okay, but then we get the data in cleaned data, and it's a dictionary at that point, and so I can get the picture. So remember that the form is the part that's coming in from the browser, right? And then I can make the picture. I can get it from there. If I got no picture, I don't need to do anything special, right? If I do, I am checking to see if the amount of data that I got from that upload is greater than that upload limit. It's good. So this is mostly here to check to make sure I'm cleaning the data. I'm not actually saving it, but I am grabbing the picture from the form and I'm checking to see if it's greater than 2 megabytes. And then I'm going to add, this is what you do in clean. Clean is just to say a nasty message. Now in this case, the nasty message I showed you before came from JavaScript, but if you somehow tricked my JavaScript and sent it, this clean would catch it. And so if I'm in my view here, clean is happening right now. Form is valid happens afterwards. So as a side effect of clean, you're saying, is the form valid? And if there was an error from this, or if there was an error like my title was too short, right? Then, boop, it would come back and say title's greater than 2 characters. Oh, we love crispy forms. Look how pretty errors are in crispy forms. That is running this little bit of code right here. If the form is not valid, and it could have been, and in that particular case, the super got upset, right? Because this min length validator triggered, and so the super got upset and set form was not valid. Now mine looked good, right? So, but now the picture's gone, so I can make a slightly longer title here and browse a completely. I don't know what I'm doing. These are really old pictures of mine. So now it's going to pass. It's going to pass this is going to pass, and I'm going to grab this, and I'm going to do my own check that's sort of a double check on this less than 2 megabytes, because even though the client protects you, and that's the more user friendly, because this is catching it after the upload happened, and that might be long. 2 megabytes doesn't take that long. But now it's going to come, and it's going to pass this and skip, and then it's going to come here. Boop, and it worked. So here's what's happening. So you've got the form. The form has like took all that data, including the file, right, and cleaned it all up. And I'm going to call form.save, commit equals false, and then I'm going to set the owner field because I'm not extending owner view here. So I got to set that owner view because I'm going to ultimately override both this post and the get, and I wasn't going to get much help out of owner at that point. And then I'm going to save the model. So form.save gives me back a model. If I don't say commit equals false, it actually does the pick.save also. So if you save the form without commit equals false means don't store it in the database. Okay, so let's take a look at what's going on here in form.save. So I have also overridden form.save, and I'm just behaving commit equals true as a default. But when I say commit equals false, then commit will be false. And so I have got to call the super, right? Actually, this is really not right. Oh no, actually, no matter what the commit is, this is the end user's wish for commit, I am going to do a super, and I'm going to run a save with commit false. No matter what this person wants it to be commit true or not, I'm going to run commit false. Then what I've got to do is I've got to grab the picture from the form. I'm in a form, and I check to see if this is an in-memory uploaded file. And there's all kind of cool magic that's happening right here. It's got this it's in memory, it's got this thing, it's an object, it's really nice. And then what I say is give me all the data, the byte array, which reads all of the pixels of the file. And then f.content type is that image/png. And I then need to put that in the instance, which is the model. I've got to add to it the byte array of the text and the content type. I've got to store both of those things, and now I'm talking to the database. The picture and the content type are being set as part of the save. Then what I do is, if commit is true, now I'm trying to mimic the save behavior. Now I'm only using this one way, right, with commit equals false, but someone might leave this out and call my form. I'm supposed to actually save the model if commit is true, but in this case commit will be false, so I'm just going to return the instance. At this point I have an object model, and in that object model all these two fields are exactly the way they want to be, and the only thing I've got to do is set the owner field, which I'm doing right there, and then I'm storing it in the database, and then I redirect. And that's how it works. It's pretty cool. You got to kind of get your object-oriented Zen thing going, and pretty awesome. So I'll just go through the update view because it's not that different than the create view. So it looks the same on the get. We're going to go grab the old copy out of the database, and then we're going to make a form and inherit all the old data. Now in this one, it's not going to put the picture out there. It'll just put out a new one. So if I'm in the edit right here, it's not going to put the picture here, but it'll let me put a new picture here because that's in the form. But all the old data is sitting right here. And then that renders the update form, and then I make my changes, blah, 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 blah. Actually, blah, 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 right? Blah, blah, blah. And then when I post it, it's going to do this create form, and the difference is it's going to do a get object or 404 so that it pulls that old data from the database. And then it does the validation automatically. It calls this clean to do that validation, and then we save it, etc. And so that's how it actually updates all of this stuff. So the only thing left to take a look at is the detail page. And so some of these things we don't have detail pages and some we do. So let's take a look at this one, right? So this detail page looks just about like every detail page. Let's go take a look at the view. And so it's pretty good. I mean, we're using the same code that we've used for everything, and we're using owner detail view. We're telling it what model to use, and I'm going to use pix detail. And most of this, like again, humanizes to make times and dates look better. I'll get back to that CSS in a bit. Here you have, we'll come back to this too in a second. I'm just showing you the parts that are like the way you've been doing it. It's got the buttons for the update. This is part of the owner code, right? If the owner is the user, we're going to write a pencil on a trash little icon, and then print out the title, and then the text, and then some all, right? Some all stuff. Okay? So that's what's familiar. Let's now talk about what's different. So let's first talk about the HTML that generates this little picture. So if I do an inspect element, we'll see that what we've got here is image style, float right, max width, that's some CSS. But the source here is pix pick picture 3. And so if you look, what I'm doing here is I'm going to the pix pick picture view and then the pick ID. And that pick ID is just the pick that came in. And if we go back to URLs now, that's this one. And it goes into stream, view stream file, and it passes in, an integer number as the variable pk. So let's go take a look at that. So that's this one. And you'll notice that this is not a class-based one. It's an old school one, mostly because, hey, I'm just going to do get. With class-based ones, we can do def get and def post. But this one, I'm just going to do an old school thing. Passes in the request in the first parameter, which of course is that number 3. That's the primary key of the image that we're trying to see, right? So I'm going to do a get object or 404 and of type pick, and I'm going to look it up by its primary key, which is that 3, and now I have it. And so I'm going to send an HTTP response, but this is not a text response, nor is it HTML response. This is where that content type, going back to the model, remember this is the MIME type, that image/PNG. And so, oops, come back. So as part of the response, so now if I can get this guy to open in a new, can I make that guy open? Come on, open a new page. Can I do that? Come on, open in a new page. View image, is that gonna work? Well, okay, I guess it's sort of worked. I want to view image in view image in, okay, there we go. That's what I wanted. I'll just go back and put this in by itself. So now I can see that this is the URL that generates the picture. Now the picture is sitting in my database, right? But if I do view web developer and go into network and clear the network and make sure I've got, oh, it's already cleared. Persist logs and disable cache. Now if I hit refresh, you're going to see that it's coming back and the response content type is image-png. So to set this, and that's essential so that when the browser is seeing the pixels, it knows that this is a PNG, not a JPEG or a GIF or an MPG or a PDF or whatever. So this content type is something that we stored. We got it when we were doing the post, and we pulled it in, we took all that stuff, and if you look at forms.py, it was grabbing it here in the save method, and we got it from the form, and then we stored it in the database, and now we've got it back from the database. And so we're just saying the content type, which is a header, is pic.contentType, that's a string. And then we also have to tell it how long it is, but pic.picture is the actual pixels that are the picture, and you have to tell it how long it is. So if you look at content length, right there, 470,152, yeah, 470,152. So that's content length. We knew that from the database. And then we actually write the pixels. And the place you see this is when you click on response. Now it's basically showing you, yeah, that's a picture. But if you really looked at it, it's just, you know, bits and bytes and complete gibberish. And so that's what it takes to send that stream out. And so that's what makes it so that when I have an image tag, when I have this image tag, I can source, but I'm actually feeding that picture. Okay? So that's how the picture gets there, but then I'm going to show you how when I click on this picture, I get this overlay, and then when I click on the overlay, it goes away. Now there's all kind of fancy things, and Bootstrap has modals. I did this with the simplest and crudest of CSS and JavaScript tricks. Okay, so let's take a look at how I did that. At that point, now we're in JavaScript. So first thing I've got is a CSS, and it's this overlay position fixed, and you'll see that I have a div tag that has the picture in it, and it's got a whole bunch of CSS in it. The width is 90%, the margin top, the border is 3 pixel with a solid black. So you'll see this. It's 90% of the width, it's got a 3 pixel margin. It's the margin top is 50 pixels, so there's 50 pixels here. And so that picture is there, but because this class equals overlay, all this other stuff is there as well. So that's not the picture, that's the rest of it. So you can see that this is fixed, which means it overlaps this div and the rest of the page. This div right here and the rest of the page are like 2 layers. Z-index is 10, puts it on top. 100% width, 100% height. Display none means it starts out hidden, and then I've got kind of this little gray. You see this little gray bit? Right? And then the image has this style, the width 90%, margin top, 50 pixels. That's giving me the border and the margin and making it 90% wide. Okay? Well, let me get rid of it or hit refresh. So it's not there. It's not there. But if I do a view page source, view page source, it is there. It is there. It's just hidden, right? It's hidden because I told it to be hidden here. So it starts out hidden. So how does it unhide? Well, if I look, I've got this image here. This is the actual image. That's this image that's really showing on the page. And I've got an onClick, bit of JavaScript. And so onClick. So what I'm doing is I got an onClick there, and then I say document.getElementById overlay, which is looking for whatever tag has ID equals overlay, and then I'm changing its display from hidden to block. And so when that onClick happens, when I click on goodbye. So when I click on this image, I've got an onClick event anywhere in this image that is going to show this other div. So this other div, poof, pops out. Now what I've got is an onClick method on that div so that I can click anywhere in here, including the picture or the background, because that's part of the overlay. The overlay is the entire div in the background. So I can click anywhere, click, and then that triggers this document get element ID style display none. So it's still there, it's hidden, so I can bring it up, I can hide it. I can bring it up, I can hide it. I can bring it up, I can hide it. And I tried to make this one as simple as possible. There are prettier ways, and people put little X up here and it hides it. They make a whole modal, they use Bootstrap, they use all kinds of clever things. This is like the least clever way to make a full screen, semi-full screen pop-up of an image using a bit of JavaScript here and a bit of JavaScript here, and then some just slightly clever CSS. And I'm sure I found most of this on Stack Overflow somewhere. So I hope that you found this particular walkthrough of how to add images to a CRUD application useful. So Hope you found it useful. Cheers. Hello and welcome to another code walkthrough on Django for everybody. We're going to walk through some sample code today. It's the code that really starts using the many-to-many work a bit, and it's our forums code. Okay, so let's just walk through how it works. The idea, I've got two users logged in here, just two different users. This is also going to demonstrate the owner pattern again. So let's add a forum. Forum 1, hello. So this is just CRUD at this point. And so this looks like most of the CRUD things that we've built. I won't go through edit and the delete because the interesting part is here in the detail page. And so I can put a comment in. This is person. This is Firefox. Comment. So I got one user logged in on Firefox. Submit. And then I will refresh here in the other one, and I see forum 1. So, well, let me just make a comment. And this is Safari. So you can see that this is the Firefox comment and the Safari comment. And now if I hit refresh here in forum 3, you can see the Safari comment and the Firefox comment, which I didn't even get my typographical error done right. Well, the key is now you see the delete button is appropriate. So the comments are owned. And what's even more important is, sorry about that typo, is there's multiple of them. Right, so now if I just hit refresh here, you can see that and see these things happening. And so for one forum, each user can have many comments, right? And so this has to be a many-to-many relationship. And then if I go back to all forums, well, this guy sees the edit and the delete, and then this one does not see the edit and the delete. So you get the idea that that's pretty much what it does. So let's take a look at the code here. There is not too much tricky in the urls.py. Most of the urls.py is like all CRUD things we've built. But the comment is yet another table, because there's really two tables here. There's the forum table and the comment table. And so we've done stuff like this where we've got two tables involved. There's actually 3 tables involved, but one of them is the user. So we'll come back to this a little bit. There's not too much outrageous or new in that. But we do have 2 models. Oops, let's get that back on. The first model is the forum model. And this is, other than this new many-to-many field, this is really very straightforward. It looks like almost everything we've been doing that's CRUD. It's got some fields and it's got an owner key. And so again, there is a table out there. There is a model out there, the user model that's out there, okay? And we're in effect drawing a picture. This is a one-to-many, so that, oops, let's try this. Is the pen working? Pen, come on, pen. Hang on. There we go. So owner is a one-to-many relationship. That is that there is a user table, and then there is a forum table, and each user can have many forums, right? So each user can have many forums. So that is our table. Now, what's going to happen is the interesting part is here, but let's first talk about the comment table. So the comment table is down here, and the comment table has one user can have many comments, and one forum can have many comments as well. And so because, in a sense, there is a, let me change color here. Come on, change color. Let's go violet. Because there is a many-to-many relationship between users and forums with a little bit of comment data sitting right there in the middle, we have to model it as, that has to be modeled as a completely separate table, right? So there's only two tables here, but really there's three tables here because the user table is participating in both of these models. And so we'll come back to the many-to-many field. So this is the comment, and like connection tables or junction tables or join tables, it has two foreign keys. It's the most important thing. It's the keys in each direction. I guess I shouldn't have changed that, right? So come on, give me, can I draw? Yeah. Right, so we got the user table, we got the comment table, and we got the forum table. So forums can have many comments, users can have many comments. These are forum, and so a user can have many forums. So this side of it is a foreign key, and this is a foreign key as well, right? Coming out of the comment table, there are two foreign keys, and look at that. There's a forum key aimed at the forum model, and then a foreign key coming out of the comment to the user model. Now again, we've talked about in the lectures, we've talked about modeling data at the connection. So the text that we're getting is the text that we're getting at the modeling point is this text right here. It is the actual comment itself. And you could make a different table for it, but it's just as easy to model it right in the middle of the junction field. Okay? And so that's pretty much it. And we have to, in the forums field, we are basically saying, look, we're going all the way through the comment model, and we're coming out the other end in the user model. This related name is really, really important, and that's basically a name. Let me draw my picture again. I should have probably just drawn this picture and kept it. The user table, the forum table, and the comment table. Forum has many comments. User has many comments, right? And so, in a sense, what we're seeing here is this basically says that there is a relationship between forums and users, and it is in the comments table. The table that it goes through is the comments table. That's what the through means. And then the related name equals forum comments is actually you're installing in the user object a method, an attribute, something in this user model that says forum comments. So we're actually extending the user model. If we were looking at the user, we could say, hey, what are the forum comments for this user? And that would give us it would come over here and it would give us a list of all the forums. Actually, no, sorry. It would come over here and give us a list of all the comments. But this related name is the name of this attribute. And you don't necessarily need all the time to be able to do this. But the problem is after a while, when you're plugging so many things into the user model, you can end up with you can end up with name conflicts. And so it's good to name this thing even though we might not use it. So I hope that helps. So this is a pretty straightforward thing, other than the fact that the user model is our third table, and we're using it in both places. So there is that. So the forms, So the only place I'm using a form in here is this comment form. So I just made it, and the reason that I made a comment form is that I wanted to be able to make it look pretty. I wanted to be able to use crispy. And so instead of just making this comment form on the detail page out of HTML, I just made a form so I could use crispy in the detail page. Okay, so that's the forms. The views are pretty straightforward. The create, the delete, we'll come back to comment create and comment delete. They're not all that tricky either. Probably the trickiest thing going on in here is the forum detail view. And we're extending owner detail view, and we're gonna have the template name and the model and all that stuff. And we're not gonna post actually, you'll see in a second. We're not gonna post back to this, so we only need to get. And so if you look at owner detail view, I guess I should open up another tab. This is my arts owner. Owner detail view extends detail view, which basically demands a primary key. And so there is this primary key value. Ooh, don't do that. Don't do that. Undo. There is this primary key value that's going to come in, and that's going to come in from the detail view, which is the second parameter, which is forums, forum 3. Right, so we're going to go grab and load that object. I could have made that a getter 404. I probably actually should have made that a getter 404. So that's going to load the forum object, and the forum object is the title and the text and the owner of the forum itself. But then what I'm going to do is I'm going to say, go get me all of the comment objects filtered so that the forum value in the model equals the current forum. This forum, that is the forum we just loaded. That's the forum key in the model. So the first one is this forum in models, and the second one is this variable. I could have changed this to be, I'm not going to change it, but I could have changed this to be X. I could have changed this to be X. I'm not going to save it, although it might be. Maybe I'll just save it. Make sure I got all of comment forum. Oh, let's just make this be x2 because that's the variable. I hope I don't break the code by doing this. I'm trying to show you that this is a field in the model, and this is just a variable in this view, right? Okay. So this is going to give us a list of comments. In a sense, this is kind of like a list view. If you're dealing with a list view, you got to write a for loop to go through it in the thing. So we got all the comments for this thing, and we're passing in the comment form. That's simply constructing it. It's constructing this comment form. And then we're going to basically render the request. So we'll close that one. And so let's take a look at this detail page. This detail page is what generates this forum. A lot of it's pretty much the same. Check to see if you're the owner before you put up the little button, little pencils. That's quite nice. Print out the forum title, print out the forum text, print out this stuff is all the forum title, text, and how long ago with the natural time. So that's pretty straightforward. So that's really not all that tricky. So then what we're going to do here is if the user is logged in, and so it turns out that this does not require login, and so the only time we're going to show this comment form is if the user is logged in. So this part right here is if the user is logged in. BR clear equals all is what brings this stuff back to the left margin, even though I floated these things over using CSS. Load the crispy form tags. And then I'm going to build the form. That's this comment form that goes from the word comment, the text, the submit button, and the all forums, which is just an on-click JavaScript that sends us back to the all forums page. And that is the end of the user authenticated, because it turns out that seeing all this stuff, seeing the actual comments, that's okay. Non-logged in users can see it. And then if you recall, going back to the views, we sent in the comments, and the comments is a list of comments ordered by, in descending order, most recent first. And I guess you don't see it there, but they are most recent first. But at that point, we are just going to write a for loop to loop through all the comments, print out the comment text, print out the comment updated at, and if the owner of the comment is the current logged in user, put out a little trash icon. Okay? Put out a little trash icon. Got it? So that generates the output. That generates this page. But let's take a look at a couple of things that we're going to do. So you see this first two things, right? We are actually going to post with action equals this form right here, the comment form, blah, does not post back to forums detail page. This is the forums detail page. If you look at it, it posts to forum comment create. So let's go back to that. Forum comment create is right here. And so it's just going to run this comment create view, passing in the primary key of the forum. Okay? So then if I go into my views, forum create, comment create view. So comment create view is what's going to happen when I get this post, right? So the post is going to come in. There's going to be a comment field, which is this text field. And there is the primary key of the forum, not the comment. So now we are going to make the connection. This is where we're actually making the connection. And you'll notice that I'm just saying login required view and view because I don't have an automated way to do this. And so I'm going to do it by hand. So we're in the post. We're going to go grab the forum object by a primary key. There I am using a getter 404, so at least I blow up in the right way. Then what I'm going to do is I am going to, let's go back to models. I've got to fill out the text field, the forum field, and the owner field. And the owner field are the two foreign keys. And, oops, come back. In the many-to-many, we have to have those objects available to us. So we are going to build a new comment. This doesn't store it in the database. The text field comes from the request post. The owner field is current request user. And the forum field, the foreign key in this middle connector table, is this forum object that we just loaded. And so that fully populates a comment object. It fully populates a comment object in that post method. And then all we have to do is we have to say save it. So the comment.save takes that in-memory comment that we created with the two foreign keys in the comment and sticks it in the database. And then all we have to do is redirect. Now what we want to redirect back to is we want to redirect back to this detail page because we don't want to redirect back to ourselves and we don't want to redirect back to all forums. And so when we hit submit, we want to come back here. So it just looks like that thing showed up, but really it was a full request response cycle where it posted to comment create view, but after the post was done, it did a redirect. And we're doing post redirect, so it's cool anyways. And so this is a slightly different version of the reverse. It is the same concept as what we've seen all along, where we have like a forum ID inside a second parameter to the URL, because the reverse in this URL thing, I wish they'd call this reverse because that's what it's doing. The URL is just kind of a wrapper for reverse. Well, this is the two parameter form. So we have a one parameter form of URL, which is this one, which says go URL forums:all. It says give me the URL to the view that is named all within forums. Here I'm saying URL forums forum create forum ID. This is saying this one needs a primary key because if you go into urls.py, the forum create demands a parameter. And so we're feeding it. But you can also feed that in a reverse. And you do it with this funky format. I wish that was by position, but no, it's not. You have this args keyword and it's sending in a list of variables, and the variable is the primary key, which is the number, which is this 3. So we're redirecting to forum/forum/3, and that's where the 3 comes from. Okay? Okay, so the only thing to look at next is what happens when I hit the delete button. So let's take a look at the detail page. So remember that we cannot delete in a get, but we have to delete in a post. Okay? So in here, this is the trash can. The trash can's not going to do the deleting. The trash can is going to link to forums comment delete with comment ID. And so there's this number 3, but each of these comments has a comment ID. And so let's just inspect. You can see in the bottom, it's comment 7. This one is comment 4. And so that is the comment ID, because we're looping in this code, we are looping through for comment in comments, so each comment has the primary key. So with all that, I am just going to click on it, and of course we're going to have a verification page that turns the get into a post in a sense. I mean, it's just a page. And so we've gone to comment delete view. So forums comment 7 delete. And if you look at the urls.py, forums comment 7 delete, right? And we give it a name, and we're going to route through to comment delete view. So if we take a look at our comment delete view, well, what's pretty cool is that we can mostly use owner delete view, because by now we know it, the object, we know that we're in the comment model. The template we're going to work with is comment delete, which is pretty straightforward. Okay. So it's going to go find, and so you'll notice we don't have a get in here, we don't have a post in here, and that's because we're inheriting all that from owner delete view, the owner delete view. Now, the only thing we're overriding is the get of the success URL, because the success URL, when we're all done, we want to go back to the forum, not 7, but 3. See how we're going to go back to forum 3, and it looks like that just went away. And so the success URL actually needs to be computed based on the current forum. And so we are overriding the get success URL, which is part, not exactly of owner delete view, but the models, the generic delete view. We are returning a string. And if you go and you read self.object.forum, self.object points to the current comment. So if we're in the middle of comment for delete, while we're running in this view, self.object is the comment, right? That's number 4, comment number 4. But comment number 4.forum is the primary key of the forum that this object belonged to. By the time we're here getting the success URL, it's actually been deleted, but we still have an in-memory copy of it. So we're going to go to the forum's no. I do not intend. Where was I? Yeah, I was dragging it by mistake, trying to highlight it, right? So it's been deleted, but we have it sitting here in the memory, and so we can get its former primary key. We can get the forum's primary key. Object doesn't exist in the database anymore, but the memory copy does, and so we know what that number is. So then we go to this fancy reverse again with a parameter, and so that's how we get back. Let's see what happens in the cancel. Cancel. Oh, so it's the cancel, right. So the cancel does this. The cancel generates the URL forum detail with a comment, which is the current object, and then a foreign key into forum and the primary key of the forum. So comment forum ID is what generates this URL. And there is that URL. It goes back to the forum detail page. So if I go cancel, it goes back to the right page. And that's because comment you're walking the foreign key in this particular situation. So I think that we pretty much have covered let me just check the views. Yeah, we've covered pretty much everything that's unique in this particular bit of code. And again, the new part here is to have a connector model and then have a many-to-many field. The rest of this is very much similar to many of the other things that we have talked about. So I hope this has been helpful to you, and now you can start playing with many-to-many kinds of connections. Cheers. Hello and welcome to another recording in Django for Everybody. Today we're going to go through some of the sample code in jQuery. First we're going to talk a little bit about how the document object model works. I'll open this in a new tab. So let me view source, view page source so you can see this. So in this one, we're just going to play with the document object model. Let me make it a little bigger, real big. Just play with the document object model. And as I mentioned, all of these tags, HTML, P, all of them, they are in some kind of a hierarchical object inside of the browser. But because in the early days the browsers were so incompatible in terms of how they represented the parsed HTML, they created this concept called document get element by ID. It's a kind of a clunky. I think part of it, they made it as long as they could so they didn't run into any existing methods inside the document object. But the idea is that document get element by ID has been around forever, and it basically got you a handle on the element. And so that's all of this, including the attributes like ID equals person and the inner HTML, etc. And so this itself is an object. Let's go ahead and refresh. I'll make this a little bigger. Look at the developer console. So here we are. So let me clear this and I'll come back and hit refresh on this. I'm just looking at it temporarily. And so the first thing I'm going to do is go to console.dir, which is just dumping returns an object that represents all this information. So let's take a look at it. I'll hit refresh. And you see that span tag right there, that span tag is the ID of person, has all kinds of information inside of it, right? And somewhere in here, I hope we'll find inner HTML right there. And so you can look around, you can use a dump of this stuff in your console sometimes to figure out what you can do with these things. And I'm going to play in this particular one with inner HTML. And the first thing I'm doing is I'm going to read the inner HTML. I'm going to pull the inner HTML attribute out of this. And the inner HTML attribute is just this chuck, right? But I'm going to store it in a variable. Now I'm just storing in a variable. I'm going to console log it, and that's all I'm going to do, right? And then I'm going to put an alert out with that thing. And then I'm going to change it. So you can put these on the left-hand side because the JavaScript can change the document object model in the browser, and it will say Joseph, right? So if you look at the view source, that's what I'm looking at right now. View source here, you see that it's in this span tag, it says Chuck. So now we've run it, and it came along, and I'll hit refresh again so you can watch. In the middle of that alert box, right here, the data is still Chuck, right? And so look at the document object model right there is Chuck. And then as soon as I let the code continue, by pressing OK, you will see that it's going to modify it and it's going to say Joseph. Okay, now if you look, the source code that originally came from the server said Chuck in it, and now it says Joseph. Now you can, so this is not really the document object model. The HTML is the HTML. The document object model is what's inside the browser, in the browser's memory after the HTML has been parsed. And you've probably done this a million times already, but when you say inspect element, you are not looking at the source HTML, and it even looks quite different, right? This makes sense. It's like pretty and it's indented, and you see the document object model. And so this is the screen you're looking at, and this is the data behind your screen you're looking at, where it says ID person Joseph. But if I go back to the original thing, it never changed the source code. It says ID person Chuck. And so you can see how it can change the document object model. And so that's the That's the first bit about this dom01.htm code. Okay, is that just you can change the document object model. So let's take a look at dom02. And so let's view the source of this one. View page source. So make a big. Oops, make it a little smaller. Okay, so in this one, what we're doing is we're adding an onClick method, and we've been talking about this for a while. And in the onClick, we're running JavaScript. So this is JavaScript, document get element by ID stuff, inner HTML equals back. Well, let's find where stuff is. Stuff is the span tag that has an ID of stuff. It happens to have stuff as its text as well. So it means that when we click on the back link, it's going to run onClick, its onClick method. That's the definition of the onClick method, event-driven programming. So what we're going to do is we're going to set the string to back inside that span tag, and then we're going to return false. And remember, return false basically says don't do the actual click. So usually hrefs, anchor tags, cause a click to happen. And similarly, if we send it to fourth, if we click the other one, it'll put the string to be fourth. And so let's do so this is saying stuff right now, which is exactly what came from the server, right? So the server sent this document, the HTML. So if I do an inspect element, you will see the part that when you inspect the element, you see the actual document object model, what the browser is actually showing you. So you'll notice that now I can modify based on user action in an onClick method. I can modify it. So I click on back, and you see that the document object model changed. And as soon as the document object model changed, the part that we're seeing, there was no interaction with the server here whatsoever. And so I can click forth, and you see the document object model change, back, forth, back, forth, back, forth, and you're watching the document object model changing. The source code never changes. That is long. At this point, that was 30 seconds ago. It retrieved it, and it built the first page. As a matter of fact, the fact that there was ever the word stuff in this span tag, that's just gone now. It's just not there. It's not remembered. We rewrote the document object model. The JavaScript code plays with the document object model, not the original response from the server. And so that's another little example of playing with the document object model, just to kind of emphasize how it is that, just to emphasize the fact that what we're watching on the screen is the document object model, and that we're seeing the document object model on the screen, and the JavaScript can change it. And then if we do view page source, we are seeing what originally came from the server. Okay, and so this is the code that originally came from the server. And so we're going to do a couple things here. At the bottom, I'm going to have a global variable called counter equals 1. We'll just console log it, mostly because in case I want to debug what's in this UL tag, which got an ID of the list. And then I'm going to define a function, and we'll come back to that. I'm going to call that function when I click on the more string, right? And onClick says call the add function and then return false. And again, that's to suppress. Return false is to suppress the default behavior of the href, of the anchor tag, clicking on the text of the anchor tag. So I've got code that will run under more, and what the code does is adds to an element. And so let me refresh this. View page source. Oh, I didn't want to view page source. I want to inspect element. Okay, so now we have the inspect element. That source code is just there. I threw that up with some clever JavaScript. So here we go. So we got this item, we got this UL tag, right? And so this is the document object model. And right now, because we haven't done anything, it mimics what came from the server. And now I'm going to say more. And you see that I got a new thing in the document object model. So if I go li, and close those all down, more, right? And so the document object model is changing, but of course the stuff that came from the server is not changing. So let's take a look at how this is accomplished, okay? So every time we click the more button, it comes into this add function, and it's going to use the document object model to create a new li tag model.
I can give it a class. And if you look at the document object model, you see that my new LIs have a class, a CSS class on them called list item for no particular purpose. Just you can do this stuff. It's not. And I set the inner HTML. Now at this point, this X contains an LI tag that is not connected to the document, but it's fully sort of, and I concatenate the counter, which is why it says 1, 2, 3, 4 as these things are put on. But then what I do is I say, let's inject this little X, this little tag that's living out in a variable, let's actually move it into the document. So what I do is I say, let's go grab the list, which is the UL, and append a child. Well, this LI tag is a child to the UL tag. And when I'm done with this append child, I'm going to have another child. It could be something other than an LI tag. I just happen to be making an LI tag. So lines 13, 14, and 15 here are making a new LI tag, and then line 16 connects that LI tag into the document object model at the appropriate place. So the next one is going to come, we're going to append a new child. So at the end of this, now we got first item, counter 1, counter 2, 3, 4. There are 5 children for the LI tag, and if I click it again, there will be a 6th child for the LI tag. And so there you go. And so that gives you a sense of how we mess with the document object model using normal vanilla JavaScript. And up next we'll take a look at some jQuery samples that really give us a better pattern for messing with the document object model. Thanks. Hope this has been helpful to you. Hello and welcome to another walkthrough for Django for Everybody. So in this walkthrough, we're going to play with some of the jQuery examples. Before this, we did the document object model way of doing things. And jQuery, of course, is a better way or a newer way of dealing with the document object model. And there's other ways as well, but jQuery has been something we've used for a long time. So let's take a look at the first one and take a look at the source code. And here is some code. Let me just view source. It happens to be showing you the source in case you don't know to view the source, but let's go ahead and view the page source here. Make it a little better. This is my little, that's my little magic to show the source. But basically, let's just take, this is showing how to do basic things in jQuery. And so if I hit refresh again, you'll see it hits an alert button. Can I make this bigger? Yeah, make it bigger. Okay, so here's a basic jQuery. So the first thing is jQuery is a software library of a bunch of functions, actually kind of one function named $, that has a bunch of methods to it. And we load it, so you have to load it. So you'll notice that I have to load this before I reference this $. So, but I'm also loading it kind of at the end of the document. There is a discussion about where you load this, and best practice tends to want to load it in the document and have a line above which there's static HTML, and then pull your JavaScript down to the bottom of the document as much as possible. But a lot of people don't do that, but I'm just trying to do it here. But this is about JavaScript. So the thing we talked about in lecture was how the $ is just an object. It's not language syntax, it's just an object. And so we're calling the $ a function, and the $ function is being passed a parameter of the document. Document is the JavaScript variable document that represents the document object model. It's all the pixels and the things that are on the screen and the thing you see when you do view source. Now, the place we tend to start in jQuery is we use the document ready function. And so what this thing is, document ready, is a bit of code. And we go into first class functions here. Document ready says, please run this little function that I'm giving you when the document is ready, when the document loading is finished. So in a sense, when the whole document is finished and all the stuff has been parsed and all of the ancillary elements have been loaded, etc., then call my code. And we're using first class functions because we have an anonymous function that's got an alert and a console log, just so we can see when it happens. And so it's not very impressive. It's just, and when I hit refresh on this page, let me do a window developer console, so you can see this. So you can see that, clear that.
if I hit refresh, it's going to wait until the page is fully loaded, and then it's going to run those 2 lines of code. Okay. The alert happens first, and then the console log happens second. Now remember that alert is a very aggressive way of doing debugging in that it actually stops the browser in its tracks. Console log just sort of prints something and keeps on going. And so there's nothing, when it's in the middle of that alert, the browser gets to do nothing else. It doesn't like run the next line. It's really stopping everything. And so document ready, function, call the $ function, pass in document. It returns an object that has a function, a method called ready. And the ready function takes one parameter, and the parameter is some code to be run. So this is kind of what's called an asynchronous programming model, in that I am not running this function right now. I am telling jQuery to run the function later. The other thing to notice really quick is there is no function name here. And that's because we don't need to name it. We could put this in a named function and tell it to run function XYZ here, but instead it's basically convention because of the awesomeness of first-class functions in jQuery, in JavaScript, to just put the code right there. And so it looks like syntax soup, but it's really not. Call a function, get the object back, call the ready method, pass in one parameter. Oops, don't do that. Pass in one parameter, which is source code, and then you have the end of the function, which is this parenthesis, and then this all here is in effect one line of JavaScript. Okay? So that's the first one. So now we take a look at the next one, and this one here. Let me window do a console. Turn on a console, web developer console. Okay, hide that. So when this page loads, there's another JavaScript constant called window. And so window is not the whole document. The document might be larger than a window, and if you have if your window, let me make it like this. So if your document is bigger than your window, you get a scroll bar. If your document is not bigger than your window, then you don't get a scroll bar. Okay, and so the window is the browser's concept of what you're seeing, not necessarily what's there. Inspect element is everything on the page. Now it's including stuff that might not be viewable. Now this one's so small, but you get it, the idea that DOM is always there. Window is what's here. So one of the things we like to do if you're building accessible responsive or accessible content, sometimes you want to check when this thing is resized. And so we say $, which is a function, the jQuery function, that returns a jQuery wrapped version of the window object, and we're going to call a method in that called resize. And what we're saying is this is another example of delayed execution. Say please execute this code when the window is resized. Okay, so we're not executing the code right now. We are executing the resize function, but we're passing in data, and then jQuery is going to store that for later. And when jQuery detects that a resize has happened, it's going to call our code. Now all this code does is print out the current $window width and $window height. Now it turns out that in the old days, it was really difficult to figure out window width and window height, because width sometimes included the scroll bars, sometimes it didn't include scroll bars on different browsers and different versions. So jQuery is conveniently telling us what the width really is, so we can write code like to take 80% of the width, whatever it is we want. We can say 80% and we know it's going to work consistently across all browsers. That was part of what jQuery did, was it standardized things that were different across browsers. So now let's resize the screen. Right? Let's resize the screen, and every time the screen resizes, you can see that I am getting, my code is being called as a part of the method. Right? So my code's being called. So this is called event-driven programming. We are not running our code right now. We are asking the browser to run the code for us when something happens. And so that's part of jacking into jacking into the jQuery's event system. Okay, so I hope you found this useful. Hello and welcome to another walkthrough for Django for Everybody. We're continuing our walkthrough through the jQuery. In this one, we're going to play a little bit with the onClick event, and it's very similar to this DOM one, but showing you how instead, let me open them both. So if we review this DOM one, and we do a view source, page source. So basically what we did is we had an anchor tag, right, in the DOM, we have back and forth, and we have an anchor tag and we put the onClick, and we're using what we call vanilla JavaScript. And so we had a onClick, and then we would play with document get element by ID. And I want to show you how we do this same thing in jQuery using a similar kind of a thing. So let's just play with it. We're going to have a spinner come and go, toggle the spinner, and then we're going to turn the background red. Okay, so we're going to do it with a little different style. So let's refresh it. Let's turn on our, make it bigger, make it smaller, and then view console. Okay, so let's take a look at view source. We got that one. Let's do view source on this one. View page source. Okay, so I sort of mentioned the fact that we tend to like getting our JavaScript toward the bottom of the page. So if you look at the top part of this page, lines 1 through 8, you see that there is no JavaScript in there, not even an onClick. And so the key is with jQuery is there's this pattern of like having relatively static HTML and CSS, and then at some point start doing your JavaScript and then enhancing the page. And so we're loading the jQuery library on line 9, and then on line 11 we have a document ready. Now I talked about this in a previous walkthrough. Document ready is using the dollar function, passing the document as a parameter, getting back an object, calling the ready method in the object, and then passing one parameter, which is code, to the ready method. But it shouldn't take you long to just grab this line of code and paste it in. Document ready function, parenthesis, curly brace. And then you also have to paste line 19 here, which is close curly brace, parenthesis. And then you just kind of ignore those two lines and realize what it is that I want to run at the moment the document's ready. So pretty quickly, the whole document ready thing just is a thing you do, and you cut and paste it from one file to the next, and it looks kind of like syntax salad, but it doesn't matter, because then ultimately the code that runs when the document is ready is the part that matters, and you just work on that. So let's take a look at what's going on here, and we're again hooking up two events. So first we're doing is we're going to go look up the tag that has tog, #tog, and that looks up the tag, this anchor tag that is got an ID of tog. And then what we're going to do is that wraps that element in jQuery and then calls the on, which is a method, and then we have a series of events, and we're asking for that click event, and we're saying when that click event happens, run this function. It's only a one-line function, right? It's only a one-line function that says $spinner toggle. So this onClick isn't connected in until this line of code runs, but then it's like an onClick got added to the anchor tag. And so the ready function delays till the page is loaded. And then within the ready function, we're registering a click that's going to delay until the click happens, right? So the click hasn't happened yet. And the same thing is we're going to find the tag that has an ID of red, and we're going to, when that clicks, we're going to go find the ID of para, which is this tag right there, paragraph tag, has this text, where's the spinner in it, and we're going to change its background color to red. And so those are just two things. Now, at the end of this page, really nothing has happened, but we have augmented the markup, right? And so we can take a look now. We can take a look at like this. We can inspect the element for a bit, and you'll notice it says event. So that means that there has been an event listener that's added to it. And so toggle spinner has an event listener and red has an event listener. And so that's what these two lines of code did, is they basically registered an event listener for these two links. Now, ultimately, it's not that different than if we put an onClick in. The difference is this is the jQuery way of doing it, and that is leave the HTML alone. Just generate HTML, putting ID tags and class tags and style tags and whatever, and then later augmenting it in the ready function, and then we can use that. And so it achieves the same thing, but this is sort of the jQuery way of achieving. So # spinner toggle, well, that changes this display none to display block and back and forth. And then the background color red is just a CSS variable. So let's go play with this a little bit. Okay, so let's look, where's the spinner? Let's find the spinner. Here's the spinner. So here's the thing. In this spinner, you'll notice it says display none. Where's the spinner? So here's where's the spinner, and there's an image tag, but it's hidden. Now this is a common thing. Spinners come and go. We use them to indicate to our users what's going on. And this one's there already, but it's not shown. Now when I toggle it, the toggle is actually going to read this, figure out what the current status is, and then change it, and then toggle will go back. So watch down here where it says display none as I toggle it, and watch the fact that the spinner's there. And so the display none was taken out, right? So now that spinner's there, and we see it because display none is not there. But if I toggle it again, it goes away and display none happens. So it's not just markup that we can change. We can change CSS, we can change just about anything. So I can turn this spinner on and off, and we're modifying the document object model, and we're seeing the document object model modifications are being seen live, and we're seeing the results of the changes to the document object model as the spinner appears and disappears every time we click the spinner. Okay? And so if I look at this this paragraph tag, that's this whole thing. And if I turn the red on, you can watch as we are updating the document object model and changing the CSS. That will add a style tag. So watch. Boop. And so there we go. We added CSS, it's background color red, which of course took the whole paragraph to make it red, and away we go. And so I don't have a way to turn it off, but you could certainly rewrite this in a way that turned it off. And so this does no particularly interesting thing other than the fact it shows you how we sort of add ID tags and then connect events to those ID tags toward the end of the page rather than using onClick in the middle of the page. Okay, so I hope that you found this particular walkthrough helpful. Cheers. Hello and welcome to another Django for Everybody walkthrough. We're currently walking through the various jQuery ideas. So in this one, we're going to replicate the code we did in the document object model. Let me go back and open both of these. This one and this one, jQuery 04, and so what we were doing is we're going to achieve the same thing. So we're going to click on this More button, and we can add a new item. And this is using vanilla JavaScript, and then we're going to do it again using jQuery. So I may come back and talk about that, but let's look at the one using jQuery. So again, every time we click on this, we're going to get a new counter. And let me take a look at let's just inspect element and then watch. So here we go. See, it's got one li tag. Doot, doot, doot. Okay, so it's not that different. We're going and appending a child here. So let's just see how we do this in jQuery. Okay, let's take a look at the source. So the first thing that we'll notice is in the sort of jQuery style, we have HTML that has no JavaScript in it. Then we include the jQuery library, and then we're going to do some jQuery setup, and we're going to augment the HTML up here. And so it's pretty simple. We do document ready. which means that after the document's fully loaded, lines 12 through 16 are going to run. Lines 12 through 16 are going to run. And we're going to hook in a event to this little anchor tag. So we got an on-click event, and when that's going to call a function. And so these 3 lines of code are going to happen when someone clicks on more. So what are we going to do? Well, when someone clicks on more, we're going to console log that we clicked on it. Then what we're going to do is go grab the UL tag, # the list, which goes and finds the element that has the ID of list. And then we're just going to append to it. And then we're going to create a string, which will then be turned into HTML. And we're just going to concatenate an li, counter is, and then the number counter, and then we add 1 to the counter. And so this I find this pretty clear. We're just adding a string as if there was a string here between lines 5 and 6. And away we go. So we will click more, and it will add an item. And of course, it's adding to the counter, and so the number goes up. And so if we compare and contrast, view page source. If we compare and contrast the document object model of this and the jQuery of this, now this is really simple code, okay? So in the document object model, we're sort of creating an element, we're adding to it, we have to know the various things that are in there, and then we're going to do get element by ID, because get element ID was, again, the thing we had in 1995, and then we're going to append a child. jQuery just feels to me just more like I can say what I want to happen. And so it's like jQuery is a higher level way of interacting with the document object model. And that's exactly what it is. And that's exactly what it is. jQuery is a library that's ultimately doing the exact same things to the document object model. It's just I don't have to write quite so much code, and I don't have to remember quite so many things, because jQuery says, you know, these are common things people do over and over, so I'm going to make it as easy as I possibly can and give you a pattern and say, just do it this way. And so that's how this all works. And so, like I said in the lectures, I'm not going to give you a ton of jQuery examples that I walk through code by code, because once you get the basic pattern down, it's just not that hard to use. So I hope you found this walkthrough useful. Cheers.
So now we're going to use JSON to build a very simple chat application. I love to use chat applications to play with JSON, because really they are, and there are so many better ways to build a chat application than the way I'm building it. I'm just using this as a great way to talk about JSON. So what we're really going to end up doing here is we're going to have 2 windows, and each of them, 1, 2, each of them will be doing the same thing. And they both have a chat button. There's a back end. And when we press the submit and send a new chat message back, the other one is in a loop. And it's polling. It's checking to see if there's new chat messages. And when there is a new chat message, it uses AJAX to pull that back. The chat messages, an array of JSON objects. And then it updates this part here. And so that's the idea of JSON, is that we can use JavaScript to update some part of the screen and leave the rest of the screen alone. And so it's not like this whole screen has to blink. Now, when we're doing things like making menus at the top and moving back and forth, we make it look like certain things are not changing. But in this situation, everything outside that little chat box is not changing. We're going to do a full request response cycle when you type in something and press the chat button. So that's the basic idea of this application. So here is how it's working, basically. You see, if you watch the network, every few seconds, about 4 to 5 seconds, it's doing a retrieval. So it does a retrieval, does a retrieval, does a retrieval. And what it's getting is a JSON array of little messages. And then it reads this array, and then it displays them. It wipes this window out using jQuery, and then it redisplays the messages. And in this case, it's not really getting the new message, it's just getting all the message, and it's just rewriting the whole thing. And so if you got to watch to make sure that you see the new messages coming. So here's a bit of code in urls.py. we have just the main view to talk, to do the talking. And then the messages is just going to be our bit of JSON stuff. Okay? And our model.py, it's pretty simple. It's got an owner. We're going to use the owner pattern, even though we're going to do a little bit more of the work ourselves. And it has a text field, and that's pretty much it, other than the stock date fields that we normally have. So if we take a look at the views.py, we're going to do simply a rendering of talk.html. You'll see when we get to talk.html that the dynamic part, you might be surprised, like, where are all the old messages? The old messages normally would be retrieved right in here, but they're not, because we're going to do that in JavaScript. And that bit of like retrieve the messages, the most recent messages, is going to be done in the browser now rather than in the server. So it's going to be a request to show the page, and then the page is going to start and go grab the messages. And we just have a normal form, and we're going to grab the message text from that form, and then add the owner to be request user, and then save it, and then we're going to redirect back to ourselves. And so that's the view, and that's really quite simple. The interesting part is in the template, and so we have a bunch of stuff in the template. This part here is pretty straightforward. We have that form that's at the top, and the form is at the top, and we got leaving, we got reset, we got a chat button, we're going to post back in. And then we have this chat content, and that's important because the chat content is that part on the screen that we're going to replace over and over and over again. So one of the things that we're doing here is we're going to grab a spinner and grab a URL to a little spinner that we've got stored in a static area. And that spinner, you know, one of those little dot, 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 dot things that goes round and around, that's just an animated GIF. And what we're going to be doing is you put that out so that if it turns out that somehow your JSON is not working, the spinner stays there, and that's kind of a clue to you, at least as a developer, and maybe to your poor end user, that it's not running. But the idea is that spinner will be running, but then it'll be immediately be replaced by the data we pull in from JSON. So here's the interesting part. This is a function that right now it's just going to call a function, and we'll get this started up in a bit. This function is going to do the hard work. The function is the part that's going to get triggered every once in a while to go retrieve all of the data. So we'll just call this function update message, and what it's going to do is it's going to go give us a console log, and then we're going to grab get JSON, which is jQuery to retrieve a JSON URL, and then this get JSON takes two parameters. The first is a string, which is a URL. The second is a bit of code, and then the data that comes back from the JSON, meaning this data right here, which is an array of arrays, is going to be passed in as rows. So, you know, until you're really comfortable, I put a console.log so you see each time it's called. Then what I'm going to do is I'm going to do chat content empty, and remember the chat content is that little part right there that we're going to wipe that out. That's just a jQuery to wipe it out. And then I'm going to loop through the rows. Yeah, we're going to loop through the rows. For var, we're going to loop. There's two rows here. Rows.length is 2, and then we're going to grab it, and then we're going to say we're going to append a paragraph tag in the first part of the row, plus a break tag and 2 non-blank spaces. That's so that it indents 2 spaces. That's the time underneath the text. And then we're going to take the second element of that row and print out a paragraph tag. And so that's what is going to put the rows of the chat. That's going to wipe it out and then fill it back up. We just append it. Append around and around and around and go through and append. And then what we're going to do is we're going to set the timeout to call ourselves again in 4 seconds. So that basically says this is actually part of vanilla JavaScript, and we're saying 4,000 milliseconds from now, or 4 seconds from now, call this again. And so it's only going to do this after it has successfully got the JSON back. And so if the system starts slowing down, after it's done the update of the little part of the screen with the chat messages, then it's going to say, and then run me again in 4 seconds. And that's what's going to happen every 4 seconds. But then what we're going to do is also after that, we're going to trigger that we're going to get this thing started. And so we're going to say, under document ready, there's the document ready, these 3 lines. We're going to tell Ajax not to cache that data because we expect every time we're going to call, we want the new messages. We're going to call update message, which is immediately going to start an Ajax request and then rewrite chat content and then wait 4 seconds and then do it again and again. And so this is like priming our timing loop. Okay? And then once we've done that, the only thing left to do is look at what is going to happen in that code that's going to give us back all those Ajax messages. So this is the talk messages. That's our URL that's going to do that. It's a GET request, and we're just going to go read all of the message objects ordered by created at, the first 10 of them. So that's what that does. And we're going to, instead of just sending the messages down, we're going to augment it. And so we're going to take the message text, and then we're calling natural time. Natural time is the thing that says 13 minutes ago or 14 minutes ago instead of some long, ugly time thing. And that's something we're getting from Django. And so that is the result. The results is a new array. Messages is an array, and results is the array that looks like this. And what we've done is we've changed this second parameter basically for each of the messages using natural time. And then results, in this case, is an array. Actually, it's a list. I'm confusing my JavaScript and my Python. We're in Python right now, and so it's a list. And then we just return a JSON response, which serializes that into JSON and sends it all back. So you kind of get the idea of how you build a chat, and you can see how this is what's coming back, and it's hitting this messages, and this little cache equals false is adding this so that the URL does not seem to be the same URL from the browser's perspective. So it's really just taking a timestamp and appending it so the browser sees it not as the URL it retrieved before, so it doesn't have.
Hello and welcome to another Django for Everybody code walkthrough. We're going to do another walkthrough of a different part of the chat application. And so this time we're going to actually do some chatting. And I probably won't need this now. So this chat is really designed to run simultaneously. So normally this would be 2 different logged in users. This chat doesn't really do anything particularly for logged in users. So I'm just going to use 2 windows logged in as the same user, but so the idea is, and we can see this going on right now. If we do a tools developer console, we can just watch. We can watch this, clear it, and you'll see that every 4 seconds it's making a request and it's getting some JSON back. Requesting JSON, yeah, I got it. Requesting JSON, I got it. And then we can watch in this other window at the same time. Clear this. Every 4 seconds, it's going to do an AJAX request, requesting JSON. Now, if we watch the network tab, we can see what it's doing. It's requesting JSON. Now, the page is not refreshing. What's happening is in the background, in JavaScript, it's actually talking to the server, okay? And it's doing that every 4 seconds, and it's doing the same thing in both of them. So this is a polling application. You know, these could be on completely different computers. It's polling to see if any new messages have shown up. So I'm going to say new message. Now, this is just a traditional form, and this is going to submit. So you'll see a post redirect that happens here. Boom, boom, post redirect. I'll come back to that. And then that new message already appeared just because the timing was perfect, right? And so I typed it in on this one, and it worked. So here is the post. It posted that message. Headers, parameters. It sent new message, and it sent the CSRS middleware token. And then the post did a redirect back to talk, and then it showed the messages. So this reset, cancel, chat, this is just a standard form. I guess let's just take a look at the page source here. This form is a standard form. It just is submitting it. It's submitting it with a post, and it's just standard stuff with a CSRF middleware token, et cetera, et cetera, et cetera. So the posting of new messages is not the tricky part of this. So let's walk through the simple posting of new messages. Talk, the /talk goes into my views.py. And so this is my talk main. And I guess I should probably, I don't need this one anymore. Let's take a look at the models file. Take a look at the model file. So there is a data model for this. It is a one-to-many. We got text fields. We got a primary key. Everybody can put more fields in so that we do know who they're owned by, so that we know who is allowed. We do have an owner, but we don't have any trashing, so we don't have any delete. This is really quite simple at this point. And so we got the two fields created at and updated. Of course, are handled on automatically. So do not worry about this bit right here. That's just so that for my online system, all it's doing is it's throwing away chat messages that are more than 60 minutes old. You could put code in there like this, but this really doesn't implement it. It just is something because of samples that's online. Don't worry about that. What it's really doing here is just rendering chat/talk.html. Okay, so that's what the GET request is. So that means if we just hit enter here, I'll come here, hit enter here, that's what happens. Okay, and then a few seconds later, I get the messages show up. But you'll also notice that when I just hit enter and I do a GET request to that page, for a little while I see a spinning GIF. Okay, and so that all happens here in chat/talk.html. But before we leave the view, it's pretty straightforward. When we hit the chat button here, it's going to send a post data and the name of this form. Inspect element, that's what I wanted. The name of this thing is a name message, right? And so I'm going to say post message, request post message, and I'm going to set the owner field. This is just a model, message model. Then I'm going to store it, and I'm going to redirect back to the GET request. All right. So that's how I do cool new message, and that's what happens when I press this button. Now we're going to find out how in this other tab, boom, cool new message shows up 2 seconds ago, right? I did nothing in here other than navigate to the tab. And now we want to see how that all works. So let's talk first about the HTML. It comes down here. This is the source as created, and this is the template that creates the source. It's a pretty straightforward template. We got some chat main. The chat static is a little bit weird, and so let's take a look at how that works. That is this line 63. Chat static generates this, and if I look at my URLs, I'm mapping the static to something that's in a folder. So let's pop up a thing, ls-l. So in static, there's a single file called spinner.gif. And if I take a look at what spinner.gif, I think this will open it in a minute. Yeah, so spinner.gif is just an animated GIF image of this little spinner. Also looks kind of like a Walmart logo. And so if you look at the page that's generated from the view source, and we've been sitting here for minutes now, but if you look at what originally came from the server, you see that there was, didn't mean to click there. Let's do it again. View source, come down. Here on line 62, what came from the server was HTML that put that spinner out, okay? And that just is our way. So I've put this spinner here in case the JSON Ajax doesn't work. Because if it were to blow up, right? If it were to blow up, that thing would run there. Now I've artificially slowed this down, and I'll show you how I did that, just to let that spinner show for 1001, 1002, boom, now it's gone. I can make that speed up a lot by changing this chat talk, but just understand that we often fill the areas that we're going to replace with a spinner so that if something goes wrong, we have given our users a clue. Okay, so then we're going to build function update message, and it's probably easier to look at it in view source. So oh dang it, I did it again. I didn't mean to click on that. There we go. So update message. So $getJSON takes one parameter /chat/messages, which of course is the URL for chat::messages, which maps to urls.py, chat::messages, which is talk messages view, which is, we don't need this anymore. That's this view right here, talk messages. We're going to make it be a login required mix-in, and then we're going to read all the messages by looking at our message model, message objects all, order by, descend and create, add, and give me the first 10. And then what we're going to do is we're actually going to call this natural time. Natural time is a really cool little Django feature that gives us times, and it says 7 minutes ago, 3 minutes ago, rather than some big long time that looks like with long dates and February 22nd, Wednesday, 2020, or whatever it is, right? So I could send messages here into, I could send the messages back, but then I would have to convert these into prettier things, but I want to convert these inside of Django because I have this wonderful utility. So what I'm going to do is I'm going to loop through the message array that I got back, and I'm going to return, I'm going to make a new array, and it's an array of arrays basically, and it's a to thing where I got the text of the message and a pretty version of the time, and then I append that to the array, and then I return the array. So I'm returning an array. Now it turns out an array of arrays. It turns out that having the outer result, having the outer thing be an array is actually sort of tacky, but it's really supposed. So if we look at, for example, we go to the network, and we look at this, and we look at the response, we see that it is an array of arrays, right? Let me make this so I can click better on it, right? It's an array. The outer object, the outer thing in our JSON is an array, and then I've got just a linear list of arrays. And there's 2 items in each array. One is the time, one is the text, and the other is the time. And so this message payload that's coming back, this is that results. And of course, JSON response serializes it, and then we're going to see how we deserialize it, right? And I think I might be able to open this in a new window. Can I open? Yes, I can. So I've got this opened. If I look at the raw data, that's what the raw data looks like. If I look at the parsed JSON, it's an array with 0 and 1 and 0 and 1. And if I look at the headers, it, of course, is application/JSON. And all that work of producing the response is here in talk messages, where we create a data structure inside a variable inside of Python, and then we just serialize it and send it out using Django's built-in response. Okay, so that shows how we put messages in. That shows how we feed messages out in the format of JSON. Now let's talk about how we get those messages into the screen. Okay, and that's this update message. So update message is just a function. We'll eventually, in document ready, we're going to say, hey, Ajax, don't cache the messages. And so what that's doing is adding this little number that changes. It's really just the time, but that means that the browser is not supposed to, sometimes when the browser sees the same URL over and over and over again, it's like, oh, I already got a copy of that. And we're like, no, don't let us. So we're saying, don't cache it, put a little thing on it so the URL is actually changing. It's just, this question mark is like a query parameter, and it forces the URL to change. Then what we're going to do is we're going to wait 2 seconds and then call update message. We could call update message right here if we were in a hurry, but I'm going to wait because set timeout is vanilla JavaScript that basically says run this code, run this code, and it's a string with code in it. but hey, it's JavaScript and code and data are kind of equivalent, and wait 2 seconds, 2000 milliseconds. So this right here, instead, I could say update message right now, and then it would start immediately, but this set timeout is why when I press refresh, I get to see my cool little spinny thing for a few seconds, then it's too late, okay? So otherwise I would just call update message. Got it? Okay, now, at some point, this timer will expire, 2000 seconds will expire, and then it will call update message. So, 2 seconds later, it starts calling this code. And so you see it says requesting JSON, and then it calls jQuery to ask for some JSON, and it calls chat/messages, parses it all, deserializes it all, and then calls my code with the resulting messages. The resulting messages, all those messages, which is an array of arrays, passed in as the variable rows, and I immediately console log it. So now if I'm going to go look at the console logging, I can say what's coming back. Oh, it's an array. How come there's only one? How come there's only? Oh, okay. Yeah, it's an array, and in that was 3 minutes ago. How come I'm not seeing all the rest of it? Maybe it's only showing me. Yeah, it's only showing me the first one, but there you go. So I'm console logging it. I put these console logs in just because I'm so nervous all the time. Did it really work? Am I really running my code? Because the browser, when it blows up, is really quite silent, right? Very, very silent. Okay, let's go back and take a look at web developer network. Yada, yada. Okay, so at some point, I am gotten called. I log it. Then what I do is I go up to chat content, which has initially it has the spinner on it, and then I empty it out. That's jQuery, just emptied out, and then I go through and I loop through all the rows, which might be 0. If it is 0, then you're going to see nothing. And then I'm going to grab the row sub I, which each row has 2 things in it, and then the message is the sub 0 element, and the time is the sub 1 element. And I'm just using jQuery append to throw a little paragraph in with that text. So if you were to do an inspect element here, you would see that this is a paragraph. Oh, come back, chat content. So let's see if we can catch it. We might catch it emptying it out and then filling it back up. Doesn't look like we're going to catch it. But basically it wipes all this stuff out. Oh, there it did. You see what it did? So here it is, and now it's going to wipe it out and then fill it back up with the same thing. Okay? So you'll see how it does an empty of that whole div, and then it fills it back up. And so we can see it. Here comes, emptied out, and then fill it back up, and it's got the same stuff. Now what's happening is it's all happening so quick that we don't see any flicker or anything here. But every 4 seconds, this is being rewritten and rewritten and rewritten. Oh, and you'll notice that my selection died because it's not the same. It's not the same text anymore. It's not selected because it got deleted. I selected something and it's about to get deleted. Here goes, deleted, come back. Oh, and you'll also notice the 11 minutes change. So, and at the end of this, when it's successfully returned, we say, well, run me again 4 seconds from now. So the set timeout, once it runs it, it's 1 time. There's another way in JavaScript to say run this every 4 seconds. But I actually prefer waiting for it to succeed because it turns out, and I'm not going into it in great detail, but these things can have errors. And then you can put extra code in here to handle errors. But what I'm doing here is I'm only running this if it is successful. And so I'm only running it again. Why bother? And if it is slow, because this is asynchronous code, it takes a while, in this case a zillionth of a second, it takes a while between the time it starts the request and the time it gets the data back and calls our code. But let's just say that the server was overloaded. It might take 2 seconds between the start of the request and the call of the code. And so this just says that if it's it'll be 6 seconds everything, because if it's slow, I'm going to only add 4 more seconds. So I wait till it's all done, I wait till I get my data, and then I say, okay, run me again in 4 seconds. Now, this ultimately is a very simple polling application which is inefficient, and there is a technology called WebSockets that makes this a whole lot better. But we'll talk about that perhaps some other day. Cheers. Hello and welcome to another walkthrough for Django for Everybody. In this particular walkthrough, we're going to play with the favicon. And so the favicon is a special little icon that shows up at your root /favicon.ico. There's a whole series of favicons, but this is sort of the original classic one. And you should be able to see it. And it's also what happens in your bookmarks or your little tabs. And so it's kind of a fun little way to brand your site. And if you've been grabbing my code, you have got a favicon sitting here in Django's home static favicon.ico. And if you look at urls.py down later, it adds a path using the static file server, and it sort of goes to the base directory of the Django application and adds home static. And then if there's a path that matches, this is the path that matches, then this is the file that it looks up, and then that serves up the contents of that file at favicon.ico. Now, what you want to probably do is make your own favicon. So let's go ahead and make our own favicon. Here is a favicon converter, and let's go ahead and grab a file. Let's see, Sakiger. Going to make a little Sakiger icon instead. And so I did it. It converted it to an icon. Let's see what we got here. And I'm going to download a zip file with a bunch of icons, and it'll go into my downloads. So here it came into my downloads. It's already downloaded it, and that is an icon. And so an icon is a special kind of an image. And so now what I'm going to do is I'm going to go into here, and I'm going to upload and overwrite this with a new file. And so here we go. I'm going to upload that favicon. And I believe it's uploaded right this second. Now, here's a weird thing. Now I should be able to go here, and I should be able to press refresh. I don't think reloading my application is going to make much difference at this point, but icons are heavily cached by the browser. So one thing to do is just, ooh, I didn't mean to start that. Didn't mean to start Camtasia. Sorry, didn't mean to start that. So I can go here in a different browser, and I can see the icon. Or I can add a get parameter, and then I can see that icon. X equals 3. And now I can see the icon. So So if you come here and you press refresh, what you'll find is these icons are heavily cached. And that's just because you don't want to overload the server getting an icon on every page. So to really do this right, the way to force the cache, and we've seen this like in JSON, you can add a get parameter x equals 42. And that basically says it's going to ignore this, and it's just going to get, because that's a query parameter, it's not part of the path. And it's going to load the new icon. So it might take a while before you're going to see that icon show up, and so don't feel too bad. If you can do this thing where you go directly and you add this question mark, you should be able to see your brand new icon. And then later, or maybe if you run with a different browser, but if you've used a different browser and it's got a cached icon, away it goes. And you can go Google how to clear the favicon on my browser, and you'll find it's not trivial. So this is the way that I do it. I just add a get parameter, and then that does it. So I hope this little favicon walkthrough was helpful to you. Cheers. Hello and welcome to another walkthrough for Django for Everybody. In this walkthrough, we're going to look at social login. And we're going to use GitHub to do our login. And we're going to use a piece of code called Social Login Framework. And you can read this. This is the link documentation to social login. You can read through all this stuff, but I've actually, in my home, I've already done most of this, and if you based some of your stuff on the settings. So if you've been using my code for a while, every time you say manage.py, it says if you want to use social login, please see this file, and which registration it's doing. And so we're actually going to, it's not really broken, but you'll notice now I'm going to show you where these messages are coming from and what we are about to change. So, bring this one over here. So first off, where those messages are coming from is down here deep in the settings.py, about line 176. It's going to import from GitHub settings.py. And GitHub settings.py is a file, but this file doesn't yet exist. So if you go into DJ Free Samples, you will see that there is a GitHub settings dist, but there is not a GitHub settings.py. So this blows up, and otherwise, it prints that message. So there's where that message happens. And so if you look at the documentation, we're going to put the GitHub OAuth 2 backend, etc., etc. Okay? So what we need to do basically is we need to take this file. There is a file called GitHub settings dist.py, and we have to make a new empty file called GitHub settings py. So create that new empty file. And then the first thing we're going to do is we're going to just take all of this and we're going to paste it into it. So from the dist. So this idea of a file with a dist name, that means it's kind of the distribution file. It's not the real file. And so I'm just going to save this file for now. Now the problem, and so if I go here, back here, I believe that at this point it won't say anything because we have a file, right? And it says we've switched to using, it was using login, and then now it's using login social. And so the login is a registration template. So this was the login that you've been using until you turn the social on. And it has some rules that says, you know, here's where you do the URL, you get a form, etc. So you get to set this login. This is a long time ago that we set this thing. But social login, if you read all the documentation, read all this documentation, social login, you have a different way of doing it. So this is asking if that social auth GitHub key has been set properly, and that's this key right here, and otherwise it's not set. So if it gets set, then it's going to do a link to this social begin GitHub. And this is something that's documented in this Django framework. So somewhere in here is the begin. Yeah, so this is an example of how you call Google. So you do this social colon begin. And this social, going back to settings.py, oh, we got to go into the urls.py. So let me go here and then go into urls.py. So there we do add something here, and that is that we switch to social login. We try to import that same GitHub settings, and if we do get GitHub settings, we switch to using the different template, and you say template name, and then use that as social for our social login. Okay, and then it prints out this little error message. Okay, so that redirects to social login, and we also have OAuth, the social namespace social for the social Django URLs. Now that social Django URLs is configured by some of those settings. Okay. Okay, so we have this file called GitHub settings.py, but we can't use GitHub yet because we have to get a key and a secret. And so the instructions are right here. So we go to GitHub developer settings. Now I'm not going to show you the ones I'm using for the projects or the samples, but what you do is you just add a new OAuth app. My cool app samples. And I give you some example things to put in here. So this home page is really samples dj4e.com. Samples, and then you've got to set the login And this is what you're going to need, although I got to update it. The application, I got to change this to be samples.dj4e.com. Okay, and then I register the application. And now I have an ID and a secret. Don't worry, I'm going to delete this later. So then what you do is you go into settings, not settings dist, and then you go in and you paste that in, and then you paste this secret in. I hope I got the secret right. Yeah, this secret. So now I save it, right? So I save it, and let me go into my web tab, because this is my pay account. And I'm going to go to samples and reload samples. I'll just go over here and I'll do a manage.py check. And I hope everything is right still, but it's a good test. And it is using the social login, and it looks fine. Okay, so I've got that. Now let's just see what happens when I say log out. And now if I say log in, I get this login with GitHub because I set that. So if all goes well, I should be able to log into GitHub. Now what's happening is GitHub is asking Charles Severance, me, the logged in user, whether or not to share the data to my Cool App samples. Okay, so I'm going to authorize it, and then it's going to send back, and then I'm logged in. And interestingly, now it knows who I am. It's a GitHub account, and like if I go into, where are we at? Where's the menus at? Menu, because that is based on that email account. That's a Gravatar that's based on the email account. So now I'm logged in, and away it works. So that's the basic idea. It really comes down to create this GitHub settings, use the GitHub settings dist, and away you go. Yeah, the GitHub settings dist, and you copy that into GitHub settings, and then you put your real account in there. Now I'm going to go ahead and go back and delete this application so you can't use my keys. Now it's not going to work anymore. Okay, so there I go. So I hope this was helpful to you, that walk you through a little bit of what it takes to get GitHub authentication working. I would observe that the reason I chose GitHub is that you can do the same with Twitter and you can do the same with Google, but they're a lot, they don't trust you as much, and so you have to do a lot more work to prove to them that you're worthy of using Google and Twitter instead of or Facebook. Those are all much higher bars to get permission to use it. GitHub is really easy. So hope this was helpful. Cheers. Hello, and welcome to another of the sample code walkthroughs on Django for Everybody. This particular sample walkthrough is the favorite things. You can see the source code here in favs. Hopefully you have, like I do, the whole source code of this entire DJ free samples checked out somewhere, maybe on your local computer, or maybe on a separate Python Anywhere website, in a way that you can watch it. And if you don't have that, you can play with these samples here at samples.dj4e.com. I'm going to run my local copy. So let's talk a little bit about what we're doing. We're really demonstrating many-to-many accounts, but in this case we're also demonstrating Ajax. And I can show you how Ajax works at a high level. So normally if I click on, raindrops on roses and all things, you see an entire request response cycle. You see lots of things going on here. And if I click on this, I go up to here, the very first page is a bunch of HTML that came out, and then the rest of it is like the Bootstrap, etc., that was loaded by that page. So you have to kind of scroll back up. But now I'm going to clear this. I'll go back to all things. So that was one page with lots of sort of derivative stuff. But what we're going to do in this is when we hit this favorite button, we're not going to see a full screen refresh. We've got some JavaScript code in here that's going to make this, when I click on it, it's going to make it filled in. But it's also going to have to update something in the database so that it remembers that this is one of my favorite things for the logged in user. So I'm going to hit it, and you see that I hit this favorite, and that called a view inside the server which updated the state, And now if I refresh the whole page, it's going to show it to me, and it's remembered this, right? So I refresh the entire favorite list. And if I add a new one, whiskers on kittens, this is just a normal bit of code that's not that different. Sound of music. So like this one I've got a favorite, this one I don't have a favorite, right? I don't have that favorited. And so, but Ajax is the way that we can both, well, it's just JavaScript and jQuery that's updating the UI, but we can change data on the server by just hitting a URL, in this case with a post request. So if we look at this, it actually sent a post request. If you recall, we're not supposed to change the server state on a GET request. So this is, to not be tacky, we're going to send a post request. And again, if you see this in the source, which we will, you don't want a spider to go down these GET requests. They'll see these URLs in the JavaScript, and we just hope, and they won't do it because they see it's a post request. So so if I hit refresh now, the data has been updated. So if I take a quick look at the admin user interface, oops, admin, and I look at favs, this is my many to many, well, let me just stay here, right? So this means that the user, DJ4E, likes raindrops. And so if I do a refresh here, so that means that me, the logged in user, DJ4E, likes this. Now, if I say I would also like Whiskered on Kittens, it's going to update the database, see there? And then if I come over here, I can hit refresh, and you see that DJ4E likes raindrops. And it's just a many-to-many table with an outward connection to raindrops on roses, and another outward connection to the user DJ4E. Now I'm going to delete this. I'm going to delete this from within the administration. Now this is exactly what the undelete button does. Now, the state of the system doesn't know that I deleted this in the background, but if I hit refresh, you see it now knows that it's deleted, and because it actually went and it queried all those tables, and there was really only one favorite. Okay? So let's take a look at the way this kind of comes together. We will eventually get back to all this JavaScript. So let's start with the models. The model, yeah. So thing, of course, has some title, like a lot of things, some text. We have a foreign key into owner because we want to be able to mark these things as belonging to somebody. This owner right here indicates who owns it, i.e. who will get the edit and delete, just like everything we've done that does that. Favorites is the new bit we're adding. And so we're basically saying, okay, we're going to, so this foreign key is a one-to-many, right? Because that's one user to many things. But this is the many-to-many. And this is also to auth user. Normally many-to-many is three tables, the kind of the left table, the right table, and the middle table. Well, in this case, we got the one table, but the right table, as it were, is the user model itself. And that's okay, because the user model is a table, and all we're doing with settings.auth user model is knowing what table that is. And of course, the created at and updated at in the title, that does. So this is our through model, and of course, when you're in the middle of a foreign key, you effectively have a foreign key to the left and a foreign key to the right. And so this is like, we have a foreign key back to thing, and that's a one-to-many relationship, and then we have a foreign key to the users, and that's a one-to-many relationship. In this case, the onDelete models equals cascade means if a thing is deleted and there's a fav row that references the thing, the fav rows that reference the thing will be deleted. And the same is true for if a user gets deleted, all the fav rows except. So either side, either the left or the right of this, we could, if one of those records goes, the corresponding records in fav will be deleted. And you can either delete things or you can delete users, and the fav rows are sort of automatically maintained. Now the one thing we're doing here is a little different than what we did in the comments one, is we've added this unique together. And that simply means that you can't insert more than one combination of a thing and a user. So it's not like you can favorite it a lot. If you keep hitting favorite, there's only one row. If there's a row in here that exists, i.e. right here, if this row exists and it connects the two, then it's favorited. So in the other examples, you'll notice that we modeled something at this connection. This is really a pure many-to-many. And this unique together basically says the only data that matters is the actual connection between thing and user. And this is just kind of a little fancy way to make it so that the admin user interface looks really cool. Right? DJ4E likes whiskers. That's what you're doing with these string classes. Okay? So, of course, you'll do your migrations when you get that. That's already taken care of. Let's take a look at a couple of things. Let's just start with urls.py. Make it a little smaller so it sort of fits better, a little wider. There we go. So this looks very similar to a lot of things that we've done. We've got a main view, we got a detail view, we got a create view, delete view. So those are all sort of, we've talked about those before and we've used those. This is the new thing here. And so this is the URL that we're going to hit if we're going to do a favorite or an unfavorite, and it is the primary key of the thing. And that's why I name this thing/thing primary key. I might want to even call that thing PK, and then favorite, right? And then that's going to call the add favorite view. And of course, this thing favorite is just a way to reference it in templates and in views. And the same thing for unfavorite. So we've got a little tiny add favorite view and a delete favorite view. And in terms of this, the only real code that we're going to change from previous examples is the list view, because the list view has to be augmented to actually show the little asterisks, and the list template has got to be augmented. As a matter of fact, the most complex bit of this is the list view, and these two have got to be added as well. So let's take a quick look at the views. Let me go ahead and cd templates /favs. So let's start with our list view. Okay, and come on, go a little larger. There we go. Here's our list view, and let's take a look at our list view. So the first thing is, because of that owner field, right, I am going to import the owner detail view, owner list view, and owner create view. And so I've got that, and actually I'm importing it from a different project. That's okay. This owner.py is in the myarts, but you might have it also locally. It'd be owner.py. So again, the whole idea here is that the owner field in the models, vi models.py, this owner field is managed, like in many of these, by us creating my /myarts owner. And basically we're creating this owner list view, the owner detail view, owner create view, and if you recall from these are the places where we've kind of overridden the original automatic create view, automatic update view, which we've used for lots of things, except when we're creating it, we've got to put the request user in right before we split the save into two pieces, and then we half save it, then we set the owner field, then we finish the saving, and then the update view and the delete view is more about the query set, and it basically says, I'm not going to let you retrieve this for update. That's what query set is. I'm not going to let you retrieve this for update unless you own it. And so that's what this is basically saying is, I'm going to also filter these based on the owner must be equal to the current logged in user. And this code right here is exactly the same for delete. So what we're doing is loading the record prior to delete, and we're saying, look, if you don't own it, I'm not going to load it, which means you can't delete it because it gets a 404 not found. And so again, that's in the delete view and the update view, right? That's all here because it's going to do a get or 404, right? And so in there, it does a get 404. In this particular one, we got to do our own get or 404. And inside delete view and update view, it's going to do a get or 404, get object or 404. and then this code right here, if it's like ID equals primary key and owner equals self.request user, the answer is no, and so this is going to blow up, this delete view and update view. Now, that's just a review of stuff we've been doing for a couple of examples, so I'm not going to go into super great detail. So what I want to do is I want to show you thing list view. Now, actually, it does owner list view, but if you go back and look at owner list view, it doesn't really do anything other than the base one. But so it's basically looks like most of these, except what we've done is we've overridden the get request. So we're overriding the get request, and some of this is the stuff that's part of the default, meaning it always would go get thing list objects.all, and it would always pass into the template thing list. And if you take a look at the template, right, what it does is it checks to see if there's a thing list, then it loops through it, and then it prints all this stuff out. And literally, a lot of this is very similar to everything we've done with previous sample code, right? But the problem is we need to get the data so that we can know the starting value, whether these are supposed to be filled in or not, right? And so what we do is we say, okay, and we only going to do that if they're authenticated, because if we're not logged in, if I log out, I don't have any favorites. I can't unfavorite thing. I can't favorite things because I'm not logged in. And so I don't do this, right? So if the user's authenticated, then I'm going to do this. And it also means that in the template, all of this stuff, this is the favorite code, only happens and only shows if the user's authenticated. So I'll log in. DJ4E, log in, and now it's actually pulling this extra data. And so here we are in views. If the user's authenticated, let's go to the current logged in user and get a list of their favorite things, but only the ID field. Now, this would give you a list of objects, and each object would be ID:1, ID:2, ID:3. And so we use a bit of list comprehension so that I end up with a favorites that's just a list of the IDs of the things for which I have a favorite. So in this case, if this is like thing 1 and this is thing 4. And so in this list, that list will be just 4 because 4 is favorited and 1 is not. So I might have 50 of these and you might only have 2 of them favorited. And when it's all said and done, this favorites list, if you printed it out, okay, let's print it out. Print favorites. Print that out, and you will see, let me hit refresh here, and then go over to my run server, and it's a list with the number 4 in it. So 4 is a favorite, and 1 is not a favorite. If I hit this, and then I hit refresh, and I look at this print, you'll see that 4 and 1 are my favorites, right? And then if I unfavorite 4 and I hit refresh, you will see that 1 is the favorite, okay? Now that then drives into that, and that just is passed right here into the template, yeah? And then we have this new stuff in the template. Now we're in the middle of looping through all the things, which this is the loop that goes through all those things. But here we are in the middle if the user is authenticated. And so we basically have some code. Anchor tag href equals # is our key that says don't actually go anywhere. And the onClick is the method. And that's going to call some JavaScript. And it's going to call as a parameter, see I got a single quote here, the URL for the thing unfavorite of thing ID. And I'm also passing thing ID as a parameter. So if you do a quick inspect element right here, inspect element, you see that onClick favPost, this is a URL to hit, and that's the ID. So I'm passing those in as parameters and then return false. We'll go through that JavaScript in a second. And I also give this an ID so that I can reference it down in that function that I'm going to build in a second. So that's here, ID equals favorite. Now, I need to decide whether or not to show which of these two to show. So it turns out that there's actually 2 stars. And what I'm really doing is I'm showing one star or the other. You don't notice that, but if you look down here, there are actually 2 stars. Here's one star, and here's the other star. So there's actually, I can let's see if I can convince it. If I can convince where is, oh, it's got to be here, display none. If I can change this to be display inline, you'll see that there's really 2 stars. And all I'm doing, now this is not going to be much, this is not going to work. I don't know how well this is going to work because I manually unhid it, but there's actually 2 stars, right? But what happens is that I hide the star that's filled and show the star that's filled appropriately. So let me refresh to get it so that, but there's 2 stars there. One is hidden and one is not. So it turns out that what this is this is 2 bits of making a star, and all I'm doing is I'm stacking 2 stars. I'm stacking an orange star on top of a blue outline star. And then what I'm doing it twice. So that's a link, but what I'm doing is if the current thing is in the favorite list, remember I did that, then I'm going to add a style equals display none. And if, in this case, that one's, if it's not in the favorite list, I'm going to hide this one, right? This is the unfavorite, and this is the favorite. And if it's in favorites, I'm going to hide the favorite. So if it's already a favorite, I'm going to show the empty star that's got an unfavorite link. Show empty star. Show a full star with an unfavorite link underneath it. My mind gets all messed up on this. And then if it is in favorites, show a filled in star with an unfavorite. Yeah. If it's not in favorites. Oh, right. I got, it's almost a double negative, right? If it's not in favorites, hide it. So this kind of flips, but okay. So this is an empty star that'll, if you click on it, favorites it, and this is a filled in star that if you click on it, unfavorites it. Okay? So let's take a look at this. Now then there's the tricky bit. The tricky bit is that when you click on the one that you can see, and in this case, the one I can see is this one, right? So I'm here, I can see this one. So it's going to click on fav post, passing in fav's thing unfavorite, where that is the key of the thing. Here's the whole thing, right? And passing in that number. We'll see what that's for in a sec. Okay, so now I'm going to switch to the JavaScript that handles this. Okay, so now we got this function fav post. And you don't have to modify this. So this is the URL that we're going to post to. We're actually going to send no data to it, and then thing ID is so we can have a number. So this fetch is built into the browser. You may have to do what's called a polyfill for fetch if you have a really old browser, but we're not. And so those are called polyfills, things to say like, oh, this is Internet Explorer 10 or whatever, and I need X. So fetch basically takes the URL and then a object with method post, yada yada. You can go look all this up. You don't have to worry too much about it. Content type, and I'm not sending any data. And so this is a post with 0 data. And then the way this works is this fetch function starts the fetch, but then it delays it because it could take a long time to go across the internet, go through the server, and come back. And then what it does is it comes back and then calls this function when the response returns back to the browser. So this is the browser talking to the server, and then you split your code into 2 parts. The part that gets it started, and then the part that in effect asynchronously reacts to the finished. So that's why I'm saying log finished. So you see, oh, it finished. And then the next thing I do is I go grab those 2 little stars and I flip them. I hide them. If they're visible, I hide them. And if they're hidden, I make them visible. So unfavorite star thing ID, which means it comes back to this little guy here, and it just toggles them. So when I do this, it's actually hiding one and showing the other, hiding one and showing the other. I could have done this with differently, but that's really what's going on. And you can see the display none flipping back and forth down here as I flip it. And of course, it's also changing it in the server with the post request. So if I sit here and I look at the network, and I go unfavorite, favorite, unfavorite, favorite. And that's because as I'm showing it and hiding it, it's also toggling what happens when I click on it. If this is shown, then it's going to call unfavorite. Oh, this is now shown, it's going to call favorite. So the empty star is going to call favorite, and the filled in star is going to call unfavorite. Pretty cool, huh? I mean, you could probably come up with some better HTML, and so again, if you look at the console, this is quite nice. I got some debugging here, right? Favorite, favorite, finished. So that's actually going on here after the network shows when they start. Now the finish so fast it's hardly whatever, but then this shows when it finished. Okay, and so that's how you debug this. Now you might have problems on your own code when you're doing stuff like this. Okay, but in this you just don't have to change much. So that is probably the hardest part of this. But then the last thing that we've got to do is we've got to go into the views.py and handle these posts to favs, thing, favorite, finished, right? So we got to hit the posts. So if you take a look at URLs, I'm probably going to need models. Keep models up. URLs.py. So this is the routes. So it's really simple. Remember, this thing is the primary key of the thing ID, not the favorite ID. Favorite does have an ID, but we're not really using it. We're using the combination of the thing ID and the user ID, basically, as the index in the favorite. So we go find favorite view. It's down near the bottom. And so if you recall, most forms we require CSRF, and we could have put the CSRF in here, but it was a lot simpler to just make it CSRF exempt. You kind of have to decide on security whether or not it's okay. Like, I could write a code injection that would favorite a bunch of books for you. Is that really that dangerous? But you could make this more secure. But what I did is I made it CSRF exempt. Okay, and so if you go read to Stack Overflow, you have to import these things and then add this little thing that basically says, hey, we're not going to blow up CSRF. If you don't, these things will get 403s, I think, which is not allowed, but you don't want that. And then after that, this looks like pretty much any other thing. It's a login required mixin, which basically means a session has to be established. We're not really caring it. We're just extending a normal view. It turns out there's no UI to this. If you look at the response is empty. But that's okay because the damage has been done in the server as a result of the post. So we got a post method. We're overriding from view, and we're taking self and request, which we always get, and PK, of course, which is the second number, right? I guess it's in URLs, right? PK is whatever this second number is. It's that parameter. And we get PK as the parameter, come back, views. There we are. Print some stuff out. I'm going to load the thing that corresponds to the PK or blow up with a 404, right? So you can't just guess. I can't just say, I can't, if I pick a PK that doesn't exist, nothing happens. And then what I'm going to do is I'm going to load the old favorite. I'm going to create a new favorite, and I'm going to put to the left and the right the user value of favorite, right? So we're setting these two parameters right here. Setting thing and user. So thing is being set to the current thing we just loaded, which is got a primary key. And the user is the current logged in user. Now, we're going to save it, but we're going to do it in the try except block because what if there's already one there? And if you recall, you can't, because of unique together, you can't save the same combination of thing and user twice. And there's other ways I could have done this that are a little more complex, but I kept it simple. I just did a try and said it's okay if it blows up. That means it's already there. Because I don't let you really hit the favorite twice, but if you somehow could like click on this, if I could do an inspect element, and okay, and like so we're unfavorited. So, but I could unfavorite twice, right? All I'd have to do is somehow convince myself to grab this URL. It's not favorited, and you think, oh, don't do that. Well, the user can always like and put this URL in. I just unfavorited it. What did I do wrong? Oh, too many favs. Come back. That's a second unfavorite. Well, I don't know why that that blew up. Well, let's stop playing with that. Let's see. Did it complain in my thing? Thing 1 unfavorite. Favs thing. Oh, I know why. Duh. I'm doing a GET request. There is no GET request. Come back. Yeah, you can't always put it in a browser and make it work. Teach me a lesson, right? There's no def GET. And I can make it work, but that's a GET request. And so it's like, sorry, there ain't even a GET request here. Okay, so high level, we get the thing's primary key, we load the thing, we create a link, we create an object to put into fav with the two pieces, and we try to save it and don't really care if we've inadvertently double saved it, because our UI is sort of keeping us from causing that to happen. Okay? So that's the favorite. The delete favorite is even easier, right? So in delete favorite, we're CSRF exempt. We have to be logged in, because if you're not logged in, then request user is going to blow up. This line's going to blow up because request user is not necessarily set if you don't have login required. So that's why we drop login required mix in right here. And then we load up the old thing. And that's because we need to put it in this effect filter. So this is like a where clause in SQL. Fav objects get user equals the current logged in user, and thing equals T. T was the primary key of that thing. So if we can get it, then we delete it. Now, if again somebody manually found their way to the unfavorite button, even though we've hit it cleverly, they could still find their way, or a web browser might find its way. We're like, okay, we tried to delete it, it's not there, there's nothing bad, we'll just kind of fav not, it does not exist, and we're going to pass. And then we return an HTTP response, which is in effect emptiness. So when we come here, go to the network, refresh, clear everything, unclear it, right? There is nothing there. So we returned an HTTP response, but the most important thing is that we sent back a 200. So this, implicit when you're doing this is there is a 200 going back. And so it is successful. Okay? And so I think that this is pretty much all I have to cover on this, how to build a favorites. The quick way to test this is you should be able to turn these things on and off and watch the network tab. And then if you hit refresh, these two things, the state of these should be the same, meaning that you've properly recorded them in the database. So when I had it breaking, I would hide it, and then I would refresh it, and the little orange star would come back. So I hope this was helpful to you. A helpful little walkthrough going through the favorite sample code. Cheers.
Hello and welcome to another walkthrough for Django for everybody. In this walkthrough, we're going to take a look at the sample code called well. The the name well is based on a long time early pre-internet forum in Berkeley, California, and so you can go look up the well. So the basic idea of the well is it looks exactly like MyArts. It's pretty much a clone of MyArts. So if you recall MyArts, you had articles CRUD, article submit, article CRUD, delete, just a basic article CRUD, right? So the only difference between this and the well is there's a search box here. So I can search for things that have yada in them, and then I can clear the search box. And that's it. So first, let's observe something that we can observe from the outside. When I do a search, the search is a get parameter. And the reason for that is that we want this, get parameters are get URLs are idempotent. So that basically says go to my blog and find all the blog posts that mention
1, 2, 3. So I could, I could put that in as, clear my search here, and I could do, let's search for DSS, DSS search here. So that is, this URL is the search for the ones that are DSS. So now I've bookmarked both these, and now that is going to be a short link to the ones that say DSS. So what I'm going to do is clear this search now, and this will show you something about idempotent URLs. I'm going to say yada 456, I was here, submit. So now I have two that have the word yada in the title, but watch what happens when I go to the URL that I bookmark. So I see now two posts. So the key of idempotent is not that you get the exact same page, you get the exact same logical page, not the exact same text every time. It's not like a cache that just clones the text. You know, I go to this before, and then I go to it now, and if I then delete this one, and then I go to this again, that's the ones that have yada in them. And so that's why we're going to do a search for yada. And it's really quite simple here. I'll show you everything, but let's just start with an inspect element so you can see what's going on here. The first little trick here is you can construct that URL, and this goes way back. This goes way back to a form without a method equals post, which means it's a get method, which means that this name equals search becomes, it just goes on and it does a get request. So instead of doing a post request, which we've been doing for weeks now, this does a get request and it adds a get parameter. Okay, and so we've got in our view, our main view that is we're seeing a get parameter. It is not a different view. We're getting a view with a get parameter. And that also means that if I inspect element on this little undo icon that I made, inspect, all I'm doing is I'm making a link to /well without the parameter. So it's super easy. So like get rid of the search is just go to a different URL. I could have done it with, well, it is an anchor tag. It's an href tag. Look. So I've just gone to well and it's not there. It's the same view. So searching, and if you were to go and take a look at how Amazon or Google, they do search, they're forever putting that stuff in the URL so that you can then bookmark them. And so I'll get rid of those I'll get rid of those bookmarks later, but you see how that is idempotent. That's the get. When I said weeks ago, I said get URLs are idempotent. I can now sort of show you in code that we're writing how that works. Okay, so let's take a look at our code. I'll clear my search here. The code here is pretty straightforward. We've got a really simple model that was pretty much taken straight from the MyArts code. This is like it's got a name. I called it post instead of articles because I've got all these applications running at the same time, so I have to change a few names here and there. Related name is when we're poking a lot of we're putting a lot of foreign keys into owner across my Django project. So you got to be careful to choose a name for related names so you don't end up with a collision. You can't just say owner or whatever. So I call this post owner so that you don't back in the owner model. Back in this model right here, the auth user model, we're pushing, in effect, methods or attributes into that model. And so we got to name them. And so this related name is really quite important to make sure across all of my applications. And what I mean is these are all applications in one giant Django project. So this name here wants to be, and lots of these applications are using owner. And they're making a foreign key into the auth model, which is perfectly okay. It's just you got to be careful about the related name. Okay, so that's why that's there. So let's take a look at the urls.py. The main URL that we're going to change is this one, right? It's the list view, and here it is in the list view. And I don't know which way to go first here. let's compare and contrast this list view with the views in MyArts. So in MyArts, the list view, I could just borrow owner list view, which was like extended generic list view, and I just say my model's article, and it was good. But now I got to do a whole bunch more work here. So I actually am going to, and I might have been able to do this by sort of overriding a few methods like we have done in the past, but I just decided that I would simply write all the code. And so I'm just extending view here. So I'm only extending view to make post list view. I'm still following the pattern so I can say what the model is. I'm not sure I even use that. Let's see if I use model. Yeah, I don't even need that. Template. Am I using that? It was kind of, yeah, so I'm using the template name here. So I still am going to use the template name. But I didn't need the model because the reason I didn't need the model is I'm just explicitly using post in all the places. And so just get that. So it's not, I mean, I don't like code that does nothing. It's always a mistake. Okay, so the get request. Most of this is in a get request. There is no post here because in the list view, which is this view, there is no post. This form is a get request. That's a get request. And all it does is we are going to do a get request, and we're going to do two versions of that get request. And we're going to have one version of the get request based on whether there's a search get parameter or not. So we're basically saying go grab a get parameter. Get the get parameter using the get method of a dictionary. The big uppercase get is the dictionary, and lowercase get is the name of the method in Python. Search is the key, and then default is false. If we get a string, then we've got to search and filter. But let's start with this. All we're doing here is we're grabbing the objects, and this is the kind of code that is done automatically in owner list view, which is then generic list view, right? So this is just, I'm just doing the code. Now the thing I get to do with this that's really nice is I can go through and augment this object list. Now, so this is a list of objects, and I'm going to change each object, and I'm going to add a field. Undo, undo, undo. I don't know what I just did. Undo, undo, undo. Okay, that I want to keep. So this is an object. So objects is a list of objects, and I'm going to grab it, and I'm going to add a field. So you can sort of in the middle, you can add this natural-updated, and I'm going to base it on updated at, which is the long, ugly-looking date. It's a real date, but it's a long, ugly-looking date, and I'm going to run that through the natural time filter, which again is something built into Django that puts in this 15 hours ago thing, which is much nicer than just putting the date out. Okay, and so we're going to send the objects in this post list, which is the list of objects, and then we're going to send the string, the search value in, just so we can show that. Yeah, so that when we want to see this yada, so you can actually change this, right? So we want to put this back in, right? So we're going to pass that into the template, and then we're going to render the template. Dump queries is code just to show the queries that are actually being run if I was running this locally. So let's take a look at the code. So for most of this, literally, it's the same thing. Okay. So it's basically looping through. It's doing a little bit more tricky stuff here. If the text is less than 100, I'm putting it all in. In the list, I'm only going to put so if the post is the length is less than 100, slice is 0.99. How come I can't see that? Yeah. Oh, that's because I'm not the owner. That's because I'm not the owner. Posted by DJ Free Samples. Who am I in this situation? Well, let's add a post. A title. Zap. 1, 2, 3. Submit. Yeah, so it's showing this detail. That's what I was confused about. See this little detail? Oops, not with that end if. That post text length greater than 100. So there's actually a bug in this code right here. And since I'm running it on samples, it'll take me a while to get it updated. But I'll just point out that there's a bug here and I want to fix it. Because I really, this if post owner ID, that's our standard, like to show the edit and delete. And I inadvertently had this code that's showing the actual text. This is what I wanted to look like. I wanted a title and I wanted a short summary. So you'd have to go into here to get the whole summary, but the short summary of the text. So this code, when you run it again, you will see, after I update all this and push it through GitHub and run it in production, I will fix this, okay? And so that is what makes this, to keep that nice and short. 99 might be too long of a thing. I'd rather that stuck to one line, but whatever. Posted by the username in this case. There's the username. That's nice. And a URL into the post detail. So this is really straightforward stuff other than that little cool bit there of putting the summary in. But the only thing we really have added here is this form. And we are going to do a form. It's going to, because we haven't said action equals on the form tag, it is going to post right back to the same URL that it came to. I mean, not post, it's going to do a get because there's no method equals post here. It is going to get right back to this same URL. And I have the input with a placeholder. The placeholder is what gives me this little searchy bit thing. See that? It's not really the string search. It's a placeholder if it's empty. And then I have value equals, oh no, undo. Value equals search here, which is taking the old search value. Old search value. Ooh, Zap was there. And so that's putting Zap back in there. And of course, it's escaping it. And so if we were, you know, there's no HTML entities problem here, or whatever. And I put this in an if, right? And that you don't have to put these on separate lines. You see me doing a lot of that where I'm having the if and end if on separate lines. But here I just have it like right in the middle of a line, and that just is going to emit that text in the middle of that line. I'm using a font awesome icon for the search so that I get this little search button. That's kind of cute. That's a thing called font awesome. You can go look that up. And then I have a link that goes back to well:all. I could probably call this like request.path or something because it's really would be the same thing. Instead of URL well:all, I could just go back to the request path, which would be // but it doesn't matter. Well:all is nice. And then I throw another font awesome in there, which gives me a little undo thing. And we've been using these little font awesome creatures for a while now. And so that's really all that is needed to get this new bit of user interface into the output. And so really the only thing left to show you is the code where it handles the search. So there is a filter. So post objects all order by, that's what happens if it's not searching. So what you see here is all we've done is instead of saying all, we say filter. And there's a couple of ways you can do filters. You can do like just if you're doing one field, this is a really funky syntax. It uses 2 underscores. Title is a field in models.py, right? Title is a field in models.py. Double underscore contains, that is like an operator, and then this is a string value, which is just a string here in our Python code. Now I want to actually search through both the title and the text. So I'm going to have to make myself a combined search. So I'm going to make a query. And I'm going to use this dbModelsQ, which means I can create a query in, and I could do it in a really long, yucky query there, but I'm going to start with a query that says the title contains the string, and then I'm going to add to that an OR clause. We're stuck in Python, right? It's not SQL. We're stuck in Python, so we got to have this funky thing. So this says these two things create a thing that basically says if the title contains that string, whatever it was, zap, if the title contains that string or if the text contains that string. Select it. And now instead of all, I put filter query, so I pull the query in. And then select related. This is an efficiency thing that says, look, I'm going to actually look at all the data. So run that whole filter, run the username, do a bunch of stuff. So I got a comment toward the bottom of this that talks about select related, and then the order by, and then showing just the first 10. That's the same. And there we go. And then we augment that, and then away we go. And so search is either, in this case, search is either the get request from the former get, this is that value in this particular instance, or it is false. And then that triggers, of course, this bit of code in the template. So that's pretty much it. I mean, I certainly probably over-talked it. It's not that complex. And then so I want to show you only one more thing for this before we wrap it up, and that is a new pattern. So you'll notice if you look in here, there is only one view. There is just the post list view. And if we take a look at articles, we've got these views, the detail view, the create view, the update view, and the delete view. And they all extend owner create view and then just change these variables. I overwrote this list view because I had a whole bunch of other things I wanted to do that owner list view wasn't going to do for me, right? And so, but you'll notice that in the well, I don't have those. So let me show you how these are, and you'll notice I have edit views, right? I got them, they're still there. And there are templates. CD templates, well, the templates are there, okay? And as a matter of fact, in this one, I changed the default name of the templates because I'm kind of tired of putting underscores in front of certain things. But let me show you how I solved the problem of where are the views. They're actually fully in urls.py. So here is, so I import owner list view, owner detail view, owner create view, and owner update view. And so what I'm saying is map the post/int pk, which of course is the detail file, right? Post int pk. And I would like you to call owner detail view, which is a class that's come from myarts.owner, as view, and then you can put a series of key value pairs in that override the default values of, say, model and template name. And so I'm saying models equals models.post. I know that. That's the name of my model, right? And then template name equals, and now I'm even saving, I'm taking the app name, which happens to be sitting conveniently in a string here, and concatenating it to detail/HTML. And so that is the view. And of course, name equals is just part of the URLs thing. And you'll notice that when I do the create view, I set the success URL, the model, the template, and now remember, I want to hide some of the fields. I want to show which fields are there and which fields aren't, right? And so if we look at this views, you see like which fields you actually want to show, because I don't want to show the created at, etc., and the updated at, right? In the models, I don't want to put owner out. I don't want to put created at out. So I'm going to give a list. I'm going to give a list. Come back. I'm going to give a list of the fields I want to show on my create form. So again, these are sort of class-wide variables that turn into object instance variables when it makes this view, and it overrides all these things. And so all the stuff that I was doing in views.py, I am now doing in urls.py and just reusing owner create view. And you see in update, delete, they're all kind of there, right? And so I don't actually need to put the views in. And this is really, it looks a little more complex, but I think it's a lot prettier than putting these silly views in over and over. So that's a pattern that you may want to use. It made it easier for me to rename from well to something else if I wanted to, because really well is only hard-coded one place in here. So that's kind of cool. Okay, so there's a couple of lessons here. You know, one is this searching. One is the search and how that works, but then also a new way to create views that never really leave urls.py. You could build, and remember, I built this owner detail view to meet my needs. So things like template view, That's something that isn't just a bunch of code somebody wrote. So, okay, well, I hope this walkthrough of the well sample application has been useful to you. Cheers.